Hey guys, this is my most sold course and I hope that it will be super useful to you. If you want to become a mobile game developer, watching this course will just skyrocket your skills to the next level. So have fun, enjoy the course, and if you want more specific courses or just want to support my work, consider getting mobile mastery at tapsil.com. Hey guys, and welcome to this brand new course on making an arena shooter roguelike. Okay, so in this first lesson, we are going to take it easy and start planning our game, okay? Because planning is one of the most important things you can do to successfully create a game. It will make everything so clear. This document right here is going to follow us all along the course, and it's going to help us actually a lot. So let's start with the first word here, arena. It means that we are going to have ta-da! An arena, of course. So let's color it. Okay, here it is. Perfect. So it does mean some things here. First off, it means that we are going to have collisions between the player and the arena, right? What we can also imagine is having some greenery. So maybe let's draw some green dots here. Maybe something like this. Perfect. So we can have some objects just to make the scene more interesting. Okay. So we've got collisions. We've got, let's say, vegetation, stuff like that. Some grass, maybe trees. So we can have shaders for these objects. Perfect. We can also imagine different ways to create the arena. So we've got collisions, but we can use basic colliders. So let's drop this somewhere in here. This can be basic colliders. So basic box 2D maybe, colliders, or we can have a tile map system like so. Perfect. What else? Then let's actually tackle the shooter word because it's going to be a little bit more interesting. So let's drop these somewhere around here. Perfect. And let's tackle the shooter. Boom. Okay, so shooter. Shooter means that we are going to have guns and more generally weapons. So let's create, boom, weapons. We will have two kind of weapons. So we can have guns which are range weapons. So let's actually just write range. And we can also have melee weapons. Cool. Who's going to hold these weapons? Well, the player. So we will have a player. A player needs to move. So we need a player controller, something like that. The player will move inside of the arena. So it will need to collide with the walls of the arena. So it will definitely need some kind of detection or collision. Okay, collision detection. So we are already starting to understand a little bit more the architecture of the game here. We've got the arena with collisions, we've got the player with a controller and some collisions. And by the way, the weapons are not going to move by themselves like in, I think it was Blast Valley, a game from Voodoo. Yeah. So the weapons right here will be attached to the player. Okay. So we can actually drop them inside of a big square like this. Like so. Perfect. We can remove the arrow. Here we go. So we've got the player controller, collision, weapons. Okay, so this is for shooter. And for roguelike, what we can write is draw a nice arrow here. We can imagine having stats for the player. We can have enemies. A roguelike can be a dungeon roguelike, so we can have rooms, but we are not going to use rooms in our case, but we can still write it. We can have waves of enemies, so we will need a wave manager. We will also have multiple kind of enemies. We can have melee enemies. We can have range enemies, and we can have bosses too. Okay. Perfect. So these are the three types of enemies I'm thinking about here. But of course, as we go, we can still improve on this document here. And by the way, I'm using Affinity Designer here, but you can use any other software that you like. I'm thinking about Milanote, I'm thinking about Notion, and there are so many others. Photoshop maybe, Illustrator, anything you want. Anything that makes your thinking better. Okay, so let's keep it right here for now and start working on our player. Okay, so the first thing we are going to do in the next lesson is actually not start by working on the player, but on something way more important again. And let me present you source control. Because oh, not source controls, but source control. Because when making a game, you are going to change the code or your code base so many times. And it's good to have a kind of source control so that you can come back to a previous version whenever you make some changes. Because you might make some changes and make mistakes. It happens. We are humans. So yeah, I'm going to show you how to use GitHub Desktop in the next one. And then we can start creating our project. So see you there. Welcome back, guys. In this lesson, we are going to learn how to use GitHub Desktop to prevent any unhappy accident. So, the first thing you want to do is to go to this link, so desktop.github.com. I trust you can do that, but I'm going to leave a link in an article linked with this lesson. So let's download it. I've already done so. You can then install it, okay? So you can download it for macOS or for Windows, depending on what you're using. And once it's done, you can open it. Perfect. So this is actually the repository I've used for making the course. So let's create a new one. So we can add right here, create a new repository. Perfect. We are first going to give it a name. So let's call it Kawaii Survivor Course. You can add a description if you wish. Okay, let's select the path. So I'm on the right path, thank God. And then we are going to use a git ignore file. So basically the git ignore file will tell GitHub not to upload or to add files or folders to the commit. And when you use Unity, as I'm going to show you later on, you're actually telling it not to include the library folder and some other ones, okay, that are not really inherent to your project. You can also add a license, but because we are creating a local backup, no need to do so. So let's create the repository here. Perfect. It has been created. So what you can do now is jump to your repository by right-clicking and open or show it in the Explorer. Here we go. So let's open the git ignore file. And you can see that it won't include the library, the temp folder, the obj, build, builds, logs, and so on. And you can add your own folders right here. Let's say you are using recordings, but right here it's already included, but you can add some other folders if you wish so. But for now, we are not going to touch this. It's not important. We want to make the game, okay? So let's open Unity Hub, perfect, and create a new project. So for your reference, I'm using Unity 2023.2.16, okay? And I highly encourage you to do so because it will make working with shader graphs easier later on, yep. Or you can use a later version. So let's now create our project. So new project, let's use Unity 2023.2.16. So we can select Universal 2D for the template, and let's select our folder right here. Kawaii Survivor Course, select the folder, and let's name the project Kawaii Survivor Course. Let's create it. And once it's done, of course, we are going to move it because right here, if you press F5 right here, nothing happens, but it's coming. Here we go. We will need to grab all of the folders that we have here and drop them in here. So yeah, see you after the project has been created. All right, the project has been created. But if we open GitHub Desktop right now, we can notice that it has included the library folder and some other folders that we should not have, like the temporary folder that we've got right here and some other ones. This is because, as I told you, we need to move the folder to another place. So first off, let's quit Unity so that we don't have any errors. Then what we are going to do is grab all of the content of this folder, so the one containing the Unity project, and cut it. So Control X or Command X on Mac, Control or Command V right here. We can now remove this folder like so, go back to GitHub Desktop, and we can now notice that we only have 45 files that we are going to drop in our first commit. Perfect. So let's call it first commit. Like so. Commit to main. Cool. So once it's done, you can check out the history right here. We've got the initial commit that has the git ignore and git attributes, and our first commit that actually contains the project files. So what we're going to do in the next one is open our project and finally start doing something in Unity. Finally, I'm sorry, but these two steps were really important here. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are going to open Unity, finally. Okay, so let's do that. I think that this one is not working anymore. Okay, that's what I thought. So what we're going to do is remove it from the project list, like so, remove the project, and select open. It should be somewhere around here. Yeah, it's actually here. So Kawaii Survivor course, open, perfect. And let's meet on the other side. All right, finally, the project has opened. So if you are new to Unity, don't worry. I'm going to explain every window step by step. But first off, I think that your window or your layout will actually look like this, default. Perfect. So we are going to rearrange things a little bit. But before that, we need to configure our game for Android or iOS, depending on the platform you want to develop your game on. And keep in mind that it will also work for PCs. And normally it should work for consoles, but I haven't tested it. Okay, so let's first select File, Build Settings, and switch to Android if you're targeting Android platform, or select iOS if that's the case. So let's select Android in our case and switch platform. And quick tip here, make sure that's the first thing you do, because the more assets you have in your project, the more time it will take to compile and reconfigure all of the files, okay? So yeah, let's now wait for Unity to do its thing here, okay? Hurry up, please, I've got a course to make. Here we go, perfect. We can now close the build settings window and we are good to go. If you want to know, by the way, if it has worked correctly, you can notice that the Unity logo is next to your target platform. So it should be next to the iOS platform if that's the one that you've selected. Perfect. So what we are going to do now is import the starter pack that you can find in the first lesson and also in this one normally. I'm going to try and add it to this lesson. So here it is. I'm going to open it. So double click it. It should open it with Unity. And if that's not the case, you can still drag it and drop it inside of your project window right here, along with your assets. So let's import all of this big, beautiful stuff, and then we are good to go. Hopefully. All right, once you've imported all of the assets, we are going to loop through them just a little bit, just to have a bird's eye view of what's contained in it. So I'm just going to diminish the size of this because I really don't like seeing big icons, but it might be the case for you. And it's actually more convenient if you want to use Mineral, the package I've provided that helps you or allows you to actually change the color of your folders. Indigo, let's say. Yeah, perfect. Okay, cool. So we've got some basic sprites that you can find in Kawaii Survivor sprites, enemies, let's say. You've got some characters right here that you can spot right here. So this is Smirk, Snark, Pop, Dave. Thank you, Alex, for all of the assets. You can contact him if you need some. And yeah, so we've got some sprites. We've got some audio sounds. So an axe sound, a gunshot, some random knife attacks, this one and this one. We also have some fonts that we're going to use later. And yeah, basically we also have a mobile joystick and a bunch of icons that you can find here and inside of this folder too. This was a free pack that I've grabbed from the asset store. You can still go show some love to Heather Engineering on the asset store. And also some other things that we are going to have a look at later on. All right. The last thing I want to do before actually starting the project and playing with the player is rearrange the windows a little bit. In Unity, again, if you're new to Unity, you can rearrange the windows as you wish, and that's really cool. So I like to have my inspector next to the hierarchy. So the inspector is basically where you can see the settings or the data for the object you've selected in the hierarchy. The hierarchy contains your scenes, and each scene contains game objects. Every game object has its own settings and components, okay? So this is basically what you need to know for now, and we are going to go in more details later on. So I like to have the inspector right here. I like to have my project window just below the hierarchy. The console can go below the inspector so that we have a big space here for our scene and game. So I'm going to drag the game and drop it somewhere around here. Perfect. I'm also going to select simulator here so that I can see what my game will look like on a real device. So let's select the iPhone 12 Pro Max, let's say, and rotate it. Here we go. So now we have a better view of how our game will look like. If you're happy with the view or the layout that you've made, actually, you can save it. So let's click on the top right button right here and save the layout to, let's say, Kawaii Survivor Course, but you can rename it landscape or Android landscape, iOS landscape, whatever you want. I already have a landscape one here. Okay. So I think we are good to go. In the next one, let's start working on the player. See you there. Welcome back, guys. In this lesson, we are going to start our player controller thingy. Remember, we've said that we needed a player, so we are going to try and start with it. Our player will actually be rendered with a sprite render component. Okay, so we can bring these down, maybe bring this one here. We've got our player rendered with a sprite renderer, and then we will control it with a player controller, and we will also need to add collisions. So let's start with the sprite renderer feature here. We can go back to Unity, perfect. Let's open the Kawaii Survivor folder, sprites, characters, and let's start with Dave. Hey, Dave. So what you can do is either drag it and drop it inside of your hierarchy or drop it inside of the scene view, not in the game view, not in the inspector, not in the console, okay? So let's drop it inside of the hierarchy so that it's placed at 0, 0, 0. Okay, so right now Dave is too big, he's eaten too much. So we are first going to rename it Dave, like so. And by the way, quick thing here, if you select the sprite Dave right here, and have a look at the inspector, you can spot the settings for that sprite. So right now, Unity thinks that there are multiple sprites in Dave. No, there is only one sprite. So what we're going to do is select single and then apply. Perfect. Dave has disappeared, but we can bring Dave back, like so. Awesome. So let's remove our previous Dave and use the new Dave. Perfect. So our Dave has two components right here, a transform component and a sprite component. The transform component will help us move Dave, rotate Dave, and scale Dave. 3 things we can do with Dave. Oh, he's so cool. This is basically what the transform component represents, the position, the rotation, and the scale. You can also scale Dave proportionally or scale Dave like so, horizontally, vertically, and so on. So let's reset Dave. You can click on the 3 dots here and reset Dave's transform. And you can do the same with every component. You can reset them, remove them, copy them, and so on. Okay? So each one of these is a component here. Perfect. To move Dave, you can either edit its position right here, rotation right here. Rotation along the y-axis doesn't make any sense because it's going to be weird, like so. We are in 2D. We need to rotate it around the z-axis, like so. You can do that from here, from the inspector, or from the scene view. You've got some tools here. So this is the move tool, this is the rotate tool, and this is the scale tool, and this is the rect tool. Bim, bam, boom, 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 like so. And this is the everything tool. I don't know how it's the transform tool. This is actually the transform tool. You can move it, rotate it, and scale it all at once. And this is the hand tool, I think, or the pan tool. Or perfect. So these are 2 ways you can move, rotate, or scale any object in your scene. So we can already imagine that one way we will need or use to move Dave is to access the transform component right here and edit these 3 values, or actually these 2, because we are not going to change the z value. Come on, we are in 2D space. All right, let's now tackle the sprite render component. It does have a sprite, so we can change that sprite. You can decide to render a cotton candy gun or anything else, but for now we are just going to render Dave. You can also drag anything from the project window and drop it here if you want to change the sprite, like so. Perfect. Control Z to come back, of course. You can flip it along the x-axis or y-axis and also change its color. It's actually a multiplication here, a product that's used. So yeah, make sure to use this accordingly. We've got some other options, but let's actually keep that for later. Right now, we want to move Dave. So in the next one, let's learn how we can do that. Welcome back, guys. In the previous lesson, we've learned about Dave. Yeah, we can say that actually. So we've learned about the transform component and the sprite render component. So we can actually open our image right here or file. And I don't know if you want, we can color this in red or green because yeah, we've done that. Perfect. So now we need to control Dave. So let's go back to Unity. And as we've said in the previous lesson, one of the ways we can use to move Dave, like so, is to access the transform component and change its position along the X and Y axis. Okay? So let's just reset this. But there is another way we can use because moving Dave, we're using the transform here, can and will cause issues when we'll work with detection. Because ideally, later on, we will have an arena. Remember? And inside of our arena will be Dave. And Dave needs to collide with the walls of the arena. So if he needs to collide, we will need a collider, right? But this is not the first thing we want to use here. Another way to move an object in Unity is by using physics. So what we are going to do is add a new component, go under the Physics 2D tab, and select Rigid Body 2D right here at the bottom. What you can do is also write rigid body 2D. Perfect. Here is our, oh, come on, where is it? Control Z, no, Control Shift Z, it's not working. Anyway, I'm going to add it again. So rigid body 2D, boom, like so. So if we hit play to start our game, I think Dave will fall. And Dave is falling. He is falling because we have added a rigid body 2D component to it. And that component applies physics to any object that has it as a component. But what we can do is prevent Dave from falling. So let's set the gravity scale to 0. If we now hit play again, he should not fall. And he's not falling indeed. Perfect. Nothing. Okay, cool. Then we don't want Dave to rotate along or around the Z-axis like so. It's not something that we want, or at least we don't want to rotate it after colliding a wall or an enemy. So what we can do is expand the constraints and check freeze rotation. Now Dave won't be able to rotate. Perfect. There are more options right here, but we are going to go through them later on in the course. So now to move Dave, let's make use of the rigid body 2D component. For that, we are going to create our first script, the player controller, that will allow us to edit or manage Dave's velocity. All right, so let's open our Kawaii Survivor folder. Right-click and create a new folder. Let's call it Scripts. Open it, and again, right-click, create a new C# script, and let's call it Player Controller. Or you can call it Character Controller or Dave Controller or anything you want. But just make sure that you understand or that at least it's clear for you, okay? The goal of this course is not for you to follow along and make the same things as I do. You should not copy what I do, actually. You should rename things from time to time so that you understand what you're doing. Because at the end of the day, the goal will be for you to grab a course and make your own game or games, hopefully. All right. So let's now select Dave. We can actually collapse our two components and add the player component script like so, or by looking for it in the search bar. Player controller. Perfect. We can now open it. If that's the first script you ever open in your life, congratulations. This is a big step. And this is actually the start or the beginning of an amazing journey. All right, so let me explain quickly for those of you who are new to this. At the top right here, you've got the libraries that you are using. So these ones are grayed out, so we are not using them. We can remove them, but this one is not grayed out. So if we comment it using 2 forward slashes, we are going to have an error because the mono behavior class right here is contained inside of the Unity engine namespace. All right, so this is a class, this is a namespace. If you want to create your own namespace, quick tip, you can write namespace blah blue and add some brackets, curly brackets actually, like so. And you've created your own namespace like so. So in another script, you can use using blah blue. Let's try here, using blah blue. Perfect, semicolon, here we go. So let's remove these because we are not going to create our own namespace yet, like so. How was it at the beginning actually? Control Z. Here we go. So we've got the name of our class player controller, and Unity has added 2 methods, the start method and the update method. As you can see right here, the start method is called before the first frame update, and the update method is called once per frame. So it depends on your frame rate. If you are running at 60 FPS, it's going to be called somewhere around 60 times per second. If you're running at 30 FPS, somewhere around 30 times per second. Okay? So what we are going to do first is try and grab our rigid body 2D because this is the one that contains the velocity of the player. So let's add a reference to our rigid body 2D. So public rigid body 2D, let's call it rig. You declare your variables after the class declaration, if that's an optimal way, but you can actually declare them after the methods. It's weird, it's not conventional. So yeah, the best way to declare them, it's right after your class declaration, okay? Basically, you declare your variables, then your methods, all right? So let's go back to Unity, and right away we can spot that Unity has added a rig component. So we can grab the rig and drop it here. This is one way of doing things. But we are already doing something bad here. What is it? If you've watched the promo video of the course, you've noticed that I told you that we should not use that many public variables. Why? Because if we do so, we can imagine another script, maybe the enemy script, can access the rigid body of the player. And this is not what we want because we only want the player controller right now to be able to access it. So what we're going to do is make it private. Okay? That way we can't access it from any other script. But if we make it private, we are not able to spot it here. So this is another issue. To fix that, we are going to add an attribute. And to add an attribute, you can use brackets like so and write serialize field. By adding or using this attribute, Unity will serialize your field and display it inside of the inspector. Hooray! We fixed our issue. So the rigid body won't be accessible by other scripts, and we are still able to access it. That is so cool. Another way we could have done it, if we don't want to display the rig inside of the inspector, is to actually remove this and write rig equals get component rigid body 2D. So at start, Unity is going to go and grab the rigid body 2D attached to the player right here, and we'll then be able to use it. But if we don't have any rigid body attached, so let's remove the rigid body component here, okay, and hit play. What will happen in your opinion? Nothing, because we haven't done anything with the rig right now. But if we try and use the rig, so rig.let's say velocity, because we said that we wanted to control the velocity of the player, let's say equals vector2.right, just to go to the right. Vector2.right is actually a vector with 1 along the x-axis and 0 along the y-axis. So let's now go back to Unity, hit play, and what will happen now? Error. There is no rigid body attached to the Dave game object. But a script is trying to access it. Okay, so it's telling us that we don't have any rigid body attached to Dave, and of course we don't. So what you can do here is make sure that you have a rigid body 2D attached to Dave, or if you don't have one right here, what you can do is specify or tell Unity that if you ever add the player controller script to an object, a game object, it should automatically add a rigid body 2D. So we can tell Unity to do that using another attribute. So require component type of rigid body to D, like so. And just like that, Unity will add a rigid body to D whenever you add the player controller to any object. So let's remove the player controller and add it again. Just like that, Unity has automatically added a rigid body to D, as we've said. So this is another way of doing things, and now we won't have any more errors. If we hit play, Dave should move to the right. And yep, it's also falling because we haven't disabled the gravity on the new one. And we also need to reset or freeze the rotation. So let's now hit play again. And now Dave is moving to the right. And because he has no gravity, he's actually moving straight and not stopping. That is so cool. So this is how we can use the velocity to move Dave in the next one. Welcome back, guys. In this lesson, we are going to keep working with Dave so that we can actually control him. So the first thing I want to do here, because we've added source control, is to actually use it. Yeah. So let's commit all of our changes here because we've added so much. So let's call it initial changes maybe, or initial scripts, or maybe Dave control, or maybe Dave rigid body, or maybe Dave. Let's actually call it Dave. That's actually straightforward. Okay, and when all of the changes has been committed, we can keep going. Okay, perfect. All of our changes have been committed. So let's go back to Dave. In the previous one, we've seen that we were able to control Dave with the player controller, but by managing or editing the velocity. So now what we are going to do is to move him using this velocity, but we are not going to change or set the velocity right away. What we are going to do instead is use our joystick that I've added as a resource attached to this lesson to move Dave. So let's actually open the prefabs folder inside of Assets, Mobile Joystick, Prefabs, drag the mobile joystick zone inside of our hierarchy. And right away, we can notice some weird things here. This is because the joystick zone must be dropped inside of a canvas. A canvas is actually used to display or use UI elements in Unity. So for that, I'm going to right-click, select UI, Canvas. Perfect. Let's first set up our canvas here. We are not going to deal with the canvas component, nor the graphics raycaster, but let's have a look at the canvas scaler component. Right now, it's using a constant pixel size. Instead, what we want to do is scale with the screen size so that it's actually better rendered on all displays. So we are dealing or making a landscape game, so we want to select width. And for the reference resolution, I'm going to set it to 1920 by 1080p. Perfect. So if you press F in the scene view, it's going to focus your canvas. Perfect. You can actually select the rect tool to have a better way of the bounds of the canvas. Awesome. We can now grab our mobile joystick zone and drop it inside of the canvas. Here we go. So we can actually rearrange this a bit more and select the zone we want the joystick to actually be controllable. So I'm going to set it to something around here, because we can imagine having some buttons at the top right and the top left of the screen. All right. So now you can actually have a look at other resolutions. So iPhone 12 mini, Apple iPhone SE, Pixel, Galaxy S10, and here we go. Perfect. So now if we hit play, we should be able to control the joystick already. So let's try that. Yeah, here we go. So it seems a little bit weird because it's not set up correctly right now. So what I'm going to do is actually go down, select the mobile joystick component, which is right here, and set the move factor to 1. Let's now hit play again. If we try this out, it's way better already. It's a little bit weird still, but we can tweak this value to make it fit our needs. So 0.5, maybe 0.7. Yeah, 0.7 seems cool. All right, let's try on another device. Yeah. Okay, so 0.7 definitely looks really cool. All right. So we now have a joystick, and by the way, I've provided the joystick here, but I'm going to attach, I think it's 4 lessons from a previous course. It was the hybrid casual one, where I explained how you can make this exact joystick. All right. If we select the mobile joystick right here, we can notice that it has a mobile joystick component attached to it. Let's open it. Cool. So it has a bunch of variables and methods. It's actually really simple when you know what you're doing, and you are going to reach that stage. I promise you, if you follow this course, you are going to be able to write way more complex things than this one. All right. So everything here seems to be private. This is public. Okay, so this is private. But one thing that is important to us here is the get move vector method, because it is public, so we can access it from the player controller, so from everywhere else, and use it to set up our velocity here. So you now know how to create references to other objects or scripts. So as a quick exercise, 5 seconds, define a reference to the mobile joystick script right here, like we've done for the rigid body 2D previously. 5, 4, 3. You can actually pause because 5 seconds is actually, no, 5 seconds is enough. 1, 0. All right, we are going to write serialize field, private again, as we've said previously, mobile joystick, and let's actually call it joystick, like so. So we first need to set the class type, then the name that you want to give it. And a convention in C# is to write the name of your variables in camel case. So if you have one word, it's going to start with a lowercase letter. But if you have multiple words, so joystick, let's actually call it player joystick. So player joystick, like so. So the first letter should be in lowercase, and all of the other first word letters should be uppercase. I hope it's clear. I think you got it. All right. So let's now use the player joystick to control our Dave guy. So we can simply write inside of the update method. And again, this is not the best way to do it, but I'm going to show you first this way and then the better way. Rig.velocity equals player joystick.getMoveVector. Here we go. So let's now go back to Unity. We know that the joystick does return a vector 2, X and Y. So this is really useful in our case. So let's now select Dave and reference the mobile joystick. We can save, hit play, and if we don't move our joystick, Dave is not going to move because the move vector is actually 0, 0. But if we move it just a little bit, we can start seeing Dave moving. Ooh, that is so nice. So now you know how to control a character or any object using a joystick. How cool is that? This is actually a huge step, so you need to celebrate that. Have a break, have a Kit Kat. So where is Dave now? Dave is actually really far. He's at 41.5. So let's reset its position like so. And you can notice that it's actually really sensitive here. So we need to bring or tune down the sensitivity. And a way to do that is to add another variable inside of our player controller. So let's add it. Serialize field, private float, move speed, like so. And what we can do right here is use the get move vector, so the vector 2, times the move speed. That's helping us tune down Dave's speed. So let's now go back to Unity. All right, let's set the move speed to, I don't know, I think 1 was a little bit too much, so maybe 0.1, only 10% of what we had previously. Should be good, actually. So yeah, that's actually already pretty cool. Yeah, I love it. Okay, cool. But there is another issue here. Dave is too big. Have you noticed? Dave is huge. So we need to make it a little bit smaller. So what we are going to do is set its scale to 0.3.3. Here we go. That's way better. That way we can have the arena around him. So maybe the arena can be the size of the screen here. Maybe 5 units tall, or maybe 10 because we have 2 ways, yeah. And 1, 2, 3, 4, 5, 6, 7, 8. I think we are going to make it 5 by 8. Yeah, it might be better. Anyway, we're going to check that later on. Right now, there are something more important here. First off, I want to hide this black opacity thing here, or transparent image. And for that, we are just going to select the mobile joystick zone, select the color property of the image here, and tune it down to 0. Perfect. Now it's fully transparent. That's one thing. The second thing, which is also really important, is to multiply our vector by time.delta time. This will make it responsive across different devices because you will have old devices, old phones, and new devices, and some are more performant than others, of course. So we need to take the frame rate into consideration here, and that's how you do it. Okay, so now if we hit play, Dave is gonna go a little bit slower. So let's try and move him, sorry. Yeah, he's definitely too slow. So what we can do is, again, increase its move speed. Yep, 3 seems decent, but still too slow. Yeah, 7 is okay. Okay, let's keep 7 for now. Perfect. So now that we have configured Dave's movement. Oh, one thing here, quick tip for beginners. If you are inside of the play mode, and you try and change a variable, so let's say 15 for here, yeah, that now Dave is faster. But if we exit the play mode, Unity brings back the previous value, so keep that in mind. So one way you could do is to keep the value in your mind and then add it if you exit or when you exit the play mode. Or what you can do is copy it, just Control-C, Command-C, and then paste it whenever you're done. That's one thing. The second thing I wanted to tell you is that if we hit play again and move outside of the bounds of the camera, Dave is not visible anymore. So we now need to move the camera along with Dave up to a certain extent. And this is what we're going to see in the next section. See you there. Welcome back, guys. In this lesson, we are going to start working on the camera for Dave. So, if you remember well, in our file right here, we can actually check this or maybe change the color to green, like so. Boom, we've done the player controller. And just so that they have the same color, I'm going to use it right here too. Okay, so we don't have any collision right now, but we are going to work on the camera. And by the way, we need to add camera here. Okay, camera, here we go. So let's grab the weapons, bring them down, boom. And we are going to work on the collision later on. So how is our camera going to work? We are first going to set up our system, or think about it, and then implement it. So imagine that this is our arena right here. So here is our arena, and this is Dave. By the way, I'm just going to set the roundness of the corners to 15%. Cool. So this is Dave. Let's imagine that our camera is something, or the frame of our camera is something like this. Okay, boom. Let's select a blue color for the camera. Yeah, no arrow. And let maybe diminish the outline. Here we go. Let's actually group Dave and the camera. So Control J. Okay. So if Dave moves somewhere around here, the camera should follow Dave. But as soon as Dave gets closer to the edge of the arena, we don't need to show all of this, okay? So all of this will be a solid color, I guess. So we don't need to show it. So what we would want is the camera to stay here, somewhere around here actually, if Dave gets closer to the edge, so that all of the enemies are still visible and Dave too, okay? But if Dave starts moving up again, the camera should then follow, right? So we can already think about the logic being camera, follow Dave, but if Dave gets closer to the edge here, along the X or Y axis, don't follow him. Keep your previous position, okay? So there is a cool way to do that in Unity, and I'm going to show you that in the next one. See you there. Welcome back, guys. In this lesson, we are going to help the camera follow Dave, even though he's really fast and so on. But yeah, the camera can do it. So let's trust her or trust it. I don't know. So yeah, let's first select our camera here. The first thing we want to do is bring it back a little bit. So for that, we are going to increase the size of the projection, of the orthographic projection actually. So let's set it to, let's say 9. Seems like a good value. All right, here we go. Then we can keep the near and far clipping planes as they are. No need to dive deeper in details in these ones. But what I want to do here is to change the color of the background. So I'm going to select environment here and set the background color to white. Here we go. That's way better. After that, we are going to create a new script that we are going to attach to our camera and move the camera along with Dave. Here we go. So right click, create a new C# script, camera controller. Here we go. Once it's compiled, we can grab it and attach it to our camera, like so. So I showed you the way where you could actually drag it and drop it inside of the inspector, like so. But you can also drag it and drop it inside of the game object in the hierarchy. So let's remove all of the other ones. We only do one camera controller and open it. Perfect. So we want the camera to follow the player. So we need... What do we need? A reference to the player, of course. So let's add that. Boom. Let's write serialize field, private, transform. So we need the transform component of the player because we want to follow or track its position. Player, or maybe target, just to make it more generic. Target. Then if we go back to Unity, we should have a target field right here. So let's wait. Yeah, perfect. Let's actually collapse the camera component, collapse the universal additional camera data, and specify Dave in our target. Cool. So right now, if we hit play, nothing will happen because we don't have any logic here. Then what we are going to do at start is simply follow Dave. And a good practice here when you want to follow something with the camera is not to put that inside of the update method. Actually, if you want to use physics, it's also a good practice not to put that in the update method, but in the fixed update method. So you know what? Let's do that. And just before that, let me explain quickly. I'm going to leave a link in the description here for that, but Unity has an execution order for all of its scripts and the methods inside of its scripts, okay? So you can spot the start method right here and the update method right here, okay? So we can already see that there is something before the start method that we can call, so reset, on enable, and awake. But in here, we are interested in the physics. Using rigidbody2d.velocity is using physics, means using physics actually. So we need to run our physics inside of the fixed update instead of the update method, okay? So this is for the game logic, ideally. And to follow stuff, you want to wait for them to move. So you first move your game objects, and then you follow them. That's the core principle of following. So we need to use late update instead of the regular update. This is a quick thing. Again, it's important to know, even though that's not going to break your game if you put everything inside of the update method. But yeah, let's actually use good practices from the start. So let's go back to our script here. We want to put our physics inside of the fixed update method. So fixed update like so. Let's actually make it private, not private. Come on. Let's grab this and paste it here. We can remove it from here. Boom, remove the update method. And now we've got a clean script for the player controller. And of course, we're going to test that. So let's now go to camera controller and implement the late update like so. Perfect. We can actually remove the start and update method. And inside of here, what we are going to do is change the position of the camera. So we need to access what's the component that contains the position? Yep, the transform component. So transform.position equals, let's say, target.position. So we want to place our camera at the same position as our target. This is not going to work, but let's do it anyways. Let's hit play. And right now, the screen is blank and Dave has disappeared from the game view, but it's still in the scene view here. So what did happen here? We've got Dave at 0, 0, 0. And we've placed the camera at 0, 0, 0. So we can't spot Dave because we are actually at the same position. If we switch from 2D view to 3D view right here and press F to focus the camera, you can press multiple times actually to zoom in or zoom out. Let's hit pause and bring the camera back. Now if we bring it back, we can spot Dave. But if it's forward or in front of him, we won't be able to spot him. And we are placing it at the same position as Dave, so it's not going to be visible. If it's at 0, maybe if we set the near clipping plane to 0, we can spot Dave, but that's not optimal. So what we're going to do is use the same X and Y position, but keep the Z position at -10. So let's go back to our script here and create a new vector 3 for the position. So a vector 3 is simply a data structure with three values, the X, Y, and Z. So let's call it target position equals target.position. So we are creating a new vector 3 and giving it the position of Dave's position. But we want to keep our current position along the z-axis. So target position.z to access the z value of our target position equals not 0 but -10 because we had -10 previously. Then we can move our camera, so transform that position to that specific position. Okay? I hope this is clear. If not, please leave a comment in the comment section. Now we're going to hit play and we should be good. So let's check. Yep, we are still at -10. And if we move, yeah, the camera is actually moving with Dave. So let's go back to 2D mode. You can click here, move Dave, and yep, the camera is following Dave perfectly. That is so cool. Okay, so that's one thing here. But it's still really weird because we can't spot that we can notice that Dave is working in the game view, and we haven't clamped our camera position yet. So let's do that in the next one. See you there. Welcome back, guys. In this lesson, we are going to clamp the camera follow logic thingy so that it does follow Dave and while he's inside of the arena, actually, and stops following him if he exits or gets closer to the walls of the arena. I know, we don't have an arena yet, but just imagine it because we're going to add it in the next section, actually. Okay, we are going to explore time-lapse and tile maps and so on, not time-lapse, come on. But anyway, all right, so let's go back to Unity here and open our script, the camera controller script, and let's specify a minimum or maximum X and a minimum and maximum Y until we follow Dave. So for that, there are multiple ways actually to we can use. We can first off write serialize field, private float, minimum X, another one for minimum Y. And by the way, quick tip here. If you want to duplicate a line in Visual Studio, you can hit Ctrl D or Command D, and it will duplicate the line you are in. Like so, boom, 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 boom. Okay? Perfect. This is a quick time saver, actually. We can also add some other ones. Private float, minimum... oh, that's minimum Y. I think I'm going to write max X here. And this is going to be minimum Y and maximum Y, like so. And then what we can do here is, again, process our target position. So target position dot X equals mathf.clamp. We want to clamp our target position, so target position dot X, between the minimum X and the maximum X. And again, Ctrl D, like so. We want to clamp our target position dot Y between the minimum Y and the maximum Y, like so. Here we go. And this is already enough, and this is going to work. This is good, but there is a better way to do it. I'm going to show you that later on. Just after we try it, actually, in 1 minute. So the minimum X should be something like, what did we say? -8, I think. 1, 2, 3, 4, 5. Let's say -5. Maximum should be 5. Maybe this one can be -3. And maximum 3. Yeah, let's try that. Okay, so let's try and move Dave. Yep. Okay, so if we exceed a certain point, the camera is not following anymore. Yeah, that is so cool. Okay, nice. Here we go. This is exactly the behavior that we want for the camera. So it does follow it until a certain point. So in here, you can notice that it's 5 units along the x-axis, but only 3 units, I think, yep, along the y-axis. That is so cool. It's going to make more sense when we are going to add the arena of course, with the collisions and so on. But first off, let me show you a better way to do this, because it's actually really annoying to write min x and max x and so on. So instead, what we're going to do is create a new vector2. We've seen vector3s though, so you know what a vector2 is. Serialize field, private vector2, min max x y, like so. And we are going to use it right here. So min max xy.x. So this is the x component of the vector2. This is the y component. This is the y component, but I think we should be using x here. So minus min max x and here min max xx, if it does make sense. And in here minus min max xy.y, and in here min max xy.y. So we are using the y value here and in here the x value of the vector2. So let's go back to Unity and set the min max to 5 and 3. And we should now have the same behavior. So let's give it a shot. Okay, let's move. Boom. Yeah, same behavior. So we move until 5 units along the x-axis and 3 units along the y-axis. And same thing down there and on the left. Perfect. So we've now clumped the moving or the following of our camera. That is so nice. There is still one issue here. Imagine that if we've forgot to add Dave or reference it. So let's remove it from here and hit play. Error. Why? Because the camera controller did not find any target here. Nothing has been specified. So to prevent that issue, you need to at least make sure that you've specified Dave, or check if you have a target before doing anything. So if the target is null, what we're going to do is return, not do anything. So if you write return here, you're not going to apply or execute this code. But we also want to let us know ourselves. So debug.log warning, let's say, like so. And we can write something like no target has been specified.
Come on. No, that's all. Come on.
Oh, come on. Like so. Okay, cool. So let's now go back to Unity again and try this out. Boom. Make sure that we don't have Dave here specified in our camera. All right, no target has been specified, so we don't have any more error, but at least we just get a warning. Having an error can cause issues to other scripts and your game can crash, it won't work properly. So make sure to think about these cases. If you forget to specify something, like we've done inside of our player controller, by adding this attribute, we make sure that we do add the rigid body component, okay? So, yep, this is one thing. So let's exit here and respecify Dave or reference it again. Boom, let's grab it, drop it here. We can actually collapse the camera and we are good to go. One last thing I want to show you in this lesson, so it's a quick tip, let's say, is adding headers. So if you've taken one of my previous courses, of course, you know what I'm talking about. But for the new students, here is how it goes. We can add a header attribute like so, so 2 brackets, header, just to label our categories, let's say, or our variables. Normally, it's actually an attribute for fields, but you can actually trick Unity or hack it to display it for a bunch of variables. So let's say settings here, or maybe elements for this one. And the move speed is actually a setting, so header. And by the way, again, quick tip here, go take my Code Ninja course. It's free. And it will show you how to create things like these way faster. Because if you've noticed here, I've written HH, tab, tab, and boom. Visual Studio has written the header thingy for me. This is called a code snippet here. So these are settings. We can bring the rig here. Perfect. Again, quick tip. Come on, this course is full of quick tips. Have you noticed how I did move the rig like so? Whoa, whoa, amazing. So you can simply press Alt or Option, I guess, on Mac, and use the arrow keys to move any line or any piece of code up or down, like so. Really cool and really fast once you get the grasp of it. So this is okay for the player controller. Let me show you how it looks now in the inspector. Here is Dave. And now we've got some names for our categories or variables. That is way cleaner and makes debugging easier, actually. All right, let's do the same thing for the camera and we can call it a day. So we've got the target here, elements, settings. Here we go. Let's go back to Unity. Compile, please. And yep, that is way better. We've got the elements and our settings. That is so cool. All right, this is it for this lesson. And in the next one, we can start adding our arena. See you in the next one. Welcome back, guys. In this lesson, we are going to use Cinemachine to control our camera like one of my students pointed out. Because right now, if you remember well, we are using the camera controller and we also have the camera shake right here. So using Cinemachine will make things a little bit easier. All right, let's jump right in. The first thing we are going to do is disable our camera controller right here and import the Cinemachine package. So let's open the package manager, select the Unity registry and write Cine for Cinemachine. Okay, let's install the package. And when it's done, we can close the package manager window. Awesome. To use Cinemachine, we are going to create our first virtual camera. So let's right click, Cinemachine, virtual camera. Awesome. Once this is done, we are going to rename this one player follow camera, because you can have multiple virtual cameras in your game and smoothly move between them. This is not the point of this lesson, so we can tackle this later on maybe, if that makes sense. Otherwise, we are just going to use one camera. In the environment, I'm going to create a new game object to hold my camera stuff. So let's call it Cinemachine stuff. Actually, let's not look really far. Let's grab the player follow camera and drop it inside of here. We are going to drop this game object on top. Perfect. And now we can actually remove our camera controller. So let's remove it. Here we go. After adding the virtual camera, you can notice that there is an icon here next to the camera. This is the Cinemachine brain. If you want to use a virtual camera, you need a brain. Okay. I had to pause because I was like, you need a brain. Okay, we all have a brain as far as I know. Anyway, but yeah, you need a Cinemachine brain attached to your main camera. And you can notice that the live camera, so the virtual camera used right now, is the player follow camera. Awesome, this is exactly what we want. We are going to disable the UI so that we can spot our changes in the game view, okay? So let's now select our player follow camera. There is a bunch of settings you can play with. So I'm not going to tackle all of these, but I'm going to explain the basic behavior. Right here, you've got the ortho size. So this is the orthographic size we've used right here, okay? Right now it has been set to 16, something like that. So we want to diminish it to 7 or 8. I don't remember what we've used, but let's keep it to 8, okay? So if we hit play right now, nothing will work. Let's actually try and select Dave, move it a little bit. The camera is not following. Why? Because we need to set it up in the body component here. We've got two main components, the body and the aim. One is for the following logic, one is for the aiming logic. So if we select Dave and set it as the look at object, the camera is always trying to look at Dave. So let's try and move Dave a little bit. You can notice that it does look at Dave, but it's like tilting or rotated by a certain angle, and it's kind of weird. It's actually a really nice effect if you want to use it in your game, but this is not the desired behavior here. So let's hit Ctrl Z. Okay, let's select our player follower camera again and remove Dave from the look at field here. We are also going to set do nothing for the aim. We don't want to aim at anything. We just want to follow Dave. Got it? So let's grab Dave and set it as the transform of the follow here. Now, if we grab Dave and move it, the camera will follow Dave. That is so nice. It's already working as expected. And what's cool about Cinemachine is that you already have some damping here. So if you set the damping to 2 by 2, let's say, and hit play, notice how it goes. Of course, we need to re-enable our UI. Let's go here. Okay, let's try and move. And the camera is smoothly following Dave, which is really cool. You might want this for your game. Okay. Again, I really encourage you to play with the settings that you can find here. There are so many. You can select transponder here. You can select framing transponder if you want the camera to be smooth before a certain point, but strictly follow the player inside of a certain zone. There are so many things you can do actually. So feel free to experiment with this. Okay, so let's jump back to our transposer here. This is enough in our case. Okay, so now the camera is following Dave, right? But we need to clamp the camera because previously with our code, we told the camera to not go that close to the border of the arena so that we can better notice enemies if they are close to Dave, okay? And for that, we are going to add an extension to our camera. So let's select an extension here and select the Cinemachine Confiner 2D. Awesome. To confine the camera, we need to set up a shape, and our shape here needs to be a 2D polygon or a 2D composite collider. You can't use a box collider, unfortunately, here, or a box collider 2D. So let's create our bounding box. So let's right-click, 2D objects, sprite, or actually we can right away create a game object, actually. Let's call it camera bounds. Here we go. We are going to add a polygon collider 2D. Nice. And we are going to select our camera here and specify our collider. Perfect. So now the camera is going to try and keep what's visible inside of this box. Well, right now it doesn't make any sense because the camera view is a little bit too big, but let's actually select our bounds and increase them. So we want 4 points. Perfect. The first one can be somewhere at, actually we can edit the collider and then change these values. So let's grab this one, drop it here. Okay, somewhere around here. Perfect. Let's just increase it a little bit and then I can better explain. Okay, here we go. You can disable the collider, by the way, because otherwise Dave will collide with it. No need to put it or set it as a trigger. The only important thing here is to have the collider, even though it's disabled. Okay, so now we can select our player follow camera, and you can notice that the polygon has not been updated. So let's invalidate the cache, and now it has been updated. But now, seems like we have 2 polygons, right? Let me explain. Here is the first one that we've drew, right? So this is what the camera is going to be allowed to see inside of its view frustrum, if I can say so. And the little one here is the zone where the camera can move. If we diminish the auto size, let's set it to 5. If we invalidate the cache again, you can notice that the camera is allowed to move in a bigger zone. Why? Let's re-enable our collider so that we can better spot the changes here. We can select Dave. Oh, we can't move the collider in the same time. That's bad, but we can deal with that. Let's move Dave to the top right, somewhere around here, okay? Let's now select our camera, and you can notice that the view frustum of the camera is really close to the bounds here. We can actually move Dave a little bit more, right? Can we? That's decent actually. Okay, because the camera here is at the limit of where it can move. Got it? So you can play with the shape of the collider to have the desired behavior. In my case, I'm going to grab Dave here and put it at the top right. Okay, so now we can play a bit more with the bounds. So let's edit the collider, and I want to allow the camera to spot just a tiny bit of the arena bounds. So something like that. Okay, boom, boom. Seems decent. I'm just going to set up these points a little bit better here. So 23, 13, minus 23, 13, minus 23, minus 13, and 23, minus 13. Perfect. Now we've got a perfect rectangle. So let's select the camera and invalidate the cache again. Perfect. This is exactly what we want. But the auto size needs to be increased a little bit. So maybe 7, yep. Maybe 7.5. Okay, seems decent. Okay, cool. So let's now hit play and see how it behaves. I'm just going to drop Dave at the center of the screen, enable my UI, hit play, and look, as I've told you, Dave has been pushed to outside of the bounds here because if we select our bounds, here they are. We haven't disabled them. Come on, how did I forget that? Okay, so let's now try this out. Boom. Now the camera is moving, and when we get close to the border, it doesn't follow, which is exactly the behavior that we want. So cool. Awesome. There is still one thing we need to change here. Let me show you. Let's go and select un le pieu, let's say. So a weapon that should shake the camera. Okay, so we've got Le Pew and the cotton candy, right? Let's try and shoot. The camera is not shaking, which is really bad. Why? This is because we do control the position of our camera using the virtual camera now, not using the camera parent. So camera shake here doesn't make any sense, okay? So here is what we can do. We are going to copy this component. Here we go. Let's now remove it from here and add it to the camera parent. Boom, and paste components as new. Perfect. So now the camera parent is the one that's going to shake, the one that's at the center, okay? Because the camera is now the one moving, not the camera parent. This is really important to note. Then what we want to do is set the blend update mode here to fixed update. Otherwise, it won't work. So let's now hit play. Let's go, select the cotton candy gun. It should also shake the screen actually. Boom, here we go. Now that's working perfectly, using Cinemachine, of course. Okay, so you now have two methods to control your camera using Cinemachine and using a custom script. Cinemachine is actually easier, I think, in my opinion, but sometimes you might want some really tricky behavior, so it's good to know how to make a custom script. Okay, I hope that this was useful, and thanks again to the student who suggested me to add Cinemachine because it's actually really important, and see you in the next one. Welcome back, guys. In this lesson, we are finally going to add our arena. That's going to be so cool. So, to add it, we are going to add a sprite like we've done for Dave. So we can either grab a sprite from here, sprites, terrain, let's say, left, top. We've got some tiles here that we are going to use when implementing the tile map. So let's just use maybe the, I don't know, maybe the wall actually. Okay, so let's grab it and drop it here inside of the scene. I'm going to move it to the right. Okay, somewhere around here. It's actually going to be 5 units far, or maybe 10. I don't know, let's drop it to 10 units far from the player, okay? It's actually pretty close here. So maybe we should move it to 20. Yep, maybe 22. Yeah, that's okay. So let's stretch it so that it does or counts for a big wall. No, not that wall. So yeah, let's go on. So we've got our first wall here. Let's select it, hit Ctrl D to duplicate it and move it to the other side. Again, let's duplicate it, set it at 0. Maybe we can rearrange it a little bit, something like that. Okay. By the way, you can press Alt to edit it horizontally or vertically, like so. Boom. And another thing here, you can notice that I'm trying to select it, but I can't. This is because I'm selecting the UI instead. So in Unity, right here, you can select or click on the eye so that you can't select your UI and can't spot it. If you want to see it and prevent clicking on it, like so, you can click on the hand. Now I can see the UI. This is the white border right here, but I can't select the UI. That can be convenient in some situations. All right. So right now I just don't want to see it. Perfect. So let's set the scale along the y-axis to 1, stretch it, and maybe I can drop this at 12 maybe. Yeah, I think it's decent. So let's duplicate it and set it at -12. So this is a really rustic arena here that we are using, right? But don't worry, we're going to fix that later on. Now if we hit play, we are still going to be able to move, like so. Yep, cool. And we can already notice that our camera behavior is exactly like we want it to be. We can see some parts of the walls here, but the main part of the game view is actually the terrain. That is so nice. So you can tweak the values here if you don't like them. Maybe we can set it to 4 or maybe 5 actually, like so. Yeah, you can play with the values as you wish. So issue here, I can go above the walls. That's not what I want. So what we are going to do is add a collider to the walls and a collider to the player so that both objects can collide and we can prevent the player from going too far actually, okay? So let's exit the play mode, select our 4 walls, and what, in your opinion, can be the best collider for each one of the walls here? Any idea? It's actually pretty simple. So let's use a box collider 2D, like so. Perfect. And you can notice that Unity has added the collider because we've got this green outline. Let's actually disable the selection outline so that we can spot the green lines here. These green lines represent the bounds of the collider, okay? And you can actually edit the collider by clicking on this icon. So let's actually just play with it so that I can show you that you can do it, but it's not useful in our situation because they are already pretty good or pretty well set up. So let's re-enable our selection outline. Perfect. We've added colliders to our terrain or walls. So now let's add a collider to Dave. Where is Dave? Press F. Boom. We can disable the gizmos if this icon is bothering you, or actually tune the size down a bit. Perfect. So let's add our collider. We can use a capsule collider 2D, like so. The size can be diminished along the x-axis. So this is the one that best fits Dave, but performance-wise, this is not the best one, actually. Because the more complex the collider, the more resources your game will need. And in our case, this is not really important, but if you're making a bigger game, and I hope that you will do so, you will need to take performance into consideration. So again, let's use good practices from now on. So let's add a circle collider 2D. This is the easiest collider and the least performance hungry you can use. We are going to edit the collider to match maybe the width of Dave. We can actually dismiss that, that's okay. He has a big forehead, but he's good with it. So yeah, that's cool. All right, so you've got a bunch of options here that you can tweak or play with, but for now, let's not touch them. So let's hit play and see what happens now. We've got a rigid body, we've got the collider set up, so we should collide with the walls. Yay! Now Dave's movement is clumped by the walls without any code. So we've seen that we were able to clump the movement of the camera programmatically by code, but we are also able to clump the position of objects using physics. And that's really cool. So now that we know how to configure a really basic arena, and by the way, we could have actually expanded on these and made the arena a little bit prettier, like so. Maybe use a simple color, or maybe let's set the color to blue, remove the walls texture and use a simple square. Yeah, something like that. I don't know. It's actually way better already like so. But in the next one, we are going to learn how to use the tilemap system to make our game even better. And right now you can notice an issue, by the way, but we are not going to deal with it right now. So see you in the next one to learn how to fix this. Welcome back, guys. In this lesson, we are going to keep implementing our arena here. So we've used basic shapes like squares previously, and now we are going to use the Unity tilemap system. Okay, but first off, if you remember well, we had an issue in the previous lesson, if I do remember well too. So let's check this out. Yeah, here it is. So right now the player is rendered behind the wall here. That is a bad situation. This is not what we want. And to fix that, what we can do is select the player right here and increase its order in layer to 1, 2, or 3, or anything else, or above 0, or the order in layer of the walls. Unity uses that to determine what gets rendered first in 2D. Okay, when you deal with 3D objects, it's actually the Z position and the shaders and so on. But right now, we are going to deal with that in more details later on when adding vegetation or greenery inside of our scene, because it's going to be more relevant. But yeah, for now, keep in mind that the higher the order in layer, the, let's say, closer it will be from the camera, okay? So yeah, we could either do that, or if you want to keep them on the same layer, what you can do is add sorting layers here. So let's exit the play mode here. What we can do is actually duplicate this wall, bring it down. Where is it? Sorry, here it is. Okay, so let's duplicate the wall, bring it up above the player, maybe just to cover half of the player. Okay, so that we can notice the changes right here. No need to enter the play mode. Perfect. Okay, so we are going to click here in layer and add a layer, but we don't want to add any layer right now. We want to add a sorting layer. So we've got the default layer, but we can add another one. So let's add another one for the bottom layer. Let's grab it and drop it just before the default layer. Then what we can do is select the wall or anything we want to display or render behind everything else, like a background, like, I don't know, it can be some particles, it can be anything you want actually. Select the default right here and switch it to bottom layer. Here we go. So now everything inside of this sorting layer will be rendered before or behind any other layer that comes after it. Okay? Perfect. So this is cool for this wall, but we are not dealing with this one right now. We want to change the render or the sorting layer of all the other walls. Bottom, let's hit play. Try to move a little bit and see if our changes have been applied. Okay, so boom, let's move to the top. Yep, perfect. We are also rendered on top of this one. What about the bottom one? Yep, sure. And the right one, perfect. That is so cool. One quick thing that I noticed here is the joystick. It's a bit annoying when it comes on top of the player, you see? Yeah, it's really weird. So what we're going to do is decrease its opacity. So let's select the mobile joystick outline and knob here and set the alpha to, let's say, maybe 20 or 10 actually. Yeah, 10 should be enough. Let's hit play and check if it's okay. Even though we can actually already notice the joystick right here. Okay, yeah, that's way better. And it's at least noticeable too. That is so cool. Okay, let's save our changes here. Perfect. We can also push our changes because we've made some changes to the camera controller and player controller. Okay, so what we can write is maybe camera control or camera follow as you wish. Okay, cool. Once that's done, in the next one, let's actually jump straight into making the tile map. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are finally going to learn how to implement a tile map in our game. And it's going to be way better than these 4 walls right here. So yeah. Okay, so we can keep them for as a reference, sorry. But what we are going to do is right-click, create an empty game object, and call it walls. We can reset the transform here, just not to mess with the position. Select all of our 4 walls and drop them as children of the walls game object. That way, if we want to disable the obsolete or the previous walls, we can. Perfect. So now let's create our tile map. For that, I'm just going to right-click, select 2D object, like so, tile map, rectangular. And you can spot that you can also create hexagonal tile maps and isometric tile maps. So it's pretty cool if you want to make these kind of games. All right. So we've got a tile map here. We can actually diminish the size of our simulator window. Cool. And we can spot the grid of our tile map here. That is so nice. Okay, let's start by creating our first tile because a tile map should contain tiles. Yay! Okay, so window, 2D, tile palette. Let's grab this window and dock it wherever you want. So I'm going to dock it just next to the simulator right here and create a new tile palette here. So let's call it my palette, let's say. Yep. Or maybe terrain or arena. Yeah, just arena. Let's create the palette. We can save it wherever we want, but I'm just going to create a new folder inside the Kawaii Survivor folder. Let's call it tile map. Okay, and let's save it right here. Cool. So now to create our first tile, what we can do is simply drag a tile, a sprite, or a texture. Okay, so we are going to drag a texture, a sprite, sorry. So let's open our sprites folder, terrain, and let's drag the top tile, let's say. Here we go. Let's just call it top asset. Perfect. So now we can already paint our tiles on the scene. Yay! That is so nice. It's working. But we can notice an issue here. Our tile is way bigger than the grid size. So there are 2 solutions to that. The first one is to select our top image right here. And by the way, you can switch it to single. Yeah, it's actually really similar. So you can keep it multiple or single, it's going to work. Okay. But what you can do, because this image is 256 by 256, is change the pixels per unit to 256 to 256, apply, and now it's exactly 1 square. That is one solution. But here is another one that I prefer. So let's apply the changes here. Okay, not working. What we can do is select our grid and set the cell size to 256 by 256. And now our tile will occupy one grid exactly, one grid size. Okay, so again, this is a choice. If you want to have smaller tiles, it's your choice. You can do so. And you now know how to do it. That is so cool. So again, experiment. This is a really important point here. Experiment a lot. This is how you're going to learn. It's not by simply following videos. I'm showing you the tools that you can use to make your games, but you need to experiment, like really. That is the most important point. Okay. So we know that the player can go till 5 units. So 1, 2, 3, 4, 5. Is it somewhere around here, the maximum? No. The position of the walls, come on. We need to follow along. So it should be something like that, right? So let's actually paint the outline of our arena like so. Perfect. What we can do then is select the rectangle box tool thingy and paint everything else here, just so that the camera does not show anything, another color actually. All right, we can now remove our walls, but now, unfortunately, the player won't collide with the tile map. To be able to collide with the tile map, we need to add a tile map collider component. And just like that, you can now notice the green lines that represent the collider. Okay, perfect. We can already try this out, so let's hit play. And normally our player should collide with the borders of our grid, our tile map, because we've disabled the walls, remember? Okay, let's try this out. Let's go to the right. Boom, we've collided with the border. Yay! We still need to change the ordering layer or the sorting layer of our thingy here, our tile map, but it's working. So let's try this out. Let's go up, change the sorting layer to bottom. Yeah, that is way cooler than previously. But don't forget to change it again if you exit the play mode. Remember, when you hit play, it doesn't save all of the changes you are making. So keep that in mind. Okay, so we now have our basic tile map and collider. In the next one, we are going to learn how to make it prettier using the sprites that I've provided here. And of course, again, make sure to use the sprites that you want. If you find another set of sprites, feel free to use them because they will fit your style and it will actually make for a pretty good exercise. So see you in the next one. Cheers. Welcome back, guys. In this lesson, what we are going to do is make our scene prettier. So the lesson is actually going to be pretty chill. And after that, we will add some greenery, some vegetation, a shader with using shader graph. And then I think we can take a break because it's going to be something like 1 hour and a half or 2 hours of content. And after that, what you can do is experiment a little bit before going to the next section. Got it? Perfect. All right, so we have our basic tile here. Let's add the left tile that we've got. So let's drag it and drop it somewhere around here. Let's save it, select it, and place it on the left. Perfect. So now we need to place it on the right and top and bottom. Okay, so what we can do is create another tile, or you can simply rotate it by 90 degrees by clicking right here. So let's drop this here. Okay, let's rotate it again on the right, rotate it on the bottom, and it's already way better. So now let's cover the edges here because I want to have a rounded corner, okay? So I've prepared the sprites again, but you can create your own ones. Come on, just take these as a template. So let's drag the top left corner, drop it, I don't know, maybe here is more relevant, yeah. Yeah, that's actually more relevant, cool. So we should have the top left border, like so, cool. And we also have the top left border. These two are not the same, but yeah, we can't use this one, yeah. This is the top border here. So we are gonna drop it here, I guess. Yeah, that's not the best position, but it will do. Okay, that's okay. All right, so let's start with the corner. Where is the corner here? Oh, don't tell me I did remove it. Oh, I removed it. What a boy. Okay, so top left corner, let's drop it here. Yeah, here we go. All right, so let's select this one, rotate it twice, drop it here. Perfect. Now we need to make or change these three ones actually. No, these two ones, of course. So let's select this one. We will need to rotate it once, I guess. Drop it twice, sorry. Yeah, twice. Drop it here. Select the other one, rotate it twice, and drop it here. Here we go. This is a really cool corner here. Okay, let's do the same thing for the other ones. So this should be something like this, I guess. Yep. Let's use this one, rotate it once, maybe twice more. Then use this one, and I think you got my point here. So I'm just going to time-lapse this, and you can do it on your own. We are good to go now. Perfect. So now let's try this out. What we can do first is click on W on your keyboard or any other key, but W is a shortcut for selecting the Move tool. You can also press R for the Scale tool, T for the Rect tool, and E for the Rotate tool. Yeah, that's actually this one. If we select the tile map now, we can notice that Unity has automatically added some colliders to our new shapes here. So the collider will also be rounded. That is really cool. So let's give it a shot. Okay, so let's jump back to the simulator here. All right, perfect. Yeah, the collider seems like it's rounded too. Yep, really cool. It's working. Awesome. All right, in the next one, we are going to grab some resources like some bushes, some grass, and make our scene a little bit more interesting. Okay, I'm going to leave a link to the images we are going to need or use in the next one, of course. So see you there. Welcome back, guys. In this lesson, we are going to beautify our scene a little bit because it's way too blank in my opinion for now. So yeah, what we're going to do is grab some assets from the asset store, and these are the really popular free platform game assets from Bayat Games. Thanks a lot. And yep, I've noticed that there were some bushes and grass models somewhere around here. Let me show you. Boom, bam, beam, beam, boom. Yeah, here they are. So these bushes are quite interesting, and these are grass models too. Sprites, actually. These are not models. But yeah, let's grab them. So let's add them to our assets. We are now able to open them in Unity. Okay, let's allow the browser, of course, blah, blah, blah. Cool. So now it automatically opens the package manager. So let's import this version into our project. And if you haven't downloaded it yet, you will see a download button instead of the import. So you will need to download them and then import them. Okay. So let's import these assets. Perfect. And once it's done, what we're going to do is close this window, open the Bayat Games folder, free thingy, environment, PNG, 512, environment right here. Okay, so this is a single sprite for now. We can switch that to multiple, and apply our changes, and open the sprite editor here. What we're going to do is let Unity automatically slice our atlas. To do that, we are going to select Slice, Automatic, and Slice. Boom! We can rename this one Bush. And maybe we can use these ones. Wait, this is a simple image here. So what we can do is remove this one, this one, this one. You can remove things and rearrange them as you wish. This is actually a single image here. So let's expand it a little bit. Okay, maybe to the bottom. Perfect. We can call this one grass. Here we go. Let's also use one with a rock here. Maybe this one. So rock and grass. Rock and grass. Yeah. Okay. Okay, that's really nice. We can apply now the changes. Cool. We can exit this. Grab the bush, drop it inside of our scene or inside of our hierarchy. That's actually similar. So let's drop it inside of the hierarchy. And what we can do is create an empty parent for that. So create an empty parent that we are going to call vegetation. So vegetation. Okay, perfect. So this sprite is right now a little bit too small. So wait, we should have some bigger sprites here. New details 8 times. Yeah, here they are. Come on. Okay, so environment, new details 4 times. No, this one is actually better. Way better. But wait, you know what? I'm going to search for the other ones and come back to you.
12 seconds later.
Here we go. That's actually way better. Indeed. Okay, but at least you've learned how to split a sprite or an atlas, actually. Okay, so you want to select environments, okay, PNG, all 4 times, or maybe 2 times, but I think 4 times is actually a good size. Yeah, this is way better, actually. Not this one, but yeah, this one is pretty cool. So I'm going to remove this one, and this one, and keep this one, okay? So let's rename it Bush, not George. Okay, let's resize these. Oh, come on, I don't want to edit the tile map. But what I'm going to do is, yeah, the size is decent. So let's drop one here. Duplicate by hitting Control D. Drop another one maybe somewhere around here and somewhere around here. Perfect. So maybe we can move this one this way. Yeah, it's better. We can also add some grass elements. So let's drop them here. Okay, let's rename it grass. Drop it here, just to make the scene a little bit more interesting, you know. And some with rocks. So boom. So rock and grass. Yeah, keeping the same naming conventions. Maybe here and here. Just, I think it's a little bit too much, so I'm going to remove the grass here and this one. Yeah, that's actually better. All right, cool. So we've now added some elements to our scene. Let's hit play to see how it goes. And of course, I hope we will have some issues so that I can show you how. Okay, so this is not an issue. You can clear it. But if we move towards here, first off, the character is really fast. Yeah, he is really fast. So what I'm going to do is diminish its move speed. So let's do that right away. Maybe 5 should be enough. Hit play. Because remember that later on we will add stats to our player. So we will be able to increase the move speed. 5 is still too much, but that's okay for now. Okay. So Dave has an order in layer of 0. This bush right here also has an order in layer of 0. If we increase it, Dave is going to render behind the bush. Okay? But we want Dave to render above the bush when he's somewhere around, let's say, I don't know, here maybe? Okay? Actually, right here too. Somewhere around here, Dave should render before the bush. Okay? So in front of it. Actually, this should be the limit. And if we pass the border or the line right here, Dave should render behind it, okay? Behind the bush. So how can we manage that? Well, one way we can do it is by setting a position, or maybe the position of Dave should be somewhere around here. We can then offset the sprite and compare the 2 positions here between the bush and Dave, okay? And if Dave's Y position along the Y-axis is greater than the bush, then it should be behind it. If it's less than the bush, so right now it's 1.937, this is 2, so this is higher, it should render behind. Got it? If it's higher, so 2.17, we should render this boy behind the bush. Got it? I hope this is clear. But let me now show you what happens with the grass or the rock texture. So let's bring it here. Okay. So here is Dave's center. So this is Dave's position here. Okay. And this is the rock position. So right now we have an issue, right? Because this is at minus 6.39. This is at minus 6.6. So Dave should normally render on top of the rock, right? So 1. But right here, Dave's Y position is actually greater than the rock's position. So minus 639, minus 629. So Dave should render behind it, right? But it's more logical to render it in front of the rock, not behind it, because the bottom of Dave is lower than the bottom of the rock. So we should actually take the bottom of each sprite into consideration, right? So in the next one, it's going to be clearer. I'm going to show you how to change the pivot or the center of each sprite so that it can be easier for us to deal with. Okay? So see you in the next one. Welcome back, guys. In this lesson, we are going to fix our order in layer issue that we talked about in the previous lesson. So just as a reminder, here is Dave, here is the rock, okay? So right now, the rock is lower than Dave along the y-axis, right? So normally it should render behind it, before it, sorry, in front of it. That's the case. But it should not render on top of Dave because Dave's bottom is actually lower than the rock's bottom. Got it? I don't know if it makes sense, but if it doesn't, please leave a comment in the comment section and I will try and explain in a different way. But I'm sure you got this. Come on, you're smart. All right. So one technique I'm going to show you is to offset the sprite's pivot point to the bottom of each sprite so that it makes it easier for us to deal with the order in layer, okay? And it's actually going to be easier to deal with animations too because we will want to bump our Dave a little bit later on, okay? So yeah, we will need to scale it along the Y and X axis. And anyway, let's make things step by step. So let's select Dave. Click on the sprite or maybe open the sprite editor right away. And you can see this blue dot here. This is the pivot point of our sprite. So we are simply going to grab it and drop it at the bottom, somewhere around here. Or what we can do is change the values right here. So 0.50. Or what you can also do is select bottom. So bottom center. Perfect. So this does change our pivot point automatically. So let's select bottom center and hit apply. Cool. So we now have another issue to deal with. Dave's bottom is actually at the exact position of the Dave game object, so that's one really good thing. But our collider here is a little bit offset. So what we're going to do is offset our circle collider to the top, somewhere around here. Perfect. So 1.8. Cool. So now this is good for Dave. What about the rock here? Let's open this. Center, bottom center, apply. I'm actually going to drop this somewhere around here. That's more logical. Yeah, apply this. Perfect. And same thing for the grass. So let's open the grass, bottom center, apply, and the bush, bottom center. Here we go. Apply. Here we go. So it did change the position of our elements a little bit, but it's not an issue in our case. All right, so now it will make it easier for us to render or manage the sorting order here. So let's learn how we can automate this. First off, we are going to open our sprites folder, scripts folder, no, sorry, come on. And let's create a new script, call it sprite sorter. Once it's compiled, we are going to add this script to all of our scripts, all of our sprites. Come on, not scripts. So let's select Dave 2 and attach the sprite sorter. Perfect. And already we are starting to notice an issue here. We have a bunch of scripts attached to our game object. So a bunch of components actually attached to this game object. We are going to split them later on. For now, let's just make this work and then we can refactor, okay? At the end of this section. So let's open our sprite sorter. First off, we will need a reference to the sprite renderer because this is the one containing the order in layer. So let's add a header, elements, serialize field, private sprite renderer. Let's call it sprite renderer. Yeah, just keep things simple and readable. Inside of the update method, we constantly want to change the order in layer of our element depending on the transform or the Y position of its transform, the thing that we are moving, okay? So in the case of Dave, it's actually the same game object, but later on it won't because we are going to split the movement from the rendering. You can clear this, perfect. For the sprite, for the rock and grass here, it's gonna be okay because we don't have any collider or any other script attached to it, so it doesn't make sense to create another game object, okay? Perfect. So let's specify the sprite renderer here, the sprite renderer here too. Okay, boom. We can actually specify it once and remove the other ones, duplicate and so on, but that's okay. For now, we are just going to specify the sprite renderer anytime we want, okay? Like so. Okay, perfect. Nice. Same thing for Dave. We need to specify the sprite renderer. It's right here. If you can't spot the sprite renderer, by the way, at the top, you can either drag it and drop it here, or you can select Dave, the game object that contains the component you want to attach. Okay, perfect. So in here, we are going to need the Y position that we want to compare or used to set the ordering layer of our sprite. So sprite renderer dot order or sorting order equals transform.position dot y, let's say, times 10 for now, because the Y position is actually contained between, I think the walls were between -5 and 5 or something like that. Yeah. How much was it? So this is 0. So 1, 2, 3, 4, 5, 6, 10. I think it's 11. Okay. So if we've got something between -11 and 11, if we've got two objects inside of the same cell along the y-axis, it's not going to be really useful. So what I propose to you is to multiply the value by 10, then convert it into an integer so that we can take the first decimal into consideration. Okay. All right, I hope this is clear. I'm going to explain another way just really quickly. So right now, this one is at -6.3. Dave is at -6.4. If we only take the first digit into consideration, they will have the same ordering layer, which is -6, okay? So we will have an issue here because Unity won't know which one to render first and which one to render after. But if we take the second digit, so 64, and this one will be 63. So it's already way better. And you can decide to take two digits into consideration to have a better render. But come on, only two digits is okay. So we've got this, but we've got an error because it is a float and our sorter order needs to be an integer. So we can just cast our value into an integer and the whole value. Don't forget to add the parentheses here because otherwise you will only convert this one. It's actually going to work, but yeah, just in case. Because if we had a floating value here, you would have an error. So yeah. All right, so this should be good for now. So let's give it a shot. We can hit play, I guess. Let's try and move Dave manually, not with using the joystick, but so let's drop it here. Let's move it down. And we can notice that our ordering layer is switching, is changing actually. We have just used the opposite values. So we just need to add a little minus sign here. Let's go back to Unity now. And hopefully it's going to be fast enough so that we can hit play. Here we go. Let's now give it a shot. Let's drop it here, bring it down, up, down, up, down. This is working super perfectly. So let's try and move it right here. What we can do is maximize the simulator by double clicking on it. Quick tip here. You can actually maximize any window by double clicking it. Boom, boom. Okay, perfect. So let's bring it down like so. Okay, what about this one? We are behind, now we are in front. What about the bush? In front and behind. Yeah, that is way better. It's actually going to make for a more polished game. Okay, cool. Perfect. This is it for this section. I think it's somewhere around 1 hour and a half now that we are coding or creating that game. So first off, congratulations. I really hope you've enjoyed what you've made so far because it's actually really good already. You have a character, you know about sprite orders, you know how to move a character, you've learned how to create your own joystick, hopefully. You've learned about tile maps and colliders, collisions, rigid bodies, some really good coding practices using the serialized field attribute, the header. You've learned how to differentiate between a private variable and a public variable. You've learned how to require a certain type of component so that you don't get a null reference exception like we had previously. And you've learned how to use time delta time just to make your game more responsive. You know that you need to set up your physics inside of the fixed update and that your camera should follow inside of the late update. You know that there is a certain order of executions of the scripts and methods in Unity. And if that is not already really cool, I don't know what is. So just keep going. I'm going to try and create a small exercise or a quiz at the end of this section, just for you to see if you've understood everything really well. And yep, then you can go on. So see you in the next one. Welcome back, guys. In this lesson, actually, let's start this lesson with other words. Some of you told me that there was a cool built-in way to manage sprite sorting. Because remember, we are using the sprite sorter in our case to put sprites that should be in the front. And whenever it's relevant, we should put them in the back. Like when I go behind this bush or in front of it. Remember? And yeah, so some of you, again, pointed out that there is a built-in way. So this is what we are going to tackle in this one. Okay, let's jump right in. So first off, I want to open the sprite sorter and disable its logic, like so. Let's just comment it and see what happens. Normally, we should not have any more sprite sorting in here. So let's hit play. All right, let's go. Let's not select any weapon. And here we go. Now Dave is rendered on top of the bush, even though it should be behind. Same thing for the enemy. On top of Dave, even though it should be behind. Okay, so now we are back to our original state. What we want to do then is open our settings folder, select the render 2D, and at the top right here, under the general tab, you can spot the transparency sort mode. Let's select custom axis. We want to use the y-axis for our sorting. After that, we can select our Dave render and all of the other renders we want to affect and set the sprite sort point to pivot. That way, the pivot of our sprite will be used to determine if it should be rendered on top or behind any other object that is nearby, okay? So let's apply the same settings for our vegetation sprites. So let's select all of them, set them to pivot, and same thing for our enemies. So let's open our Kawaii Survivor, prefabs, enemy. Let's select this enemy. So we want to select the enemy render and spawn indicator. No, actually, we are only going to select the enemy render, not the spawn indicator. So let's set this one to pivot. Okay. Let's do the same thing for our range enemy. So enemy render, pivot, again, perfect. And zombie. That's a new boss that I've added in one of my last lessons. So I invite you to go check it out. Boom, boom, boom. Yeah, sprite sort point. Here we go. Pivot. We can actually also remove the sprite sorters, but let's do that later on. Okay. So now let's hit play and everything should be top notch. So let's give it a shot. Okay, let's go. Let's go behind the bush. Yeah, it's already working. So no need to write the sprite sorter script, actually. That's cool. Awesome. What about the enemies? Nice. They're rendered on top. Okay. Oh, so this is not working properly here. Why? I think that our enemies have a sorting order of 1. Let's have a look. Enemy render. Yeah. Order in layer 1. Let's set this to 0. Same thing for our range enemy. And same thing for zombie right here. 0. Here we go. Okay, let's try it out. Boom. Here is our first enemy. Yeah, that's way better. So now we are on top of it. And now he's on top of us. Cool. Nice. So it's blinking, which is really weird. This is because our following logic is a bit weird. So let's change it right away. For that, we are going to open our enemy follow script. I think we've got it right here. So that's the enemy movement script. And inside of here, we are going to use the move towards method. Okay. So we can just comment this line, duplicate it, and set our target position to be equals to vector2.move towards, transform that position. The target position should be the player position. So player.transform that position. And we can use the move speed times time.delta time for the max distance delta. Here we go. Perfect. So we don't need the direction anymore, nor that other line. We can remove this. We can actually use an expression bodied statement here. If we haven't tackled this yet, we will tackle this later on, don't worry. And we can remove the update method. Perfect. Let's jump back to Unity now. All right. Let's hit play and see if it's fixed now. Okay, let's go. Boom. Here is our first enemy. Let's wait for a little bit. Okay, he's coming, he's coming. Perfect. Now it's not blinking anymore. Cool. Awesome. So what we can do now is remove our sprite sorter scripts. Actually, we can select the script and remove it right away. Perfect. So of course we will have some missing script exceptions. So we will need to remove the component from all of the game objects that had that script. So let's remove it from these two. Okay, perfect. What about the other ones? Let's select our range enemy. Boom, these two had the sprite sorter. I think the zombie also had it. So let's remove it from here. Perfect. And same thing for our bushes here. Okay, let's remove the script from here. Again, from Dave. So let's remove it from here and we should be good to go. Awesome. Let's now hit play and see if it's still working. All right, let's go. Boom. Let's go on top of the enemy. Yep. Awesome. Really cool. Nice. And we can even hide behind the rock. That is so cool. Okay, so thanks to these students, we are now able to apply the same behavior with less code, which is really cool. Thanks. See you in the next one. Hey guys, in this lesson, we are going to refactor, if I can say so, our player, because as I've told you previously, it's a good practice to split our rendering from our logic. So yeah, let's do so. Okay, so what I'm going to do now is duplicate Dave by hitting Control D and make it a child of itself. Okay, so I'm just going to rename this Dave render. Okay, maybe we can rename it player or character render, or keep Dave as the name of our player. And then what I want to do is remove the rigid body. I can't because the player controller depends on it. So you first need to remove the player controller, and then we can finally remove the rigid body. Perfect. Let's also remove the circle collider so that we only get rendering components on the Dave render game object. And similarly, what we are going to do is remove the rendering components from Dave, the game object. So let's remove it from here. We are also going to remove the sprite sorter because we don't need it anymore. And we are left with the player controller, the circle collider, and the rigid body. Okay, perfect. So why did we do that? Because later on in the course, we are going to animate Dave. So we will want to scale it like so, like horizontally and vertically. And if we do so while having the collider on the same game object, we will also scale the collider. And this is definitely not what we want. So generally what you want to do in your code when making games is split the logic from the rendering. All right, so now what I also like to have is a scale of 1 for the main game object, and I can now scale back the Dave render to .3.3. Cool. So we need to scale our circle collider again, so I'm going to do so. Here we go, perfect. And we should now be good to go. So what we can do is try that again. So let's hit play. All right, let's move a little bit behind the bush, in front of the bush. Perfect. So now Dave is a little bit too fast, but that's okay. I think I'm going to set the speed to 3. Yeah, that's decent. So let's actually set the speed to 3. Here we go. So now we've successfully refactored our character. Awesome. And this is something we need to keep in mind from now on. Always split your logic from your rendering. Okay? And this will apply for scripts too. All right, next thing now. Let's make our scene a little bit prettier, okay? Because right now we have a bunch of game objects and it's really not convenient. So what we are going to do is split all of our game objects into different categories. So for that, you can click on Tools, Organize Hierarchy. I've made that menu using a custom editor script, and you can actually have a look at my Code Ninja course. I think that I show you how to do that. So let's click on Organize Hierarchy. Perfect. And 4 new game objects, actually 7 if I know how to count, have been created. So one for the environment, the gameplay, the UI, and the managers. So let's grab the vegetation, the grid, our previous walls, the global light, and the camera, and drop them inside of the environment game object. Perfect. And again, I'm doing it like so, but of course you can decide to sort them or lay them out as you wish. Okay.
So let's grab the event system and the canvas, drop them inside of the UI, and Dave inside of the gameplay. Perfect. Right now, everything has been sorted out perfectly. Quick tip again. I don't know if I've already told you, but you can collapse or expand everything with a simple click. Simply press Alt and click to expand or collapse everything. Perfect. And it works for game objects and the scene and also in so many other places. Cool. So this is it for this lesson. In the next one, we are going to try and build the game and see if it works properly. Because it's always a good practice to test your game from time to time. Like, I don't know, maybe after implementing a new feature or so. Because your new feature might work perfectly in the editor, but not that good or that well on an actual device. So yeah, make sure to test your game from time to time. So for that, I'm going to click on File, Build Settings, and everything is good here. So let's open the player settings. Perfect. I'm going to grab the window and dock it next to the inspector. This is where I like to have it. Okay. So let's select the player tab and change some things here. So the company name is Tabsil. Okay. Product name Kawaii Survival Cruise. We can add an icon. So let's add Dave as the icon. Perfect. Let's now select resolution and presentation and make sure that the default orientation is set to landscape right. You can actually also select auto rotation and disable the two portrait modes so that the player can actually play in landscape right or left, depending on his or her preferences. Okay. Next, let's open the Other Settings tab. And one really important thing here is to make sure that your scripting backend is set up to ILG-CPP. This is really important if you wish to publish your game later on. And also enable the 32-bit ARM architectures for old mobiles. And of course, you can still select your target, minimum target API and so on. But for now, we are not going to dive deeper into this. After that, we should be good. So we can open the publishing test settings. You can create a custom key store if you wish to do so, or just build the game with a debug key. Okay. And this is actually going to work perfectly when testing the game. So let me plug my device here and come back to you. All right. It should be good. So now let's open File, Build Settings. And if you're seeing this message right here, so unauthorized device detected, on Android, here is what you need to do. So open your settings right here, okay? Go to the bottom here and select development options. And if you can't see the development options, here is how you can enable them. And after that, you can select development options, go down here and enable USB debug. So let's authorize it and we should be good. So now in Unity, let's refresh and we can select the device. Perfect. So now let's build and run the game. I'm going to create a new folder for all my builds. So let's call it builds, boom. com.tabsil.kawaii survivor version 1. Enter. Let's do it.
One eternity later.
All right, so the game has finally been built. I'm going to try and play it a little bit. Okay, yeah, seems like it's working really well. And I can hide behind the bush like so. I can move. Yeah, that's so cool. So one thing I'm noticing right here is that the game feels a little bit laggy because it's trying to run at, or at least it's not trying to run at 60 frames per second. So we are going to add that change only, and we can call it a day. So let's close this window, clear the console, open our inspector. And what we're going to do is select one script or maybe create a new one. You know what? I'm actually going to create the game manager right now and add that one line to make the game smoother. So right click, create C# script, game manager. Perfect. Once it's done, I'm going to create a new game object under the manager's game object, game manager, and attach this script. Let's open it. All right. So inside of the game manager, we are going to write application.targetFramerate equals 60. That way, Unity, or the game actually, will always try and run our game at 60 frames per second. You can decide to select 50, you can set 30, whatever you want. But if you want a smooth game, you can select 60. And later on in the game, maybe in the settings, actually, what you can do is add a way to diminish the target frame rate, because of course it's going to drain the battery a little bit more, okay? So it might be an issue for some players. Yeah, we can add it later on, of course. So now what we can do is try and run the game again and check if it does make a difference. So let's go back to Unity. Let's select File, Build Settings, Build and run our game, version 1, of course, because we haven't changed that many things. Quick note here, the second time you build the game, it should be faster because all of the setup has been done. All right, Unity has built the game, finally, and now if I try and move, it's definitely way smoother. So our code has worked. Cool. So in the next one, I guess that we are going to add enemies because I'm feeling alone in here. See you in the next one. Welcome back, guys. In this lesson, we are finally going to add our first enemy. So let's do that. Okay, so we are going to proceed like we've done for Dave. So we will have the logic separated from the collider. Okay, so here's what we're going to do. Let's grab our sprite first. So sprites, enemies, ghost. I'm using these ones, but of course you can use the ones made by Alex. So let's grab the ghost, drop it on the scene or in the scene, press F in the scene view to focus it, and here we go. So let's drag it and drop it next to Dave just to have a better idea of its size. Okay. Then what I'm going to do is right click, select create empty parent to split the logic from the rendering again. Come on, you know that now. So ghost or maybe enemy, enemy, and this should be the enemy renderer. Okay. So we've got our sprite renderer. We need to add a sprite sorter. So sprite sorter, like so, drag the sprite renderer and drop it here so that it actually renders correctly on top or below the player or any other sprite. Cool. And the first thing we want our enemy to do is follow our player. So we are going to create our enemy movement script now. So let's open the scripts folder, right click, create a new C# script, enemy movement. Here we go. We can now grab our script and attach it to our enemy, not manager, sorry, enemy. Here we go. So how is our enemy going to follow our player? Well, we first need to find the player. So for that, we can either use tags. So you can select Dave and add a player tag like so. Then what we can do is inside of the enemy movement, search with any game object with that tag. But this is a method that I don't like using, honestly. So what we are going to do instead is add another script to our player, which I'm going to call player. And our enemy will first look for any game object that has the script player and store it whenever it finds it. Okay, so let's create our player script now. Okay, player, here we go. We can now grab our player script and attach it to Dave. Here we go. I'm just going to grab it and drop it at the top right here. Perfect. And once the enemy has found the player, how is it going to follow it still? Well, first off, let's select our enemy and make sure that the transform has been reset so that we actually move the enemy instead of the renderer. Okay? So that's one thing. And to be able to follow Dave, we are simply going to grab Dave's position minus the enemy position, normalize it, and it's going to give us a direction that we can follow. Then we simply need to move our enemy along that direction. Later on, if we want to add obstacles to our scene or our arena, this method won't work anymore, of course. So we will need to use some kind of path-finding algorithm, but let's keep that for later on. Okay, let's now open our enemy movement script. Perfect. So the first thing we need to do is to grab our player. So we are first going to create a variable right here, private player. We can actually add a header elements maybe. Yep, cool. And at start, let's search for that player. So player equals find first object by type player. And Unity will actually go and look through all of the game objects and find the first one that has a player component. After that, if the player is null, so if we haven't found any player, we want to destroy our enemy, okay? So what we can do is debug.log log warning maybe. No player found. Auto destroying. Boom. Auto destroy. Oh, come on, not here. You're ruining my joke here. Auto destroying. Like so. Perfect. And we can then destroy this game object. So the one that has the enemy movement script. Perfect. So this is just to make sure that we don't get any error later on. But if we've found a player, we are going to calculate the direction of the movement. So first off, I am just going to drop the logic inside of the update method, and we'll refactor this later on. So vector2 direction equals player.transform.position. So we first access the transform component of the player and grab its position, minus transform.position. This does give us a vector, but it's not normalized. So we will So we are going to normalize this one, .normalized. Perfect. Once we've got our move direction, we are going to move, of course. So vector2 target position equals transform.position, so the current position, plus direction times a certain move speed times time.delta time, again to make it responsive. So let's now add our move speed here. Boom, settings, serialize field to be able to spot it inside of the inspector, float, move speed. Nice. Of course, we are getting an error because the position is not a vector 2, so we are going to cast it vector 2 transform.position. Perfect. So our target position, each frame, will be our current position plus the direction times the move speed, basically. Okay, so we move by a certain amount along that direction. Got it? And finally, we can actually apply that position. So transform.position equals target position. Nice. I hope you get this right. If not, please leave a comment in the comment section and I'll explain in another way. All right, so we can now go back to Unity, set up our move speed. So the player has a move speed of 113. Okay, so let's use 1 for the enemy. It's actually going to be different because Dave is using physics, but yeah. Oh, nice. The enemy is following us. Help. Help me. Nice. This is working perfectly. Here we go. So let's go. Let's try and go under it. Okay, nice. Yeah. Well, of course, we need to fix this because right now it seems like the enemy is trying to reach this point. Okay, so this is the player position. So what we are going to do is also move the enemy render or the sprite up a little bit like we've done for Dave. So move the pivot point so that it's actually rendering correctly. So let's select our enemy renderer, select the ghost and open the sprite editor, move the pivot to the bottom center like so and apply. Perfect. We can now select our enemy and we can notice that it has been moved correctly indeed. Cool. It will be so much easier to animate it later on. You'll see. So let's hit play and check if it's working correctly. Okay, come on. Yep, perfect. That is so cool. Let's go down. Yep, following. Yeah, in front of us. Let's bring him next to the bush here. Oh, come on. Faster, please. 3. Okay, something like that. Is it rendering correctly? Yeah, perfectly. That is so nice. I love it. And I hope you love it too. By the way, if you're enjoying the course so far, feel free to leave a review, maybe 5 stars. Thank you so much. Okay, so in the next one, we are going to add a little bit more logic so that the enemy explodes whenever it reaches the player, okay? And after that, we can add the logic for attacking the player, okay? So it will imply adding player health and so on. But yeah, we can do that. See you in the next one. Hey guys, and welcome back. In this lesson, we are going to explode or destroy the enemy whenever it reaches the player. So first off, let's hit play just to remember where we've left it. So we've got the player moving, okay, the enemy is following, and nothing else. Cool. Okay, so first things first. What I want to do is to, of course, commit the changes because I always forgot. And this is something that we need to do every time we implement a major system or something new. So in here, we can say added enemy. Yep, something like that. Cool. We could have added enemy following player and so on, but that's okay. All right, perfect. So now what I'm going to do is open the enemy movement script because what I want to do is destroy the enemy whenever it reaches the player. So whenever it's close enough, okay? So let's open our script in here. Perfect. And inside of the update method, should we refactor right now or not? I think we should. So let's create a new method first. Private void follow player. Like so, perfect. We are going to grab our logic and paste it in here. Cool. So inside of the update method, we can simply call the follow player method and it will apply this logic. Again, private here means that no other script can access this method. Perfect. So after following the player, we can add another layer of logic. Check if should attack. Or maybe try attack. Yep. It's actually better. Try attack. So private void, try attack. Here we go. So to try and attack the player, first off, we need to be close enough. So let's check the distance between the enemy and the player. So float distance to player, let's say, equals vector2 dot distance. And this is really handy. This is a method that returns the distance between two vector2s. So between transform.position and player.transform.position. Perfect. So we now have the distance between the enemy and the player. What we can do is check if it's below a certain threshold. And if the enemy is able to attack, we can attack. But right now we just want to explode or destroy the enemy. So, okay. So if the distance to the player is less or equals to our, I don't know, maybe player detection radius, something like that, we could have used a hard-coded value, by the way, in here. Let's say 5 or 1, actually 1 unit, but it's actually better not to. Why? Because when tweaking your game, tweaking the values of your game and balancing, it's a good practice to have your values or variable as accessible as possible, just to prevent some additional compilation time. Right now, if you want to change the value 5, you will need to save again, and Unity will compile again, and you will lose so much time. So yeah, let's use player detection radius. Let's duplicate this line, Control D or Command D again. Player detection radius. Cool. Are we good here? Yep. So if that's the case, destroy game object. Cool. So now let's go back to Unity and set our player detection radius. Let's actually set it to, let's say, 1. Okay. So I'm just going to grab the player, the enemy, sorry, move it a little bit further because 1 in here means 1 unit inside of Unity. So let's hit play and see what happens. So the enemy is getting closer. It's coming, it's coming, it's coming. Disappeared. Cool. So once the player was close enough, the enemy destroyed itself. But one thing I don't like in here is that I don't have any clue of how far it is. So balancing the game will be quite difficult. And for that, I'm going to show you a way. You can use gizmos. So on draw gizmos. Just by adding this method, you're telling Unity that you want to draw something inside of your scene, actually. Or inside of the game mode right here if you enable gizmos. Okay. So let's go back here. Perfect. And what we're going to do is first off, set up the color of our gizmos. So gizmos.color equals, let's say color.red. Perfect. So this is the red color, 1001. And then we can draw a wire sphere. So gizmos.draw wire sphere. Okay. We need to specify the center of the sphere and the radius. So the center of the sphere will be transform.position because this is the position we are using to calculate the distance to the player. And for the radius, we are simply going to use player detection radius. Cool. We can save, go back to Unity. Oh, cancel this. And right away, we can notice the radius inside of our scene. That is so much more practical because we can now increase it or decrease it, and it makes it way easier to tweak. So let's set it to 3 just to test it out. Let's hit play. And whenever the radius comes towards here, boom, destroyed. That is so cool. So yeah, keep in mind that Gizmos is a really powerful tool. So try and use it from time to time to make your game dev easier. Okay. So I want the enemy to be able to attack the player once it's close to something like that, maybe 0.5. Let's actually try this out. And we can still change that value later on, of course. So here we go. It gets closer. It's getting closer. And boom. All of a sudden. That is so nice. One more thing here. If you have a bunch of enemies, so let's duplicate this boy a bunch of time. Okay, maybe something like that. We can actually hit play and see how it looks like. But what I want to show you here is that we are having a lot of gizmos and it might clutter our scene a little bit too much. So there are 2 ways we can use to prevent that. You can use the onDrawGizmos selected method to display the gizmos only if the game object is selected. Okay, so let's go back to Unity here, select the enemy. Oh, this is the renderer. But if we select the enemy, we can spot the gizmos here. Same thing if we select multiple ones. Perfect. But if you don't select any enemy, you won't spot the gizmos. And the other method you can use, because this one can be tricky at times and you might want to see the gizmos from time to time, even though you are not selecting your object, is add a boolean. So maybe we can add a header for debugging. Serialize field private bool show gizmos or display gizmos maybe, or maybe simply gizmos, something like that. And in here, you can use the onDrawGizmos method. And if your gizmos are not enabled, you can simply return. Okay, so let's now go back to Unity. And if we select any of our enemy, we can enable the gizmos to display all the time. And same thing for this one and so on. That is so cool. And you can, of course, enable or disable multiple ones at once. Cool. So that was a nice quick tip. So I'm sure that you're going to find a good use to that. And in the next one, let's actually add some cool particles whenever the enemy explodes instead of just destroying it. Because we must make our game enjoyable and beautiful from time to time just to enjoy the process a little bit more. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are going to add some cool particles to our enemy whenever he explodes or it explodes. All right, so let's grab one of these. Maybe we can actually remove the other ones. Select the enemy and press F. Cool. So in here, what I want to do is right-click and create a new effects particle system. Cool. So let's call this one, let's call these pass away particles, something like that. Or you can use another word that I don't want to say. Okay, so right after you do that, you should spot things in your scene here. So these are particles. And here is the component that does manage these particles. So just to have a better view here, we can grab the console, drop it here. Okay, project. Oh, come on, where is my inspector? It disappeared. Oh, come on. Unity from time to time does things like that. So what we are going to do is click here, add tab, inspector, and here we go. We have it again. So what I want to do is drop it somewhere around here, but I don't want the other ones to interfere. So let's grab this, drop it here maybe. Okay, like so and like so. Perfect. Here we go. So let's now select the particles again. Sorry for that. Unity can be quite tricky from time to time. So yeah, you need to deal with that. All right, so for these particles, first off, let's think about what we want. I want some little circles that blast from the center of the enemy, somewhere around here maybe, and have the same color as the enemy. So what we can do first is have a look at the color property. So you can change it, set it red, or you can use the eyedropper tool and click on the enemy. Cool, that's the first step. Now our particles have the same color as the enemy. So nice. So of course, there are so many settings or modules that you can have a look at right now, but we are not going to tackle all of them right now. It would be really heavy on our brains. Not only yours, but mine too. Come on. So yeah, what we are going to do is boom, boom, and it didn't work, so I can't collapse all of these. Okay, so we need to click them one by one. Of course, that's okay. We have patience in here. Okay. So let's first change the renderer here. Right now we have squares, but we want circles. So we are going to jump to the renderer module here and change the material. So let's create our first material, I guess. So right click, create a new folder for our materials. Okay. We are going to create another folder for the effects just to better split our materials. Right click, then create a new material. Perfect. So this is going to be the enemy
Pass away. Particle. Okay.
And right here at the top, you can select the shader you want for your particles. So usually for particles, you want to use something like particles, standard unlit or surface, or mobile particles, alpha blended, multiply, and so on. So I like to use alpha blended. And again, there are so many shaders you can use. You can create your own custom shaders if you want to display something funky. So yeah, let's go on and just use this one. Alpha blended. Okay. We are going to change the texture of our particle because right now it's still a quad or a square. So let's search for a circle texture. Oh, don't we have it? Oh, I know why it's not working. This is because it's looking for a texture, but we do have a circle sprite in here. Here it is. So what we need to do is search for circle in our project window. Select it. Okay, let's quit this. And we have a way of accessing our circle really quickly. So let's select it and change the texture type here to default. Okay. Let's enable or apply our settings. Perfect. Now we can go back to our material, which was somewhere around here, and select our circle. Perfect. Here we go. So now let's assign this material to our particles. So let's select the particles and grab it, drop it here. Cool, we have circles. Hooray! But right now they are still a little bit too big. So what we're going to do is change their size. So here we can spot start size. Let's set this value to 0.2, something like that. And it's already way better. Another thing here that is bothering me is the orange outline. Quick tip, what you can do is disable it. So let's click right here on the gizmo settings and disable selection outline. Here we go. Whenever we need it again, we can re-enable it. But for now, it's bothering us, so let's not use it. Okay, so next I'm going to grab the particle system and drop it somewhere around the center. And you can also spot some blue circles or cyan circles. This is the shape that is used by the particle system to emit the particles. So let's switch to 3D mode and you can notice that it's in fact a cone. It's not two circles. So we are going to change that. We can open the shape module and change the shape to circle right here. Cool. And we are now back in 2 dimensions. Let's switch back to 2D mode. Perfect. And what I'm going to do is diminish the radius of the emission circle. Perfect. Something like that should be good. And what I can spot is that our particles are displayed above the enemy. I think that it's okay because we are going to hide the enemy or destroy it whenever it passes away. So the particles will actually render correctly. Okay, let's play again. Perfect. Next step. Let's change the emission because right now it's emitting particles over time. We don't want that. We want to emit a burst of particles whenever the enemy passes away. So let's emit, let's say, 15 particles, something like that. And again, they are too fast. So we can change the start speed to 1. Okay. We can also change the duration of the particle system to 1 so that we can spot our changes way quicker. But if you want to shorten the lifetime of your particles, we can actually change this right here. 1 should be enough for some explode particles. One other thing that we can change is the size of the particles because right now they have the same size, but we can click right here on this arrow and select random between 2 constants. So let's set the size between 0.1 and .2 should be good, or maybe .05. Again, you can tweak these values and make them yours. I'm just showing you how you can do it, but of course, don't follow me 100%. Try and tweak values from time to time and make the game your own, of course. After that, I want to add a little bit of gravity and maybe fade the particles out. I don't know. Maybe I'm just going to add some gravity. So gravity modifier .3. Okay. Does it make sense? Maybe .1? Yeah, should be enough. I think it's okay, yeah. Maybe we can actually scale them down just to prevent having this abrupt or sudden disappearing. Yeah. So here is what we're going to do. Size over lifetime. Boom, click it, and you can change the graph right here. So let's select this one. They start off big, and then they get smaller as they go. Okay, here we go. And of course, feel free to have a look at all of these modules here that you can change. You have noise. If you want to add funky effects again, there are so many modules that you can experiment with. But for now, it should be enough. There are still two other things that I want to change here, which is the looping. So I want to disable looping and I want to disable play on awake. Why? Because I want to be able to play the particles whenever I want, and I don't want them to loop whenever I play them. And next thing, again, is the stop action here. Whenever the particles are done playing, right now we are just going to destroy them, okay? All right, I think this should be enough for this one. And of course, have fun experimenting with the particle system component. In the next one, we are actually going to implement the logic to play these particles. So see you there. Welcome back, guys. In the previous lesson, we've added the pass away particles for the enemy. So in this one, we are going to implement the logic to actually play these particles whenever the enemy passes away, of course. Come on. So for that, we are going to open our enemy movement script. And one thing that you can notice here is that our enemy movement script is getting bigger and bigger, and it's not really logical because it's enemy movement, and we are going to add particles. Particles are not meant to be added to the movement, but don't worry, we are going to refactor all of this later on. All right, so let's add a new header for the effects. Okay. Quick exercise here, by the way. I invite you to add the logic by yourself first and then watch the video. So here are the steps that you need to apply or follow. We are first going to add a reference to the particle system, okay? Then inside of the try attack method, instead of just destroying the game object, you want to create a new method, let's call it pass away, that will first off play the particles and then destroy the game object. But there is a catch here. If you destroy the game object right after playing the particles, the particles will get destroyed too because they are a child of the enemy, of course. So you will need to unparent the particles first, then play them. Okay? So just pause the video and do this exercise. It's actually really simple. I'm sure you can do that. Good luck. All right, here is the solution. Serialize field, private particle system, pass away particles. So this is a reference to our particles. Then inside of the try attack method, instead of just destroying the game object, we are going to call the pass away method. Okay. Private void pass away. Like so. Inside of the pass away method, we are going to destroy the enemy, of course. But first off, we need to unparent the particles and play them. Quick tip here, if you don't know, you can comment any line of code using 2 forward slashes. But if you want to comment like multiple lines, you can use forward slash and a little star, then little star, forward slash. Perfect. One quick way to also do that in Visual Studio is to select the code that you want to comment and hit Ctrl-K, Ctrl-C to comment it, or Ctrl-K, Ctrl-U to uncomment it. That's just another quick tip here. So let's unparent the particles first. So pass away particles. To unparent an object, you need to access the transform component. So transform.parent or setParent null. There are two ways you can do that. You can either use this line of code or .parent equals null. This will make the passaway particles a child of the scene. Okay? Having no parent in Unity, of course, means being a child of the scene. Cool. So let's go back here. I'm just going to use the first line of code. No need to rewrite it twice. And then passaway particles.play, of course. Yep, should be good. So let's try that. And then I can show you another quick tip. Really quick. I love quick tips. Do you? Please let me know in the comment section or by leaving 5 stars. Cling, cling. Okay, so let's go back to Unity now. Passaway particles, grab them, drop them here. And what we can do now is play to check if it's working correctly. Okay, come on, Mr. Enemy. Come on. And yeah, the particles have been played. And we've also destroyed them automatically. They did destroy themselves, actually. We can play that again just really quickly. You can skip this, but I just want to show you that the particles are going to unparent. I can hit pause. Boom, here are the particles. Let's hit pause again, and now they've disappeared. So this is not the best way of doing things because it's not reusable. Ideally, we would love to reuse these particles or the enemy, but later on we will see how to do that using pooling. Okay, last quick tip before we jump to the next lesson here. If you have an if statement, so a condition with one line of code inside of it, you can remove the brackets. And I actually love to do that. Maybe you don't, so don't do it if you don't like to do it, but I find it way cleaner actually this way, okay? So in the next one, we are going to add a spawn indicator. So it will help us know whenever an enemy is going to spawn and where he is going to spawn, okay? Because later on, of course, we are going to add a wave manager, and it's actually really tricky. Can I move here, please? Nope, I can't. And it's actually going to make our game way cleaner and more professional. So see you in the next one. Welcome back, guys. In this lesson, we are going to add a cool spawn indicator to our enemy to know where he is going to spawn. Okay, so the first thing I want to add here is a new sprite, of course. So we can either duplicate the sprite renderer like so and call it spawn indicator. Okay, something like that. So right now it does have the same sprite as the enemy. Of course, we need to change that. So let's click on here and select outline. I don't know if it was outline, circle outline. Is there another one? Okay, maybe we have the spawn indicator. Spawn circle outline right here. This is not... Oh yeah, this one is better. Is it just me or is this outline thick? We do miss Danny. Come on, come back, dude. All right, so let's use this one. Perfect. We first want to center it on the enemy, of course, and let's scale it proportionally. So you can press Alt and Up or Option on Mac and scale it down to something like that, depending on the perspective that you want to have in the game. So I'm going to use this scale. Let me have a look at how it does look like inside of the scene. So we are first going to color it. Boom, boom, perfect. This is decent, actually. Yeah, I like it. If you don't, that's okay. You can change that. But yeah, should be good for a spawn indicator. Okay, so there is one thing I want to show you here. If we hit play, we do have this spawn indicator in the 0 layer, and the enemy renderer is also in the 0 layer. So it might cause issues regarding rendering, but it won't, because the enemy will be hidden when the spawn indicator will be shown, and vice versa. Whenever the enemy will show in, we are going to hide the spawn indicator, so that's okay. Now that our spawn indicator renderer is correctly set up, let's add the logic, of course. So let's open our enemy movement script. Again, this should not be in the movement script. We should create another one. And don't worry, I'm going to leave the refactoring for the last lesson of this section. Hopefully, remind me if I forget. So let's think about what we want to do first. At start, we don't want our enemy to be displayed. So in here, we should hide the renderer, okay? And we should also show the spawn indicator. Okay, cater, perfect. What do we want to do then? I want the spawn indicator to bump or to scale up and down. And this is, of course, again, another preference, but you can decide to have another animation for your spawn indicator, and you can also have another spawn indicator actually, but I'm going to show you how to use this one. So I basically just want it to bump like this, like in the promo video, just to create an alert actually, and to show the player that something is about to happen at that position. Okay, so let's scale it back to 1. Okay, and so in here we can write scale up and down the spawn indicator. Okay, so we need to scale it up and down, and after, let's say, show the enemy after maybe 2 seconds. 1, 2, no, 3 seconds. Okay, 3 seconds should be good. And of course we can tweak this value later on. So we will show the enemy. We will also need to hide the spawn indicator. And because our following and trying to attack methods are inside of the update method, we need to prevent following and attacking during this whole procedure here. Okay, so prevent following and attacking during the sequence, let's say, during the spawn sequence. Okay, cool. So these are the things that we need to do, okay? It's a good practice here, just a personal preference actually that I like to do, is to write some comments on what I want to achieve. And then it makes my thinking kind of crystal clear. But at least it makes for a good guidance and a path to follow. Okay, so let's tackle the first steps. We need to hide the renderer and show the spawn indicator. Okay, so renderer, do I have a reference to the renderer? No, we don't. So let's add it. We can create a new header for the spawn sequence elements. So spawn sequence related stuff. Okay, so we need the renderer, private renderer, or you can add the sprite renderer actually. Render. We also need the spawn indicator. Perfect. So let's hide the renderer. Okay, dot enabled equals false. This is how you can disable a component, and it works for all of the mono behaviors. Quick tip here. If you want to inspect a method or a variable, you can hold Control or Command on Mac and click on it. And you can notice that the enabled boolean is a variable inside of the render component. Perfect. So let's now go back to our enemy movement here. So we do hide the renderer and we need to show the spawn indicator. So spawn indicator.enabled equals true. You can also use the game object here. You can like write render.gameObject.setActive false. Okay, it's actually the same thing. It's just that if you have multiple components attached to your render or spawn indicator, it's going to enable them and disable them. So right now our render does have the sprite sorter and the sprite renderer. So both of the render and the spawn indicator. So if you disable the game object, it's going to disable both of these objects. But if you write enabled equals false, it's only going to disable the component here, not the whole game object. So if you have another layer of logic on your renderer or any game object that you have, it's not going to interfere with it. Your changes will only going to apply to the renderer or the component that you are disabling. Got it? If not, please leave a comment in the comment section. All right, so in our case, we are only going to disable the renderer here. No need to disable the whole game object. Okay, so let's remove this line from here. Okay, so we hide the renderer. We show the spawn indicator. So we need to scale up and down the spawn indicator now. But before that, let's actually give it a shot. So let's go back to Unity. Select the enemy because we need to specify the renderer and the spawn indicator. Let's hit play, and right away we can notice that our enemy has been hidden, but it's still following the player. Come on, it doesn't make any sense. Anyway, let's go on. Okay, so let's try and scale it up and down. For that, there are two ways. We could either use an animator component and attach it to the enemy to be able to animate the renderer or the spawn indicator and so on. But I'm going to show you another way first, because we are going to use the animator later on actually when animating the player and the enemy, okay? And in the next one, we're actually going to use a twinning library to animate the spawn indicator. It's going to be fun. See you there. So there are many twinning libraries you can use, and twinning libraries, by the way, are just pieces of code that help you move, scale, rotate, apply animations by code, and make our lives way easier. So there is LeanTwin, which is free. There's also DoTwin, so this is the free version, but there is a paid version that is more complete, if I remember well. I'm used to use the LeanTwin version, so this is the one we are going to use. And of course, make sure to experiment and go have a look at all of the different possibilities and select the one that you like most, of course, as usual. Okay, so let's go back to Unity here and import the LeanTwin library if it's not already here. Do we have it? Lean? No, we don't have it. So we need to import it. So let's go back to the website here and add it to your assets. I'm just going to add it from my package manager right here because I already have it. But if not, please make sure to download it. I'm going to try and leave some links attached to this lesson. Okay, so let's search for LeanTwin. Here we go. Let's import the version 2.51. And as you can see right here, they are flexing a bit. Like it's used in Pokemon Go, which is a really good thing. Like congratulations. So yeah, let's learn how we can use it too. Okay, so let's go back to our enemy movement script here. We are going to scale the spawn indicator up and down. So for that, we are going to use LeanTwin to call the library .scale. As simple as it gets. Open the parenthesis, and we notice that we need to specify a game object, a to vector, so this is the target scale, and a time, so the duration of the animation. Then we have more options that we are going to experiment with. Okay? So let's specify the object we want to scale. This is the spawn indicator.gameObject. Here we go. We need to specify the target scale, and I'm going to specify it just above this line. It's actually going to be cleaner. And the time, so the duration of the movement, should be something like, I don't know, let's say .3. Here we go. So let's now set our target scale. So vector3 target scale equals. We want to scale it up to the target scale multiplied by 2, let's say, so .8. Yeah, that's too much. We had .47. Maybe we can use .5 in here. Yeah, .5, .2, and 1. Here we go. Yeah, that's actually better. It's going to be easier. We can use maybe .75. Yeah, that's still too much. So .6 should be good. Okay. So we need to multiply it by a factor 1.1. Okay, maybe times 1.1. It's okay. Times 1.2, .6. Perfect. Oh, this is actually a good quick tip here. You can do operations right inside of these fields right here. So you can say 5.10. Here we go, 15. .5 times 1.2, .6. Perfect. This is really useful in some cases. So let's go back to our script now that we know what scale we need. So let's use the current scale first, spawn indicator.transform.local scale. This is the current scale, so .5, .2, and so on, times 1.2f. And of course, right here, I'm using hard-coded values, but again, you can create variables for these and it will make tweaking, balancing, and so on way easier. So we are going to scale to this value. So now if we hit play, the spawn indicator should scale up to this value. So .6 and something here. Let's hit play. Let's have a look. And boom, it has scaled up. .6, .24. Awesome. So we want to make it scale up and down in a loop, maybe 4 times or 5 times before spawning the enemy. So just for testing purposes, let's set the move speed to 0 so that the enemy won't move. And let's add our loop. And for that, again, really simple. Set loop ping pong 4 times. It will do this 4 times. So let's now go back to Unity and have a look at it. Boom, hit play. 1, 2, 3, 4. Awesome. How fast was it? If you were to use the animator, you would have to add keyframes wherever you want your animation to apply, or maybe create it once and then play it 4 times. detect whenever it has played 4 times, and then play the idle animation or so on. Anyway, use tweening wherever possible because it will make tweaking values and balancing way easier than using the animator component. All right, we now need to show our enemy after 3 seconds, or after this has been completed actually. So it's not after 3 seconds, but after the loop animation or the scale animation. Here we go. So to do that, again, there is a really simple way using the lean tween library. You can add another extension method in here. So dot set on complete. Here we go. And you can call whatever method you want whenever this is complete. This is a really powerful way of structuring your animations and code actually, or your logic. Okay. So whenever the animation is complete, what do we want to do? We want to show the enemy and we want to hide the spawn indicator. So let's create a method to do that. So private void spawn sequence completed, let's say. So we want to show the enemy, okay, and hide the indicator. So I'm going to grab these 2 lines, drop them here. We want to set the renderer enabled to true, and we want to set this to false. Okay, so we can now call this method whenever it is complete. So cool. Quick tip here. If you don't like how long this line is, what you can do is press enter and enter, and this is actually way more readable this way. Perfect. So now we should be good. And you know what? Just for testing purposes, I'm going to set the move speed to 1 just after the sequence has been completed, just so that we can actually move our player. But right after testing, I'm going to show you a better way. So let's now go back here. Okay, let's select our enemy and hit play. Hopefully everything should work properly. So we should have the spawn indicator scale up and down 4 times, then show the enemy and move. That is so cool. Congratulations. Congrats. It's working. If you've understand this correctly, you now know how to better structure your code and create things one after the other. So this is one way. There also is coroutines, of course, and you can also use asynchronous code, but this is already really good if you've reached this point and understand. If not, please make sure to leave a comment in the comment section or ask anywhere. I'm going to try and answer as quickly as possible. Okay, so in the next one, let's actually complete our spawn sequence and allow the enemy to attack or follow the player after he's done spawning. See you there. Welcome back, guys. In this lesson, we are going to complete our spawn sequence. So let's jump right in. Okay, so right now we've set the move speed to 1. This is not what we want. We are going to remove this, okay. We are also going to set back our move speed to 1 inside of the inspector so that it's always 1 actually, okay. And we now need to prevent the enemy from moving at start. So for that, we can add a condition. Let's say something like if we can move, or maybe if has spawned, then we can do this. Boom, and boom, here we go. Let's remove some lines, make our code a little bit prettier. Here we go. Here we go. Perfect. So if the enemy has spawned, we can then follow the player and try and attack him or it or her. Okay? So this is one way we can do it, but a better way is to add kind of a security check. So we can check if we haven't spawned. So if has not spawned, then we are simply going to return. Otherwise, we can apply this code. And this has exactly the same behavior. It's just way cleaner in my opinion because you have multiple checks. So has the enemy spawned? Has it this? Has it that? And if that's the case, you can go on and apply your logic. So let's add this boolean now. Maybe somewhere around here. Yep. No need to show it in the inspector. So private bool has spawned. Okay. So booleans are always false at start. Okay. And if you want it to be true at start, you can specify it. But by default, it's false. If you are afraid of it being true, you can write equals false, just as a precaution, but no need to do so. Okay, so boom, 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 it's already false, so we are not going to follow nor attack, but after the spawn sequence has been completed, we can set it to true. So has spawned equals true. this will enable the update method to run the following code here. So let's try this out. Let's go back to Unity, hit play, and normally it should work properly, please. So spawn sequence, boom, 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 back, spawned following. That is so cool. Oh, I love it. Look at how much you've accomplished already. That is amazing. So we still have one thing left before we can jump to the player health. And this is allowing the enemy to attack us. Oh, by the way, there is an issue here. Have you noticed that my joystick is now a square? I did not think about it, honestly. This is because we've turned our circle right here into a texture instead of a sprite. So what we can do is actually duplicate it, keep one, like let's say circle text, and this one can be the circle sprite. So let's change it back to sprite. Okay. We can then select our pass away particles, select the render right here, and it's using the circle sprite, and it's actually still working. Why? Because you can use sprites or textures inside of the texture field of the material right here. So this is the texture and this is the sprite. Both of them are working. Okay. So we now need to select our joystick again. Here it is, missing sprite. Let's reference it again. So here we go. Oh, come on, sprite. We should set it to single, by the way. Sorry. Apply, and here we go. That's way better now. Cool. So in the next one, let's allow our enemy to attack the player. See you there. Welcome back, guys. In this lesson, our enemy will be able to attack us. But next, don't worry. We will allow ourselves to fight back. Okay, so let's open our enemy movement script. And again, I know we are going to add the attacking logic, and this is not really the best way to do things because this is the enemy movement script. But don't worry, we are going to refactor, of course. I just want to show you how you can actually apply your code, because don't fall in the trap. If you always think about refactoring, it might be an issue because your code needs to work first. Here is the logical path that you need to follow. First off, make the code work, even if it's spaghetti code. Then refactor. Otherwise, it doesn't make sense. You won't refactor something that's not working, right? So yeah, let's complete this, and hopefully after that we will refactor. And we won't forget to actually commit our changes here. Should we commit them right now? Yeah, let's actually add these. So enemy spawn sequence. Here we go. Okay, so let's allow our enemy to attack. First off, to attack means having a damage variable, because we need to know how much damage the enemy will do to the player. Okay, so let's add a new header here. Let's call it attack. Okay, so serialized field, private, integer damage. Our damage value will be an integer. You could use a float here. It's actually pretty similar. It's just that integers are integer values, of course. They don't have any comma or decimals. So we've got the damage, and after that we will also need an attack rate, just to know how frequently the enemy should be able to attack the player. But for now, let's just apply some damage to the player whenever we are close to it. So try attack. In here we are not going to pass away, but instead we are going to attack. Here we go, private void attack. Boom. And right now we are simply going to debug.log dealing plus damage plus to the player. Here we go. You can create strings by using the plus sign with any value that you want. There are so many ways you can actually create strings. So you can use the string builder, you can use the $sign and so on, but I'm going to show you the way that I'm using most, and then you can go on and search for other ways of writing strings. Of course, feel free to do so, or ask ChatGPT. So use the one that you prefer. I'm going to use concatenation. All right, so let's go back to Unity and hit play, and hopefully the enemy should attack the player. By the way, we should move the console somewhere around here. Okay, come on. 1, 2, 3, boom. Dealing damage. And right now the enemy is dealing damage 60 times per second because we set the FPS to 60 if I remember well. So let's count. We are right now at 775. Let's count 1 second. So 1, 2. Yep, it's actually 60. We were at 775 plus 60 should be 835, 837. It's actually, yeah, perfect. We got it right. All right, so right now the enemy is dealing damage to the player a lot, but it's 0. I forgot to set this to 10. Let's just test this quickly. Okay, let's move towards the enemy. Okay, yeah, dealing 10 to the player. I forgot to add damage, come on. Anyway, you got it. Dealing 10 damage to the player, okay? Or attacking the player with 10 damages, or any sentence or any syntax that you want to use. But yeah, you got it. Okay, so 10, perfect. So now we need to add a kind of delay for the enemy to be able to attack the player. Not that frequently, come on. So let's add that at the top here. Under the attack header, we are going to add a new serialized field, private float this time because we are going to deal with time and timers. So attack rate, here we go. Then we are going to create 2 other fields, an attack delay and an attack timer. Of course, you could have used an attack delay right here, like you can hit the player every 3 seconds, okay? But I like to use frequency. I don't know, this is a personal preference, but it will be like 2 times a second, 3 times a second, and we can actually rename this attack frequency so that we know that this is a frequency. So private float, attack delay, and this is going to be the attack timer. So the timer will be useful because we are going to increment it on each frame. And whenever we pass the delay that we have calculated, then we can allow the enemy to attack the player. Okay? So here is how we are going to proceed here. Right now, we are trying to attack the player inside of the update method. Every time, 60 times a second. This is not what we want. We want to try and attack if the attack timer is greater or equals the attack delay, okay? But we first need to calculate this attack delay because right now we only have the frequency. So inside of the start method, and it's starting to get really filled here, busy. So we need to refactor again. But what we can write is attack delay equals 1f because we need to use a floating value. If you use just 1, this is considered as an integer and the result will be an integer. So we will miss decimals. So we need to specify that we want a float divided by the attack frequency. And this is our attack delay. Perfect. If you want, we can debug this. So debug.log attack delay plus attack delay. Okay, perfect. Let's now go back to Unity. Let's set the frequency to 2 times per second or maybe 1 time per second. Yeah, we can allow the enemy to attack once per second. And again, it makes really easy to tweak the values here. Okay, the attack delay is 1. If we allow the enemy to attack twice per second, normally it should give us 0.5. And that's the case. So the enemy will be able to attack 2 times a second. Okay? All right, let's now go back to our script and complete it because the enemy is not attacking us right now. So let's dealing damage to the player first off, just before I forget. We can remove the pass away call right here. So if the attack timer is greater than the attack delay, we are going to try and attack. So if we are close enough, but if not, we are just going to wait, okay? And our wait method will actually be pretty simple. So private void wait. Okay. We are going to increment the attack timer. So attack timer plus equals time.delta time. So time.delta time again is the interval in seconds from the last frame to the current one. So this is the duration of a frame of the previous one actually. So this is the whole logic behind the attack. Let's try this out. Let's hit play. And there is going to be an issue here, but I let you imagine what it can be. Okay, come on, come on, come on. Yeah, the enemy is attacking now. But again, it's still attacking so many times per second. So what's the issue here? In your opinion, what did we miss? If you already know why, well done. If not, let's think about the process here. So if the attack timer is greater than the attack delay, we try an attack. Perfect. So we are going to try an attack after this is greater. Otherwise, we wait. So we do increase the timer, right? So after the timer is greater, we are attacking, but we are not resetting our timer. Every time you attack, you need to reset the timer. Okay? So inside of the attack method, we are going to write attack timer equals 0 so that we can start counting again. Let's give it a shot. So let's hit play. Okay, let's move towards the enemy. And now we can see that 1, 2, 3, 4, 5, 6, 7, 8. Now the enemy is attacking twice per second. Indeed, it's working as expected now. Perfect. If you've reached this point, you've done great. Well done. In the next one, we are going to refactor our enemy movement, but I just wanted to say that you are doing great. Well done. And please make sure to experiment, tweak the values, change stuff so that you can better learn and actually benefit from this course. In the next one, let's learn how to refactor our enemy, and then I can create a small quiz to check if you've understood all of the little points that we've tackled. But we've already done so much, like the spawn indicator, the enemy following, the attack logic. You've learned a lot in this hour and a half or 2 hours. So, good job. Hey guys, and welcome back. In this lesson, we are going to take it easy, okay? Because we are going to refactor our enemy here and turn it into a prefab, of course, so that we can use it and reuse it. Okay, so the first thing I want to do here is open our enemy movement script, because as you can see, we've got logic for the movement, and we also have some general logic like the pass away particles, the rendering, the spawn indicator, and so on. So ideally, what we would want to do is split this into 2 scripts, okay? So let's do that. Let's create an enemy script. So right click, create a new C# script, and call it enemy. Let's attach this script to the enemy, like so. Perfect. I'm going to move it up. So you can either move it by dragging it and dropping it, or you can click on the 3 dots here and select move down or move up. Okay. So the first thing I want to do here is to move all of the things that are not related to the enemy movement inside of the enemy script. So I'm going to double click it here. And what we can do is drag the enemy script, boom, like so. So let's open it first. We can drag it and drop it on the right here. I'm just going to hide the Explorer, or maybe make it smaller because I might use it later on. And yep, should be good. Okay, maybe make more space here. All right. Cool. So let's grab our player first. So I'm going to hit Control X or Command X and drop it right here. So now the player lives inside of the enemy script. So it will need to pass it into the enemy movement. You can either do it like so, or look for the player in both scripts, but that's not ideal. We are trying to refactor here. So we've moved the player, okay? So I'm just going to make some space here. Okay, cool. Inside of the start method, I'm going to grab these lines, boom, Control X, and drop them here. Perfect. Let's move down again. Okay. So the enemy movement script needs the player to follow it, of course. So the enemy movement script does need the player. So we will add a reference to it, but the enemy script will be responsible for passing the object to the enemy movement, okay? So we can imagine playing the spawn sequence inside of the enemy script, and after that, passing the player to the enemy movement so that it can follow him, okay? So let's keep a reference to the player right here. So private player, okay? So header elements, but we are not going to reference it as we've done previously, okay? Let's add our 3 things right here. So Control X, move them here. All right, because the enemy will manage the spawn sequence. I'm going to grab these 2 lines. Okay, drop them here. We can actually remove the comments now, like so. Here we go. The target scale, we can grab this. We can actually grab the attack logic too. So let's grab these lines, drop them here. And instead of having this code inside of the start method, I'm going to create a new method. So private void start spawn sequence. Here we go. We can grab these lines, drop them here. That's already way cleaner. So start spawn sequence. We will need a reference to the attack and damage. So let's grab these, drop them here. Let's also grab the pass away particles because it doesn't make sense to have these inside of the enemy movement script. So the enemy movement script only needs the player, the move speed, and the player detection radius. Cool. So the start method can be empty. We can actually remove it, like so. Awesome. Let's go on. So inside of our enemy script, we've got an error. It doesn't know what the spawn sequence completed method is. So we are going to grab it from the enemy movement script. Let's drop it here. Perfect. Let's remove the comments because we know that the logic is working now. Here we go. Perfect. We can remove this one from here. The attack logic should go inside of the enemy script. So boom, paste it here. All right. And inside of the update method of the enemy movement script, we can follow the player if he's not null. So if player is different than null, then we want to follow it. So this is a good logic to implement because the enemy will actually determine whenever we need to set up our player. So let's remove this security door. Okay, cool. Let's grab the wait method, attack method, and pass away method and drop them here. Here we go. So try attack, yep, of course we need to add the try attack method here. Perfect. So we also need the player detection radius right here. Boom, let's grab it and drop it somewhere around here maybe. Yep, cool. What we can do now is grab the gizmos too and drop them here if we need them. Okay, so the boolean for the gizmos should live inside of the enemy script too. Here we go. And that's already way better. Okay, so now we need the enemy script to pass in the player to the enemy movement script. So for that, I'm going to create a public method. So public void store player. Okay, so this dot player equals player. You can use the keyword this to reference a class variable. So right here, this dot players means this player right here that we've got at the top of the script, and player does mean the local player variable used in the method. So if you really want to avoid any issue, you can add maybe an underscore here, even though I'm not a fan of this method, or call it differently. But again, it's a personal preference here. I like to use this keyword. Okay, so store the player. When do we want to store the player? By the way, we can remove this debug line here. Okay. We can remove this one too. Perfect. And in here, we will need to grab the player and actually attack it. Let's remove this comment. Okay. And let's store the player. So once the spawn sequence has been completed, we are going to store the player. So let's write movement dot store player and pass in the player. Perfect. We just need to reference our enemy movement script now. So every enemy will move. Quick exercise here. What can I do to make sure that we have an enemy movement script attached to the game object here? What attribute can I use? Of course, the require component attribute. So require component type of enemy movement. Awesome. So we just need to store it now. So let's add a new header for the components like so. Private enemy movement. Cool. And inside of the start method, I can write movement equals get component of type enemy movement. Here we go. So we make sure that we store it before we apply any logic. Start spawn sequence. Okay, there is still one thing that I want to do here because I'm enabling the spawn indicator here and disabling it here. So maybe we can add a method to enable or disable stuff. Okay, here is what we're going to do. Private void set renderers visibility boolean state, or maybe visibility. Inside of here, we can use this boolean to set the visibility of the renderer and the spawn indicator. So let's grab both of these, drop them here. So if we want to enable the renderer, we are going to use the visibility. But in here, we want to hide the spawn indicator. So we should use the opposite value of the visibility. So this operator right here takes the opposite value. So if this is true, it's going to take false. If it's false, it's going to be true. Got it? So we can now use this method right here. Okay, so let's pass in true. Perfect. And we can also use it right here and pass in false. So this is one way we can use it. The second way we can use it is by setting a default value for our visibility. So you can say visibility equals true. Just as an example. So if you don't pass in an argument right here, it's going to use the value true. If you want to pass in false, you need to specify it. So this is just, again, a quick tip that you can use. All right, I think we should be good here. So we've got around 118 lines, here 30 lines of code. This is decent. So let's go back to Unity now and edit our scripts here. So we will need to specify the renderers and so on, but that's cool. So renders. Here is this one, the spawn indicator, the pass away particles. The damage will be 1 for the frequency, and maybe 1 for the radius. Let's enable the gizmos. No, 0.5 it was. Okay, cool. And we can have the move speed in here. That is so nice. Let's test it out. Okay, spawning, spawned, following. Really cool. Everything is still working perfectly. I love it. Okay, so now that our enemy has been correctly set up, we can turn it into a prefab. So for that, I'm going to create a new folder, prefabs, grab the enemy and drop it here. So what is a prefab? A prefab is an object that you can use and reuse multiple times. And the power of prefabs is that you can have multiple enemies, not like that, sorry. Let's grab this one, duplicate it a bunch of time, okay. So imagine that I don't like this image here, the sprite used for the enemy. What I can do is open the prefab in prefab mode, change the renderer. So let's say I want to use, why can't I see them? Let's increase the scale, please. Let's say when I want to use snark 0 as the enemy, or maybe this one, okay? So let's use this sprite, go back to our main scene, and all of the enemies have been changed. See the power of prefabs now? They will help us save a ton of time. So yeah, let's hit Ctrl Z to bring back our old friend, and we can now commit our changes. So let's open GitHub and write in enemy logic. Okay, yeah, something like that. So we've added movement, attack, and refactored. And also prefab, actually. Cool. Boom. So now that's done, I invite you to take on the quiz and jump to the next section. It's going to be amazing. Welcome back, guys. In this section or lesson, we are going to work on the player health. So we will actually manage attacking the player. So the enemy should attack the player. And we are also going to tackle a little bit of user interface to display the player health bar. All right. So the first thing we want to do is open our enemy script, because in the last lesson we have added the attack method, but we are not actually attacking the player. So we already have a reference to the player and we know how many damage or how much damage the enemy should deal to the player. So let's go back to our attack method right here and write player.takeDamage and pass in the damage. As easy as it gets, like so. So we now just need to add the take damage method inside of the player script so that the player can actually take damage. So let's copy it, open our player script, and we can press Ctrl click here, Ctrl click here again, using the quick tip from a previous lesson if you remember well. And we can now create a public void take damage that takes an integer as an argument, damage, like so. Perfect. So it needs to be public, as a reminder, because we are using this method or calling it from outside of the player script. Okay? Perfect. So the player script here will not be the one responsible for managing the health. Okay, we need to add another script. It's actually way cleaner. So what we are going to do is create a new player health script. So let's go back to Unity. And we can already start organizing our project window a little bit better. So we are going to right click, create a new folder for our player related scripts. So let's grab the player controller, drop them inside of here. It's going to reload the domain, of course. We are going to do the same for the enemy and the managers. So create a new folder, enemy related scripts, enemy and enemy movement, boom, right here. And same thing for the managers. So right click, create folder, managers. We can actually consider the camera controller as a manager. Come on, that's okay. All right, perfect. We can leave the sprite sorter here, but if you've got any idea on a folder name where we can drop this, maybe effects or something like that, you can actually create it and go on. All right, so let's open our player folder and create our player health script. So player health, here we go. Let's now attach our player health script to our player, Mr. Dave. All right, let's grab it and drop it somewhere around here, just after the player controller. We can actually collapse the rigid body and circle collider to make it more readable. And we can now open our player health. Cool. Our player health script needs to manage taking damage. So we are going to add a public void take damage method with an integer damage, like so. And we are going to call this method from the player script so that the player doesn't have to manage everything, because you can actually think about it like a manager. The player script here is kind of a manager that will manage all of our other scripts, okay? Everyone who wants to talk to the player or talk to the player controller will need to go through the player script. Got it? Same thing for, I don't know, maybe the game manager. He will call the player and tell him to stop moving or to pass away and so on. It's just a better architecture instead of allowing other scripts to directly access your player health or player controller and so on, okay? Again, you can think about it like a hierarchy in a company. You've got the boss, the CEO, and then you've got some managers under him, and maybe some other managers under the managers, and so on. And each one is managing or controlling 5 people or maybe 10, something like that, just to make it more manageable, actually. Same thing here. One script can manage 5 to 10 scripts. And as you make games, of course, you will find a good balance between what you need to do and what you like doing, okay? Again, it's a process and you need to have fun making games. So feel free to actually take this as a basis and then expand on it and make it your own. Okay, so enough chit chat. Let's open our player script here and let's add the require component attribute so that we can actually call the player health component. So the player requires the player health. So player health, here we go. We are now going to add a reference to it. So components, private, player health. And again, you could have made that serialized and attached it to the inspector, but I like to do it like so. What I'm going to show you here is a quick tip that you can use and that you are going to use. Instead of storing our player health component inside of the start method, we are going to store it inside of the awake method. So awake, here we go. The awake method is called just before the start method. If you remember Unity's execution order that we've seen in the camera lesson, if I remember well. I'm going to drop it here. All right, so right here, player health equals get component of type player health, of course, here we go. And inside of the take damage method, we can call player health.take damage. And let's pass in the damage, of course. Perfect. So now if we go back to Unity, we should not have any error, so we can keep going. All right, perfect. So let's now open our player health and implement the logic. Inside of the take damage method, what do we want to do? I can give you 5 seconds to think about it, but it's actually quite simple. We are just going to take the health of the player and subtract the damage from it, right? Pretty simple. So let's actually try this out. We are going to add a health variable at the top here. So maybe we can call it settings, yeah? Drop it under the header settings. Serialized field private integer, not float, health. Perfect. So let's now go back to Unity and think about it a little bit further. So let's initialize our health to 10, let's say. Let's now hit play and let's allow the enemies to attack us. So maybe we can move towards this one so that only one of them does attack us. Okay, so 10, 9, 8, 7. Yeah, it's working. It's already pretty good, huh? Really nice. So let's now another layer of logic and we can call it a day. So let's open our player health script and prevent the health value to be negative. The minimum value should be 0 actually, okay? So instead of subtracting damage here, what we're gonna do is create a new variable. So int, let's call it real damage. Real damage, damaga, come on, equals mathf.minimum between damage and health. Indeed, we cannot subtract more than health. So we should take the minimum of these two values. So if the damage is 10 and our health is 9, we should subtract 9. Got it? We should not subtract 10. And in here, instead of subtracting the damage, we are going to subtract the real damage. And finally, we can check if the health is less or equals to 0. So it should be 0 at max actually. So let's drop 0 in here. Perfect. We can just call the passAway method. So passAway, like so. Private void passAway. In here, I'm just going to debug.log DED, like so. Okay. So let's try this out. So let's go back to Unity. Let's hit play. All right, let's try and get DED to write in the console. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. DED. Our Dave is DED. Okay. Anyway, you now get the logic right. But in the next lesson, we are going to add another layer of logic to make our code more efficient, actually, because we should not have the health right like this. Okay. We should have a max health, initialize the health with that value and so on, because each player will have, let's say, a base health and a health stat improvement or a disadvantage. Got it? So yeah, let's meet in the next one and implement this. See you there. Welcome back, guys. In this lesson, we are going to improve our player health script and hopefully we will still have time to implement our health slider here at the top left. Okay. So let's open our player health script. What I'm going to do in here is add a private integer max health. Here we go. And this is the one that we are going to serialize to be able to spot in the inspector, because our health should actually be private and hidden. We should not be able to change that. At start, we are going to initialize our health to have the max health value, because as I've told you in the previous lesson, each character will have its own max health. So maybe Dave will have 0 as an addend, maybe Snark will have 5 additional health at start, maybe some other one will have less. We don't know. We want to make it flexible. Okay? So yeah, at start, health equals max health. What we can do in here just for debug purposes is debug.log health plus health. Here we go. Just to check if it's working. In here we can debug.log max or maybe health initialized to health, like so, just to be sure that we've initialized our player health. Having the max health will also help us calculate the ratio between the health and the max health, so a value between 0 and 1, and we can then apply that to the slider. Okay? You could have used another way here. Maybe you could have initialized the slider at health. So maybe if it's 10, you can initialize the slider to 10 and then remove the damage, but it's actually cleaner to do it that way. Okay? All right, let's go back to Unity, initialize our max health to 10, hit play, and let's get hit by the enemies. Health initialized to 10, perfect. Health 9, 8, and we go on. Cool. So you could do this, or quick tip again, you can switch to debug mode right here. And if we switch to debug mode, you can spot private variables. So we can spot the health and many other variables or components. Cool. You might use this in some occasions. All right, so now that we've got this, we are going to add the player health slider right here. So inside of our canvas right here, we do have the mobile joystick zone. Okay, so this was our first element contained inside of the game panel because we are using the joystick when playing, right? So one thing I like to do is creating panels for each of my game states, let's say. So when playing, let's say we are inside of the game state. So I want to have a panel for that state. So let's right click, UI, panel. Let's call it
game. Like so.
and we can now grab our mobile joystick and drop it here. One thing you need to make sure of is that your game panel or your panels in general are stretched on the canvas. Okay, they should occupy the whole space. So let's press F to have a better look at it. Here we go. This is our panel. What we want to do for our panel here is set the color alpha to 0, remove the background sprite because we don't need it, and uncheck the raycast target. Otherwise, we won't be able to control our joystick here. It will block raycasts. Okay? So we can select this one again, right click, select UI, and slider. Perfect. Let's call it health slider. We can drop it at the top left, and you can press Alt and press to snap it to the top left corner. And you can do the same thing for all of the corners or positions here. Okay? So let's actually enable the gizmos so that we can spot the borders of our canvas right here. I'm going to drag this somewhere around here for now. Okay, maybe we can make it a little bit bigger. Yep, something like this should be cool. Yep. I want to hide this knob right here because I really don't like it. So what we are going to do is remove the handle slide area. We can disable the interactability because we don't want the player to be able to change the value of the slider manually. Set the transition to none. Perfect. And in here, you can set the minimum and maximum values of your slider. So as I've told you before, you could actually set the maximum value to health. So if your health was 10, you can set it to 10 and then assign the health every time. But one thing I like to do is to keep the value between 0 and 1 and use a ratio, so a value between 0 and 1 for the slider. Okay? But again, you're free to choose whatever method you like. Another thing you might want to know is that you can change the direction of the slider. So like so, maybe from bottom to top and so on. This can be useful when making a gauge or something. Okay? Perfect. So we've got the slider. We are going to change the color of the background here to something a little bit darker. Let's change the sprite to a container, I guess. No, not the container, maybe square 50. So let's write SQ. Here we go. This one is good. Maybe we can change the pixels per unit to 3, 4 to get a more or less rounded edge, corners, sorry. 4 seems correct. Yeah, maybe 3. Yeah, okay, let's keep it to 3. And we can do the same thing for the fill area here. So let's change the sprite to square 50, this one, and the pixels per unit to 3. Cool. So right now, it's not really noticeable because we are using a white color. So what you can do is change the color to something bluish, but in general, health bars are red. So let's use a red color. Perfect. And one thing I like to do is also add an outline to the slider. So here's how we are going to do. Right click, select UI image. We are going to stretch it on the container, on the slider actually, and use the square 50 outline, which I should have somewhere around here. Perfect. Let's set the pixels per unit to 3, like we've done for the other ones. And one thing you can notice now is that the outline is a little bit too big. So let's first change the color, like so. It's way more noticeable now. And we can also select our background and stretch it. Same thing for the fill area. Stretch it, like so. One thing you can do here also is to grab the fill area, drop it inside of the background, and add a mask component so that you can't see these little thingies here, like so. Yeah, we can still spot a little bit, but one trick I like to do is to select the outline and set all of the offsets to -1, -1, -1, and -1. That way, it's offset by 1 pixel and you can't spot any issue. All right. So now I just need to resize my health bar to something like that, and it's already pretty cool. Perfect. Cool. So we now have our health bar. What we can do is add a reference to the health bar and change the value property of it to display our health. So let's learn how we can do that in the next one. See you there. Welcome back, guys. In this lesson, we are going to add the logic to manage our health bar right here. So let's first open our player health component here. Cool. So we need a reference to our slider. So let's do that. Let's go back to our script and add another header for the elements. Okay. Serialize field, private slider, health slider. Here we go. So we are getting an error here. What you can do in Visual Studio, and I'm sure you can do that too in other code editors, is check for the quick fixes here. So right now it's telling us that the type or namespace name slider could not be found, so on and so on. So what you can do is hover it again and select the quick fixes here using UnityEngine.ui, because the slider component is inside of the UI library right here. So we need to add the library to be able to use the component. Okay, perfect. So right now we should have a reference to the slider inside of Unity. So let's select our player health. Let's grab the health slider and drop it here. Perfect. So we now want to change the value of the health slider. So at start, our health equals max health. So the slider should be full. So what we are going to write is health slider.value equals 1. Perfect. We can already try this out. So let's go back to Unity here, wait for it to compile again. All these compilation times do take a lot of time. Let's hit play. And yep, perfect. Our health slider is now full. Awesome. So you now know how to control the value of the slider. Quick exercise here. Inside of the take damage method, every time the player takes damage, you want to update the health slider. So you need to calculate the ratio between health and max health and apply it to the value. Come on, do that. I'm sure you can do it. Okay, here is the solution here. So we are going to write float health bar value equals health divided by max health. But if you do that, health is an integer, so the result will be an integer, so either 0 or 1. And this is not what we want. So we want to cast the health variable to a float. That way we can have fractional numbers. So health bar value equals this. So we can write health slider dot value equals health bar value. Like so. Let's give it a shot. All right, let's hit play. Boom. Wait for it to compile again, as usual. And let's get hit by enemies. Oh yeah, it's working. Diminishing until the Dave is DED. Nice. Really cool. So congratulations. You now know how to link UI elements to logic. And that's a huge step again. Well done. I think that when adding the level bar, I'm going to let you do that by your own and then show you the solution. It will actually make for a pretty good exercise. All right, in the next lesson, we are going to learn how we can add a text inside of the health bar to display the actual value of our health. And again, feel free to do that before you watch the video so that you can actually practice and learn faster. See you on the other side. Welcome back, guys. In this lesson, we are going to learn how we can add a text on the health bar that does display the actual health, okay? So we can imagine adding it something like health/max health, something like that, just to have a better reference to it, okay? All right, so let's add a new child for our health slider, and this is going to be our first text here. Hooray! All right, so UI text mesh pro should be somewhere around here. Cool. So because this is the first text that we are adding, there is the TM Pro importer. Import the TM Pro essentials, of course. Let's go on. Here we go. And then we've got our Text Mesh Pro properties here. So the text input is simply the text input. So we will write something like 0.5 divided by 10. Okay, so / maybe with spaces in between. Then you have the text style, you've got the font asset, and so on and so forth. But we are just going to tackle the settings that we want to use, and feel free to experiment with these, okay? I'm going to give you some quick tips along the way. Don't worry about that. So first things first, I want to change the font of my text. So I'm going to click here and maybe use the Helvetica or Sublima, okay? But if we want to use the Arial font that I'm providing here, let's open the Kawaii Survivor folder, fonts, Arial. I need to unzip it. So let's show that in the Explorer. Right click, unzip, boom. Let's now open the folder and we've got a font asset. Okay, so this is a font. We need a font TM Pro. So we need to right click, create a new Text Mesh Pro font asset SDF, which stands for signed distance field. We might experiment with these later on, but for now, let's keep things simple. Let's click here, perfect. And this is the one that we can use. So let's go back to our text here, grab the SDF and drop it here. Perfect. We are now using the Arial rounded font. Cool. Let's actually rename this health text so that we don't get lost and we can actually find it later on if we want to use it by searching it, health, like so. Cool, nice little tip again. All right, then what we want to do, let's imagine first that we've got a long text. It is overflowing. This is definitely not what we want. So we are first going to click on the anchor here, press Alt or Option on Mac and click in here so that the Text Mesh Pro here stretches on the slider. Cool. Then you want to check auto size so that it doesn't overflow. So even though it's still overflowing here, it's just because we need to set a minimum size that is smaller than this, okay? Then we want to align it to the center, like so, and we can actually remove these lines because you now know way more about Text Mesh Pro. And this is already looking pretty good, huh? The only thing I want to add here is a little outline. So let's increase the thickness of the outline to something like 0.4. And we can also dilate our text so that it looks way better on the device. So maybe something like that should be good. Yeah, here we go. So adding the outline here will make sure that our text does display correctly on both dark backgrounds and light backgrounds, and light ones actually. Okay. So this is good. So what we are going to do now is add the logic to control that text. Okay, so let's go back to our player health script. And again, you should have done that because it was an exercise. And if you're not doing your exercises, you won't progress. Come on, it's not a progress bar. Anyway, so let's add a new serialized field, private text mesh pro UGUI. Let's call it health text. Here we go. So again, you can use a quick fix to add the TM Pro library, or you can press Alt Enter to directly use the quick fix. Here we go. And again, for Mac users, Option Enter. Here we go. So at start, we should have health text.text to access the text property of our Text Mesh Pro equals, let's say health plus a / with spaces plus max health. Here we go. And we should actually be good. So we are going to update the text in the start method and also right here after updating the slider. And again, in here, you can spot that we are reusing the same line of code twice. Same thing for the slider value. So maybe there is some refactoring that we can do here. Should you do it by your own or should I help you? Anyway, let's test this and then we can discuss. All right, so we can now grab our Dave character, assign the health text. So let's grab it, drop it here, hit play. Our text has been updated. That is really cool. And if we take damage, 9 of 10, 7, 6, 5, 4, 3, 2, 1, 0. DED. Again. Really cool. So we've got the health bar working. We've got the text working. I think we are good to go. All right, so what we are going to do now is refactor our code a little bit, and then we can jump to the next section, which will be about weapons. Because, of course, we need to fight back. Come on. So I told you that we were using the same lines twice here, so we can actually copy these lines here. Maybe we can cut them, and instead of adding the logic, I scrolled down. I think it was like so. Yeah, perfect. We can call the update visuals or update user interface or update whatever you want to call it. So let's call it update UI. Okay, boom, private void update UI. Like so, boom. Maybe we can actually drop it after the pass away method. So maybe we can select these, boom, 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 using the Alt key and the arrow keys. Yep, cool. Let's paste our logic in here. So we are changing the value of the slider and the text. Perfect. And we can call this method from here too. So update UI. Here we go. Let's remove this debug line. We know that this is working. We can remove the update method for now. We can remove this debug line. We can remove these curly brackets. Bam. And we can keep the debug right here because we are going to implement the logic later on. What we can actually do really quickly in here, because I can show you that actually, is reload the scene. Okay? So reloading the scene means that we are telling Unity, hey, we want to reload the sample scene we're actually playing right now, please. So we will have our enemies again and everything is going to reset. Okay? This is a technique used extensively in hyper-casual games. So you can have a look at my first course. I do use that method. So in here you can use using Unity Engine.scene management. Cool. We can debug and then call scene manager.load scene at index 0. You can actually use the index or the name of the scene. You see? Like if you write comma, you can actually use the scene name as your argument. But I'm just going to use the scene index. And just to know what index your scene is, you can select File, Build Settings, and right here you've got the scenes in build. Index 0 for this one. For big games, you might have multiple scenes, but for our case, it's a quite simple game actually. We are only going to have one scene, okay? Scenes are also generally used when you have multiple levels, maybe multiple environments, and it might make your game a little bit easier to manage. But yeah, again, for now, we are good to go. Okay, so let's test this out. So I'm going to hit play. And as you can see, by the way, our code is now really cool because it's only 50 lines long and clean. I like it. What about you? Okay, getting there. 0. You can see that the scene has been reloaded because all of the elements have been collapsed. And of course, the enemies are back. Our health is set to 10 and so on. That is so cool. You now know how to make a looping game, let's say. You can loop whatever game you have made until now endlessly. I don't know if that's cool, but I find it funny. Anyway, so in the next section, let's tackle weapons. See you there. Welcome back, guys. In this lesson, we are going to add our first weapon. That is so cool. Okay, so this is going to be a melee weapon, and next we can add a range weapon. So yeah, it's actually going to be the same behavior, almost. So let's add our first weapon here. I'm going to open the sprites folder. Let's open the weapons folder, and let's add, I don't know, maybe the Boink or Le Stab, Mr. Swingy. Let's add the Boink. Yeah, this one is pretty cool. So I'm going to grab it, drop it in our scene, press F to focus it in the scene view, and we're good to go. Perfect. So here's what we're going to do. As usual, we want to split the rendering from the actual logic. So right click, create empty parent. Let's call it the Boink. Yeah, something like that. And this is going to be the Boink renderer. Okay. So it was written the Boink _0 because again Unity thinks there are multiple sprites in here, so you can select a single or you can keep it as is. It's actually going to have the same behavior again. Okay, so we first have our renderer. Perfect. The goal now is to aim at the enemy. So let's drop the weapon somewhere around here. First off, I think that I'm going to make it a little bit smaller. So what I'm going to do is set the scale to 0.8 by 0.8 maybe. What about we rotate it a little bit? Okay, something like that. Because we will have 3 of them. I think it's still a little bit too big. So yeah, let's diminish the size of the renderer. Maybe 0.5 by 0.5 or maybe 0.6 by 0.6. Yeah, that is perfect. And again, these are just values that you can tweak. Okay, perfect. So make sure that the transform of the renderer is set to 0 for the position and also for the rotation, okay? Like so, we just want to change the scale. So here is what we are going to do now. We just want to select the deboink weapon, and what we are going to do is try to aim at the enemy. So it means that the weapon should be able to detect enemies, grab the closest one, and then align the right axis right here. Or maybe we can rotate the weapon by 90 degrees and aim or align the up vector, the green one, with any close enemy. So it should do something like this maybe. And by the way, quick tip here. You can press X to switch between global space and local space, okay? So let's say you rotate the deboink weapon. This is the local space, so the up axis is rotated, but in world space or global space, the up axis is always up, okay? So this is really useful when dealing with aiming and stuff like that. So what we want to do again is align our up vector, so the green one, with the closest enemy. So let's try and detect the closest enemy first. For that, we are going to have a weapon script. So let's open our scripts folder. We can already create a folder for all of the weapons. So right click, create a new folder, weapons. Let's open the folder and create our weapon script. So weapon, here we go. All right, let's attach our script to deboink, and open it. Cool. So first off, just to test things out, we are going to add a reference to any enemy. So let's call it, I don't know, maybe elements, serialized field, private, transform. We want the transform component of the enemy, enemy. Okay. And inside of the update method, what we are going to write is transform.up. So we access the up vector of the current transform. And the current transform, of course, is deboink's transform. So the up vector is the green one again, equals the direction from the weapon to the enemy. And you now know how to calculate directions, don't you? So try and write it by your own and then watch the solution again. Here we go. So let's write enemy.position minus transform.position.normalized. Cool. So we've just set up our up vector to always aim towards this enemy. So let's go back to Unity and give it a shot. We can select this enemy maybe. Yeah, this one. Yep. So let's grab it, attach it here. And what I'm going to do is now hit play. Okay. What I can do is also maximize the simulator. Okay. Maybe zoom in. Okay. And we can see that the weapon is now aiming towards this enemy right here. That is so cool. So you now know how to aim towards an enemy. The next step is to actually find the closest enemy instead of referencing one enemy. Got it? So let's learn how we can do that in the next one. See you there. Welcome back, guys. In this lesson, we are going to find the closest enemy and aim at it. Okay? So let's open our weapon script again. So we now know how to align our up vector with any enemy that we want. So we just need to find the closest one. There are many ways you could do that, but I'm going to show you 2 ways here. Okay? And then maybe I can make a small experiment to find out which one is the most performant. That's a really good idea. So let's start with the first one. We are first going to remove the enemy reference here. We don't need it anymore. And instead, we're going to write transform enemy, like so. Cool. And at start, it should be null, by the way. So how can we find the closest enemy? Well, we can use find objects of type. It's a mono behavior method. So we can find all of the enemies, like so. Okay. And grab maybe the first one on any one of these. Let's grab the first one, actually, something like that. So this does give us an enemy. Okay, so let's store that. or we can actually grab its transform. So dot transform. And this should be our enemy. So enemy equals this. Perfect. Why is it not working? Because we need to set up a find objects sort mode argument. So let's set it. Find objects sort mode. It should be something like that. Dot exclude the inactive enemy. So we first want to exclude the inactive enemies. So the enemies which game objects are disabled. And let's use the non-sort mode. We don't want them to be sorted. Perfect. So we now have our enemy. Let's go back to Unity and hit play, see how it goes. All right, it's compiled. Let's now hit play. I'm just going to maximize this maybe. Yeah, let's maximize it. Okay, again, it's aiming at this one. Oh, come on. Why is it still aiming at this one? Let's actually disable this boy and hit play again. Okay, maximizing. And now it's aiming at this one. Let's try and move a little bit. Yeah, it did find the enemy. That is so cool. Okay, so we now need to find the closest one, right? So this method does return an array of enemies. So we can already store them. So enemy, boom, enemies equals this. Let's remove the transform and the index. Cool. So we now have an array of enemies. Okay, how can we find the closest one? Here is a quick way you can do that, but you can actually go and ask ChatGPT for a sorting algorithm. We could use lists, but let's use an easy way here. So first off, we are going to set up an index, the index of the closest one we've found. So closest enemy index. And let's initialize it to -1. Why -1? Because it will help us check if we've found an enemy or not later on. Because of course we will need to use a range value. The melee weapon won't have an infinite range. So if the closest enemy is further than, I don't know, maybe 3 units, the weapon should not aim at anything. Got it? Then what we want to do is set up a minimum distance. So float minimum distance equals, let's say, 5,000. So make sure to use a really high value here so that you make sure that the first enemy you find is within that range, okay? And you can use the maximum range here actually to detect if you have enemies or not. But let's do it step by step. Okay, so after that, let's loop through all of the enemies. So from I equals 0 to enemies.length. We are going to check if the first enemy or the enemy at index I is within this distance, or if the distance between the weapon and this enemy index I is less than the minimum distance. If that's the case, we want to store that enemy as the closest one. Otherwise, we can skip and check the next one. Okay? So the enemy we are checking, let's say enemy or enemy checked equals enemies at index I, like so. Perfect. So we first want the distance between the enemy and the weapon. So float distance to enemy equals vector2.distance between transform.position and enemy checked.transform.position. Here we go. This will give us the distance between the weapon and the enemy. Then we can check if that distance is less than a minimum distance. So if the distance to enemy is less than a minimum distance, it means that the closest enemy index equals I, like so. And we also need to update our minimum distance so that the next enemy will need to actually have a distance less than this one, the one that we've just checked, okay? So minimum distance equals distance to enemy, like so. And these lines of code will make sure that we grab the closest enemy. If you don't get this right, please feel free to leave a comment under this lesson and I'm going to try and answer and help as soon as I can. But I'm sure you got this. All right, so at this point we can check if the closest enemy index equals -1, it means that we did not change the value right here, so it means that we did not find any enemy. So what we can do is simply maybe return or maybe set transform.up equals vector3.up so that we align the up vector of our weapon to the world up vector. Okay? You can do whatever you want here. You can align to the right or to the left or to the bottom. I've just decided to align it to the top. Okay. So let's go back to Unity, select the weapon maybe, hit play just to give it a shot. I'm going to double click here and we are getting an error already. What's that? Object reference not set to an instance of an object. So let's open our script and check what's wrong here. So I'm just going to exit the play mode, double click here. Line 43. Transform.up equals this. Of course, we are getting an error. Why? Because we haven't set our enemy. It's still null. So what we need to do in here is write enemy equals enemies at index closest enemy index dot transform, because this is an enemy. So we just need to grab the transform component of that enemy. Got it? I'm just going to test this out and then I'm going to show you an easier way of writing this. But I just want you to understand the logic first. Got it? So let's go back to Unity and we should not have the error anymore, hopefully. Let's hit play. All right, no errors. So let's open the simulator. Okay, cool. So it's now aiming at the closest enemy. Now it should aim at this one. Yeah, that is what I like to see. Let's try and switch the enemies now. Boom, this one. And maybe it should be this one now. Yep, so cool. So you're now able to detect the closest enemy. That is so nice. Let me show you how we can clean our code a little bit now. So we are storing the enemy right here. Okay, what we can do is actually remove this line. We are just grabbing the enemies. All right, perfect. And at this point, what we can do is actually grab this line and drop it here. That's one way of doing things. So we can just remove this, but it makes for a really long line and I actually don't like that really much. But what we can also do is keep a reference to our enemy. So closest enemy here equals null. Instead of keeping a reference to the closest enemy index, we can remove this. And in here, store the enemy. So enemy checked, enemy checked. So the enemy we've checked is the closest one if the distance complies with the check, okay? And then we can actually check if the closest enemy is null. And if that's the case, just use transform.up equals vector3.up. But otherwise, we can use closest enemy.transform.position for the position. Yep. So let's now go back to Unity and check if it's working correctly. Hit play. And seems like it is because we're not getting any error. The weapon is aiming. That is so nice. Let's try and aim at this one, please. Yeah, so cool. Yeah, we got it. So this is one way we can grab the closest enemy, okay? In the next one, I'm going to show you another way. We are actually still going to use this distance check algorithm, but we are not going to search for all of the objects by type because it might not be as performance friendly as the other method I want to show you. So see you in the next one. Welcome back, guys. In this lesson, we are going to tackle the second method that will allow us to detect the closest enemy. We're actually going to try and detect enemies in general because we already know how to grab the closest one. Okay, so first off, let's add a range property to our weapon here. So let's open the weapon script, header, settings, serialize field, private float range. Here we go. So you already know how to display gizmos, so quick exercise. Try and display a gizmos for the range here. I'm going to do it really quickly. You can hit pause. So private void on draw gizmos like so, maybe selected. Yeah, let's actually use the selected one. Selected gizmos.color equals color.magenta and gizmos.draw wire sphere transform.position range. Here we go. This is how we draw a gizmos again, just as a reminder. So let's go back to Unity, select deboink, range, something like that. Yeah, maybe two, maybe 3. Yeah, let's detect enemies within this range. Perfect. We can now go back to our script, and here is how we are going to detect enemies here. First off, we are going to set a layer mask for our enemies. This will help us detect enemies using colliders. So serialized field, private layer mask. Let's call it enemy mask. Okay, here we go. Now let's go back to Unity and we should see a layer mask property. Perfect. So right now it's set at nothing. That is okay. We are going to add a new one. So let's select layer, add layer, and let's add an enemy layer, like so. So we can now select the boink, the weapon again, and select enemy right here. So this will make sure that we only check for game objects or physics objects within that layer. Okay, so we first need to grab our enemy prefab. So let's select it to open the prefab here and set it under the enemy layer. We can actually change its children too, but that's okay. We are only going to use this game object. And the next thing we want to do for the enemy is add a circle collider 2D. Cool. So this will make sure that we are able to detect it using physics. So we just need to rearrange this a little bit. So I'm going to grab it somewhere around here. And again, I'm using a circle collider because this is the most performant. You know that now if you've watched the fun physics experiment. But you could use a capsule collider if you want more precise detection, of course. What we can do is actually bring it down a little bit. Yep, this should be good actually. Yeah, perfect. So let's now go back to our weapon script. And by the way, all of the enemies now have the collider. This is the power of prefabs, of course. You know that now, right? Awesome. So let's go back to our weapon. We've got our enemy mask set up correctly. So we are just going to change this logic. So I'm going to hit Control D to duplicate this line, comment this one, and instead of using this method to find enemies, I'm going to use physics2d dot overlap circle all. And this method does return an array of colliders using a point, a radius, and there is an overload method that allow us to use layer mask so that we only detect enemies. So let's do things one by one. The point is the center of our overlap circle, so it's transformed at position. The radius will be our range and the mask will be the enemy mask. And this will return an array of colliders, of course, so we can store that inside of here, collider to D, perfect. When checking right here, we know that our enemy's eye is a collider 2D, but also has an enemy class or component attached to it. Why? Because we've used the enemy mask. So we will make sure that all of the game objects that are under the enemy mask do have an enemy class. Okay? So we can write .get component of type enemy, like so. Perfect. So for the minimum distance, we can also set the range because we're actually going to detect all of the elements or enemies within that range. No need to use 5,000 for the value. And we should be good. So let's go back to Unity and try this out. Okay, so everything should be set up correctly. Let's just hit play. I'm going to maximize this. Okay, and yep. Now that the enemies are within the range, the weapon is detecting them. But if they go too far from the weapon, 1, 2, 3, yep, it's aiming up again because they are not within the weapon range. Got it? That is so nice. And of course, we can make the transition between the two vectors smoother, but let's keep that for the next one. Quick thing here. We can actually check if this method did return something. So if enemies dot length is less or equal to 0, we can simply aim up and return because it means that we did not find any enemy within that range. So no need to go through all of these steps, okay? Even though if the enemy's length is 0, we are actually not going to set the range and so on, but I just wanted to show you that. So see you in the next one. Welcome back, guys. In this lesson, we are going to lerp the movement of our weapon here because we've seen in the previous one that it was actually switching from one direction to the other and it was really not pleasant to the eye. So let's open our script right here, the weapon script, of course. In here, we are managing the up vector, right? So right now we haven't refactored yet. Let's remove this line, by the way. But of course, we are going to refactor later on, just after doing that. So yeah, transform.up equals this. So this is actually the target direction if we've found an enemy. So let's store that. So vector2 target up vector equals this right here. Boom. If we've found an enemy, of course. So it means that if we haven't found any enemy, we should lerp to vector3.up, right? So this should be our target up vector. So what I propose to you is to grab this line, drop it here, and initialize this value to be vector3.up. That way, we can use it right here, and we can also remove this and use it right here. Perfect. So now we just need to use the lerp method to lerp between the two vectors, so the current up vector and the target up vector. So what we can write in here is transform.up equals vector3.lerp between the current vector, so transform.up to target up vector, and t here is our interpolation point. I'm just going to show you how it works and then explain how you can use lerp, okay? So in here, we are just going to use time.delta time times a certain value. Let's say, let's make it a variable actually. So rotation lerp, or maybe aiming lerp, aim lerp actually. Cool, like so. Let's now create a variable called aim lerp. We can actually create a new header for animations, something like that. Serialize field, private float, aim lerp. Here we go. We can then comment this line because we are using this one to configure our up vector, and we can also drop it right here. Here we go. So right now we are using the same line of code twice, but don't worry, we are going to refactor just after that. Okay, so let's try this out. Let's go back to Unity, set up our aim lerp to a certain value, and then, yeah, we can give it a shot. So let's use a value of, let's say, if you're running at 60 frames per second, maybe we can use 60 divided, or maybe times .101, something like that. Let's hit play and see how it goes. So I'm going to play that. Okay, maybe we can make this one bigger. Okay. Yeah, this seems too slow to me. Yeah, definitely too slow. So let's write 6 here. Okay, that's already way better. And if you want to make it more responsive, maybe 12, so twice as responsive. Yeah, it's actually way better now. Okay, let's get them further, but not that close, not along the y-axis. So let's bring them down. Try and aim. Thank you. Okay, let's get them further now. Yeah, that is way better. So 12 seems like a really good value. And again, you can tweak these values and make them your own, balance your game as you wish. Come on. Okay. So this is one way of doing things. We now need to refactor our code so that it's actually easier on the eye, because a method that is 30 lines long is not really optimum. And on top of that, it's inside of the update method. So we are going to split it in two. We are going to have an aim method and another one to grab the closest enemy. So let's create the closest enemy one first. Private. It should return an enemy. Get closest enemy. Here we go. We can grab all of these lines, I guess. Yep. Okay. Let's drop them here. We don't need the target up vector in here. We are going to use it later. Inside of here, I don't want to set up our transform up vector, sorry. Let's remove this. If we did not find any enemy, we are going to return null. Okay, that is already way better. Then we can just return closest enemy. And if it's null, it's going to return null. So we are covering all of the cases here. Null, or if we've found anyone. Perfect. So this is already one thing done. Inside of the update method, we can call the auto aim method. Okay. So private void auto aim, like so. Cool. We can remove the logic related to the enemy. So let's remove this, this, all of this. Boom, boom, and I think we are good. Yeah. So enemy, closest enemy equals get closest enemy. Perfect. This is already way cleaner. Then let's think about it a little bit better. So our target up vector, we need to reference it. So let's grab it, drop it here. At first, it should be vector3.up. And of course, we always want to lerp. So we can grab this line and drop it here. But in between, we need to check if we've found an enemy or not. So if closest enemy is different than null, then the target up vector will be the direction to our closest enemy, like so. Cool. Otherwise, we are just going to lerp towards the up vector. So cool. Okay, so we can now remove these lines from here, and we are left with the auto aim method. And our code is way easier to read now. That is so nice. Always try and keep your code clean at almost each point of the development. It will make your development easier. And one thing that we forgot here is to commit our changes as usual. I always forget. I don't know how. But anyway, what can we write here? Many changes. Let's write player health. Let's write weapon attack, weapon aim, sorry. But we can also write in the next
Section.
we need to add weapon attack, please. Let's go. Let's commit the changes and we can meet in the next one so that we can actually add weapon attack. If you want more info on linear interpolation, I'm going to leave 2 links in the description. So the first one is a link to desmos.com, and it will allow you to play with these values. So you have 2 points here, and the red point is the linear interpolation between the first one and the second one. So you can play with the t value that we have used right here. So this is the third argument. And you can also move your point. So it will give you the exact value where it should be, depending on your t value of yours, of course, of the interpolation value. And if you want to go even deeper, you can watch Freya Holmer's video. It's an amazing video, actually. If you've got 1 hour and a half of spare time, you can watch it, and it does contain a bunch of information on linear interpolation and Bezier curves in general. It's really interesting. I highly encourage you to go watch it. Welcome back, guys. In this lesson, we are going to tackle weapon animation. Okay, so first off, let's create a new game object that will hold all of our enemies. So let's call it enemies. Yay! Let's drop all of the enemies inside of this game object. Cool. And we can now tackle our animations. Perfect. So the first thing we want to do is select our weapon and add an animator component. Perfect. So in Unity, the animator component is actually what controls animations for specific objects. Okay. So the only thing or property we are going to tackle in this course is the controller. Okay. The avatar, root motion, and so on are generally used when you want to animate humanoid characters. Okay. And in our case, we are not. We might add feet and hands to our character, Dave, and to ghosts maybe later on. I don't know. Let me know if you want to learn how we can do that. Okay, so let's jump back to our stuff here. We are going to create a controller for our weapon. So let's open our Kawaii Survivor folder and create a new folder that we are going to call animations. Here we go. I'm going to create a new folder for the weapon animations. So weapons, perfect. Then I'm going to right click and create a new animator controller. Cool. Let's call it weapon controller. Here we go. I'm going to select my weapon here and grab the controller, drop it inside of here. Perfect. Our controller has been attached to the animator. We can now select window, animation, somewhere around here, and animation. Cool. This is the animation window where we can set up our keyframes. So I'm going to grab it and dock it next to the simulator. Perfect. I'm also going to add the animator window. So can I add it from here? Add tab, animation. I can't add the animator. So I need to add it from here. Animator. Here we go. So this is where all of our animations are going to display, and this is where we are going to actually set up our animation with keyframes and so on. So let's do things step by step. One quick tip that I can give you here is to create a new layout for your animations. So let's save this layout actually. I'm going to save it under landscape maybe? I don't know. Yeah, let's save it under landscape. So landscape, here we go, save, and of course I want to overwrite. Perfect. I'm going to keep the inspector, but I want to remove the console for now, or maybe just dock it somewhere around here. Okay, cool. Let's grab the scene, and the animator should be somewhere around here, let's say. Yeah, this is decent. Okay. We can remove the tile palette, and we can keep the game window just below the scene or next to it. Let's dock it next to it to have our animations here. Okay. This seems like a decent layout, but of course, make sure to set up your layout as you wish. Then we can save it. So save layout, animation, or maybe kawaii animation, because I already have an animation layout here. Is it better? Nope, I don't think it is. So let's use the kawaii animation layout. Perfect. All right, let's select our deboink weapon again. And I'm annoyed here because I want to have the inspector too. So yeah, here it is. So let's create a new animation for our weapon. So let's create an animation clip and drop it inside of the animations weapons folder. Let's call it just attack for now. Save it. Cool. Once you've hit enter, you can spot your animation inside of the animator window. And right now, if you double click it, it's actually looping. Okay. So if we set up our animation, it's going to loop. So let's jump to our scene view, select deboink here, and add our first keyframe. So to add it, we first need to record. So we need to hit this small little circle. Nice. We are now recording. Okay, so we want to animate the rotation of our weapon. So right now I'm going to show you the bad way of doing it, the really bad way, okay? So let's right click and add a keyframe to the rotation. Okay, next I'm going to jump to, I don't know, maybe 1 second and copy this keyframe, Control C, and paste it here, okay? Then at the center of the animation, I don't know, maybe let's go funky and use this angle like right here. So if I hit play, boom, our weapon is going to animate like so, okay? Let's say that we also want to change the position of our weapon. So at start, it's going to be here. So let's add a keyframe. Okay. Let's add the same keyframe at the end of the animation so that it does loop correctly. Perfect. But at the center of the animation, I want to have it a little at the top and maybe do kind of a rotation. So maybe we can have it somewhere around here at this point, maybe on the right here. Okay. So let's have a look at the animation now. Okay. Yeah. That's a decent animation. It's not as good as I want it to be, but it's not the point here. I want to show you the bad way of doing things first so that you can learn the good way. Okay, so we now have our animation. Perfect. If we jump back to our scene and hit play right here, let's have a look at how it's going to behave. So it's animating, okay, but seems like it's not aiming anymore at the enemies. Why? The enemies are still within its range. So this is not the issue. The issue here is that we are controlling the rotation of our weapon with the animation, and it does override the actual aiming that we are using inside of our script. This is really bad. Moreover, if we were to add our weapon to Dave, so the character here, just for it to move with Dave, okay? So let's say we want it somewhere around here, maybe 1.5, or maybe just 1 and 1 for the y-axis. Okay, somewhere around here. Or maybe 2 actually, so it's a bit above. If we hit play, so normally it should move with Dave because it is one of its children, right? But if I try and move, look at how it behaves. Really weirdly, huh? Moreover, we are hitting Moreover, we are getting collisions between Dave, because Dave has a collider, and the enemies. We are going to fix that later, don't worry. But this is not the point. Right now, the weapon is behaving really weirdly. This is again because the animator does override the position of our weapon. So if we play, boom, it has jumped to really far, to 7 and so on. So to the values that we've actually saved. So in the next one, because now you know how to use the animator, right? And of course, before jumping to the next one, make sure to have fun with the animation, so the keyframe, and also the curves. I did not show you that, but you can actually edit the behavior of the transition between the keyframes. And we're actually going to use them later on to have a nice circular animation. Okay? So yeah, first off, have fun with these, then jump to the next lesson where we are actually going to learn how to properly use animations. See you in the next one. Welcome back, guys. In this lesson, we are going to check and learn how we can actually use or set up proper animations. Because in the previous one, we've learned the bad way of doing things, and it's not that good. So yeah, in this one, it's actually going to be better. Okay, so the first thing we want to do is to unparent the weapon from Dave. Okay, I'm going to disable the preview mode and press F to check out my weapon. Where is my weapon? Here. Click here. Here we go. Here it is. Okay, perfect. So right now, the animation is animating the boink, okay? So what I'm going to do is remove these keyframes like so, just by pressing the delete key. But what I'm going to do now is right-click and create an empty game object. I'm going to call this one animation parent. Here we go. Then what I'm going to do is grab the render and set it as a child of the animation parent. So now we can animate this boy right here, okay, without touching the actual game object. Okay, so let's set this to 0 because we are going to manage the Z rotation with the auto aim feature or method, and we can start animating our animation parent. So let's try and make it pretty now. I'm going to select the boink weapon and click on record to record our attack animation. But I'm not going to add a keyframe to the boink now. I'm going to add keyframes to the animation parent instead. So let's add a keyframe for the position and for the rotation. Perfect. What we are also going to do is actually exit the preview mode and record mode and move the render up a little bit by, let's say, 0.5, so that the handle of the weapon is actually at the center of the animation parent. You can press W and check out the pivot here. Make sure that you are selecting pivot instead of center. Quick tip, you can press Z to switch between the pivot and the center. I don't know if I've already told you that, but anyway, it's a reminder if that's the case. All right, so now that this is correctly set up, we are going to select our deboink weapon, press the record button, and grab these keyframes, move to 1 second, somewhere around here, and add these same keyframes. So Control-C, Control-V. Okay. Because having an animation of 1 second will make it easy to set up our attack speed and so on. Because there is a speed property attached to the animator. And we are going to tackle this later on, don't worry. But first off, let's record our animation again after selecting the weapon. All right, so we are starting from here and we are ending at the same position. What I'm gonna do is move to 30 keyframes. And of course here, I'm going to try and make a really cool animation, but feel free to experiment here and do your own animation. So I'm going to move it to, let's say, 3. Is it too much? Maybe 2.5? Yeah, so this is going to be the range of the weapon here. So 2.5 seems correct. And we can actually still change it later on. So 30, half of it is 15. So we need to move to minus 2.5. Or maybe minus 2, but we're going to check that later on. 2.5 for here. Or maybe, how does it look like? Oh, no, that's not the circle. Come on. So minus 125, is it better? Yeah, it's already way better. So in here, it should be 1.25, perfect. So now it looks like a circle. I just need to set up the keyframes. So for that, I'm going to switch to curves and select the X position. Okay, perfect. I'm going to hit Control A or Command A to select all of my keyframes and press F to focus them. Cool. So right here, I can play with the tangents now. So let's actually make this tangent a bit better, something like that. What about this one? Okay, here we go. Is it better? Let's have a look. Okay, already way better. I love it. Yeah, I think we're good. What if this one is actually linear? Yep, this is a cool rotation. So now it's describing a perfect circle. Nice. Okay, so this is good for the position. So now let's tackle the rotation. So at start, it should be 0. Or maybe I'm actually going to set this to 30, 35 degrees, something like that. Okay. And at the end of the animation, it should be 35 too. Okay. I'm just thinking about it a little bit here. You know what I'm going to do? I'm going to try something funky here. So the position should be set at start. So we are going to wait for 10 frames and we are going to start from 0. And at this point, we're going to switch to, let's say, I don't know, maybe 150. Bam! Like so, okay. What about the position? So 10 keyframes again. And right here, we should be at 0. But right here, how much? 150. Okay, so maybe minus 150. What about this? It's actually pretty decent. Yeah, that's okay. Maybe 150 is a little bit too much. So what about 90 degrees? And maybe here, minus 90 degrees. Boom. Yeah, I'm not the best one at making animations. I'm sure that you are going to do it better than me. So please feel free to do so and share with the community. Okay, so this is okay for the animation. We can exit the record mode, okay, and turn the deboink weapon as a child of Dave now. Okay, so we are going to set the position to 1 along the x-axis and maybe 1 along the y-axis. Let's press F to check where it is. Maybe we should use 1.5. Here we go. So that we can add more later on, maybe one at 0 and the other one at minus 1.5, something like that. So yeah, seems correct. We can check that later. Let's just test things with one weapon now. Okay, so what should happen here? We've got the auto aim feature attached to the weapon. Okay, so the weapon should always try and aim at the closest enemy. And then we also have the animation. So if the weapon is aiming in that direction, something like that, it should actually animate like so. Okay. So this is what should happen, and this is why it's always a really good idea to separate your logic from your rendering. Again, I won't stop saying that. Okay, enough fluff. Let's test it out. Okay, game window. Yeah, that's what I like to see. So now it's not detecting any enemy. That's why it's rotating that way. But when we detect enemies, it's actually trying to rotate in their direction. That is so cool. Okay, whoa. Okay, now it's starting to be funny now. Okay, so that's really nice. I can't wait to see the animations you'll come up with. But yeah, in the next lesson, we are going to learn how we can actually detect enemies with the weapon and damage them a little bit. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are going to learn how our weapon can now detect enemies and damage them. Okay, so first off, we are done with the animation, so hopefully we can switch back to our normal layout, landscape. Perfect. I'm going to remove the animator, or no, let's keep it here. Okay, so let's select our weapon. Here it is. We are going to open the script and add a detection position. So basically what will happen here is that we are going to add a point somewhere around here at the top of the weapon maybe. And this is going to be the center of our detection radius. So while animating, so while playing the attack animation, we are going to check if there are any enemies at this position within a certain radius, of course. And if that's the case, we can call the take damage method from the enemy script. Okay, so right now, I don't know if we have that method yet. We have the attack. No, we don't have that method, but we will add it. Don't worry about that. Okay, so first things first, let's add a point at the top of the weapon here. So again, it should be a child of the animation parent so that when we play the animation, the point is actually following the render, okay? And to make sure that it's following the render, you can actually turn it into a child of the renderer. So let's right click, create an empty game object. Let's call it hit detection position flower power. Okay, for those of you who got it. And what I'm going to do here, because I can't spot, but let's say that I can't spot where my hit detection position is select right here, the small icon, click it and select, let's say, the red icon or gizmo. And that way I know where my detection position is. Perfect. That is so cool. And again, you can scale up or scale down all of your gizmos. Cool. So now that I've got this, I'm going to open the weapon script and add the logic that we need here. So first off, we need a reference to this position. So let's add a new header, for the elements, let's say. Serialize field, private transform, not transfer function, but transform, hit detection, pause, or maybe transform. Like so. Yep, cool. So we can already jump back to Unity. And one thing that I want to note here, you might say that the radius that we are using to detect enemies is not at the center of the animation, right? That's okay, because we are going to detect enemies right here before actually hitting or playing the attack animation. And when we get at least one enemy, then we are going to play the animation and we are not going to take the detection radius into consideration. So that's okay. Don't worry. All right, let's add the hit detection position. Perfect. Now we can go back to our script. Cool. And what are we going to do with this hit detection position? Well, we can already add an attack method. Okay. So private void attack. So right now we are attacking continuously, but of course later on we are going to wait for a certain time. So the attack rate of the weapon and then attack. So what are we going to do in this attack method? Well, we first need to detect enemies, and we know how to detect enemies. We've done that before. So we can grab this line, paste it here, but instead of using the transform.position as the center of our detection, we are going to use the hit detection transform.position. Cool, that's one thing. Then what we want to do is change this range right here, because we don't want to hit enemies maybe 2.5 units far. I don't remember. Oh, it was 3. So 3 units far. We don't. We only want to hit enemies that are nearby the weapon here. So let's add another variable, serialize field, private float, hit detection radius, let's say. Okay, we can grab this and drop it here, of course, and we can also add that to the gizmos. So gizmos.color, by the way, it can be a nice exercise. So I am gonna let you do it. Pause the video, please, and try and add that. I'm gonna add it now. Color.red, let's say. And by the way, you can set up a custom color by writing new color, and you can use the RGB values, or you can use color.hsv to RGB if you want to use HSV, so hue saturation value instead of RGB. That's another quick tip here. Okay, so color.red, gizmos.draw wire sphere at not transform, but hit detection transform.position. And we need to use the hit detection radius. Here we go. So let's jump back to Unity. Okay, perfect. I can already, come on. Here we go. Let's increase the detection radius. And indeed, you can notice that even though we are animating the weapon, we are going to detect from this position using the detection radius that we've specified. So let's say maybe dot 3 is actually decent. And we can actually bring this down if we want, somewhere around here. Yeah, that's actually fair enough. Yeah, let's bring it up actually. Yeah, where it was. Cool. So this is the radius within which we are going to detect enemies to destroy them. Okay. And yeah, what we are going to do now is just destroy them, actually. So that's going to be cool. Okay, so let's try this. For I from 0 to enemies.length, we are just going to write destroy enemies at index I.gameObject. Let's try this. Is it going to work? I let you think about it. So let's go back to Unity. I'm going to hit play. Where is my simulator? Okay, let's move. Oh, yeah. Come on. Hit it, please. Yeah, nice. The other one. Yeah. Another one. Come on. You can't miss this. Yeah, that's working really well. That is so cool. Awesome. So we now know how to detect enemies, attack them, destroy them, actually, not only attack them. And yeah, I think you've already learned a bunch of elements in the last 3 lessons, right? So please, if you like the course so far, leave 5 stars or leave a review or something. It's helping a lot. You can't imagine. Thank you so much. And in the next one, we are going to learn how to actually damage enemies instead of destroying them. Because we are kind, come on. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are going to learn how our new weapon can damage enemies instead of destroying them. Come on, we must be cute from time to time. This is a kawaii game after all, right? So yeah, let's do that. For that, we are going to open our enemy script, okay? Nice. And inside of here, we are going to add a new public. Why public? Because we are going to call it from the weapon. So public void take damage, int damage, like we've done for the player. Nice. Later on, of course, we are going to use another logic, but right now, let's keep it simple. Okay, so now our enemy can take damage. So we are going to jump to our weapon, and instead of destroying the enemy right here, we are going to call enemies at index I dot get component of type enemy, okay, dot take damage. And of course, we need to pass in our damage. Nice. So we now need to add a damage property to our weapon so that we know how much damage we should deal. So let's add a new header, I guess, for the attack. Yep, like so. Serialize field, private integer, damage. Cool. This is one thing. So now our weapon can damage enemies. Let's jump back to the enemy script now. Inside of here, we need to diminish the damage value from the health of the enemy. So we are going to apply the same logic that we've used inside of our player health here. We will need a max health for the enemy and a health field. So let's grab these 2 lines of code, jump back to the enemy script. Okay, somewhere around here we can drop the health value or header. Boom. Let's remove the settings header. We've got a max health and a health. So what we are going to do at start is set up our health equals max health. You now know how to do that. Come on, we've done that inside of our player health. So that's why I'm rushing a little bit. Okay, health equals this, and inside of here, same logic that we've used again. We are going to grab the real damage just to prevent having negative values, even though this is not compulsory because we can check if it's less than 0, boom, destroy the enemy or pass away, okay? So let's paste these here, perfect. Health minus equals real damage. If health is less or equals to 0, what we're going to do is pass away. Cool. So we've got the particles, we've got the destroy logic. I think we are good to go now. So should we try this out? I think we can. Let's do this. Okay, so I'm going to select the enemy prefab first because we need to set up the health of our boy now. If Unity wants to reload the domain, of course, as usual. I'm losing patience here.
1 eternity later.
All right, finally. So let's select our prefab, double click it, and change the health. Let's set it to 10 too, okay? So we are not going to be able to spot the health of the enemy. So what we're going to do again is use gizmos. Exercise. Using gizmos, display the enemy health on top of its head. Okay, it can be dirty a little bit, that's okay. No need to write clean code for this because we are going to remove that after all. But yeah, try and display the health of our boy here on top of its head. Okay, I'm gonna do that right now. So let's open our enemy script. Gizmos is right here. So gizmos.color equals color.white, let's say, so that it does, or maybe, yeah, white, so that we can spot it inside of our scene. So gizmos.label. Oh, there is no label. Text. There is no text. That was a joke. You need to do it in another way. So instead, we are going to use a text mesh pro, of course. Okay, let's add that. So again, I'm kind. I'm going to give you maybe 5 minutes so that you can do that and then come back to watch the solution. All right, so using TM Pro to add the text mesh pro library. Then we need to add a text to render our health. So serialize field, private text mesh pro, health text, let's say. Okay, perfect. So just before we used text mesh pro UGUI because the text mesh pro was inside of a canvas, but there is another component that you can use in your world, which is the text mesh pro component. And right here, maybe at start, yeah, maybe at start. So health text equals health.toString. We can use the toString extension to display the health. Okay. Same thing right here whenever we take damage. Perfect. So now we can jump back to Unity, create a text, drop it on top of its head, and reference it inside of the enemy script. So right click, 3D object, text mesh pro. Okay. We can set the width and the height to 1 by 1, drop it on top of its head. We can actually change the font to Arial rounded. Let's diminish the font size to something like that maybe. Center the text again. Maybe we can try a value, maybe 50. Yeah, nice. I like it. Let's actually diminish the size of the text mesh pro here. So something about that should do. It's actually quite small. Maybe let's make it bigger so that we can spot it inside of our game view. Yeah, I like it. We can rename this health text, but we are actually going to remove it. Don't worry, it's just for testing purposes. There actually are some gizmos methods that you can use made by people from the community, okay? Or you can ask ChatGPT, but it's a little bit more complex than simply using gizmos. You need to use handles and the GUI class. We might check how we can do that later on, but yeah, remind me, please, if I forget. Okay. So this should be set up. We've got our text, we've got our health. We are going to hit play, and hopefully it should be working perfectly. Okay, let's try this. What about this one? Okay, 10, 10, 10. Looks like we are not damaging the enemies here. Did we call the take damage method or not? Let's go back to our script. Weapon, okay. Attack, take damage, of course, all right. Real damage equals this. Oh, the weapon damage I think is 0, right? Yeah, of course it is. So let's set the damage to 5. And there is also one thing that we need to check, but one step at a time, one thing at a time. Okay, let's try and attack this enemy. And boom, no. Nope. Oh, yeah. We've destroyed it. Same thing for this one. So what did happen here? We attacked the enemy only once, but he died. So we should have inflicted 5 damage, right? Okay. So here is what happens here. This is because we are actually detecting the enemy multiple times. So we need to keep a list of all of the enemies that we've attacked, if, of course, this is the behavior that we are looking for. But in this game, it is the case. So we only want to attack the enemy once at a time, okay? Once by sweep. Got it? So in the next lesson, let's learn how we can do just that. Welcome back, guys. In this lesson, we are going to improve our weapon attack drastically, because in the previous lesson we've seen that we were able to attack the same enemy multiple times in one sweep. This is not what we want, and we also don't want to allow our weapon to play the attack animation in a loop. Okay, to loop the attack animation actually. So let's tackle this one thing at a time. Let's tackle the loop first. Okay, so the first thing we want to do is select our weapon, open the animator, double click on the attack animation right here, just to open the animation clip details and uncheck the loop checkbox. Cool. So right now, if we hit play, it's not going to loop. It's going to play once and then stop. Let's have a look. Boom, it stopped. Perfect. So now we don't want it to play at start. So we need to add a dummy animation. For that, we are just going to right click, create an empty state, right click on the empty state and set it as the default layer state. Cool. So at start, the animator will play the new state, which is empty. And let's actually call it idle. And whenever we want to play the attack, we are just going to call animator.play attack. As simple as it gets. But just after playing the attack animation, what we want to do is jump back to the idle animation. So for that, we need to create a new transition. So right click, make a transition to the idle animation. Perfect. If you click on the transition right here, you have multiple settings you can play with as to know the duration of the transition. So let's hit play here. Okay, you can actually decide to switch to the idle animation right after it is complete, like so. Cool. And you can also to disable the exit time if you want to use conditions to switch from one animation to the other. But right now we are still going to use the exit time field. All right. So right now, if we hit play, nothing should happen. Our weapon should stay at its position. And that's the case. Yeah, it's aiming at the enemy, but it's not animating at all. It's still attacking. You can go like that, but of course you are going to disable that. Don't worry. You can actually add a really cool weapon. It can be a nice thing here. Maybe you can add a taser that's actually waiting for an enemy to be hit and then it's hitting it continuously. Yeah, that's a really good idea. Again, remind me if I forget. Okay. So, next, let's open our weapon script. And inside of here, we are going to add two states. So there is going to be the idle state and the attack state, right? And one way to add states to any script that you want is to use enums, enumerations. They are just a fancy way of using integers, but you can actually give them literal expressions. So here's how we are going to do. Let's create the enumeration first. So enum state, and we need to define our two states using curly brackets. You can actually go to the line for a prettier definition. So idle and attack. These are our two states. So now we need to create a state variable with that type. So private state. Cool. At start, we want to set the state equals state.idle. And if you hover over the idle word here, you can notice that the value 0 has been given to the enum value idle, and attack is 1. Okay? So if we add another one, blah, blah, let's say it's going to be 2. Got it? Perfect. Here we go. So at start, our weapon is idle. And inside of the update method, we want to take that enum or that state and do stuff depending on its value. If you want to use fancy designations, this is a state machine. Okay? So switch state. Okay, boom, boom, boom. Did we use switch statements before? I don't think we did. So let me explain really quickly. So the switch statement takes an integer or an enum in our case and chooses a path depending on the state or the value of that enum. So to use it, you write the case keyword state.idle, then you want to break after that, and you can add all of the cases of your enum here. So in case we are inside of the attack mode, break. Okay? So this is basically a fancy if condition, if else, else if, and so on. Okay, this is more suited for enumerations. So in case we are in the idle state, we are going to auto aim. Okay, but if we are inside of the attack state, what we want to do is play the attack animations and manage enemy detection. So for now, let's simply write attack state. or maybe just attacking, something like that. Okay, let's create this method really quickly. Up, and we're good to go. Cool. So we are going to have 3 situations. At first, we are just in the idle state, so we need to start the attack. So let's add our start attack method, like so. This is where we are going to call the animator and play the attack animation. Then we are going to be inside of the attacking state, and after that, we are going to end our attack, so stop attack. The start and stop method will help us detect or store all of the enemies that we've attacked previously and prevent hitting them twice. Got it? So let's proceed step by step. Inside of the start attack method, what we want to do first is play the attack animation. So we need to call animator.play attack, like so. So let's add a reference to our animator, maybe somewhere around here, serialized field, private animator. Perfect. Now let's go down here. We also want to switch from the idle state to the attack state. So state equals state.attack. Perfect. And we will also want to clear the enemies that we've attacked, but one thing at a time. Inside of the attacking method, what do we want to do? Well, we want to attack, of course. So let's grab these lines of code, or maybe just call the attack method, like so. And we will also have the logic for adding the enemies that we've attacked in our list, okay? So let's keep it like so for now. And when stopping the attack, we simply want to set the state to idle again, so that we can auto-aim and so on. So right now we are not going to use delays or timing for starting the attack. We are simply going to add a button. And there is a cool library that lets you do just that, and that's the Naughty Attributes library. So for that, we need to add the Naughty Attributes library first, of course. So let's go back to Unity, Window, Package Manager, and of course, I'm going to leave a link to the asset store for that library. Okay, so let's search for Naughty here. Here we go. Let's import the library, import everything. Here we go. And once that's done, we can close the window, go back to our script, reload the environment, of course, because it has added a new assembly. We can learn about that later too. And add our attributes. So let's add the brackets, naughty attributes.button. As simple as it gets. And this attribute will add a button inside of our inspector to start or to call this method. It does use reflection that I've taught in one of my courses. I think it was the Sigil course, if you want to have a look at it. This is a really powerful tool, but it's advanced C#. So yeah, if you're just starting out, don't bother looking into it. Okay, so now if we select our weapon, we have a button to start the attack. Nice. Let's add a reference to our animator. Boom, like so. Let's hit play. And now if we click the button, boom, it's attacking. Okay, let's go out a bit. Attack, nice. Attack, yeah, here we go. Whenever I click the button, it's attacking enemies. Really cool. We are still attacking the enemies even if we are not doing things. So this is because we are never stopping the attack. So the state is always state.attack. At first, we are in the idle state. So even if we hit an enemy, we should not be able to damage it. Yep, that's what happens here. You see, whenever I get closer to the enemies, I'm not damaging them. Because if we switch to debug mode here, we can spot the state idle. But if I click on the button, so let's go back to normal mode, attack, here we go, switch to debug mode again, we are still in the attack mode. So we need to stop attacking. And for that, we are going to make use of another really cool feature here, which is animation events. This little thingy here. So let's select the weapon. Go to the end of the animation, right here, and add an event. So at that point, we are going to call the weapon method stop attack. That way, whenever we complete the attack animation, we are going to call the stop attack method, which is going to switch the state to idle, and we won't be able to attack enemies anymore. So let's hit play. All right, let's try this out. So I'm going to select the weapon, and press the start attack button. Okay, and yep, it did work. Now I can't attack enemies unless I click on the start attack button. So let's try and kill. Let's try and make them pass away. Okay, boom. Yeah, here we go. Yeah, really nice. And now if I come and check, we can notice that I'm in the idle state. Really cool. So in the next one, we are actually going to keep track of all of the enemies we've attacked so that we don't attack them twice. See you in the next one. Welcome back, guys. In this lesson, we are going to keep store of all of the enemies that we've attacked so that we don't attack them twice. Okay, so let's open our weapon script. Inside of here, we are going to create a new list of enemies. And a list is almost the same thing as an array that we've seen somewhere around here. This is an array. But a list is way more flexible. You can add and remove elements compared to arrays. Okay? So maybe somewhere around here, private list of enemy. Okay? So our list of enemy is going to be called damaged, maybe something like that. Damaged enemies. Yeah, seems cool. Equals new list of enemy. So one way we can initialize our list is like so. So inside of a class, or we can initialize it inside of a method. But it's actually a good practice for beginners to initialize it at the top. That way you don't forget to do so. All right. So inside of our attack method, we first want to check if our enemy, so the one that we've detected right here, is inside of our list or not. If it's not inside of the list, it means that we have not attacked it yet, right? So we can attack it. But right after attacking the enemy, we need to add it to the list. Got it? So here's what we're going to do. Let me add some curly brackets if I can. Boom. So first off, is the enemy inside of the list? If yes, if no, let's say, let's attack him and add it to the list. If it is inside of the list, let's continue. Check the next enemy. Perfect. So this is inside of the awake method. But after attacking all of the enemies, we want to clear the attacked enemies or the damaged enemies list. Got it? If you've got any questions, please let me know in the comments. It should be understandable, but I can understand that at first it's a really weird concept to grasp. Okay, so is the enemy inside of the list? So if our damaged enemies dot contains, the contains method returns a boolean, so true, if the enemy is inside of the list, and false if not. So if the damaged enemy that contains our enemy, so we have it right here, but we can actually store it at the top, enemy, current enemy, or we can actually call it enemy equals this boy. So if our list contains the enemy, what we're going to do, inside the list, if not. So if it doesn't contain the enemy, what we can do is damage it. So enemy.take damage, and we right away add it to the list. Damaged enemies.add enemy. Perfect. So that way we make sure that we don't hit it twice. And after that, we're actually good to go, because if the enemy is inside of the list, we are not going to run this code. So we should be good to go. So let's remove this line, and what we can do is test it out. Yeah, should be good actually. Oh, we haven't cleared the list, sorry. So let's clear the list here. Damaged enemies dot clear. The clear method empties the list. So even if we've added enemies in this code, we are going to clear it after stopping the attack. If you want to make sure that the list is clear, you can also call this inside of the start attack method, but it should be good. Let's add it. It's just one line command for precautions. It's free. Let's take it. Okay, so let's go back to Unity now and hit play. All right, let's try and attack some enemies here. So let's select the weapon, start attack. Okay, please hit some. Yeah, nice. We've attacked the enemy and he's still alive. So we've dealt 5 damage only. Again, please. Boom. Oh, it's not detecting the enemies. Oh, right here. Because they are at the bottom. Okay, again. 5. Yeah, really cool. That's finally working properly. Awesome. So you now know a better way to implement a logic for our weapons. Really nice. In the next one, we're actually going to automate our weapon attack because clicking on the button is a little bit archaic. Come on, we're not at the Stone Age here. So yeah, in the next one, let's do that. And we can call it a day for this section. Next, we are going to add damage particles. Really cool. Welcome back, guys. In this lesson, we are going to improve our weapon so that it finally attacks automatically. Come on, it's been so long. So yeah, I'm just resetting the position of Dave here so that it's at the center because it was bothering me a little bit here at the bottom. So yeah, let's go on. This lesson can actually be a cool exercise. You can implement this logic because we've already seen how to do that inside of the enemy script. We had a attack timer, attack delay. We've used the delay right here to set up our attack. We were able to wait for the attack timer to be greater than the delay and so on. And finally, we attacked. So it's really the same logic actually here. So I really encourage you to try this exercise by yourself and then watch the solution right now. Let's do that. So let's open our weapon script. Inside of here, we are going to add a serialized field, private float, attack delay, private float, attack timer. Okay, here we go. We can actually add some space here. Inside of the auto aim method, we want to increment or manage our timing. So manage attack here, or maybe manage attack timer, let's say. Private void, manage attack timer. Here we go. We simply want to increment the timer. So attack timer plus equals time dot delta time. And if the attack timer is greater or equals to the attack delay, so you can use the frequency like we've done for the enemy, or here is another method so that I actually show you variations or various methods. You can simply use a delay. Yeah, that's okay. That's fine. It's working. So if it is greater than the delay, what we are going to do is set the attack timer to 0, not the delay, sorry, boom. So attack timer equals 0, and we are simply going to attack, like so. Cool. But one thing here, we can right now attack even though there is no enemy nearby. So instead of adding this logic right here, what we can do is grab this line and drop it right here. Boom. Okay? Just to make sure that we attack when an enemy is nearby. But this causes another issue here. We are only going to increment the timer whenever an enemy is nearby. So what we can do is separate the logic right here like we've done for the enemy. So private void, wait. Inside of here, we are going to grab this line, drop it here, so that our waiting is actually always called. Okay? We can rename this method increment timer. It will make more sense. And to rename, and by the way, quick tip here, to rename multiple instances of a method or a variable, I don't know if I told you that, but you can press Ctrl R twice or Command R and actually rename it. So let's call it increment attack timer. Perfect. So it has changed all of the instances of this method to our new name. Cool. So manage attack timer, maybe we can call it manage attack, and you can actually keep this for later on. First off, again, make sure that the code is working, then take some time and rename your methods or refactor your code. Okay? We should be good here. We are managing the attack if we don't have, if we have an enemy nearby. Attack, boom, bam, beam, bam, boom. Yeah, should be good actually. So let's try this out. Okay, let's hit play. Normally we should be good. All right, so no enemy nearby, so it should be incrementing the timer. But whenever one gets close enough, boom, come on, attack him. Huh. Why is it not attacking? So we are damaging the enemy. Oh, we need to call the start attack method, not attack here. Sorry, really sorry for that. So yeah, start attack method. If some of you got it right, well done. I must say well done because I've missed it. So let's go on. Let's go back to Unity. Let's hit play again. And normally we should be good now. All right, let's wait a little bit. Here we go. Come on. Come here. Boom. Attacking. Yeah, really cool. Nice. It's finally working. Cool. So we still have some little things to fix, like the enemies are pushing the player around. Yep, we should be good. We are going to change the gizmos or the label on top of the enemies just after this section. But yeah, we can actually take some time and refactor our code. And before I forget, again, commit the changes. So in here, we've added the weapon attack. Here we go. Nice. So in the next one, we are actually going to fix some little bugs first, and then we can tackle the damage text particles. It's going to be awesome. I'm sure you're going to love it. See you in the next one. Welcome back, guys. In this lesson, we are going to fix some little things before jumping to the damage particles. And these ones are going to be really interesting to add. Okay, so if you remember well, in the previous one, we've seen that the enemies were able to push the player, and this is definitely not what we want. So this is because our enemies do have a collider now. If we select one of these, yeah, definitely. Okay, and also because our player has a collider with a rigid body. Cool. So the collider of the player prevents us from going outside of the world bounds, so the arena bounds. So one of the solutions here would be to select Dave and turn it into a trigger collider, okay? But what's the issue here? Well, first off, the enemies won't be able to push us anymore. If we try this out, they are not pushing us, but the player is now able to go above and beyond the walls of the arena. And this is definitely not what we want. So we need that collider right here. The second solution here would be to select the enemies. Maybe we can select the prefab here and disable or turn the collider into a trigger again. So let's try this out. But what can be the issue here? Well, it seems that it could work properly, but later on we are going to add bullets. Maybe we can actually use the on-trigger enter method instead of colliding. What else? Actually, this solution could work. So this is a way you could do that, okay? But I wanted to show you something else that is a little bit more interesting. So let's select our enemy again and turn it back into a regular collider. Okay, cool. So we currently have the enemies inside of the enemy layer and Dave, so the player, inside of the default layer, okay? So let's drop Dave inside of its own layer. So let's call it player, okay? We can select Dave and switch it to the player layer. And right now we only want to change the layer of Dave, so this game object, not all of its children. Got it? So let's do that, cool. And now to prevent collisions between Dave and the enemies, what we can do is go to Edit, Project Settings, right here, Physics 2D, and we get this nice collision matrix here. So I'm just going to grab the window and dock it here. Perfect. And inside of this collision matrix, you can disable and enable collisions between objects, which is really interesting. So in our case, we don't want the player to collide with the enemies. So we just uncheck this box. Let's save, hit play to give it a shot. And now our enemies should not collide with the player anymore. Let's try that. Yeah, that is so cool. And if we have a closer look, Dave has the collider enabled, and same thing for the enemies. Right here, I should be able to see it. Yep, before it passes away. Really cool. Okay, so this is one thing. You can actually explore the general settings of the Physics 2D. You can set the gravity, you can set the velocity iterations. These settings are related to physics performance, so we aren't going to touch them right now, but it can be interesting to try and fiddle around with these. Okay, the next thing I wanted to fix is the weapon attack speed. So right now we are only using the speed from the animator. right? We are not using the attack delay that we've specified right here. So let's set this one to 0.1, let's say. So we should be able to attack every 10th of a second. So let's open our script here. And what we are going to do is jump to the attack or start attack method. Cool. So inside of here, we clear the thingies, so the list. We also want to change the speed of the animator. So animator.speed, and this is the playback speed of the animator. So 1 is the normal playback speed. That's why we've used 1 for the total duration of our animation. So equals 1f divided by the attack delay. Here we go. So we had the delay right here. So I think that we are to go. So it should be 1 divided by 0.1, which is 10. So we should attack 10 times a second. Let's try that. All right, let's hit play. Okay, let's try and, oh, that is definitely too fast. Come on. Okay, so let's diminish that to 0.3 maybe. Yeah, that's already better, actually. Okay, nice. All right, so in the next section, let's add damage attack particles. See you there. Welcome back, guys. In this lesson, we are going to create our first damage particle. Okay, so the first thing we are going to do is to remove the text or the health from the enemy here. So let's open our enemy prefab. It should be somewhere around here, prefabs, enemy. Let's open it. We can remove the health text like so, or maybe let's just disable it for now and we can clean our code later on. By the way, quick thing that we forgot to do last time, commit our changes, of course. So let's write bug fixing. Fixed collisions between the enemy and player, like so. All right, perfect. We can now go back to our code and let's create our first damage particle. So we are going to right click, create a new 3D object, Text Mesh Pro. Here we go. Let's press F to focus it again and call it damage text, let's say. Cool. I'm just again going to split the rendering from the actual logic. By the way, why do I have an error here? I don't know. So let's right click and create an empty parent. This is going to be the damage text and this is going to be the renderer. Awesome. Let's have a look at this. Has been destroyed, but you are still trying to access it. What? Where? Text Mesh Pro. Oh, it's a Text Mesh Pro issue, so it's not related to, I don't know, maybe it's in this version of Unity, but don't worry, it's still gonna work. All right, so let's set the width and the height of our text to 1 by 1, let's say, something like that. Then again, we are going to change the font asset to Arial rounded here. Perfect. What else? We can set a random value of 154 and diminish the font size to something like this, maybe 4, okay? Let's align it to the center. Just for testing purposes, we can actually grab it and drop it on top of the enemy just to see how it will look like in game. Okay, so I just need to increase the size a little bit here, and maybe we can allow the text to overflow. Okay, so no wrap here. Perfect. That way it will actually overflow and feel good. Or you could actually increase the width. That's actually the same behavior here. Okay. Maybe 7 can be nice. But anyway, it's just value tweaking here. I'm sure you can do that on your own. Okay. So now that this is good, let's move the text out of the way. But first off, let's make sure that its position is centered on its parent. Okay. So let's press W, bring it somewhere around here so that we can better notice it, okay? And the animation will be something like that. So the text will start from a certain position, maybe on top of the player or on the player. I think on top is actually better. Then it will go up for like 1 second, something like that, and fade out, okay? Like in the real game. I'm gonna drop some footage here. All right, so let's tackle the animation now. We are first going to add an animator component like we've done previously to our damage text. So animator, perfect. Let's open our animations folder and create a new folder for the effects. So right click, create a new folder, effects. Here we go. Let's right click again, create a new animator controller. Come on, you know how to do that now. And call it damage text animator. Perfect. We can now select our damage text, attach the animator, and start creating our animation. So let's open the animation tab here. I'm going to create a new animation, and it's already inside of the animations/effects folder. Let's call it animate. Yeah, as simple as it gets. So here, feel free to create the animation that you want. I'm going to create a basic one just to show you how you can do it. But yeah, let your imagination flow. All right, so let's first start by recording our animation. I'm going to add a keyframe for the Y position and another one for the vertex color here. So add a key, okay. So here's how I want it to behave. So I want the thingy to jump and come back to its original position. So I'm just going to copy the keyframe here, okay. And right here, it should be a little bit above. So maybe jump, something like that. But I'm going to make it more beautiful just by playing with the tangents here. So let's do it something like that, like a real jump, okay? Maybe to simulate gravity. Yeah, something like that is actually way better. Okay, so it will jump like so, and after, let's say, a certain amount of time, so let's move the keyframe, the color keyframe to here. But after a certain amount of time, I'm going to copy this, paste it here, and in here, I'm going to fade it out. So boom, all the way down. Maybe I can move this here. How does it look like? Nice. Pretty cool, huh?
Maybe I can select all of the keyframes and reduce the duration of the animation.
Yeah, I need to play again with the curves.
So let's press F. Okay, so
Yeah, that's decent actually. Maybe something like that. A little bit to the middle here. Yeah. Yeah, that's okay. Cool. Again, feel free to create the animation that you want here. By the way, I'm going to provide a package linked to this lesson. So if you don't want to bother creating the damage text and so on, make sure to download the package and import it in your project. Cool. But come on, it's a good exercise. So try and create it. All right. So now that I have my particle here, I'm going to create a new script that will manage this particle. So the script will have to change the value of our text here and animate the particle. Okay? So in the next lesson, let's create that script. Welcome back, guys. In this lesson, we are going to create our damage text script and animate our particle right here. So regarding the error that we had in the previous lesson, I've just quit Unity, came back, and it's gone. So if you are having the same issue, please feel free to restart Unity and hopefully it will be gone too. All right, so let's open our scripts folder right here. And can we drop our script in a folder or not? Nope. I think we are going to create a new folder for the effects. So effects, cool. We can actually grab the sprite sorter and drop it inside of this new folder. Perfect. It's going to reload the domain, of course, as usual. All right, let's now create our script. So create a new C# script and let's call it damage text. Here we go. We are going to grab the script and attach it to the damage text game object. Cool. Let's open it now. All right. So the first thing we need is a reference to our animator to be able to play the animation, right? So quick exercise. Try and add a reference to the animator and using the Naughty Attributes package, create a method and attach a button to that method so that you can play the animation just by clicking on the button in the inspector. I hope the instructions are clear, so good luck. Here is the solution. So header, elements. Here we go. Serialize field, private animator. Okay, so we've got a reference to the animator. Now we need to create the method that will play that animation. So private void animate animator.play, and the name of our animation was animate, if I remember well. So I'm just going to double check. Animator right here, animate, yup. But the issue here is that the animation would play at start. So similarly to what we've done for the weapon, we are going to create a new idle state here, animation. So idle. Oh, come on, not udle, idle, noodle. So idle, this should be the layer default state. Perfect. And we are going to create a transition from the animate state to the idle state. Okay, so let's move this to the end of the animation. Here we go. That's way better. So now let's jump back to our script and write the name of the animation we want to play. And to be able to play it from the inspector, I'm going to use the naughty_attributes.button attribute. Cool. So let's now go back to Unity and hit play just to test it out. So let's hit play. Okay. Let's select the damage text. We need to reference the animator, of course. Hit animate, and it does animate. So cool. So it's playing twice because of the transitions here. So let's select the transition and actually move it to the left a little bit. Here we go. We should not actually, let's do something like that just to prevent having another animation playing at the end, okay? So yep, it should now be good. Let's animate it. Yeah, here we go. Perfect. Nice. So when we exit the play mode, by the way, we need to reference the animator back because we did reference it in play mode. Okay, cool. Our transition is well set up. We can actually make it a little bit more relevant, something like that. Yep, actually better. Cool. So now that we know how to play the animation, what we're going to do is set a random value for our text, so the damage text, and play it again. So we first need a reference to the text. So using TM Pro. Here we go. Serialize field, private text mesh pro, damage text. Here we go. And inside of here, damage text, the text equals, let's say, a random value between, so random.range will provide a value between a minimum inclusive and a maximum inclusive for floats, and minimum inclusive and max exclusive, for integers. So let's set a random value between, I don't know, maybe 10 and 1000. Okay. So this is an integer. We need to convert that to a string. So you can cast it or use the .toString extension method. Perfect. Now we can go back to Unity and test it out. So let's first reference our text. Here it is. Let's hit play and play the animate method. Boom. 907. Yeah. 151. Yeah, cool. So nice. So now what happens if we remove the transition from here? Let's go back to our text, animate it. Okay, now it's looping. So now the issue that we have is that the text is not transparent anymore when we play it, and it does loop. So first off, let's disable the loop from the animate method. Perfect. Then what we're going to do is edit this idle animation here. So let's bring back the transition. So make transition from here to here. All right. So let's bring it back there. Nice. Now I'm going to create an idle animation. So let's select the damage text, animation, create a new clip right here. And this should be the idle clip. Cool. So inside of this idle clip, I'm simply going to set the text as transparent. So let's bring back our vertex color and set it transparent. Cool. So now if I hit play, it should be transparent at start because it's going to be in the idle state. Okay. So if we have a look at the animator, it's indeed in the idle state. Let's bring it down here, by the way, so that we can spot both the text and the animator. If we hit animate, boom, it goes back to transparent. That is so cool. Nice, huh? You like it? Let's go. So now we need to create a damage text manager that will be responsible for spawning these particles and playing them on top of the enemies whenever an enemy gets hit. Awesome. Let's do that in the next one. Welcome back, guys. In this lesson, we are going to create a damage text manager that will be responsible for spawning these damage text particles. Okay, so let's do that. So who says spawning says prefab in general, of course, because we want to be able to use this game object multiple times. So let's create a prefab out of it. So we can simply grab it, drop it inside of the prefabs folder, and it is now a prefab. So cool. We can remove it from here. Awesome. So I'm going to create a new game object that will hold all of our effects. So right click, create an empty game object, call it effects. Here we go. Let's reset its transform, and we can actually duplicate this separator or spacer and rename it space. Nice. Inside of here, I'm going to create a new game object and call it damage text manager. Here we go. Let's now open our scripts folder and managers folder and create a new damage text manager script. Damage text manager. And by the way, we could have dropped this script inside of the effects folder, or yeah, effects folder, but that's okay. Come on, it's a manager, it's an effect, so you decide. Now we are going to drag it and drop it on top of the damage text manager game object. Let's open it. Cool. So the first thing we need is a reference to the damage text. So let's add it. So elements, serialize field, private, damage text prefab, let's say. Here we go. So now we have a reference to our damage text prefab. We need to spawn it, okay? So to spawn something in Unity, you want to use the instantiate method. I don't think we've used it previously, so I'm going to go slowly here. Let's create a method that will just instantiate a damage text, okay? So private void, let's call it instantiate
Damage text.
and for now it won't take any argument here. Okay, so let's write instantiate. So this is the method you want to use to instantiate or create or spawn any game object. And it has multiple overload methods. So the first one only takes an object, so the original object you want to create a clone from. Then you have another one with the parent, if you want to specify a parent for the object you are going to create, and so on and so forth. So let's go step by step. First off, we just want to spawn the damage text prefab, as simple as it gets. So let's create a button here. So not attribute dot button, and you can already notice the power of these attributes here. Really helpful to test out things. Let's go back to Unity. We will need to add a reference to our damage text prefab. So let's lock the inspector and open the prefabs folder, damage text. Here we go. So I locked the inspector to be able to drag and drop stuff, because if it was unlocked, I would have to select the prefabs folder. Here it is. Then select the manager again, drag it and drop it. Another way you could have done that is by right-clicking, selecting properties, and you now have a floating window of your component. That might be really helpful because we can dock it somewhere and reuse it. Okay, cool. So let's remove this one. Okay, boom. Let's now hit play and see what happens. If we click on the instantiate damage text, boom, a text has been spawned here. Here it is. We can also spot it right here. And as we click on this, it's going to spawn more and more text here, okay? And you can actually inspect all of the text, and you can notice that indeed these are the prefabs that we've created. Cool. So now let's go one step further and animate the text when we spawn it, okay? So the instantiate method, if you hover over it, tells you that you are spawning a damage text. Really cool. It means that we can cache it or store it. So damage text, let's call it damage text instance equals this. Cool. So we can now access a method inside of the damage text script. So damage text instance dot animate, and we can't call the animate method. Why? 3 seconds. 1, 2, 3. This is because the method is private. So let's hold Control, click on animate, and we can notice that it is private indeed. So let's make it public so that we can call it from the damage text manager. Now it's working. So let's go back to Unity. Let's hit play. Let's select our damage text manager and spawn some particles here. Here we go. And now as we click on the mouse, like so, it's spawning more and more particles. This is so cool. That's the first step towards making a fully working damage text particle system. Cool. So there is an issue here. All of our damage text clones are spawned as children of the scene, and ideally for now we would want to spawn them as children of the damage text manager because this is the one managing them. So let's change that. Inside of the instantiate method, we can use an overload method to specify the parent, transform. So now the parent of the damage text particles will be this transform, so the damage text manager. Again, let's quickly test this out. So let's spawn some particles, boom. And indeed, now all of our particles are children of the damage text manager. Cool. Next step. We want to be able to change the position where we spawn these particles, right? So let's do that. Let's go back to our script here and set up a vector3 spawn position. So right now we are just going to randomize the position. So let's write random dot inside unit circle, and it does return a random point inside or on a circle with radius 1. We can then multiply this by a value to better randomize the position. So this times random dot range between, I don't know, maybe 1f and 10f. Maybe that's too much. So let's write 5f. Yeah, perfect. So let's use the spawn position here. And we also need to add a rotation because there is no overload method with the prefab, position, and parent. So we definitely need to use the rotation. And because we don't want any rotation applied to our prefab, we are going to use quaternion.identity. Quaternions are really complicated things, and we are not going to cover them right now, but keep in mind that quaternion.identity is the rotation 0, 0, 0, so not rotated. Okay? Cool. So let's try this out. We should now spawn our particle at a random position. So let's hit play. Let's click here. Boom, boom, boom. Yeah, we can notice, let's zoom out actually. And if we hit play, we can notice that now our particles are spawned at random positions. That is so cool. Awesome. And of course, if we keep doing this, we will be able to notice a circle because we are randomizing on a circle and so on and blah, 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 blah. Okay, enough fluff. In the next lesson, we are going to learn how we can actually spawn these particles whenever an enemy gets hit. And this will imply using actions. I've already created lessons or lectures on actions, so I'm going to drop them as appendices, okay? Make sure to go watch them if that's the first time you use actions, and then come back to the next lesson. See you in the next one. Welcome back, guys. In this lesson, we are going to use actions, and hopefully you've watched the lessons in the appendices down there, right? You did it, right? Okay, so let's go on. So first off, we need to know whenever an enemy takes damage, and a good way to do so is by using actions. So let's open our enemy script here. Cool. Where does the enemy takes damage? Clink, clink, right here. Okay, so it means that we need to do something right here. This is where we are going to create our action. So an action is basically like an event, and it will allow us to decouple our code. It will prevent making spaghetti code, okay? They are really, really helpful, so please learn about them. And if the 3 lessons that I've added are not enough, I'm going to try and link some in-depth YouTube video about actions in C#. Okay. So inside of here, we are going to do something like that, like on damage taken. Okay, so this will be the name of the action. We are also going to pass in the value of the damage so that it can be displayed in our damage text, right? So let's invoke the action like so. Invoke with the damage. Perfect. The question mark here will make sure that we don't get any error if no one has subscribed to this event, okay? And the invoke here is just a basic call of the action. So let's create this action now. Let's go at the top, and we will need to use the system library. So using system, perfect. Let's create a new header for our actions. Boom, public, static, action. It does take an integer, which is the damage, and it's called on damage taken. Perfect. So no more errors. Okay, so yeah, by the way, the static keyword here, you should know about it if you watched the lessons, but it simply means that it will be accessible from any other script, even though there is no instance of this class, okay? And this will make it really helpful to be called like enemy dot on damage taken. If it was not static, we would have to grab it in another way. But let's keep it simple for now. So now we can just jump back to our damage text manager and add the awake method. So a good practice is to subscribe to events in the awake method, okay? So we can write enemy.onDamageTaken plus equals, so it means that we are adding a callback to the action, instantiate damage text. Perfect. And we're getting an error. Why? I'm giving you 5 seconds to think about it. This is because our onDamageTaken does take an integer or passes in an integer, so our callback must have the same signature. So we need an int damage here. Here we go. And of course, we need to unsubscribe from the event to prevent having errors when reloading the scene. So onDestroy enemy.onDamageTaken minus equals instantiate damage text. Really cool. So right now, we've subscribed to the event. We are calling the instantiate damage text, so we will instantiate the damage text, but we are not making use of the damage value here. So let's pass it in right here. And of course, error again, because we need to implement our animate method. So let's hold Control or Command, boom, and add an integer damage. Here we go. So our damage text here will be damage.toString. As simple as it gets. So let's jump back to Unity now and test this out. Let's hit play. All right, let's try and hit some enemies. Maybe this one. Okay, 5. Yeah, here we go. Okay, so the particles now are playing really far away. This is because we are not using the enemy's position right now. So let's use the enemy position. Okay. So inside of the enemy script again, we need to pass in the position inside of the action along with the damage here. So let's pass in transform.position. This is the position of the enemy, okay? And of course, we need to change the signature of our action. So let's add a vector2 here. Perfect. Now we can jump back to our damage text manager and add in a vector2 enemy pause. And we can use this to spawn our particle. So we can use enemy position plus vector2.up and add an offset along the up vector. So times, I don't know, maybe 1 unit, something like that. Yeah, should be good for now. Let's try 1.5 units. And if it's not good, we can still change that. Or we can create a variable inside of our enemy script and pass it in, because we might imagine that we will have small enemies, big enemies, and so on. So the size will vary. Let's keep that for another day. This is the sentence used by all developers. Okay, so let's hit play and see how it goes now. All right. And by the way, we are now attacking enemies even though they haven't spawned, so we are going to change that. Don't worry. Yeah, now the particles are spawning on top of the enemy. That is really cool. Awesome. So sometimes, if you have noticed, it does appear, the particles appear behind the enemies. So what we want to do is select the damage text here and make sure that the order in layer is above everything else. So where is the order in layer? Right here. We can actually use a sorting layer, and I think it's going to be cleaner. Okay. Because if you remember well, we do change the order in layer of our enemies based on their Y position. So let's create a new layer here. So at the top, add layer, sorting layer, not basic layer. Boom. And let's call it top. Here we go. We can now select our damage text renderer and render it on top of everything else. So let's select the top sorting layer. Here we go. So now it will always render on top of enemies. We can actually try this out. And then we can fix this bug because, yeah, we are attacking enemies. They haven't spawned yet. Come on. That's really not a good practice here. Really cool. Nice. I love it. Okay, so we can do the same, by the way, for our weapon here. So let's select the weapon, which is right here, and make sure that we render it on top. Not here, sorry. Make sure that we render it on top of everything else. So top for the salting layer. Here we go. Because I've noticed that it was rendered just behind the rock in a previous frame here. So yeah. All right. So now that this is working, there is still one thing left that I'm thinking about here. As we go, we are going to create more and more particles. As you can notice here, like we have maybe 6 or 7 enemies, and we already have a bunch of texts here. And as you play, it might lag the game, because the more game objects you have, the more likely it is that your game will lag and be slow. So in the next one, let's learn about pooling, which will allow us to reuse old particles. See you in the next one. Welcome back, guys. In this lesson, we are going to use object pooling to make our game more performant. Because, okay, we are going to spawn a bunch of damage text right here, but this might not impact the performance that much. But when you add up these damage texts plus the bullets that we are going to shoot, plus all of the enemies, it is starting to become overwhelming. So indeed, object pooling will make our game much more performant and way more scalable. Okay, so for that, we are going to open our damage text manager. And the first thing we want to do is to add the pool library. So using Unity Engine.pool, pool, here we go. After that, we need to create our pool that will hold all of our objects. So let's do that. Let's create a new header for pooling. Private object pool of damage text. Let's call it damage text pool. Yeah, something like that.
Perfect.
Our pool of objects needs to be instantiated at start, or initialized at start, sorry, not instantiated. So let's do that. Inside of the start method, we are going to write damage text pool equals new object pool of type damage text. We are then going to open the parentheses to add all of the methods that we want. So it does take some kind of functions, some actions, to know how to deal with all of these objects. So the first thing will be the create function. Then we will have the action on get when getting an object from the pool, an action on release when releasing an object after it has been played. So in our case, after the particle has been played or animated, and an action on destroy if we want to destroy the object from the pool. So let's make it easy on the eyes. We are going to write create function, action on get, action on release, and action on destroy. Here we go. So let's now create all of this beautiful world. So private damage text create function. The create function needs to return a damage text. Okay. Then the action on get. Private void action on get damage text. Here we go. So this method will help us configure the text whenever we grab it from the pool. Okay, so we will basically just turn it on, like set the game object's active property to true. Okay, then we have the action on release. So private void action on release whenever we release the damage text. Here we go. And finally, the action on destroy. So private void action on destroy, damage text. Here we go. Perfect. So let's do things step by step. First off, when we want to instantiate our damage text, we are actually going to rename this because we are not instantiating anymore and it doesn't make sense. So let's hit Ctrl R twice or Command R again and call it enemy hit fallback. Here we go. And of course, it has been renamed here too. Inside of this method, instead of instantiating the object, what we want to do is grab it from the pool. So we will need to write damage text pool.get. Here we go. It will give us a damage text from the pool. Got it? We are then going to put it at the right position because as you can see, we are not using the spawn position right now. So let's write damage text instance.transform.position equals spawn position. And we can actually rearrange things a bit more so that it does make sense. So we first grab it from the pool, then set up the position we want to drop it at and put it there. Then we animate it. Perfect. What we also want to do in here is release the particle or the damage text after it has been used. So we know that the animation here does take 1 second, if I remember well. So let's double check. I'm going to select the prefab whenever Unity decides to compile the scripts. Okay, of course I have an error, don't worry. Let's hit here. Okay, boom. What about the animation? Can I select it, please? Animate. 40 frames, like almost 1 second. Cool. So yeah, we can release it after 1 second. That's okay, because it will turn transparent actually. So let's go back here, and to do that after 1 second, what we can do is use the LeanTween library. We've used it to scale our spawn indicator, the one we've added to the enemy. Remember, I think it was inside of the enemy script, leantween.scale. So in here, we are going to use another method inside of the LeanTween library, which is leantween.delayCall. So leantween.delayCall to delay a call after a certain amount of time. So after 1 second, what we want to do is to release this damage text instance that we've created. So for that, we need to add an action. We are actually going to add an action in the form of a lambda expression. And to do that, you are simply going to write parenthesis, arrow, and in here we are going to add the logic of our action, or you can simply call an action. So let's write damage text pool. So damage text pool dot release a certain particle. And the particle we want to release is the one we've just created. So the damage text instance. We are going to release it after 1 second. So after it has been played. Got it? Super cool. So this is how you use lambda expressions. It's a way to call actions without creating a function from scratch. Okay, perfect. So we grab the damage text right here and we release it right here. Nice. So we now need to implement these 4 methods right here. First off, the create function. The create function will simply be an instantiation, right? So if we don't have any object in our pool, we want to instantiate new ones. So we are simply going to return, instantiate a new damage text prefab under this parent. Perfect. What about the action on get? When we get an object from the pool, we need to make sure that it is active. So damage text.gameObject.setActive true. This is because when releasing an object, we simply want to set its active property to false. But if you had another logic or another way to release a game object or a pool object, you would have to apply the opposite logic inside of the get method. So let's say that when releasing the damage text, we would have disabled the animator. Inside of here, you would have to re-enable the animator or the collider or so on. Okay, so just keep it easy for now. We are going to check that more in details later on. And finally, the action on destroy will be destroy damage text.gameObject. Here we go. We are actually not going to use this, but it's cool to have it. All right, I think that we are done for our pool right now. So let's remove the update method for now. I don't think we are going to use it. What we're going to do is to actually remove the attribute here because we have arguments in our method, and naughty attributes button doesn't work with arguments, with methods with arguments. So let's now go back to Unity and give it a shot. All right, so everything should be set up properly. Let's remove this, hit play. Let's open the simulator. Okay, let's try and hit some enemies. So we have some particles right here, 2 particles. Okay, disabled. And now you can see that we are reusing previous ones, right? And when we hit enemies, the particle gets set to active and reused. So your game is already way more performant now because as you can see, we've only created 4 particles and reused them. Recycling is good for the earth. So I really encourage you to rewatch this lesson if you didn't grasp the concept yet, or leave comments in the comment section. And well done if you grasped it from the first try, because your game is now way more performant. Welcome back, guys. In this lesson, we are going to fix some stuff here before jumping to the next one, where we should be able to add the ranged enemy or the wave manager, one of these 2. Okay, so first off, when we play the game here, there are some issues. I can attack the enemies even though they haven't spawned. So that's the first one. The second one is that the weapon is not aiming at the enemy before attacking here. You see, boom, it attacks at the top first and then attacks the enemy. And the third one is that I really don't like the collision detection that we are using right now, because we are only using a circle. Let me just select the weapon. Okay, so we are using a circle right now instead of using the whole weapon. So it should be a rectangle. Okay, so for that, let's first fix our enemy spawning issue. So we are going to open our enemy prefab. So let's select it. Okay, double click it. And what we are going to do is disable the collider. Why? Because the weapon, to be able to attack enemies, takes the collider into consideration or into account. Right now, I won't be able to attack. Okay, so that's one thing. But once the enemy has spawned, I should definitely enable the collider. So let's do that at the end of the spawning sequence. So start spawn sequence completed right here. Okay, so we just need to enable the collider right here. Do we have a reference to the collider yet or not? Boom, 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 boom. I don't think we have, so let's add it. Maybe we should add it somewhere around here, spawn sequence related. Yep, serialized field, private, collider 2D. Let's call it collider. Here we go. So we have these jiggly green lines because it hides the inherited member, but that's okay. We can use the new keyword or you can keep it as is. It's going to work the same. Okay, so inside of the spawn sequence, right after it's completed, collider.enabled equals true. As simple as it gets. So we can now go back to Unity, reference the collider, and it should enable once the spawn sequence has been completed. So let's grab it, drop it here, let's hit play. All right, let's go near an enemy, and yep, awesome. The weapon starts attacking whenever he has spawned. Cool. That's one issue fixed. Let's now tackle the second issue. The one where the weapon is aiming at the enemy after one frame or after one attack cycle, let's say. So for that, we need to enable deboink here. Okay, let's open our weapon script. And what we want to do is jump to the auto aim method here. So right now, when we find an enemy, we manage the attack. So we increase the timer and so on, but we lerp towards the enemy. And this is not the best way to do it, actually. We should allow the weapon to directly aim at the enemy. And we can then lerp when coming back to our rest position. Okay? So for that, I'm just going to bring this line up just before the manage attack method. And we then need to set up our transform.up vector. So transform.up equals target up vector. As simple as it gets. Cool. So let's give this a shot. Let's hit play. All right, so right now not attacking. Perfect. Let's try. Boom. Yeah, the first attack was directly aiming at the enemy. And when the enemy gets out of the range of the weapon, it does lerp to its original position, which is really cool. Original rotation, sorry. Yeah, really nice. So you see, I really need to improve the collision detection here because we should be attacking the enemies and we are not. So that's two issues fixed now. Let's tackle the third one. All right, for this one, I'm going to select deboink, animation parent, hit detection position and press F to focus it in the scene. Let's make the game view a little bit smaller, okay? And what I want to do is take the whole bat or weapon into consideration. So I'm just going to bring this down a little bit, somewhere around here, maybe at the center of the weapon. Okay, so 0 maybe, let's try this out. And add a box collider 2D. So this is what we are going to use for our detection. We are not going to use the proper box collider 2D, but we just need a visualization of the bounds, okay? So let's click on this button right here to edit the collider, bring this up, bring this down. Oh, come on. Bring this down. Okay, let's make it smaller on both sides. You can press Alt to edit it proportionally, okay? And yep, should be nice. So let's turn it into a trigger collider. Perfect. What we want to do next is open our weapon script right here. Cool. And jump to the attack method. So right now, if you've noticed, we are using the overlap circle all method. But what we are going to do is use the overlap box all method instead. This will allow us to use our collider, the one we've just set up, as a detection box. So let's comment this, cool, and remove everything we've got in here. Boom. So what do we need? We need a point. So this is the center of our box. This is going to be hit detection radius, not transform, dot position. Perfect. Then we need the size of our box. So this is the size of the collider we've set up right here. All right. So we can add a reference to it, but we know that it is attached to the hit detection transform. So what you can do is write hit detection transform dot get component of type collider 2D, maybe box collider 2D, like so, dot bounds dot size. So this is the size of the bounding box of the collider. I think that the line is a little bit too long. So what I'm going to do instead is add a reference to the box collider on top and then use it. Okay. So let's add it, boom, bam, boom, maybe somewhere around here. Yep, should be good. Or maybe with the hit detection transform, serialize field, private, box collider 2D, hit box, or maybe hit collider. Perfect. So we can now use it down there. So this is hit collider dot bounds dot size. Okay. We can go to the line actually. Yep. Comma. Let's now specify the angle. So the angle of our box collider is the angle of our weapon. So it should be hit detection transform dot transform. Oh, this is already a transform. Sorry. So dot local Euler angles dot z. This will give us the local Z rotation here, okay? Because we know that we are going to rotate our weapon when attacking and so on. So the box will be rotated and we need to take that into consideration. All right, so, okay, we will add a comma then and specify the enemy mask. Perfect. We can actually rearrange this a little bit better. Okay, maybe something like this. Cool. Let's try this out. So we are going to jump back to Unity and select the boink, specify the box collider. Perfect. What you could have done, by the way, is also store the collider. So this could have been private right here at the top. You could have written private box collider hit collider without the serialize field attribute. And inside of the start method or awake method, you can write hit collider equals hit detection transform dot get component of type collider 2D of box collider 2D. But this brings up another issue here, because if you forgot to add the hit collider or the box collider 2D component to your hit detection transform, it's not going to work and it will throw an error. So of course, use the method you like most, but yeah, let's try this out. All right, let's try and attack some enemies now. Yep, okay, seems like it's already better. But to be sure that it's working, I'm going to hit, I'm actually going to exit and come back because there is no more enemies. All right, let's go to the center and hit pause right now. Okay, so let's select our weapon and the enemy's game object. Quick tip here, you can hold Control to select multiple elements, okay? Let's press F to focus both of them, maybe twice. Nope, not twice. But what we are going to do is zoom in a little bit and check what will happen. So we've got the box collider of our weapon in green here and the enemy collider in green too. So let's see if we can detect them properly or hit them properly actually. So we are going to go step by step, frame by frame, and right now it should attack. Okay. Boom. Now we should have a damage text. Right. Perfect. That is so cool. Awesome. What about this one again? Let's try this. Okay, frame by frame. Oh, we should have another one. Yeah, really nice. So it seems like the detection is working really well. Let's try with these ones. Okay, okay. Here we go. So here is one and here is two. Oh, really cool. Maybe three? Yeah, we got it. Here is the damage text. So cool. So we now have a way better detection. We allow the enemies to spawn before hitting them. And we also fixed the aiming issue. Really cool. So yeah, I hope you like this one. So see you in the next one. Really quick thing before we jump to the next one. Did we forget something or not? Of course we did. We must commit our changes. So we've added the damage text particles and some other fixes related to the weapon. And of course, we can still go here and have a better look at what we've changed. So in green, you have the things you've added, and in red, the things we've removed. Cool. Let's commit them and jump to the next one. Welcome back, guys. In this section, we are going to learn and add the range enemy. Why? Because this will help us understand something really important in C# and in code in general, which is inheritance. But no fancy words for now. Let's add the range enemy and learn how we can do that. Okay, so where is our enemy here? Kawaii Survivor, sprites, enemies, seed shooter. Here is the range enemy. Perfect. So what we can do already is actually duplicate the enemy, so the basic one, and change its sprite, okay? So here is what we are going to do. We are simply going to duplicate the enemy like so. Perfect. So this is our range enemy. Like so. Let's press F in the scene view to focus it again. Okay, let's make this one a bit smaller. Perfect. We can move it to the left so that it doesn't overlap our other enemy. Cool. And we can start changing things here. So first off, it's still the same prefab as the enemy, so we need to turn it into its own prefab. So we are going to grab it, drop it here. And of course, we need to turn it into an original prefab. Boom. Now this is a prefab on its own. Really cool. Okay. Then we want to change the sprite, the rendering. So let's select the render right here. Boom. And we can change the ghost here to the seed shooter. So let's look for the seed shooter. Here we go. Perfect. So as you can notice, it's now at the center of the position. Actually, it's actually centered on the parent game object. This is because we haven't changed the pivot of our seed shooter yet. So let's select the seed shooter. Okay, it is a single sprite, of course. We can open the sprite editor or change the pivot from here. Again, this is a quick tip here. So let's set it to bottom and apply our changes. Boom, the seed shooter went up. Really cool. Okay, so now I'm going to set the enemy renderer to 1. Cool, so that it is above the spawn indicator. And I think that I need to do the same thing for the enemy renderer and so on, right? Because they have the same Y position. Yeah, we definitely need to do so. So you know what? I'm going to open the prefab, so the enemy one, and set the enemy renderer order in layer to 1. Here we go. We can jump back to our range enemy and change the color of the spawn indicator. So let's select the spawn indicator. Okay, change its color to something like green. So maybe you can use the eyedropper here. Here we go. And this is already looking really good. So right now we've applied changes to the prefab in the scene, but we need to apply the changes to the original prefab, sorry. So you can select overrides here and apply all of the changes, or if you've made some changes that you don't want to apply to the original prefab, you can select the ones that you want to apply and apply them. Okay, so right now we've only changed the color of the spawn indicator and the sprite, so let's apply all of our changes. Perfect. So now our range enemy prefab should actually be, yep, like this. Awesome. So if we hit play right now, what will happen? Is he going to shoot stuff at us? Of course not. It will actually just behave like the other enemies, and we will be able to attack him and so on. Oh, by the way, we also need to change the color of the particles here. So let's select the pass away particles and change their color, to green, like so. Here we go. So we can again apply the changes to the prefab, like so, and here we go. Here is how our range enemy will behave. Let's make the scene a bit bigger. Okay, here we go. We can grab it. So our range enemy will be somewhere around here. Let's say he spawns at this position. He will try and get closer to the player, and once he's within a certain radius, okay, so we will have a gizmos here that does detect the player, something like that maybe. And whenever the player is detected, we are actually going to shoot bullets at the player. There is another trick here, which is that our enemy is well oriented on the left, but whenever it's on the right, he should actually flip. So we can either select the sprite renderer, flip it on the x-axis using this. But because we are going to have a shooting point at its nose or a mouth right here, we will actually flip the x scale of the whole enemy. Got it? Awesome. So now that we know how our range enemy is going to behave, in the next one, let's learn how we can make it behave like so. See you there. Welcome back, guys. In this lesson, I'm going to show you the bad way we could have added the range enemy, because there are two ways. There are actually multiple ways, come on. But there is a bad way and a better way, actually. So let's do that. Let's open our enemy script. Okay, perfect. So what do we want him to do? So at start, of course, it should have a health text, and so on, movement. Of course, we want him to move. Attack delay, yeah, cool, perfect. Render visibility. So this is for the spawning. We want him to have the same spawn sequence. Update method. If attack timer, try attack. Yep, that is actually pretty nice. But in here, we want to allow him to attack if the player is within a certain radius. So what we could do here is add a boolean. So let's add another header, okay? Range enemy related, let's say enemy related, serialized field, private bool is range enemy, like so. And what we could have done is inside of the try attack method. So this is if this is not a range enemy. Here is how we want to attack. But if it is a range enemy, we want to check if the player is within a certain radius. So float distance to player equals this. We can actually drop it inside of here. No need to rewrite it. Perfect. And if the distance to player is less or equals to the player detection radius, but for the range enemy, so let's write range player detection radius, then we want to attack, like so. So you can already notice that it is becoming tricky, because if we want to add another type of enemy, like maybe, I don't know, an enemy that explodes at half the range player detection radius, or an enemy that spawns and can attack the player wherever he is, but doesn't deal a lot of damage. You have so many possibilities, but it would mean adding multiple conditions. So let's just go on so that you can grasp it a little bit better. So let's drag this out. Maybe we can add it somewhere around here. Serialized field, private, float, range, player detection radius. We can actually add a gizmo to display it. So what I'm going to do is change the color. Color dot, I don't know, magenta maybe? Yep. Gizmos dot draw wire sphere transform dot position range player detection radius. Okay, perfect. So right now the range enemy will be able to attack when he's far away from the player, but he's still going to deal damage right away, which is not what we want. So we want to attack if it is not a range enemy.
Okay.
Else, so in case this is a range enemy, we want to shoot a bullet at the player. Okay, so let's just debug, because this is not the way we are going to do it actually. So debug.log. All right. There is still one thing. Right now, the enemy is trying to move towards the player and reach the player position as he goes inside of the update method. So in here too, we need to check if this is a range enemy or not. So we will have to add private bool is range enemy. And when storing the player, we can actually specify if this is a range enemy or not. So bool is range enemy. Like so. This dot is range enemy equals is range enemy. Here we go. By the way, do not code this with me, because this is not the final solution. We are going to change that later on. But I want to show you that this is not the best way of coding, because it will imply adding so much code and it's not clean at all. So is range enemy, and we also want to edit our follow player method if this is the range enemy. So if it is a range enemy, boom, like so, we want to check how far we are from the player. And if we are within the radius, then we are going to stop. Let's first calculate the distance from this to the player. Float distance to player equals vector2.distance from transform.position to player.transform.position. Okay. And if the distance to the player is less than a certain value, so attack distance, let's say, then we are going to return because we don't want to follow anymore. Okay. All right, we should be good. So let's add our attack distance. You know what? I'm going to create another header here. Range enemy related. Okay, serialized field, private float, attack distance. What we could have done is also grab the attack distance from the enemy script. So the one we've used right there, the range player detection radius, right? As an exercise, actually try and use it for the enemy movement script instead of displaying the attack distance in the inspector. I'm giving you, I don't know, 1 minute. You can cheat, of course, by pausing. All right, here is the solution. I'm going to remove the serialized field from here, rename this range player detection radius. Here we go, and pass it in in the store player method. Again, this dot range player detection radius equals range player detection radius. Here we go. So we now need to pass all of this beautiful word inside of our store player method. So we need to pass in isRangeEnemy and range detection radius. Cool. So this should be it. I'm just going to save, jump back to Unity and set up our settings. I'm feeling tired because I know that this is not the good solution, but I need to show you that because I've been there and I know that beginners tend to do that also. But again, this is not the best solution at all. All right, so isRangeEnemy, of course, this is a range enemy, and let's set the radius. It should be something like that. Okay, yeah, this one is actually pretty good. No, maybe 5. And let's diminish the radius of the player detection radius here. Have you seen? This is not related at all to the player detection radius, but we are forced to use it because we are using the same script. I don't want to be able to display that. So maybe we can add another gizmos. If this is the range enemy, do not display this, but display that, and so on. But yeah, come on, let's go on. All right, so I'm just going to disable all of the other enemies. Boom, tac, so that we can actually spot the behavior of this boy. So let's hit play. All right, I'm going to make this one a bit bigger. Cool. Let's try and see if he's attacking me. Yep, right here, shooting at player. All right, but he's not dealing any damage here. Why? If we open the shooting at player script, we notice that he's not actually damaging us. He needs to throw bullets instead. Okay, so in the next one, let's be serious a little bit and use the better approach. See you there. Welcome back, guys. In this lesson, I'm going to show you the better way of adding a range enemy or any other enemy actually. Okay, and after that, we are going to learn about inheritance, but let's keep it simple for now. All right, so here is our range enemy. We are going to create a new script that we are going to attach to this boy. So let's right click in our project window, create a new C# script, and let's call it range enemy. Here we go. Let's attach this script to our range enemy right here. Cool. And we can actually keep the enemy script for now. Okay. We can keep the enemy movement because our boy still needs to move. It's just not going to move in the same way as the melee enemy. So let's open our range enemy script. We can keep this script right here, grab the enemy script and drop it on the right because we are going to heavily take inspiration from the enemy script. Our range enemy will need a enemy movement. So let's drop it here. Okay, here we go. We are going to grab the enemy movement script, the health, text, and so on, the player, because we needed to attack it, the renders, the effects, the attack, okay, the actions, and not this, but the gizmos, yeah. So let's grab these, drop them here. We might need some other libraries, so let's drop this here. Perfect. We are not going to use the text mesh row, by the way, because we used it in the previous lesson. Let's remove it from here too. Okay, here we go. We can remove the text from here and also from there. Perfect. I'm going to save the enemy script. And what we can also do is grab elements related to health, to the movement, to the player, to the start spawn sequence, and to the attack delay. Okay, let's drop these in the start method. Perfect. Same thing for the start spawn sequence completed, set renders visibility, update, wait, try attack, and so on. So yeah, we are actually going to grab a bunch of elements already contained within the enemy script. But later on, we are going to refactor this, don't worry. I just want to show you again how you could have added other enemies to your game. So let's drop everything here. Oh, I need to copy first, of course. Oh, come on. No. So let's reselect everything here. Okay, until here, and drop them right there. Cool. So I'm going to add the gizmos, by the way, because I don't have it yet. So let's drag it and drop it at the top here. Perfect. Here we go. So basically what I've done here is simply grab the content of the enemy script and I have dropped it inside of the range enemy script. Then we are going to adapt it. So we can already close our enemy script, drop it inside of here in the same column. And quick tip here. If you want to have tabs like I have, you can actually click on the cog and group them however you want. You can place the tabs on the top, on the right, and on the left. I like to have them here and my solution right here. You can actually explore the window tab to check what you can display and what you can't. And of course, make the editor yours. All right, so this is our range enemy script right here. So we've got some errors. Let's fix them. We want to stall the player without specifying the range enemy or range player detection because we already know that this is the range enemy script. So I'm going to hold Control, click on Store Player, remove all of this beautiful world. Okay. Remove these from here because we want to have it as we had previously. So let's remove these lines of code. Yep, I think we are safe to do so. Okay. What we could have done, by the way, is also select GitHub right here and come back to a previous commit. So right click, undo commit. This is why it is really important. Okay, so let's remove these from here. Here we go. We can also open the enemy script because we're going to have an error. We can remove the range enemy related values from there. Remove this. Remove is range enemy. Nope, because we just want this. Yeah, we only want these lines of code. So I'm going to drag them and drop them here. Okay. Let's remove these lines. Perfect. Is not range enemy. Of course, this is never a range enemy. So let's remove this. And finally, we can remove the gizmos. Here we go. Now we are good to go. So we can open our range enemy and start implementing it. So let's remove these lines of code, which were related to the melee enemy. This one too. Okay, so this is the detection radius. Okay, here we go. All right, so let's remove this and these two lines because right here we should shoot at the enemy instead of inflicting damage. We can remove this and we should be good to go actually. So right now the range enemy should almost behave like the melee enemy. I'm just going to try the melee enemy again because I don't want to have errors. So make sure to test it again. Let's disable the enemy and enable the melee enemy. So let's hit play. All right, seems like we are good. Is he going to attack me? Okay, I can attack, and he is attacking too. Perfect. Let's double check if he's attacking me or not. Okay, so let's go closer. Yeah, 9/10. Perfect. So our enemy is still working correctly, which is really good. Again, quick tip here, make sure to test your game from time to time. And we also need to build the game and test it on mobile later on because this is what I've said, come on. We need to make sure that it is working. So we can re-enable our range enemy now. The first thing we wanted to do is to follow the player wherever he's going, and whenever he's within a certain reach, we must stop and try an attack. So the first thing we want to do here is to remove the enemy script from here because we don't want it anymore. We've added our range enemy script right there. Where it is? Right here. Perfect. So let's move it up. Can I, please? Thank you. Okay, maybe we can move it up. Yeah, here we go. Perfect. So our max health will be 10, let's say. We need to specify the renders like we've done for the enemy script. So let's grab the enemy renderer, the spawn indicator, the collider, which is actually down there, but you can also select the game object. The pass away particles, damage will be 1, 1, and let's set this one to 5 and enable the gizmos. Here we go. We can now apply all of our changes to the range enemy. Boom. So all of the changes have now been applied to the prefab and go on. So right now, if we hit play, the enemy will continuously follow the player, but still be able to attack within this range. This is not what we want, of course. You see, he's still following the player. And we are having an error because there is no enemy script attached to the enemy, and the Boink is trying to find an enemy script. Remember, this boy is within the enemy layer, right? But the Boink is trying to find enemies within that layer. And we don't have any enemy script attached to the range enemy. I'm sorry if this is a lot of enemies, but don't worry. Just forget this error for now, and we are going to fix it later. So to complete this method, we are just going to make this boy stop whenever he's close enough, and the other enemy should still follow, okay? So for that, I'm going to open the range enemy script. And inside of here, if the distance to the player is less than the player detection radius, we want to attack. Otherwise, we want to call movement.followPlayer. Okay? So we are going to try and follow the player while we are still far away from the player. So let's open our movement script. Okay, here it is. Let's make this one public so that we can call it from the range enemy. We also want to remove the follow player logic from the update method or just comment it. So Control K, Control C. Here we go. Not this one, sorry. And we now need to follow our player from the enemy script. So inside of the update method, movement.followPlayer. Here we go. So our melee enemy will always follow the player, but the range enemy will only follow if he's far away from the player. So let's go back to Unity. Let's enable one of the enemies, maybe this one, okay, just to see if he's still following the player. We can now hit play. All right, so both enemies are coming. Okay, I don't know. We can check this error later on. So this one stopped attacking the player, and this one came close to us. Really cool. That is really nice. In the next one, we are going to allow the range enemy to shoot bullets at us. See you there. Welcome back, guys. In this lesson, our range enemy will be able to attack us. So let's jump right in. Our enemy script, our range enemy script, by the way, is getting a little bit too long here, 150 lines. So what I propose to you here is to separate the follow logic or the main enemy logic from the attack logic. Okay? So for that, let's create another script. Let's call it, let's create it actually, range enemy attack. Here we go. We can now grab this script and attach it to our range enemy. Let's make sure it has been added. Yep, cool, perfect. Let's now open it. Here we go. So inside of this script, we will need different things. First off, we need the player because we want to shoot at the player. So elements, private, player, flower power. Okay, enough of that. Come on. All right, so we've got the player. Then we need a shooting point. So the spawn position of our bullets. So let's add another header just to make things a little bit cleaner. Settings, or maybe we can actually call it attack settings. Serialize field, private, transform, shooting point. Here we go. From this shooting point, of course, we want to shoot bullets. So we can actually add the prefab. So serialize field, private. Let's, for now, just call it game object. Bullet prefab, let's say, prefab. Here we go. What else do we need? Of course, we will need the fire rate and the damage that the bullet should cause. So for that, we are actually going to grab some logic from the range enemy script here. We are going to grab our damage, okay, and the attack frequency, okay? So let's grab both of these, boom, copy, and jump here and paste them somewhere around here. Here we go. We can actually drop this one inside of the elements, under the elements header, maybe the bullet too. Yeah, and keep the settings here. These ones should be integers, floats, strings, and so on. These are objects. Okay, we are also going to grab the attack delay and attack timer from here. Okay, let's drop them inside of here. Perfect. And implement the start method. So inside of here, we want to write attack delay equals 1 over the attack frequency. And of course, you can decide to add the delay right here, but you know me, come on. Then let's set the shooting timer. So attack timer equals attack delay. Why? Just to allow the enemy to shoot right away once he gets closer to us. You can decide not to do so. You're actually free to try this out. Next, I want to remove all of the attack logic from here. So we don't need the damage, we don't need the attack frequency, we don't need the delay, and we don't need the timer. Perfect. And now we are getting errors. So let's remove this from here. Okay, what else? Inside of the update method here, we are actually increasing the timer. This is not what we are going to do. So instead, here is what I propose to you. The range enemy won't be able to attack before he has spawned. So if the render.enabled equals false, if the renderer is enabled, we are simply going to return. So that way, we make sure that we wait for the spawn sequence to complete. And we should actually grab this line and drop it inside of the enemy script too. So let's quickly do that. Boom, like so. Now, what else? We are going to create a new method to manage our attack. So manage attack. Here we go. Let's create it just down there. Private void manage attack. It will make things actually simpler. And how are we going to manage our attack? Well, this is basically the try attack method. So we first want to grab the distance from the player. I'm just changing the naming here to comply with my scripts. So here is the distance to the player. If we are far enough, we are going to follow the player. So let's grab this line, drop it here, and invert the logic. So if the distance is greater than the detection radius, we want to follow the player. Otherwise, we want to try an attack. So try attack. Here we go. Then, what will our new try attack method look like? Well, we are going to call our range enemy attack and try attack from there, because this is where we manage the timer and so on. So we will need a reference to the range enemy attack. So at the top right here, let's add another require component attribute to specify the type of range enemy attack. Here we go. We are going to add a reference to this. So let's duplicate this line, range enemy attack, range, or maybe just attack. Yeah, that's actually simple. And we can store it just after the movement. So attack equals get component of type range enemy attack. And again, if you're not, if you don't like this method, you can still reference it in the inspector. Yeah, you can actually turn it into a serialized field and reference it as you wish. Boom, boom, boom. Let's remove these lines from here. Okay, because this is not where we are going to use them. We are actually going to wait and attack from the range enemy attack script. And inside of our try attack method, we are going to call attack.autoaim. Here we go. So let's now implement this auto-aim method. So I'm going to copy it. Okay, let's open our range enemy attack. Public void auto-aim. Here we go. So this method will need two things. First off, this is where we are actually going to manage shooting bullets. So we will need to know the direction of our bullets, right? Which direction are we going to use to shoot? So vector2 direction equals player.transform.position. So player.transform.position minus not transform.position here, but shooting point.position, because the shooting point is where we are shooting from. So using the transform.position here would create a small offset from the shooting. I'm going to try and add a small illustration here just for you to better understand. But yeah, we need to use the shooting point.position. Dot normalized. Here you go. And now that we have our direction, we are going to call the manage shooting method. So manage shooting and pass in that direction. Here we go. So private void manage shooting with the vector2 direction. Here we go. So we can already notice that we are using the player here and we haven't stored it anywhere. So one way to store it would be to look or search for it in the start or awake method. But what we are already doing in the range enemy script is storing the player. So at start, what we can do is call the attack.configure method to pass in the player. Or we can actually call it store player if we are only storing the player. Player, like so. Let's go back to our range enemy attack, create a public, void store player, this.player equals player. Here we go. Now our range enemy attack script is aware of the player. That is so cool. I'm just gonna grab this one, drop it here because it's better in my opinion. Cool. And in our manage shooting method, what we want is to increment the timer like we've done for the other enemy. So attack timer plus equals time.delta time. And if this is greater than the delay, so if the attack timer is greater or equals to the attack delay, then we are going to attack. So attack timer equals 0 and shoot in that direction. Here we go. Again, we need to create the shoot method. Private void shoot vector2 direction. What you could have done here is calculate the direction inside of the shoot method. And I think that this is what we are going to do actually. This will prevent us from overloading our methods a bunch. So let's grab this one, drop it here. We can remove these two lines. Okay, remove the direction from here, remove it from here, and from here. Perfect. So this is way cleaner. And here is a quick tip again. As you go, try and improve your scripts. This will make it easier and way cleaner and actually more enjoyable to work with. So now we have our direction. Perfect. We only need to spawn our bullet and shoot it at the player. This lesson is getting a little bit too long, so I think that we are going to do that in the next one. Right now, just for testing's sake, we can actually draw a gizmos. So let's create a reference to a gizmos direction here. Okay, we can actually drop it here. So gizmos direction equals direction. And here on draw gizmos, gizmos.color equals color dot. Maybe we can use a white line. Yep, perfect. So we can draw a line, gizmos.draw line from the transform.position. And the other vector will be transform.position plus the gizmos direction. Gizmos direction, maybe times 5, let's say. We can actually turn this into a vector2, okay, to prevent having errors, and we should be good. So now let's go back to Unity, check if we have some errors. Of course we will have because we haven't removed the wait method and the attack method from here. So let's remove these, boom and boom. I hope that we are not getting other errors. We should not. We do take damage and so on. So yeah, we should be good actually. Perfect. Let's now open Unity again. We need to reference the shooting point, the bullet prefab, the damage, and the attack frequency. So let's set this one to 1, 1. We need to create our shooting point. So right click, create an empty game object, call it shooting point. We can assign a little gizmo, maybe a blue one, sorry. Okay, let's press F to focus it, move it on top of the mouth. So we want to be able to shoot from here. Select the range enemy, grab this boy and attach it to here, let's say. Oh, I do have 2 range enemy attacks because, yeah, I've applied it to the prefab. That's why. So let's remove this one actually. Okay, let's set to 1, 1. And we should be good, so let's hit play and hopefully we should be able to spot a line whenever the enemy attacks. So let's actually wait for a little bit. Okay, let's hit pause maybe. Yeah, here we go. So the shooting will occur in this direction. So from here to here. Again, this is bad because we have used transform.position. So this is why I told you that we needed to use the shooting point position to grab our direction. So we are actually going to draw it from that position. Okay, let's go back to Unity now. Let's hit play. Okay, let's wait for a little bit. Come on, get closer, please. Hit pause. Boom. Here we go. So now the enemy will actually shoot from this position along that direction, up to the player. because this is our player position. What we could also have done is add a center to the player here to detect the player center. Or you can add a method to the player, so to Dave here, to return the player center or this position somewhere around here, maybe the collider center, or whoever wants to shoot at him, okay? Because right now we are using the transform that position. But yeah, this can be a good exercise here. You now know how to create methods and to return objects. I'm gonna give you the solution in the next episode. See you there. Welcome back, guys. In this lesson, we are going to improve our enemy again and allow him to shoot bullets at the player. All right. So the first thing we talked about in the previous one was to improve the player detection here, because right now our range enemy is trying to shoot at the player, but at the transform position and not the actual collider center. So for that, we are going to select Dave here and open our player script. Cool. In here, we can add a reference to the collider. So serialize field, private, collider2D. Collider, let's call it. Here we go. Let's drop it at the top. And we can add another method, so public vector2, to return the position where the enemies should shoot. So get, let's say, shoot position or get center, something like that. Yeah, call it whatever you want. Again, I'm really not good at finding names. And in here, we want to return the collider.center. Oh, and of course we can't because we're using collider2D. So we know that we are using a circle collider2D. So let's specify that. Perfect. And yep, we should now have not the center, but the closest point, overlap point. Oh, come on. There is the center. Where is it? Here it is. Radius and offset. Oh, we need to use the offset. So we are going to use transform.position plus the offset. Okay. So transform dot position plus collider dot offset. Here we go. And of course, this should be turned or casted into a vector2, just to prevent having errors. And here we go. So we now have the center of the player, collider wise, of course. So let's use this inside of our range enemy attack. So the direction of the movement should be player dot get center. We can remove the transform that position minus this. Okay, so this is a vector3, this is a vector2. So we can actually cast this boy into a vector2, or what we could have done is also change this method to return a vector3. Boom, boom, boom. This is good. We just need to set up our collider right here. So let's reference it, grab it, drop it, play it. Bam. All right, so now let's have a look at our scene. And whenever the enemy gets closer or close enough, let's hit pause. Boom, here we go. So now the bullet will be shot from this position to the center of the player. Perfect. This is exactly where we want it to be. All right, so now that this is good, you can actually apply the same logic to the enemy, but this is okay because he's trying to get closer to the player. So it's okay, it's cool. And now let's add bullets. So let's grab the bullet from the sprites folder, but first off, we can actually apply the overrides to the enemy prefab, range enemy attack, blam, blam, so on. Yep, perfect. Let's create our bullet now. So sprites, enemies, maybe seed. Here we go. So this is the bullet here. Nice. I think that it has a decent shape and decent size. So what we're going to do again is right click, create an empty parent as usual. And this is the enemy bullet. This is going to be called enemy bullet render. Here we go. Nice. What we are going to do then is add a circle collider to the enemy because we want it to be able to interact with the player. We just need to diminish the radius to something like that. Maybe actually, yeah, something like that should be good. Cool. And the basic behavior of our bullet here is that it's going to have a rigid body like we've added to Dave, okay, right here, so that we can initialize its velocity at start and then let it do its thing, okay? So we are going to spawn it from here, then give it a certain velocity along the x-axis, and it should actually go towards the player. I don't know what I'm using should, but of course you never know what will happen in Unity. Anyway, let's go on. So this is our bullets. Let's add a rigid body 2D component. Here we go. We don't want any gravity to affect it, so gravity scale equals 0. Our bullet will not go that fast, so no need to use a continuous collision detection. It will be less performant because it needs more resources. And yep, we should be good. So now let's turn this one into a prefab and attach it to our range enemy attack. So prefabs, grab this, drop it here. We can remove it now because we are not going to use this one. Let's assign our bullet prefab. So enemy bullet, here we go. Let's open our range enemy attack. And inside of the shoot method, we can actually remove the gizmos. We know that this is working. So let's remove this. Perfect. We've got our direction and you know how to instantiate a bullet. So quick exercise. Try and instantiate the bullet first, then access the rigid body and give the direction multiplied by a certain velocity as the velocity of the rigid body. It should be pretty straightforward. Please try and do so, then come back and watch what's next. All right, here is one solution. So first off, we need to instantiate our bullet. So instantiate the bullet prefab. We are going to instantiate it as a child of the scene because if it is a child of the range enemy, it will move with it, and this is not what we want. So we actually need to specify the shooting point dot position as the spawn position and quaternion dot identity as the rotation. So quaternion dot identity. Here we go. So this should return a game object for now. So game object bullet instance equals this. Here we go. So first off, we want our bullet to face the player. So bullet instance dot transform dot right, because if you remember well, we are using the right vector to follow or to aim at the player, right? Where is our bullet? Right here. Here we go. We are going to move along this direction. This is why transform dot right should be equals to direction. Perfect. Then we want to access the rigid body. So bullet instance dot get component of type rigid body 2D dot velocity equals direction times a certain amount. So let's say, I don't know, maybe 5 for now. Okay. So this should work properly. Let's give it a shot. Let's remove the bullet from here, select the range enemy. Everything is set up correctly. Perfect. Let's hit play. And normally he should be able to shoot bullets at the player. So let's try this out. Okay. Moving towards the player now, maybe. Okay. All right. It's funky now. Why is it behaving like so? This is because whenever we spawn the bullet, it's actually colliding with the circle collider of the enemy, right? If we have a look at here, the circle collider is not a trigger, but right now it's moving. Boom, boom, boom. Awesome. So I know what you're thinking about. It feels like something else. It feels like it's not a bullet, but yeah, you can change the sprites. Come on. Anyway, so our bullet will behave like a trigger. So we can select it and turn it into a trigger, hit play, and now it will actually work properly. So it will pass through the enemy and pass through the player. Okay, let's try this out. All right, boom. Yeah, that's way better. So we now just need to add detection to our bullets so that we can actually damage the player. Let's do that in the next one. Welcome back, guys. In this lesson, we are going to add logic to our bullets so that they can damage the player. Okay, so for that, we are going to try and detect collisions or trigger enters between the bullet and the player. So we know that our bullet has a circle collider along with a rigid body, and our dear friend Dave also has a rigid body with a circle collider. So it means that we can collide with it, but because at least one of these two have a rigid body 2D, it means that we can detect collisions in a certain way using built-in methods. Okay? So let's create our enemy bullet script. So scripts, enemy, right-click, create C# script, enemy bullet. This is because we're also going to have a player bullet, of course. We now need to attach this script to our bullet. So let's open our prefabs folder, enemy bullet here, and add the enemy bullet script. Cool. We can now open it. Awesome. So inside of this script, what we are simply going to do now is add the onTriggerEnterToD method. And this is a callback whenever an object enters a trigger. So it will definitely fire whenever the bullet hits the player or enters the player trigger, or the player enters the bullet trigger. One of these two. Okay, so in here, we can check the collider. By the way, I like to rename this because the collision name doesn't match the type here. So collider. So we can check if the collider dot try get component, we are trying to grab a component attached to this collider. So it will return true if that's the case. So if we find the component we are looking for, and false if we don't. So out player. Let's try and find the player. So if we do find it, we are going to execute this logic. Otherwise, nothing will happen. This does prevent us from killing the enemy or anything else. Okay, we could have also used layer masks, but I wanted to show you how you could do that in another way. So if we detect the player, we are going to call player.take damage, and in here we need to know how much damage the enemy bullet will deal. Ideally, you don't want to attach that value to the bullet. You want to attach it to the range enemy attack or your enemy. Except if you want to add multiple weapons to your enemies, then it's another story. But we already have the damage right here, so later on we will grab it from here. Right now, let's just try and deal damage to the enemy. So let's deal 1 damage. Here we go. Then what we want to do after that is destroy the bullet because we don't need it anymore. So destroy, destroy game object. Here we go. This is the simplest way you could have added this, because if you remove the start and update method, this is working and it's 14 lines long. 15, come on. Let's make it smaller. 13, nice. It's only 13 lines long, okay? So yeah, let's try this out. So let's go back to Unity. And then, of course, we are going to use pooling. It's going to be an exercise, so get ready. Okay, so we don't need to do anything in here. Let's hit play. Okay, let's wait for a little bit. The enemy should be able to shoot in a moment. Okay, boom, 9, 8, 7. Let's try and avoid them. Come on, shoot at me. Hey, you did not touch me. Hey, I'm here. Come on, you missed it. But unfortunately, we can't fight back. This is because we don't find the enemy script again. You know that. So yeah, this is already really cool. The enemy can shoot bullets at us, and it's actually dealing damage to the player. Perfect. But we still have some issues here. As I've told you, right here, we don't want to add the damage as a hard-coded value. We want to grab it from the range enemy attack, ideally. And there is also another thing here. We are accessing the rigid body, so by using the getComponent method, and we don't know if the bullet instance does have a rigid body 2D. So this is not object-oriented friendly. What we would like to do, ideally again, is to grab or call the enemy bullet dot shoot, and it will manage itself. So we will have the require component attribute and so on here. So let's improve that in the next one. Welcome back, guys. In this lesson, we are going to improve our bullet so that it is more object-oriented friendly. Good. So let's open our enemy bullet script right here. To shoot the bullet, we are going to add a new method, which is the shoot method. Of course, come on, Mr. Obvious. So public void shoot. What will we need inside of this shoot method? Of course, we need to know how much damage we will deal, because the range enemy attack is the one that holds the damage value right here at the top. And yep, we need it. So let's add int damage. Secondly, we also need to know the direction of the movement. So vector2 direction. Perfect. And in here, we can then apply our direction to the velocity of our rigid body, which means we need a rigid body. So require component of type rigid body 2D. Here we go. So let's add a reference to our rigid body here. So header elements, serialized field, not serialized field, come on, private rigid body 2D rig, let's say. Here we go. And inside of the awake method, we can store this rig. So rig equals get component of type rigid body 2D. Here we go. Inside of here, we want to store our damage, by the way. So let's add some settings. Private integer damage. We can store it. So this dot damage equals damage. Perfect. Which will help us deal damage to the player using this value. So no more hard-coded value here. Cool. In here, we also want to use the direction to orient our prefab, like we've done right here inside of the shoot method of the range enemy attack. So we want to set the right vector of our transform to that direction. So let's go back to our enemy bullet and write transform.right equals direction. Cool. We can also apply the velocity. So rig.velocity equals direction times the move speed, a certain move speed. So in here, you're free to actually add the move speed to the enemy bullet or pass the move speed with the direction. So inside of the range enemy attack, we can imagine the enemy being responsible for determining the velocity of the bullet. But in my case, in this case, actually, I like to add the velocity of the bullet to the bullet. That way it makes it more tweakable, okay? And again, feel free to change that if it feels weird to you. So in here, what I'm gonna add is a serialized field, boom, 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 like so, move speed. So I think we are actually good right here. So what we're gonna do now is edit our range enemy attack. Instead of spawning a bullet instance as a game object, we want to spawn it as an enemy bullet, okay? And it means that we also need to change the declaration right here at the top, like so, enemy bullet. This will allow us to call the shoot method inside of the enemy bullet script. So in here, bullet instance.shoot, we need to pass in the damage and the direction, like so. This is already really nice. We can remove these two lines, we can remove this one, and we should be good to go. So let's go back to Unity here. Select our enemy bullet prefab to set up our velocity. We're gonna set it to 5 like we had previously. We can select our range enemy and pass in the enemy bullet, like so. So if you've noticed, we had a type mismatch because we had a game object previously and we were referencing an enemy bullet. Okay, so we should be good. We can apply the changes to the prefab and hit play. So let's see how it looks like now. I'm gonna try and move it a little bit. Okay, yep, he's shooting bullets at us, right? Does it deal damage? Yeah, 9, 8, 7, and so on, come on. All right, perfect. So this is working. The enemy is following and we can turn this one as a slower enemy maybe. So what I'm gonna do is select, boom, this one, maybe move speed half of the other enemy's speed because he's a range enemy, come on. But later on, we will make them really fast, like, I don't know, maybe 5. Oh, he's dead. Where's he? Oh no, the scene has been reloaded. But yeah, later on, we will balance the game so that it feels more polished, okay? So in the next one, as a cool exercise, I invite you to add pooling to the enemy bullet. Okay, so basically this is the one that will manage the pool, the range enemy attack, because he only has one type of bullet in our case. And yep, you will have to release the bullets and so on, like we've done inside of the damage text manager, if I remember well. So yeah, you can heavily take inspiration from this script and add pooling to the range enemy attack. I'm sure you can do that. See you in the next one for the solution. Welcome back, guys. In this lesson, we are going to pool our enemy bullets because, as we've seen, it's going to be way more performant than spawning them and not reusing them. All right, so for that, we are going to open our range enemy attack script. And we are first going to add the library. Have you done your homework or not? I hope you have. So using Unity Engine pool, of course, then I'm going to create the pool maybe somewhere around here. So bullet pooling. Okay. Then I'm going to create the pool. So private object pool of type bullet, enemy bullet, of course, bullet pool. Here we go. We also need to instantiate the pool in our start method. So bullet pool equals new. Object pool of type enemy bullet, and of course we need to pass in all of the functions like we've done in the damage text manager. So we can grab these, boom, copy them, paste them here, and of course we need to remove some parentheses Here we go. We now need our create function, action on get, and so on. So let's grab them from here. Here is the create function, like so. Of course, we are going to edit them, but I just don't want to rewrite them. So let's drop them here. Cool. So this one should return an enemy bullet, damage text printed, enemy bullet, enemy bullet, enemy bullet, and enemy bullet, enemy bullet. Yay. All right, so let's rename these really quickly. This should be our bullet prefab. So bring it here. Okay, so this should be a bullet. Okay, same thing for the other ones. Boom. And boom. Perfect. So the first thing we want to change here is our create function. When creating the bullet, we actually want to configure it and pass in the range enemy attack. That way, we will be able to release the bullet because as we've seen inside of the enemy bullet script, the bullet is managing itself and right now it's destroying itself, but it will actually not be responsible for that. The pool right here or the range enemy attack will be responsible for managing the bullets. Okay, so let's implement the create function. First off, we want to create it. So enemy bullet, let's call it bullet instance equals instantiate. The bullet prefab, of course, at the shooting point dot position, like we've done right here, actually. So shooting point dot position, we will need to pass in quaternion dot identity. So quaternion dot identity. Here we go, and we should be good. Then we need to configure our bullet and pass in the range enemy attack. So bullet instance dot configure with this. And I don't know if I've already told you that, but the this keyword refers to the current script. So in here, this refers to the range enemy attack, this one, okay? That way, the bullet instance will be aware of its parent or the one that has created it, and will be able to come back to it, okay? So we can then return the bullet instance, like so, perfect. And let's create our configure method for now. So let's open our enemy bullet script and create the public void configure, and it should take a range enemy attack as an argument. So let's call it, range enemy attack. Perfect. So for now, we are just going to cache this and use it later when releasing the bullet. So let's create a reference to it, maybe inside of the elements header. So private range enemy attack, like so. And in here, this dot range enemy attack equals range enemy attack. Perfect. Let's jump back to our range enemy attack for now. We can remove this line. And we are now going to grab a bullet from the pool instead of instantiating it right here. So we can write bullet pool dot get. Perfect. That's way easier. So let's now implement our action on get method, which is right here. So we actually turned the game object true for the damage text, but we want to do something else in here. We first want to reload the bullet and then move it to the shooting point, because let's say we've created a bullet at some point. It has moved and is kind of far from the shooting point, so we want to bring it back to the shooting point. So first off, bullet.transform.position equals shooting point.position. That's one thing. Then we want to set it to true, but we also want to reload it. And reloading it here means maybe re-enabling the collider or maybe its direction and so on. So bullet.reload. Here we go. We can now remove the spaces and we are going to implement the reload method. So let's open the enemy bullet script and create the reload method. So public void reload. Okay, so what do we want to do inside of here? Well, our bullet had a certain velocity, so we need to stop it from moving. So rig.velocity equals vector2.0. That's the first thing. Next, when triggering the player, we were destroying the bullet, which is really bad. So let's remove this line. And instead, what we're going to do is actually disable the collider and call the release method or release the bullet. Okay, we should actually trigger this action on release. So let's go back to our boy enemy bullet. Okay, and let's write get component of type collider2d dot enabled equals false. That's one thing. Cool. But a better approach would be to store the collider or to tell Unity that it does require a collider 2D. Okay, so let's do that instead. So type of collider 2D, perfect. We can actually, oh, why do I have an error here? It does expect a thing, boom, bam, beam, yeah, like so. So let's add a reference to the collider, private collider 2D, collider, here we go. And at start, we can write collider equals get component of type collider 2D. Perfect. So we can now disable the collider, cool. And we are also going to release the bullets. So range enemy attack dot release bullet, and we can pass in this bullet. Perfect. And again, let's jump back to the range enemy attack so that we can release the bullet. So let's add a public. Maybe we can add it somewhere around here. Yeah, public void release bullet, enemy bullet bullet, and let's call bullet pool dot release bullet. Perfect. So now we should be good. So let's try this out. Go back to Unity, clear the console, and normally we should not have anything to specify in here. So let's hit play and see what happens. All right, let's open our game window. Here it is. Cool. Here's the first bullet. Okay, so we are getting an error here. Weapon, that's okay. This is because we can't attack this boy. Right now we can see that a lot of bullets are being created and we are not detecting the player. So what happens here? The issue here is that whenever one bullet touches the player, the circle collider of the player gets disabled. So this is really bad. Why does that happen? This is because the collider here refers to this collider, so the player actually, the one that we've hit. Instead, we should use this dot collider. So this is one thing that you need to make sure of. So always double check your values. This is why some people like to call these in another way, like with different naming conventions. We can call this collider or underscore collider and so on. But honestly, even though I've made this mistake here, I really like to use this keyword. So pick a method, make a choice, and go with it. All right. So now let's go back to Unity, and we should be good. All right, let's wait a little bit. Okay, shoot at me, please. 1, 2, 3. Oh, come on. Some bullets are hitting, some are not. And why does that happen? Because we haven't re-enabled the collider when reloading. So this dot collider, or actually we can write collider dot enabled equals true. Let's now go back to Unity. Let's hit play, and we should be good. Should. Okay. So let's move a little bit. Okay, so that's 1, 2 bullets, 3, 4. So we can notice that the enemy has shoot 5 or 6 bullets, but only one has been creating, and we are reusing it. But there is still one thing that we need to take into consideration. If the bullet doesn't hit us, it will continue its road infinitely. Like this. You can see that there are now 2 bullets, 3 bullets, 4 bullets, and so on. So we need to make sure to release the bullets after some time, maybe 5 seconds or something like that. Or you can decide to have a collider or a trigger at the bounds of the arena to release the bullet. Again, it's your choice. So let's release the bullet after, let's say, 5 seconds. So for that, we are going to use the lintwin library again. So lintwin dot delay call after 5 seconds. What do we want to do? We want to release this bullet. So let's use a lambda expression. Range enemy attack dot release bullet. This, like so. But let's make sure to pass in this game object, by the way, so that we can stop or cancel the call or this twin if we've hit the player. Otherwise, the bullet will be released and we are still going to try and release it. That's really not logical. So if we hit the player, lintwin.cancel game object. Here we go. Perfect. What you could also have done is use a coroutine. So let's say you don't want to use the lintwin library. Let's comment this. What you can do is start a coroutine and call it, I don't know, maybe release coroutine. Here we go. Let's create that coroutine somewhere around here. So I enumerator release coroutine. Here we go. And in here, what you want to do is wait for, let's say, 5 seconds. So yield, return, new, wait for seconds, 5 seconds. Here we go. And after that, you can just call the release bullet. So range enemy attack dot release bullet. Here we go. We need to pass in this, by the way. And to stop this coroutine, what you could have done inside of here is stop coroutine with the name of the coroutine. So release coroutine. And of course, parentheses. Here we go. So that's one way you could have done that. And you can also stop all of the coroutines if you only have one coroutine, let's say. You could call stop all coroutines. And this will make sure to stop this one and all of the other ones if you have any other ones. Got it? I hope this is clear and helpful. So I like to use lean twin. So I'm going to remove this, and boom, remove the coroutine. Here we go, and remove this line and uncomment. Here we go. We should be good to go, so let's try this out. Let's hit play. All right, I'm gonna wait for a little bit, try and avoid some bullets. Here is one. Let's follow it. Okay. It has been released. So both our bullets have been released. And now it should be shooting this one maybe. Yep, awesome. This is working really well. Cool. So this is it for our range enemy, but as you can see in our range enemy script, we have a bunch of logic that we've grabbed from our enemy script, the melee enemy actually. So is there a way to reuse the same code in a different way? Maybe keep our common things in one script and put enemy specific logic in other scripts so that we can keep short scripts and prevent having duplicate lines? Of course there is. And you are going to learn how to do that in the next one. See you there. Welcome back, guys. In this lesson, we are going to learn about inheritance. So this is a fancy word just to say that our player will be able to attack enemies and range enemies without adding more lines of code. So right now, the player or the weapon actually is able to detect enemies, which are right here. So we grab the enemy script, but our range enemy doesn't have an enemy script. So let's fix that. Okay. So the first thing we want to do here is open our enemy script and rename it. Why? Because we are going to have two kinds of enemies right now. We can add more later on, but for now, we just have melee enemies and range enemies. So what I'm going to do is hit Control R or Command R twice and call this one melee enemy. Cool. So is everything working correctly? I don't know. We're going to wait for a little bit and find out. Normally it should. All right, so everything is still working. What we are going to do, by the way, is hit play to try this out, just to make sure, and then we can commit our changes because we haven't done that in the previous one. This is the beginning of the section, so it's a good time to actually commit the changes. So yeah, seems like everything is working correctly, but I can't attack the range enemy. Okay, so let's fight back. Let's commit our changes. So we've added range enemy. Here we go. So now let's clear the console. Okay, let's open our script. So we have our melee enemy. What we are going to do is create an enemy script to merge these two enemies in one. So let's create a new C# script, enemy. Here we go. And let's open that script. Boom. So I'm going to have the enemy script right here and grab the melee enemy script and move it somewhere right here on the right. For now, I can just clear the Unity project so that we have a bunch more space. Here we go. And what I want to do right away is instead of inheriting from the mono behavior, so the 2 points right here mean inheriting. So the parent of our melee enemy script is the mono behavior class. So if you hit Control and click on mono behavior, you can see all of the variables and the methods that we can use inside of the melee enemy class because its parent is the mono behavior class. So in the previous one, we've used start coroutine, and you can actually print, you can actually use did start, did awake, and so on, and so many others. You can again click control behavior and see that you can enable it, is active or enabled, component, and so on and so forth. So let's go back to our melee enemy script. Here we go. And let's inherit from the enemy class. Perfect. So now because it inherits from the enemy class, it also inherits from the mono behavior class. So we can still call the start method and update and so on. If the enemy class did not inherit from the mono behavior class, like so, you would have errors here. We would not be able to call the basic start method, which is included in the mono behavior, the get component, find first object of type, destroy, and so on. Okay? So this is one thing you need to keep in mind regarding inheritance. And I'm going to explain things here, but if you don't understand, please make sure to leave a comment. I'm going to help. And if you want some specific lessons only based on inheritance, let me know. I'm going to try and make them. All right, so let's find common things between our melee enemy and our range enemy, okay? This will guide us to create our enemy class. So I'm just gonna bring this down. Okay, so let's grab our range enemy and drop it maybe somewhere around on the right. Yeah, where is my mouse? My mouse. Okay, let's keep it here. Maybe we can drop it here in the middle. Oh, this is really tiny. Can I just please? How do I move this boy? Oh, right here. Here we go. All right. So what I've done here is put the tabs at the top here, so you can actually place them on the left and so on, so that we can better see our 3 enemy scripts. So I can actually zoom out, but I'm afraid that you won't be able to see it properly on a small screen. So let's keep it as is for now. So both our range enemy and melee enemy do contain the movement script. So what we can already do is grab this, Control X, and drop it inside of the enemy class. And by the way, the range enemy should also inherit from the enemy class. So now we can notice that we have an error regarding the movement script. It is inaccessible due to its protection level. So you could make it public. Now it's accessible, but it will also be accessible to other scripts. So the one that inherit from the enemy class, but all of the other ones too. And we don't want that. We only want to allow the classes that inherit from the enemy class to access the enemy movement. So for that, we are going to use the protected keyword. This ensures that only classes inheriting from the enemy class can access this boy. Okay? So we can remove it from the melee enemy class too, and go on. This is actually really simple, as you can notice. We are going to do this for all of our properties and fields. So let's grab the health. Okay, Control X, drop it here. Perfect. We are also going to remove it from here. We are getting errors, so we need to make these protected, and health should also be protected. For now, of course, because we are doing this to prevent having errors, but maybe all of the health logic will be inside of the enemy class, so we might be able to keep these private, but one thing at a time. So both of these boys have the player, so let's bring it here. Here we go. And you can actually speed this up if you got this point, or follow along if you want to make sure that you understand the whole concept. So let's remove this. Okay, let's make this protected. Here we go. Both of our scripts have the renderer, spawn indicator, collider, and has spawned. So let's boom, drop them here. And of course, protected, boom, protected. I can actually copy this keyword and paste it every time, just so that I don't get tired. Effects, pass away particles, attack player detection radius. Both of them have the player detection radius. So let's grab these, drop them here. Here we go. And again, protected. Oh, come on. I forgot that I was copying other things from other scripts, so I can't do that. Protected. Okay, I can remove these from here. Remove the pass away particles and the player detection radius, but I need to keep the damage and attack frequency inside of here because we are not managing them inside of the enemy script. I'm going to remove some spaces here on damage taken. So let's also grab this action. Okay, drop it there. Let's remove it from here. Debug to boom, boom. And of course, I'm getting an error here for the action because I need to add the system library. So using system, here we go. Let's remove the gizmos from here too. Okay, protected to prevent having an error. And here we go. That is already way cleaner. You see, no more bunch of variables, and it's already really cool. So now that you got this, in the next one, we are going to apply the same logic for all of the other methods, just so that you can tinker this out and think about it a little bit more. So see you in the next one. Welcome back, guys. In this lesson, we are going to keep implementing our inheritance. So let's go on. Let's open our scripts. Here we go. What we are going to do now is go on with our methods. So we've got the start method. Both of these contain the health equals max health. So let's remove it from here, drop it here. We can also remove it from here. Movement, attack. This one doesn't have the attack component. So we are only going to grab the movement. Okay. Same thing for here. Player, okay, boom, remove it from here, add it here, of course, remove it from here. If player equals null, start spawn sequence, boom, like so. Let's do this, here we go, and I'm sure you get the point here, so no need to follow along with me. Try and do that by yourself and come back when you are done. So bim bam boom, let's keep these two, and then we are going to actually implement some other things here, don't worry, because right now we are not calling the start method from the enemy class inside of here, but one thing at a time. So let's grab the start spawn sequence, because it seems like it's the same one, same thing for the sequence completed here. Set renders visibility has spawned, collider equals true, and move store player. Okay, so let's grab these two. And make sure to do this step by step so that you don't miss anything. That's really important here. So I'm just going to, yeah, I've duplicated this. Okay, perfect. Here we go. I did not forget anything. Yep. So let's remove these two. Okay, so set renders visibility. I'm going to grab this one, drop it here. Perfect. Let's remove this. What about the update method? Both of these check if the render is enabled. So I'm going to grab this line, drop it inside of the update method, remove it from here too. Movement.follow player, and here manage attack. So this is not the same logic. So let's keep it as is. Okay. Then we can go down, try attack distance to player. Okay. So this is again not the same logic. Attack, take damage. Take damage should be the same one. So on damage taken, pass away, blim bam boom. Yep. Let's grab this one, drop it here, remove it from here, okay, pass away, and on draw gizmos. These are the same. So let's grab these two, not here, right here, perfect. We can actually remove the spaces here, here we go, and remove our two methods from here. So this is not a fun thing to do, I'm okay with you, but this is something that will drastically improve your coding skills because it will help you implement way more enemies way faster and help you make your code more sustainable. So let's save our scripts here, boom, boom, okay. So this one is now 50 lines long, 40 lines long, and this one 111. So that's really cool now. It's way easier to debug and to spot wrong things. Oh, we've gained some lines here, 40 lines long. Okay, cool. Anyway, so now if we go back to Unity like this, okay, if we hit play, I'm not sure it's gonna work properly. So let's try this out. Yay, we've got errors. So enemy, not set to an instance of an object. Here, not set to an instance of an object. Not set to an instance of an object. Why? This is because our start method, update method, start spawn sequence, and so on are not called from here. This is why it's not working. Moreover, you should not be able to create an enemy object. This doesn't make sense. So because we have the range enemy, the melee enemy, but enemy doesn't make sense in our case now. Look, if I take a random game object, so let's take the effects game object. If I try and add the enemy script, it works. What? It should not work. So to fix that, we are going to turn our enemy class into an abstract class. Here we go. That way, we won't be able to instantiate that class or create an instance of it. So now if we try again and grab this, drop it here, can't add script behavior enemy, the script class can't be abstract. of course. So this will prevent us from creating a basic enemy that doesn't make sense. So we will need to inherit from this class to create any enemy. Okay, perfect. The next thing we want to do is to call the start method, so the enemy start method, inside of the range enemy and melee enemy. So for that, what we can do is use the same logic that we've used before. So let's write protected. Here we go. So now all of the children classes can access the start method, but you can see that there is some green jiggly lines right now. So start is called, but it does hide the inherited member enemy.start. So we can either use the new keyword to tell Unity that this is a new start method, but that way it won't be called. We will actually call the start method from the enemy class. Let me show you. If we go back to Unity, hit play, the spawn sequence. So let's try and add some debug lines. So debug.log start range enemy. And this one should be start enemy. So debug.log start enemy. Okay, let's now go back to Unity. Okay, we can actually also add a debug line inside of here. So debug.log start melee enemy. Here we go. And you know what? I'm actually going to drop these at the top so that I don't get any error, or so that it displays before getting any error. So let's drop this here. Here we go. And let's now go back to Unity. If we hit play, let's wait for a little bit. We can notice that our start range enemy has been called, the start melee enemy has been called, but the enemy one has not. This is because we need to better manage the order our elements or methods are called. Right now, we debug this, then we are getting the component, which does work, but then we are trying to stall the player that has not been initialized by the enemy class yet. So make sure to first call the base start method, the one inside of the enemy class, then apply the specific logic of your enemy. Okay? So for that, what we can do is call the base.start method, which will call the start method from the enemy. So let's actually call this one here too, base.start. So now when calling the start method, we are going to grab or call all of these before applying this logic. So now if we go back to Unity, hit play again, what we can notice is that our enemy is shooting. Okay, this one is moving. So we have less errors than before, but we still have errors, of course. But in here, start range enemy, start enemy, start enemy, start melee enemy. Okay. So we've started with this one, then base.start called this, and same thing for the melee enemy. We base start, so we've debugged start enemy, then start melee enemy, and this is what we can notice here. The other way we could have made this, and the one we are actually going to use, is by using the virtual keyword. So by adding the virtual keyword inside of the enemy class, we allow other scripts to override the base start method. So this one, okay? So that way we can keep the void start, but we are going to use override void start instead, and it needs to be more accessible, so it cannot be private. Instead, we are going to make it protected to have the same protection level as the base class, and we can now keep our logic as it is. So same thing here, protected, override, start. Here we go. So let's now go back to Unity, hit play, and it's working as it should, except for the other things that we haven't implemented, but let's keep that for the next one. Okay, got it? So I hope this was helpful and it helped you understand inheritance and actually polymorphism, because this is actually polymorphism. You allow a method to have a different shape. Poly means many and morphism means shape. So you have different behaviors depending on what you want to achieve with the same method name. I hope this was really insightful. And as an exercise, actually, you can try and implement the same logic for all of the other classes here. So yeah, try this out. Can be fun. See you in the next one. Welcome back, guys. In this lesson, we are going to keep refactoring our code. Okay, so let's go on. Oh, I wish Udemy had an option to display two screens, even though I only have one screen. And actually, I have one screen just to get used to using one screen, because if I had two, I'm sure I would forget to display the other one and show you what's in there and so on. So yeah, I only have one screen actually. Really fun fact here. It's not fun at all. But anyway, okay, let's go on. Let's tackle the update method. And by the way, we can remove the start debug from here. Bim, bam, boom, like so. Let's remove this too. Okay, just to make our code cleaner. Clean code, clean code. Okay. So in our update method in here, in the base class, we check if the render is enabled to allow the enemy to attack, right? So we should do the same thing here. But unfortunately, if we write base.update in here, let's try this, but we need to make it protected first. Like so, okay. Let's use the same logic inside of this update method. Here we go. So we can actually use new just for testing purposes. Boom. New, come on, I can't type. Hurry up, here we go. Let's now go back to Unity and check if this is working. So previously, we've seen that our range enemy was able to throw bullets at us, even though he was not visible. So he had not spawned yet. And right now, same thing. He can still shoot at us. Because using this logic right here will not return inside of this new update method. It will just return in here and not apply the logic that you might have after this line, okay? So this doesn't make any sense. Instead, what we're going to do is keep this one protected, but turn it into a Boolean. And let's change its name to can attack. So if we can attack, return false. If we can't attack, by the way, but otherwise return true. So this is one way we could have written this method. Another way you could have written this method is by writing return render.enabled. So it will return true. If the render is enabled, we can attack. Otherwise, we can't. So yeah, should be good. Here we go. So now we can check if we can attack or not. Let's remove the new keyword, keep this one void, and check if we can attack. So if can attack, or instead if we can't attack, let's return. Here we go. Let's apply the same logic for our boy right here. Boom, if can attack, but if we can't attack, and we should be good. So let's try this out. Let's hit play. And now we can notice that our range enemy is not attacking before spawning, which is really cool. And no more errors, by the way. Can we still attack this boy? Yeah. Okay, so the behavior is already really cool here. We still have this error where we can't attack the enemy, which is really bad. And we actually still have things to implement in here. So I think that we're actually done in here. We've got all of the logic that we need. One quick thing I want to add is allow our range enemy here to face the correct direction, because right now he's facing right and shooting left. So it doesn't make any sense. Come on. So let's open our range enemy script, and what we can do inside of the update method, so really quickly, is write transform.localScale equals player.transform.position.x. Wait, 1 second here. I'm just going to reset things how I had them. I can remove the tab 3 melee enemy. I'm not gonna need it for now. I can grab this boy, drop it here. Here we go. Oh, what a relief it is. Come on. Now I can see further than 3 centimeters. Anyway, so in here, the logic is that we just want to grab the X position of the player, so where it is along this axis, and if we are on the right of the player, we should face left. So we are going to grab the local scale and set this boy to -1, okay? The X value, or the value along the X axis. Otherwise, it should just be 1. Got it? So in here, we are going to check if this is greater than transform.position.x. And if that is the case, so you can use this syntax, you can check something, then add a question mark, and the first value will be the value if it is true. So if it is true, our scale should be vector3.1, and by adding the 2 points here, you can add the false statement. So if it is false, If it is false, we want to set it to vector3.1, not times -1, because we only want to change the value of the x-axis. So you can use an extension method that I've provided, x -1. And if you want to know more about extension methods, by the way, I invite you to go check my Code Ninja course. It's something like 40 minutes long for now, but it's free and it contains some really cool tips and tricks. So go check it out. All right, so this is one thing. Let's now check if this works. So let's hit play. All right, so let's wait for a little bit. So the range enemy is facing left and now it's facing right. Yay! Facing left, facing right, facing left, facing... So cool. All right, so this is working. And in the next one, let's learn how we can actually make our weapon attack both enemy types. It's going to be really simple. And I'm sure you can do that because you know that both enemies inherit from the enemy class. That's just a quick hint. So implement that and let's check for the solution in the next one. See you there. Welcome back, guys. In this lesson, we are going to learn how we can allow the player to also attack the range enemy. Okay. So for that, we are going to open our weapon script. Okay. Because right here, we were looking for a melee enemy. And instead, we are now going to look for an enemy. How easy was it? So we, of course, need to change this. Okay, enemies equals get component enemy and so on. Damage enemy. So the damaged enemy list should be a list of enemies instead of melee enemy. Yeah, right here. So enemy. And same thing in here. Cool. So that's one thing. Is it working now? No more issues. Should be good. So let's try this out. Okay, let's hit play. All right, let's wait for it a little bit. Let's try and attack this boy. Okay, so I still can't attack this enemy. Why? Because of course we also need to edit our get close enemy method. It should return an enemy instead of a melee enemy. So let's remove this, and this. Here we go. So now we should be good. Hopefully no more melee enemies. Oh, right here. Enemy instead of melee enemy. Okay, bim bam boom. Yep, we should be good now. So let's go back to Unity again. Let's hit play. Let's try and attack this boy. Okay, here. Yeah, awesome. This is now working really well. That is so cool. So that's one way we can allow the player to attack two types of enemies. But later on in the course, we might want to add something else, maybe like a tree, like in Brotato. When you hit or destroy a tree, you get you get some more health or some food or something, okay? So in the next one, let's fight back and give ranged weapons to the player. See you in the next one. Welcome back, guys. In this lesson, we are going to learn how to add ranged weapons. And just before that, we are going to commit our changes, of course. So let's open GitHub and add maybe enemy... refactor, something like this. Maybe we've used inheritance. Hooray! All right. And again, before that, so I invite you to try and add the range weapon by yourself. Please just try this exercise because you now know how to manage attack. You know how to manage bullets thanks to the range enemy. You know about inheritance because we tackle this with the enemy script, right? So basically, here is what you should do. You're going to duplicate the boink, the weapon, okay? You are going to change the weapon script here for a melee weapon script. You are going to create a new weapon script, which will be the parent of the melee weapon and the range weapon. You can steal the logic from the range enemy regarding the attack and merge all of this beautiful world and it will give you the range weapon. So I'm going to try and do that really quickly now, but please, again, try and do this exercise. I promise if you can do this by yourself, you will drastically improve your coding skills. So let's do that. Okay. So I'm going to duplicate the boink. Here it is. Let's call it, I don't know, maybe cotton candy gun. Yeah, that's the one that I've used. So cotton candy gun. All right, perfect. Let's press F in the scene view, move it to the left so that I can better see it. I'm going to change the rendering first. So the point renderer here should be gun renderer maybe. Like so. Let's try and find our cotton candy gun. So cotton, here it is. Perfect. It should face up, of course, because we always want to face up like we've done for the boink, so that we can better manage the animation. This one will actually not contain animation. You can try and add a recoil animation, but it's not compulsory. All right, so do we need a collider? Nope, we don't. So we are going to remove this. And instead of the hit detection position, what we're going to need is the bullet shooting point, like we've done for the range enemy. Okay, so let's rename this shooting point. And of course, it's shooting, not shotting, like so. We can remove the box collider. Here we go. Next, what we want to do is create the range weapon script. So let's open our scripts, weapons, right click, create a new C# script, range weapon. Here we go. Of course, we are also going to create the melee weapon script. So right click, create a new C# script, melee weapon. Here we go. And of course, this will also allow you to create explosive weapons or maybe turrets or any other weapon you would like to add. All right, we can now open our range weapon. Let's reload this. Of course, I don't know why the environment has been changed. That's odd, but that's okay. We can also open our weapon script. So let's grab it and drop it maybe to the left, on the left, sorry, like we've done for the enemy script. I'm also going to place the tabs on the top so that I have more space right here. Okay, and let's implement this. So our range weapon should inherit from the weapon script, which is already really cool. Then what we are going to do is add a reference to the shooting point. So let's create a new header for the, let's say, settings, serialized field, or maybe it should be elements actually. Elements like so, private, transform, shooting point. Here we go. After that, we can implement the auto aim method. So private void auto aim like so. Do we have it right here? Auto aim closest enemy and so on. Okay. Increase attack timer. We don't want to do the same thing, but let's grab this. It will make for a pretty good basis here. So we don't have the get closest enemy method, but we can grab it from the weapon script because it will be inherent to the range weapon and the melee weapon. So let's check where it is. Here it is. Protected. Of course, you now know how to do this. Okay, so after that, inside of the condition right here, we are not going to manage the attack, but we just want to aim and manage the attack later on. So target vector up is this, target up equals this. Inside of here, we want to return if the closest enemy is different than null. And instead of increasing our attack timer, we want to manage the shooting. So manage shooting, like we've done for the range enemy, of course. Private void manage
Shooting. Oh, come on. Like so. Here we go.
Inside of here, we can actually grab the logic from the range enemy attack where we increase the timer and shoot it at after that. So we can grab this, go back here, drop it here. All right. We will definitely need an attack timer and an attack delay, but we can already add the shoot method. So private void shoot. Perfect. The attack timer and attack delay are contained within the enemy script. So attack delay and attack timer. We simply need to turn them into protected variables. So let's do this like so. Now we should be good. Are we? Yep, we are. Awesome. We are getting there. So the shoot method will look something like that. First off, we need to know how much damage we should deal, like we've done right here. Okay. So we need to turn the damage here into a protected variable. Perfect. Let's go back to our range weapon. And as we've done for the range enemy attack, we can create a pool, but for now, let's not create the pool and just shoot. So we need a reference to the bullet and we are going to shoot it. Okay. And the direction will be pretty straightforward because it's the transform.up vector. By the way, we are getting an error here. So the aim lerp here should be protected. Here we go. We can now go on, set up our direction will be transform.up, but we still need to create our bullet prefab. So what I'm going to do now is actually create the prefab. Yeah, it's the best choice in my opinion. So let's right click, create a new script, C# script, bullet. And for now, we can actually duplicate our enemy bullet like so. Let's call it bullet. Let's open it. We are going to change the renderer and rename it bullet renderer. Let's grab the cotton candy one. So cotton, here we go. This one is a little bit too big for now. So we can change the scale of the renderer right here. Maybe 0.2. Is it better? Let's check by comparing to the other bullets. So maybe it was seed in my opinion. Okay, boom, yep, this is it. This has the same scale, so yeah, should be good. And we can still change the scale later on, of course. So we've got our bullet here. Let's remove the enemy bullet script and pass in or add the bullet script. And of course, I'm rushing a little bit here because you already know how to do this. We've done that. If I were to repeat the same things over and over again, we would never finish this course. So here is the collider, by the way. We have a better way of how it should look like. So .17 should be good. .17, here we go. Yep, that's way better. So let's open our bullet script. We can also open the enemy bullet script because it will almost have the same behavior. Let's grab these two attributes like so. We will need a rigid body, a collider, of course. So let's drop them here. And we can also refactor our code later on because our enemy bullet and bullet will almost share the same code and the same behavior. So we will add the move speed, the damage. Let's grab them. Drop them here, but we will add a little bit more things here. We need to add a reference to the enemy mask so we can actually hit enemies. So serialize field, private layer mask.
Enemy mask. Here we go.
After that, we are going to add the shoot method. So public void shoot, and we will need the direction. So vector2 direction and int damage. Just to be more consistent, I'm actually going to set the damage first and the direction after that. Boom, like so. Here we go. So we can already write this .damage equals damage. And for the direction, we are actually going to use it right now. So transform.right equals direction and rig.velocity equals direction times move speed. Here we go. We are just going to store our rigid body and collider like we've done inside of the awake method. So let's grab these two lines, drop them here, remove the lintwin call, or maybe we can just comment it because we're actually going to call this later on, I think. So yeah, let's go on now. We can add the onTrigger enter to the method. I'm going to change this to collider. Okay, and we need to check if the collider is inside of the enemy mask. If it's not, we should not be able to hit it. So if is in layer mask, collider.gameObject, enemy mask, and this is in layer mask method is actually a method that we're going to add right now that will allow us to check if we should hit that enemy or not. What you could have done is check if the collider had an enemy class. But let me show you something else. And I'm going to make sure and add some more lessons on layer masks as appendices in this section. Okay, so private bool is in layer mask. We need a layer and a layer mask. Okay, let's call it layer mask like so. Boom. So we should actually pass in the layer of this game object. Again, please, I invite you to go check the videos in the appendices and then come back here so that you know how layer masks work. Okay? So return layer mask.value and 1 bit offset to the left by layer. It should be different than 0. Here we go. This is how you know if a layer is inside of a certain layer mask, because a layer mask can contain multiple layers. But of course, another way you could have done that is by using the try_get_component method like we've done here. But I want to use this method here for variation first, and also because we might have multiple things we can attack or that bullets can damage aside from enemies, like trees or other things. So yeah, let's go on. So if the enemy is inside of that layer mask, or if the collider is inside of the layer mask, first off, what we want to do is disable the collider. So this.collider .enabled equals false, so that we don't hit the thing multiple times. We can also decide to destroy the bullet. And you know what? I think that's what we are going to do just to keep it a little bit more simple for now. So destroy game object. But before that, we of course want to attack the enemy. So attack collider.get component of type enemy for now. As I told you, we might attack things other than enemies, so we should not use this later on. But private void attack enemy, like so. And inside of our attack method, what we want to do is simply call enemy.take damage with the bullet damage. Here we go. So right now, there are still some issues here that we're going to fix, of course, because we might hit multiple enemies at once here. Like in one frame, we might trigger multiple enemy colliders, and this is not optimal. So later on, we will actually add an enemy variable that we can cache. And if we have a target or an enemy already targeted, we should not be able to attack more enemies. All right, so we have our bullet. So we are now able to spawn it from the range weapon. So inside of here, we want to add a reference to our bullet prefab. So maybe serialize field, private bullet prefab, of course, shoot. We want to instantiate our bullet. So bullet instance equals instantiate the bullet prefab at which position? At the shooting point, of course, and quaternion.identity, like so. Shooting point.position, not like so, because this is a transform. And we want to be able to shoot it. So bullet instance.shoot, the damage should be damage, and the direction should be transform.up. Here we go. So this should be enough for shooting bullets. We are not calling the auto aim method from anywhere. So let's call it from inside of the update method, so that we are always trying to aim at the closest enemy. Do we have some errors in here? I hope we don't. So let's go back to the main scene, select our cotton candy gun, and instead of adding a weapon script, we're going to remove this and add a range weapon script. Perfect. Let's grab it, drop it here. We're having an error here because I think it's related to gizmos, right? It is? Yep, it is definitely. So in here, you can try and check if the hit detection transform is null or not. So of course, we can write if the hit detection transform is null, simply return. Like so, we should not have that error anymore. All right. And of course, don't worry, we are gonna change this later on. But I'm sure that you've already done that. I'm just explaining so that you can follow along and make sure that this is the solution that you've implemented. So the range of our weapon should be something like, I don't know, maybe 5 or 6. Let's make it 6. Enemy mask should be enemy. Okay. Hit detection radius. We don't need this actually. Damage should be, let's say 10, so that we one-shot them. Attack delay 1. Animator should be this boy right here, even though we won't have animations. The aim lerp should be the same as this one, so maybe 12. Okay. The bullet prefab needs to be created. So prefabs, where is our bullet? Here it is. So let's select the cotton candy gun and drag in the bullet. Shooting point is this one. And we should actually be good now. Let's try this out. All right, so what the heck? So just for reference, these are bullets, the pink lines that you see here. So let's understand why they are this weird here. Okay, so, 17? What? Wait, let's fix that. So let's open our script, our prefab. It should be .17. I think it was fixed. I don't know why. Okay, that's weird. But that's okay. Why weren't they moving? Let's try this again. Did we set the move speed or not of our bullet here? Oh, we did not. So let's make it 5. Okay, now it's working. Here we go. But it seems like we are not shooting at that enemy because we don't have the enemy mask here. So let's set up the enemy mask. Okay. Let's now hit play, and we should be good because we have a move speed and a mask. So, okay, trying this out. Shoot, please. Come on. Okay, so the weapon is not shooting at enemies. Why? Let's open our script again here. And of course, we've implemented the wrong logic here. So if the closest enemy is different than null, we should actually shoot at the enemy. So we should grab this line, drop it here, and actually set up this right here. So the up vector. And otherwise, we should grab this, boom, 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 and drop it here. Here we go. Now we should be good. So let's try this out again. And I'm sorry if this lesson is a little bit too long, but I don't want to split it that much because we've already done that previously. So yeah, it will be 1-2 lessons at max to implement the range weapon, and then we can jump to the wave manager, of course. And let's double check this. Okay, so we should actually drop this one here, and the up vector, wait, let's drop this here and remove this, drop it here. Because this is when we don't have any enemy, and this is when we have an enemy. So we are managing this. Okay, boom, bam, bim. Yep, we should be pretty good here. Yeah, should be nice. Let's give it a shot. All right, let's try. Shoot, please. Yeah, awesome. It's working. Really nice. Finally. All right, so we are just going to rearrange this and add the melee weapon, of course, because we don't have it, but that's already pretty good. So this one can be at -1. How much was it? 1.5? Yeah, 1.5. Okay, cool. So this is where we are going to have it. Maybe we can move it to the left a little bit, but for now this is okay. Or we can make them smaller. But yeah, in the next lesson, let's go on and wrap this up so that we can tackle the real thing. See you in the next one. Welcome back, guys. In this lesson, we are going to keep implementing our range weapon, or actually I should say implementing the inheritance between our range weapon, melee weapon, and weapon in general. So yeah, let's open our script. So let's weapons, okay, melee weapon. We should attach the melee weapon script to the melee weapon, so to the point here. Like so. Maybe we should move it up. So let's move it up and implement this one. Because right now, if you remember well, our range weapon inherits from the weapon, but our weapon is what we've used for the melee weapon. So this is really not what we want here. So let's open our melee weapon. Here we go. This one should also inherit from the weapon script. Cool. And what we're going to do in this one is grab what we want and leave what we don't. Okay, so like we've done for our enemy script, this one should be abstract. Here we go. Then we are going to grab the state, so the enum, because we are only going to use it for the melee weapon actually. It's not relevant for our range weapon. Got it? What else do we need? So of course we need the detection transform and the hit collider. So we are going to grab these three. Okay, boom. Drop them here. Here we go. And then what we are going to do is check the errors that we have and move them to the melee weapon. So our state is relevant to our melee weapon. Let's drop it here. Okay. What else should we do in our start method here? Nothing important right now, but later on we will do some stuff. We can grab the logic of our update method, like so. Control X, drop it here because this is the one that has the states again. Our auto aim method can be taken from here. We can also take the manage attack method and increase attack timer. Here we go. Drop them here. Let's also grab the start attack, attacking, stop attack, and attack methods. Normally it should be good, yeah. Let's try and drop these here. Okay, here we go. So we need the list of damaged enemies. We should have the enemy mask, but yeah, it needs to be protected here. So let's grab this line because this is only relevant for melee weapons. Let's drop it here. Maybe we can drop it inside of a settings header, something like that. The melee weapon needs a reference to the animator, so let's make it protected. Here we go. Same thing for the enemy mask. Enemy mask, here we go, like so. Boom. By the way, did we add the mask here? Nope, we did not, so that's cool. let's open our melee weapon again. And we don't have any more errors here, but we do have some right here. The get closest enemy is already protected, which is really cool because we are using it somewhere around here. Yep. Yeah, right here. Cool. Bum bum beam. Let's grab this. Let's drop it here. On draw gizmo selected. Here we go. That's already way better. And yep, I think we are good to go now. Maybe we can remove these two things. If no, let's attack him and add it to the list. Oh, that's already what we've done. So we're already professionals here. Cool. So stop attack. The stop attack method will be called from the animator, if I remember well. So no need to worry about it. And we can clean this a little bit. Here we go. Beam. Like so. Okay. And yep, should be nice at this point, yeah? Can we go back to Unity without having any errors, please? And if everything is working well, in the next one, we can add pooling to our bullets, just to make it a little bit more performant. So the boink here, we can remove this because it's now an abstract class. The range of our weapon can be something like, how was our range here? 3 maybe? I don't remember, but anyway, we can still tweak this value. Damage can be 5, attack delay 1, animator is right here, aim lerp, I think it was 12, hit detection transform, here it is, and same thing for the box collider, and the radius can be something like, I don't know, maybe, oh, is it the one that we are using to attack instead of the range here? Hit detection radius. Okay, let me just have a quick look at it. You can select a value, press Ctrl F, check wherever you're using it. So we can remove this line. We are not using it anymore. Control F, hit detection radius. Okay, so right now we are only using this value to display a gizmos. So it doesn't make any sense because we are using the range here to detect enemies to get the closest one. So we can actually safely remove this from here. Okay, and remove these gizmos here. And instead, we are going to use the range, and we are already using it, so that's really cool. We can now go back to Unity. All right. Let's select our deboink again, and make sure that the range is the one affecting it. Okay, this is the one. Perfect. So 3. Cool. I think I'm going to try this out because, yeah, always make sure to try it out. And by the way, we haven't tried this out on mobile, so we definitely need to do so. I think I'm going to try and do that at the end of this lesson. So let's try and attack with the boink. Yeah, here is one. Okay, so the bullet is also working. Really cool. Seems like it's working really nicely. Awesome. So of course, there are always things we can improve and implement and so on. Like for instance, the auto aim method here is inside of the melee weapon and it's also inside of the range weapon, but they don't have the same behavior, right? Maybe we can use a virtual keyword right here, drop it inside of the weapon class. There's always so much you can do. But the thing that you need to keep in mind when coding on or making your game is to make it fun, right? Because if you don't have a fun game, even if you implement all of the good practices and all of the solid principles and you follow all of the object-oriented rules, you're not going to make it. So make sure that your game is fun first, then try and improve it with all of the features that you've learned to this point. Okay? So let's go on. And in the next one, let's implement our bullet pooling. See you there. Welcome back, guys. In this lesson, we are going to implement bullet pooling to our range weapon, like we've done for our range enemy. Okay, so let's go on. I invite you to do it on your own as a nice exercise. And of course, I think you've already done it, but yeah, just to make sure. So let's do that. Okay, so first off, I want to switch back to tabs on the left. Let's remove these, boom, boom, so that we can have a better view at our range weapon. And we are first going to add our Unity engine.pool library. Here we go. We also need to create our bullet pool. So let's create a new header for a pooling. Okay, private object pool of type bullet pool. Here we go. At start, we need to initialize the pool, of course. So bullet pool equals new object pool of type bullet. And we need to pass in the functions. But what I'm going to do is grab the range enemy attack. We already have it. Come on. So let's grab this. Boom. Paste it here. We can go back here, grab all of our methods. We're just going to change some stuff here. Okay. Maybe right after the update method, create function, it should return a bullet. So bullet. Okay, like so.
Bullet, 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 bullets, and bullets. Nice.
So of course, now our bullet needs a configure method. So we are going to open the bullet script and add that configure method. Public void configure. And it should take a range weapon as an argument. So let's call it range weapon. Here we go. This dot range weapon equals range weapon. And of course, we need to cache our weapon. So private range weapon. Okay, so this should be it for the configure method. So let's jump back to our range weapon. We need to edit our action on get, but let's first use the get method. So inside of the shoot method, instead of instantiating the bullet, we're going to write bullet pool.get like so. We can now jump back to our action on get. We want to keep the reload method, so we need to add it, set active true, and also drop it at the shooting position. So let's grab the reload method from the enemy bullet. Do we have it? Yep, here it is. Let's grab it, open our bullet script, and add the, maybe we can add it here or after shooting. Yeah, just after shooting, let's say. Perfect. So let's jump back to the range weapon, and everything seems to be good inside of here. We just need to add a way to release our bullet like we've done inside of the range enemy attack. So let's grab this and of course drop it here again. Okay, so this is already better. Let's open our bullet script and add a way to release the bullet. So I'm going to slow down here because I want to show you another way. So we've used coroutines, we've used lintwin to call or to delay a call to a method, but right now we are going to use invoke. I don't think we've used it before, so this is a quick tip here. If you want to delay a call to a certain method, you can use the invoke method. So you need to specify the method name. Oh, I think we've already used it. I don't remember where, but seems like we've already used it. I don't know. Please let me know. So invoke, release after 1 second. Maybe the bullets should only last 1 second because we're actually going to increase the move speed of the bullet. It should be faster than the enemy bullet, okay? So release, boom, boom, boom. Let's create the release method, private void release. And inside of here, what we want to do is call the range weapon dot release bullet this. Here we go. Really simple. We can now try this out and try and see if this is working, but we need to cancel the invocation here. So whenever we hit something, so maybe right here, instead of destroying the bullet, we are going to call release. Release, here we go. And we also want to cancel the invocation of that method, okay? So it will cancel all of the invoke calls. And because we only have one, this method should do the trick, okay? So let's go back to Unity. We can try this out already, I think. I'm just going to increase the bullet speed so that it's actually better. Please hurry up. Thank you. Prefabs, bullet speed should be something like 20 maybe? No, that's too much. Come on. Don't abuse from your powers. With great power comes great responsibility. So maybe what we can do is increase the amount of enemies. Maybe we can re-enable all of these boys here, okay? So that we can check if our weapon is hitting multiple enemies or only one. And of course, it's going to be able to hit multiple ones. So we will need to fix that later on. Okay, let's try and kill this boy. Bam! Here we go. One shot. Wait, I'm just going to increase their move speed because they are so slow. Come on. Maybe 3? Yeah, that's way better. Okay, let's try and merge all of these boys. Thank you. Please make one. Okay, getting there. Okay, no. Don't shoot at them. No, come on. Okay, one sec. This is way better. Now we should be able to hit 2 enemies at once. Here we go. This is not what we want here. Have you seen? There were 3 enemies and the 3 of them passed away with 1 bullet. Well, if this is the desired behavior, keep it as is, but this is not as I want it to be. I want the bullet to be able to hit 1 enemy at a time so that it makes more sense, okay? And maybe later on we can add some perforation or some other skills that allow bullets to hit multiple enemies at once, but keep that for another time. We also have an issue right here. So trying to release an object that has already been released to the pool. So inside of here, release bullet, we should check if the object has not been released yet, or what we can also do is open our bullet script and check if the object is active. So if GameObject.ActiveSelf, if it's not active actually, we are just going to return because it means that it has already been released. So we can now go back to Unity and we should not have this issue anymore. So let's hit play. All right, let's try and see how it goes. Here's 1 bullet, 2, 3. Oh, by the way, we should increase the, come on, the attack delay here. It should be something like I don't know, maybe .15. And we are also going to increase the bullet size. So beam, what I'm going to do is actually set it to, the collider, sorry, maybe .2, yeah, twice as big. And this should be twice as big. So let's enable proportional editing ×2. Yep, should be good. Let's try this out. Okay. Yeah, this is already way better. So it seems like we don't have this error anymore, which is really cool. So, nice. We've added pooling to our bullets. We've added so many things. Come on. Oh, by the way, let's commit our changes here. I don't know. This is the best commit title I came up with. Oh, come on, when you're tired, that's okay. You will actually be able to notice when you've made that change, and you can actually rename it. Come on, you can right click and can I rename it? Create a tag, revert changes in commit, reorder commit, undo commit, amend commit. I can't rename it. Oh my god. Oh, come on. Anyway, it's working. Hooray! So in the next one, let's allow our bullets to only shoot at 1 enemy at a time. Then we might add critical hits or the wave manager, one of these 2. I think I'm going to go with critical hits because it will also allow us to tackle other objects that we can attack instead of enemies. And we are going to edit our scripts a little bit so that we can actually do that. So see you in the next one. Cheers! Welcome back, guys. In this lesson, we are going to add a way to prevent the weapon from attacking multiple enemies at once. So for that, we are going to store a target whenever the bullet hits an enemy. That way we can prevent applying the same logic twice. Okay? So let's open our bullet script right here. And the first thing we are going to do is add a target inside of our maybe settings or elements. I don't know, you decide. So I'm going to drop it inside of the settings here. So private, enemy, target. Here we go. Then what are we going to do? Well, inside of the onTriggerEnterToD method, we are first going to check if we have a target or not. We can actually check right here, actually, before the layer mask check. So if the target is different than no, we are simply going to return because we don't want to hit anything else. Otherwise, we are going to enter the isInLayerMask condition here and store that target. So target equals collider.getComponent of type enemy. Here we go. Like so, perfect. And by the way, to prevent calling getComponent twice, we can actually attack the target right here. Like so, cool. And we are already half done. So this is working if you use the bullet once, but we know that we can reuse bullets. So for that, we also need to clear the target whenever we reload. So in here, what we want to write is target equals null, like so. That way, whenever we reload or reuse our bullet, we can still hit an enemy, okay? So I think we are good, so let's give it a shot. To ease our test, I'm going to select all of the enemies and set them at the same position, so 0, 0. Maybe we can actually move them to the right, yeah, somewhere around here. Let's hit play, And normally we should be able to make gun one enemy at a time. I'm not going to use that word. Okay, so let's try this. Boom, 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 boom. Yeah, that is so cool. It's already looking really good. I love it. Let's try and reload the scene again. Maybe you can add more enemies, actually. I'm going to duplicate these. Okay, I'm going to select one of these. Come on, come on, come on. Let's select all of these, actually. Hurry up, like so. Yeah, here we go. So we now have a bunch of enemies. Oh, this is already looking really good. I really hope you like it. Boom, like so. But our melee weapon should be able to attack multiple enemies at once. Okay, cool. That was it for this lesson. And in the next one, let's learn how we can add critical hits. See you there. Welcome back, guys. In this lesson, we are going to learn how we can add critical hits to our game. So it will imply multiple things here. Our weapons should be able to deal, let's say, twice the normal damage. And we should also take into account the damage text. So instead of displaying 10, it should display the actual damage with another color. This is not trivial, so I hope that you're really focused. Okay, so the first thing we want to tackle is our weapon. Right now, our ranged weapon and melee weapon deal damage based on this value right here, damage. I think the damage value is in the weapon script, which is closed. Really cool. So let's open it. Hip, pop, control, like so. Inside of this, we've got the damage. Indeed, cool. So we are just going to add a method to return the damage, but it won't return this value only because we are already using it. Instead, it's going to return either damage or damage times 2 if it's a critical hit. Okay, so let's create that method somewhere around here after the get closest enemy. Yep, should be good. So protected int get damage. And in here, quick tip, this is a new thing here. We are going to use out bool is critical hit, because this method will have two goals here. It should return the damage, so this one or this one multiplied by 2 if it's a critical hit. And we also want to know if it's a critical hit. Okay, so we need a boolean. And by using the out keyword, you can make a method return multiple values. We can also add more, so out int other int, out vector2, other vector2, I don't know. Got it? So this is really helpful when you want a method to return multiple values. So we can remove these and let's calculate our damage. So in the normal case, we should return damage, like so. But there is an error because we need to set the value of is critical hit. So at first, is critical hit equals false. Now, no more error. Cool. Now let's tackle when we want a critical hit to happen. It's gonna be random for now, but later on, of course, we will have stats for the player that will have a great impact on the critical percent. But right now, let's keep it really simple. We are just going to check if a random value, so random.range between 0 and 100, and this is exclusive, so let's use 101, so to make sure that we include 102, is, let's say, less or equal to, I don't know, 50. So we have a 50% chance of inflicting a critical hit, okay? So if that's the case, then return damage times 2. And we also want to set the is critical hit to true, like so, okay? Otherwise, we can just return damage, so we will not enter this condition. But if we do, of course, we will return 2. But if we do, here is what we're going to return. Perfect. So right now we are not using this method, so let's use it inside of our ranged weapon and melee weapon. We need to jump to the method where we are inflicting damage inside of the shoot method. So we can write int damage equals get damage out bool is critical hit, like so. And now this damage represents this one, not the damage that we have at the top right here. So the class variable. It is now a local variable. And we are not going to use the isCriticalHit for now because we are going to use it later on to change the color of our text. So let's just grab this line and also drop it inside of the melee weapon. So let's go down. When we hit the enemies, right here we've got the damage. So let's write int damage equals this, and this is where we are using it. Okay, I don't think we are using the damage value somewhere else. Nope, we are not. So let's go back to Unity, and now our damage text should from time to time display 10 for the melee weapon because its damage is 5, so it should double. And half of the time, same thing for the range weapon. So it should display 20 for some enemies. Let's check it out. I think I'm going to try and play this frame by frame. It's actually better because all of our enemies are on the same at the same place here. So 10, okay. This one won't touch anyone. Let's go a little bit. Oh, here it is. Here it is. Here it comes. 10, okay. 20. Here we go. It's working. So let's try and disable our range weapon to check if the Boink weapon also deals twice damage from time to time. So this was also 10, 20. Oh, 10. Really cool. Maybe 5 now. Wait for a little bit. Okay. 10. So it was also a critical hit. Really cool. So you now know how you can add critical hits to your game. That is really cool. In the next one, we are going to grab this isCriticalHit boolean and pass it in to the enemy. Because if you remember well, the enemy, if we hold control and click the take damage, triggers this action, which is then subscribed to by the damage text manager to display a damage text particle. By the way, right here we have melee enemy, but does the range enemy display particles too? I think he does. I'm just gonna double check. Yep, he also does. So it seems like we can remove this. Name can be simplified. Okay, help me. Alt, enter. So we can replace this by enemy.onDamageTaken. Let's do so. Here we go. Let's now jump back to Unity and check if it's still working. So let's hit play. And indeed it is. That is so nice. Cool. So that was one thing. In the next one, let's actually upgrade our damage text particle system to take critical hits into consideration. See you there. Welcome back, guys. In this lesson, we are going to keep implementing our critical hit thingy effect, maybe, just so that the damage text particle changes the color of the particle if it's a critical hit. Okay. So, let's open our range weapon class. And inside of here, we instantiate our bullet, but we need to instantiate it and pass in the isCriticalHit boolean. So let's pass it in, isCriticalHit, cool. We are getting an error because it doesn't implement that. So let's open the method and add a way to take the boolean as an argument. So isCriticalHit, here we go. So we want to store this value so that we can reuse it when hitting an enemy, okay? So we can go at the top here, settings, private bool, isCriticalHit, or maybe isCriticalBullet actually. Or let's keep a consistent naming. So isCriticalHit, okay, so this dot isCriticalHit equals isCriticalHit. Perfect. So let's jump to our attack method and pass in the isCriticalHit boolean. Perfect. We are now going to open the take damage method and pass in the boolean. So bool isCriticalHit, like so. Perfect. And now that we have it right here, we can pass it to the action so that it can be grabbed by the damage text manager. So let's pass in isCriticalHit. Perfect. We need to change the signature of our action. So bool, awesome. Let's now do the same thing for the melee weapon because of course we have an error. So isCriticalHit, like so. And we should almost be good. Our damage text manager now needs to be edited. So we are going to change the signature of our enemy hit callback method. Bool isCriticalHit, like so. Perfect. And finally, we can pass this to the animate method of our damage text instance. That way, the damage text will automatically change its color. So is critical hit. Let's open this method. Bool is critical hit. Perfect. So this is like a train. You're passing the argument from here to there, from here to there, and so on. But it's kind of compulsory if you want to achieve this effect. So yeah, if you come up with a better way, please let me know. Maybe I can improve the course with that. Thank you. And in here, before playing the particle, by the way, we are going to change the color of the text depending on the isCriticalHit boolean. So damageText.color equals isCriticalHit. It is a critical hit. If it is, we are going to use color.yellow, otherwise color.white. Perfect. So now we should be good. We can try this out and hopefully it will work. Hopefully it should work. So let's use two conditions here. Or maybe you can use a switch statement. Anyway, oh, come on, programmer jokes. Anyway, all right, let's wait for a bit. Okay, it's coming here. Okay, 10, that's good. What about this one? Oh, seems like it's not working. So our isCriticalHit is always false here. Let's debug this. Debug.log isCriticalHit. We can actually add a string, isCriticalHit, like so, just to check the value of our boolean. And the fact that there are errors from time to time is really good because I can show you how to debug your code. You will always have bugs and errors. You need to learn how to debug them. All right, let's check it out now. Boom. So false, false. Okay, true. Oh, so it was true. I did not check the color. Sorry. So let's try this out. Now we know that the isCriticalHit is true from time to time. So it should be yellow from time to time too. Okay? So let's go back to here. Oh, I think I know now. Okay. Okay. I got it. Yep, I got it. So here is a quick exercise. I'm giving you 5 seconds to think about what's the issue here. Taking into account the fact that when adding animations previously to the, I think it was, to the boink, we've noticed that we could not control the scale of the boink or the renderer or the rotation actually when animating it. 1, 2, 3, 4, 5. Here we go. Of course, we are changing the color of our particle. So the alpha, where was it? So prefabs, damage text right here. If we open the animation tab, we are controlling the font color. And we can't control that by code if we are changing it inside of the animation. So instead of changing the color right here, we are simply going to change the scale. So let's remove the color property. Let's record and add a keyframe to the scale, like so, boom, add key. And after some time, so where we had the previous keyframe, we are going to set this to 0. So let's play the particle again. Well, that's kind of nice, but now let's set this one to 0 too, okay? Cool. Maybe we can actually move this keyframe. You can actually make it yours, you know what? Or maybe you can decide not to scale it down and keep it as is. I'm going to try this out, and if I like the effect, I'm going to keep it. If not, I'm going to drop it. Okay, let's try this out. Yeah, now it's yellow. Here we go. So we've dealt a bunch of critical hits here. So let's drop some enemies. Okay, I'm going to duplicate them a bunch of time. Whoa, what the heck? Nice. Okay, so we have critical hits and normal hits. That is really cool. Okay, so that was it for the critical hit. In the next one, let's add candy. So that's actually what enemies will drop. We can add candy and cash actually, so that it will lead to the player level. We will allow the player to increase in level, and then we can tackle either the player stats that we can increase after each wave, or the wave manager. Yeah, one of these two, actually. And this is gonna get interesting after that. See you there. Welcome back, guys. In this lesson, we are going to add candy that we can collect, of course. So let's do that. All right, so I'm gonna use a sprite which is right here. Here is the candy. I'm gonna grab it, drop it, like so. Cool. So right now it's a bit too big. So what I'm going to do is scale it down to maybe 0.5, still too big. 0.25, that's decent, but maybe 0.3 should be good. Perfect. After that, I'm going to right click and you know what I'm going to do? Of course, split the rendering from the logic. So create an empty parent. Perfect. Let's call this one Candy, not Candy, Candy, and this one is Candy Renderer. Here we go. We want the player to be able to collect these, and we also want the enemy to drop these. So the first thing we are going to do is add a circle collider 2D. And of course, we are going to turn it into a trigger so that the player doesn't collide with it. I'm going to scale this down, so the radius to something like this, maybe 0.25, yeah, should be nice. And add a candy script so that we can actually do stuff with it. So let's open our scripts folder. Maybe we can create a new folder for our drops or power-ups. So drops, here we go. Right click, create a new C# script, candy. Here we go. All right, when it's done, we can grab the script and drop it on our candy. And then we can turn this one into a prefab because of course we are going to spawn it whenever an enemy passes away, and we are going to use pooling, and it's always the same melody. So let's actually open our prefabs folder, grab this one, drop it here, and we can already rearrange our folder a little bit because we have things all over the place right now. So right click, create a new folder for enemy related things, another one for the weapons, another one for the drops, let's say, and maybe another one for the effects, like so. Okay. So bullet in weapons, enemy in enemy, enemy bullet in enemy, range enemy in enemy, damage text in effects, and candy in drops. Here we go. Nice. So this is done. That's really cool. Now, what we want is to allow the enemies to drop candy. And you might think about it this way. You can select the enemy and attach the candy prefab to the enemy, or add another script so that he can drop candies. That might work, but in my opinion, it's not that scalable and manageable. Instead, what you want to have is a drop manager or a candy manager, some sort of manager actually, that detects whenever an enemy passes away, grabs that position, and spawn whatever we want to spawn. This is a way more sustainable way, okay? And again, this shows us the power of events or actions. So let's right-click, create an empty game object, and call it drop manager. Here we go. We are going to open our scripts folder and drops, right click, create a new C# script, drop manager. You can actually call it drops manager or objects manager, not objects manager, but power up manager, building manager. I've spent so many hours playing Minecraft. Anyway, during compilation times, maybe I can tell you about my life. Anyway, let's open our drop manager, drop this here, open it, boom. So the first thing we need, of course, is a reference to our candy. So elements, serialize field, private, game object, or maybe candy, candy prefab, okay, bim bam boom. Then we want the enemy to drop the candy, or to at least give us the position where he passed away. So inside of the enemy script, what we're going to do is add another action and trigger that action inside of the pass away method. So let's do that. We can go in here inside of the enemy header, public static action. We only need the position. Maybe later on we might need something else. I don't know. You can decide to have a difficulty level for the enemy. So the higher the difficulty, the better the drop. You can add so many things actually. The only limit here is your creativity. So on passed away, here we go. Let's go down. No more errors, please. Thank you. And in here, on passed away, let's invoke the action and pass in the transform that position as an argument. Cool. So we now know where the enemy passed away. Super nice. We can open our drop manager again, add the awake method, and subscribe to that event or action. So enemy.onPassedAway plus equals enemy passed away callback. Here we go. Let's also unsubscribe from the onDestroy method, of course, to prevent having issues when reloading the scene. And we can use the quick actions, Alt Enter, to generate the method for us. Nice. I'm just going to grab it and drop it somewhere around here. Perfect. So in here, we can write past or maybe enemy position, something like that. Yep. And right now, we are simply going to instantiate the candy at that position. Okay. So instantiate candy prefab at enemy position. And of course, we need to pass in the quaternion.identity. And we can spawn the candy as children of the parent, as children of the drop manager. Why? Because in our case, the drop manager is never going to move or be scaled or rotate. So we can safely drop them there. So let's write in transform. Perfect. This will help us clean out our scene a little bit more too. We can now go back to Unity, specify the candy prefab, and we should be able to spawn them whenever an enemy passes away. Cool, so nice, yay. All right, so where is our prefab? First off, right click, properties to have a floating window, Kawaii Survivor, prefabs, drops, candy, drag, drop, boom, play, quit. All right, let's try this out. So we are only gonna use the range weapon. Come on, attack, yeah, here is a candy. Come on, eat it. And here are more, really cool. That's so nice. One thing we can do here is add the sprite sorter script to our candy so that it does render depending on its Y position. But one thing I like to add or use is actually drop these inside of the bottom layer because we don't necessarily want to see them on top of the player or the enemies or the bush and so on. So I'm going to select candy here and drop them inside, not here, but set the render sorting layer to bottom. Here we go. Let's try this out again. Okay, so now let's try and go above it. Yeah, that's already way better. Really cool. Nice. So that is one thing. Next, what we're going to do is allow the player to detect candy so that the candy can move towards the player and be collected properly. Okay, see you in the next one. Welcome back, guys. In this lesson, we are going to make our candy move towards the player whenever it's hit by the player. So let's do that. First off, let's remove this debug line. Boom, we don't need it anymore. And we are also going to clean out our code a little bit. We can also commit our changes because, oh, we have 40 changed files. Oh my gosh, I didn't think it was that much. What did we change? I don't remember. Well, you can call the commit whatever you want. I think I'm gonna call it damage text. Oh, it was critical hit, yeah. Is maybe just critical hit. Here we go. So let's now jump back to our script, not script, but Unity, because we need to add the player detection script. So this is the one that will allow us to detect objects dropped in our scene. So let's select our player here. Okay, we don't have that script yet. We can click on the player script, right click, create a new C# script, player detection. Flower. Come on. Anyway, oh, reloading the domain. So what did I do today? I'm going to count. No, I'm not going to tell you about my life. All right, so the player detection script has been compiled. We can select Dave, grab the player detection and attach it to Dave. We can move it up a little bit, maybe just below the player health. Perfect. And let's open it. Cool. So I think that we can safely remove the start and update method because we are going to use detection and quick exercise. Try and add detection logic to our player detection so that whenever it hits or enters a trigger, it checks if it's a candy, and if that's the case, it just destroys the candy or eats it, whatever you want. So do it and finish the video after that. All right, here is the solution. So we are going to add the onTriggerEnter to the method. Change this to collider as usual. Come on, Unity, please do that. Make that change. We want to check if the collider.try get component out candy candy. So if the thing we've collided with does contain a candy component, we want to destroy the candy.gameObject. By the way, quick tip here. If we were to write candy instead of candy.gameObject, it will work, but it's not going to destroy the game object. It's only going to destroy the script, so the candy script attached to the game object. Okay? Let's give it a try so that you can actually notice what happens, but after that, we're going to change it. All right, I think we are okay here. Let's hit play. All right, let's try and hit some enemies. Boom, here's one. Whoa, he was about to hit me. Oh, bad boy. So let's try and collect the candy here. What? It's not working? It is working. What did I tell you in the previous 1 minute actually? It was just 1 minute. If you select this candy right here, let's actually select it. Okay, here it is. Let's select the candy clone. It doesn't have the candy component anymore because we've only removed the candy component. Got it? If we check out the other ones, they still have it. Oh, this one not. This one doesn't have it. Oh, these ones do have it. But what about these? We did not hit these ones. Oh, interesting. This is really interesting. That is weird. Now we need to debug this. So let's double check something here. First off, we are going to select our prefab and check if it does have the candy script. It does. Cool. So that's one thing that we are sure of. Then whenever we spawn a candy, so in the drop manager, we are going to give it a specific name. So right here, what we're going to do is write candy instance. Candy instance equals this. Okay. After that, we want to debug.log. Not debug.log. We want to change the name of the candy instance. So candy instance.name equals candy plus a random value between, I don't know, random.range. Oh, did we fall into this issue before or not? I don't think we did. So here is what happens here. In here, there is an ambiguous reference between UnityEngine.random or system.random. So you can tell Unity that you want the random class from the Unity engine by writing using random equals UnityEngine.random. This is a really useful quick tip. So let's select a random value between 0 and 5,000, like so. Then inside of our player detection script, we can write which candy we've collided with. Sorry. So debug.log collected plus candy.name, like so. That way we know which candy we've collected. And if some of the candy we haven't collected do not have the candy script anymore, it means that something is wrong and we need to track this down. So let's go back to Unity again. Let's hit play. All right, let's wait for a little bit, like so. Let's hit this one. Okay, what about these? Okay. Oh, really interesting. Did you notice what happened here? So let me show you that again. I'm just going to do nothing because it's not going to work. But all of these, almost all of these actually, except this one, have been collected. This is really interesting. What happened here is that our deboink weapon did collide with some of the candy, and it does have a collider. So even though it is not linked to the player detection script, because it does have a collider and the only rigid body is attached to the player, all of the colliders under Dave will be taken into account using the onTriggerEnter method. That is a really good point. You see, even though I did not intend to show you that, like Destiny made me show you that. So that's really cool. In the next lesson, I'm going to show you 2 fixes for that. So stay tuned. Welcome back, guys. In this lesson, we are going to fix our candy collecting issue or detecting issue actually, and I'll show you 2 ways to fix that. Okay. So the first one is to add a reference to the collider we want to use. So for that, let's add a header. Let's call it, I don't know, maybe colliders. Okay. And we are going to add a reference to our Dave collider. So private collider 2D Dave collider, something like that. After adding the reference, we want to check if the collider, so the candy right here, is colliding or touching the Dave collider. So if we get a candy from this collider, perfect. Then we also want to check if the candy collided with Dave. So if collider.is touching Dave collider, then we can process. Otherwise, boom, let's return. Cool. So this is in the case the boink or the weapon or anything else touches the candy, and we are only applying this logic if the Dave collider touches the candy. Really cool. So let's go back to Unity. Okay, so let's select Dave, pass in our collider, which should be somewhere around here. Let's hit play. Let's try and collect the candy. Okay, boom. Let's try again. Please, please, boom, boom, boom. Yep, didn't work. Let's try with Dave. But first, let's actually select this one. Okay, so it still has the candy script. Perfect. Let's try and collect them. Boom, collected. Really cool. So this is one way. The other way we could have done that is by using physics2d.overlap circle all, like we've done in the, I think it was the melee weapon. Where is it? Somewhere around here. Yeah, overlap box all for this one. But we can use the overlap circle all. So let's open our player detection again. Here it is. We are going to add the fixed update method. So private void fixed update. Let's create the array of colliders. So collider2d, let's say candy colliders equals physics2d dot overlap circle all at transform.position, but we can actually grab the center of the player, the one that we've used right here. So it's offset by 0.5. Okay, so we can actually grab this collider and pass in the offset. So the center of our detection will be transform.position plus Dave collider dot offset, I guess. Okay, but this is a vector 3, this is a vector 2, right? So let's turn this into a vector 2 like so by casting it. Here we go. Then we can specify the detection radius. So the detection radius will be Dave collider dot I don't have radius because this is a collider 2D. So let's turn this into a circle collider 2D just to make our process easier. So radius here, cool. I'm just gonna go to the line. Here we go, boom, boom. And we should actually be good. So we have the radius and the position. Now we want to check amongst all of these colliders if the collider is a candy. So you could use layer masks like we've done for enemies, or you can simply try and get the component. So both methods work. Just pick the one that you prefer most. What I'm going to write here is for each. Oh, is it the first time we use a for each statement? Really cool. So let's do it. So for each collider 2D, let's call it collider in candy colliders. So this is basically a for loop, but we are checking for components instead of incrementing a value, okay? So now we can use this collider. So we want to check if, actually this one, if collider.tryGetComponent candy, like so, and yeah, we should be good actually. Now we can collect the candy. So let's grab these two lines, drop them here. We can comment the onTrigger enter method. And this makes for another way of detecting candies. So let's try this out. All right, let's hit play. Here we go. Come on, please. Thank you. So that's one. Here are the other ones. Let's collect them and boom, we can still collect them. That is so cool. So you now know two ways of collecting or detecting objects. Really nice. In the next one, we are going to make our candy move towards the player. Okay? So first off, let's actually select the method that you prefer most. I think that I'm going to go with the onTriggerEnter method for now, but let's just comment this one just in case we need it later on. Okay, perfect. See you in the next one. Welcome back, guys. In this lesson, we are going to add some logic to our candy to be able to collect them. So we are going to make them move towards the player. Really cool. Okay. So for that, we want to open the candy script right here. And the first thing we are going to do is add a collect method. So public void collect. Here we go. And void, not voik. Come on. Perfect. So why is this one public? Because we want to call it from the player detection script. So instead of destroying the candy here, we are just going to collect it. So candy.collect. Here we go. But we want the candy to move towards the player. So we can either search for the player like we've done inside of the enemy script somewhere around here. Yeah, player equals find first object of type, blah, blah, blah. or we can pass in the player as an argument when collecting the candy. So right here in the player detection script, we are going to pass in transform so that the candy knows about the player. Okay, so let's add that as an argument. Transform, player transform. Here we go. And from there, we are going to start a coroutine. But first off, let's prevent our player from collecting the candy twice. Okay, so here's what we're going to do. We can add a boolean. So private bool
Collected. Here we go.
and we can check if it has been collected, return. Otherwise, collected equals true. This will prevent our player from collecting the candy twice because we are turning this one true after the collect method has been called. Or another way of doing this is simply by disabling the collider. And later on, we are also going to add pooling. So we are going to manage enabling the collider and so on. But yeah, this is a way of doing things. I've already showed you how you could enable colliders with the bullet, if you remember well. So let's add variation to our code. All right, so after that, let's start a coroutine. So start coroutine, move towards player. We can pass in the player transform like so, boom. Then let's create the coroutine. So I enumerator, move towards player.
Transform. Player transform. Like so. Okay. Here we go.
And now you're going to notice that I'm going to rush a little bit into coding because there are so many things that you have learned. I think it's like 10 hours now, or maybe 9 hours that you've been following with me. So you're starting to understand a lot of things. And I really hope that you are practicing along the way. Make sure to do that, please. Okay, here we go. So the first thing we are going to do here is create a while loop. So while something, we are going to do something. And the while statement here is like a loop that normally never stops. You just need to tell it when to stop. So what we're going to do is add a timer and initialize it to 0, even though it's actually 0 if you let it like so. But let's set it to 0. And while our timer is less than 1, we're going to do something. And let's not forget to increase our timer. So timer plus equals time.delta time. Here we go. Just to make sure that we can actually get out from that loop. So inside of this loop, we want to move towards the player. So let's store the initial position. So the position the candy is at when hitting the player. Vector2, initial position equals transform.position. That's the position of the candy. Inside of the loop, what we want to do is lerp or use a linear interpolation to move towards the player from this initial position using the timer as our interpolation value. So transform.position equals vector2.lerp from the initial position towards the player transform.position using the
Timer. Like so. Cool.
I hope this is clear. We've seen linear interpolation previously, so if you don't get it here, please make sure to rewatch the previous videos. So what we need to do now to prevent having this error is to yield something, because not all code paths return a value. And the yield statement is the one used to return a value inside of coroutines. So real yield return, let's say null inside of here. Perfect. After we've reached the player position, we should exit the loop so we can safely collect the candy. So let's call the collected method, let's say collected. So private void collected. And inside of here for now, let's just disable the game object. So game object does set active false. Here we go. What we can do now is jump back to Unity. You could actually destroy the candy here, but later on, of course, we're going to use pooling, as I told you. So yeah, makes sense to disable it for now. Okay, so let's try this out. Boom, boom. Let's hit these ones. Perfect. Let's try and collect the candy here. Okay. What about this one? Yep. That is so nice. Okay, cool. So right now the candies are moving towards the bottom of the player, but you can change that by getting the player center. So what we could do instead of passing in the transform here is passing the player game object. So get component, let's say get component of type player. And to make sure that, oh, by the way, yeah, we need to change the collect method here. It should take a player as an argument. So let's change that to, okay, and vector to target position equals player transform, but this is not a transform anymore. So let's change that. Boom, player dot get center. Here we go. But if you use the position or set up the position right here outside of the loop, it's not going to work properly because the player is moving. So you constantly need to grab this and drop it here, okay? Just to make sure that you update the player position inside of the loop. So let's comment this one and use the target position here, like so. And we also need to make sure that our player detection, has a player component. So required component type of player. This is one way you could have done that. There are so many other ways, of course, but I'm showing you one at least so that you can get the ball rolling. And then I invite you to go search for other ones. Okay. So boom, boom, what about this? And now they are moving towards the player center. Got it? Hope this is clear? Cool. In the next one, instead of adding pooling first, what we are going to do is add cash. So from time to time, enemies should drop cash instead of candies so that I can show you one really cool thing. See you in the next one. Welcome back, guys. In this lesson, we are going to add another type of collectible, which is the cash. Okay. So we are going to grab that from the sprites, but first off, because it's going to have almost the same behavior as our candy, what I want to do is duplicate the candy and rename it cash. Here we go. We can remove the candy script like so and add a cash script that we are going to attach to this. But first off, let's change its renderer. So let's select this one, rename it cash renderer. Here we go. And search for the cash sprite. This one. Maybe we should actually scale this up. 5.5 maybe. What about the collider actually fits it. So that's really cool. All right, so we have our cache prefab here. Let's create the script. So scripts, drops, right click, create, C# script, cache. All right, when it's done, we can actually open the prefabs, cache here, and add the cache component, like so. Cool. So our cache will have the same behavior almost as our candy. So we can open our player detection script, and inside of here, what we can do is check if the collider has a cache component. So we can grab these lines, drop them here, write cache, rename this one cache. Okay, drop it here like so, and cache.collected like so. Perfect. So of course we need to add the collect method to our cache script. So let's open the candy script. We can grab these lines, collect them, and open the cache script, drop them here, add the boolean, so private bool collected like so, and this should work properly. But so let's go on first, and then I'm going to show you something. Don't worry. We are using a lot of duplicates here. We are going to remove this. So let's open our drop manager, duplicate this line. We want to spawn a cache prefab, like so. And inside of here, we are actually going to randomize if we should spawn a candy or a cache prefab. So let's do that, yeah. Bool should spawn cache equals random.range between 0 and 101 is less or equals to, let's say, 20% chance of dropping a cache. Yep, should be good. So let's create a reference to the droppable, so the thing we wanna drop. So game object droppable equals should drop cache. Should we drop a cache? If that's the case, that's the cache prefab. Otherwise, like so, candy prefab. Here we go. And then what we can do is use this droppable instead of, oh, by the way, I should use game object here, like so. And we should now use this droppable instead of the candy here. So let's use it here, and let's rename this droppable instance. This is a game object. Perfect. So this is, again, just for testing purposes. I'm going to rename this droppable. Perfect. Let's now go back to Unity, reference the cache right here, and everything should work properly. So here is the droppable thingy, cash, boom. Let's hit play. Let's try and drop some cash. Okay. So this one dropped a candy. What about these? Do we have a cash in here? I think I'm seeing one. Yeah, here it is. Really cool. Okay, so let's select this one. Maybe we can move it somewhere around here. We should have two other ones, I think. What about this one? Yep, perfect. And this one too. Let's select it and move it here. So now if I try and collect them, boom, 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 it's working. Okay, perfect. But if we were to add multiple collectibles, so maybe candy, cash, maybe we can add a chest. We're actually going to add a chest, of course. Maybe we can add something else. I don't know, maybe a power up. Maybe there are so many things again you can add. So instead of rewriting or duplicating the same lines of codes over and over again for every collectible, what we're going to do is use interfaces. So in the next one, let's clean our code a little bit so that we can use these. See you there. Welcome back, guys. In this lesson, we are going to create our first interface. Hooray! Really cool. So interfaces basically are just contracts between scripts. If a script implements an interface, it must implement the methods and properties that the interface contains. This is the basic definition, so let's go on and create one so that we can better understand the concept. So let's create a new folder, boom, for our interfaces. Here we go. Right-click, create a new C# script, and let's call this interface iCollectible. So this is a good practice to start your interface's name by the letter I. It's a convention, but if you don't like it, don't use it. But it's actually a good practice. So let's do it. Let's open our interface. Here we go. And the first thing we want to do is change the class keyword to interface. This is not a class. There is a difference between these two. So it should not inherit from mono behavior. And we can remove our two methods. Here we go. So right now, our iCollectible interface is blank. What we are going to do is add one method. It's going to be void collect, and we are going to specify the player, like so. So right now it's void, so it means that it's private, right? So private void? Nope. Why? Because by definition, the methods contained in the interface should be callable, so you should be able to call them from other scripts. That's the whole principle of these. So it's actually public, okay? By default. Perfect. Now that our interface is correctly set up, what we're going to do is open our player detection script. That's the first step, actually. Instead of trying to get the candy component here or the cash component here, what we are going to do is search for an iCollectible component. And let's rename this one collectible. Here we go. So this does not have a name by default. We can actually remove this. But if you wanted to have a name, we can add that as a properties, but let's actually remove this for now. We can also remove this line. Perfect. So now our player is searching for iCollectible interfaces, okay, instead of scripts. So no more errors for now, but we won't be able to collect our candy and cash yet. What we need to do first is to open our candy script and implement the interface. So you can add a comma here and add iCollectible. Perfect. So right now we do not have any error. Why? Because we already have the collect method. But if the collect method was not present, we would have an error here. As you can see, the candy does not implement interface member collect. So you could use the quick actions here, implement interface, but we already have it. So here it is. It has created it for us, but we already have it. Come on. We are good boys and girls. So yeah. Let's remove these comments here. I'm actually going to rename this player, by the way, while I'm here. Perfect. Start coroutine, move towards player. Let's clean our code a little bit while we are here. Perfect. Yeah, let's apply the same logic for our cash. So iCollectible. And again, we already have the collect method. Player. Here we go. Let's remove this. Cool. And later on, as an exercise, you can actually refactor this because these have the same methods. You now know how to inherit from a script. So I invite you to create a droppable currency script drop these methods inside of that script and inherit from the droppable currency instead of the mono behavior. We are going to do that in the next lesson, but it is a really nice exercise. Okay, so let's try this. Is our interface working properly or not? Of course it is. Come on. Okay, well, let's wait a little bit. Boom, bim, bam, boom. Okay, so do I have some cash? Nope, no cash. You know what? What I'm going to do is actually spread out our enemies. So what I'm going to do is remove these. Let's select this one, press F. I'm going to spread them around the map like so. Okay. Just to make sure that we actually have, we can notice our drops. So bim, bam, boom. Okay, so now we have a cache here. Okay, let's wait a little bit. Defeat them. Here we go. So let's try and collect this one. Yep, collected. What about these? Also collected. Really cool. Oh, I love it. Okay, really nice. So one quick thing before we jump to the next lesson. As you've noticed, I had to get really close to the candy and cash to be able to collect them, right? Have you noticed? Just let me show you again. Boom, I really need to hit it. If I'm close like so, I can't collect it. And even though this is really logical, it's definitely not optimal for player experience. The player should be able to collect these, even though he's somewhere around here, you see, like maybe at 1 centimeter, it's really close. So yeah, this is why I actually prefer the other detection method, the one using the overlap circle all method. The other way you could have done that is by adding another collider. So maybe not Dave collider, but let's call it collectible collider. Like so. And we can create another one. So let's go back to Unity. Let's select Dave. Create a new game object, sorry. Collectible collider. Let's add a circle collider 2D. Is trigger. Let's offset it by 0.5 like the other one and increase the radius to, I don't know, maybe 1. Yeah, maybe 1.5. Let's be gentle here. Let's now hit play. All right, let's try and defeat some enemies. Here we go. So the variable collectible collider, has not been assigned. Sorry. Yeah, let's assign it, of course. So right here, collectible collider, hit play again, and we should now be good. So let's try this out. Let's try and collect some candy. Yeah. Right now, I'm able to collect them even though I'm a little bit further away. So that's already way better regarding player experience. So, yep, that's what I wanted to show you here. I can increase the collider, boom, 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 and collect everything. So we can already imagine adding a power-up that just increases this radius to be able to collect all of the candy inside of the map. Okay? There are other ways of doing this, of course, but that's one of them. All right, so in the next lesson, let's refactor our code so that it's actually prettier. See you in the next one. Welcome back, guys. In this lesson, we are going to do two things. The first one is inherit from the droppable currency, so the script that I told you about in the previous one. And we are also going to add pooling because you now know how to add pooling. Come on, you've done that twice already. Really cool. So let's go on. Okay, so inside of the scripts folder, what we're going to do is open the drops folder, right click, create a new C# script, and call it droppable currency. Here we go. And of course, you can name it however you want. Just try and use some namings that make sense. I'm really not the best at finding names. I'm sure you're better than me. But yeah, I'm going to show you how to do it. All right. So our droppable currency is actually going to have the behavior that our candy and cash have, but it should be abstract. So first off, let's actually grab these methods right here, maybe with the collected too. Okay, so like so. We can grab the collected boolean at the top too, and we are going to remove the start and update one. So let's drop these here. Here we go. We can remove the start and update method. The class will be abstract, because again, we don't want to be able to create a droppable currency as is. It's either a candy, a cash, or anything else. And our class should also implement the iCollectible interface so that our candy and cash doesn't. Okay. The collected method should also be abstract because we want different behaviors for the candy and the cash. because later on we are going to have a currency manager, and when we collect a candy, we should add candies. If we collect cash, we should add cash, and so on. Of course, you could use enums to fool that situation, but let's use variation, of course. Come on. We need to learn multiple ways of coding here. So let's make this one abstract. And of course, it needs to be protected so that the other ones can see it. Let's remove the behavior from here. Boom, 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 and boom, like so. We can now open our cache script. We can remove the start and update method. And let's inherit from the droppable currency instead of the mono behavior, like so. Same thing for the candy, boom, like so. Remove the start and update method. And we can then remove everything inside of here except the collected method. So let's remove this, perfect. The collected method should be protected. So protected, override, void collected, like so. And we're going to use actions to determine if we've collected a candy or a cache. So using
System, like so.
header, actions, public static action. Let's pass in a game object because we want to add it back to the pool when used. Uncollected. Perfect. Let's remove this space. And in here, uncollected, invoke game object. Really cool. So both our candy and cache will have the same lines of codes here. Of course, there is still another way to improve this, but come on. We're not here to improve our code. We are here to make a fun game and from time to time improve the code. Come on, at least. So yeah, let's grab these lines, drop them here like so. So this will help us determine if we've collected a cache or a candy just by checking if the game object has a cache or candy script attached to it. So using system right here, and that's already one thing done. So let's now improve our drop manager with pooling. Of course, we need to use the pool library. So using Unity Engine dot pool, like so. Let's create two pools. So one for our candies and one for our cache. Header pooling, private object pool of candy pool. Let's duplicate it, call it cache pool, and it's going to be a pool of cache. Oh, really nice. Let's initialize our two pools at start, so we can already grab the script from the range enemy attack, I think. Pool. Yeah, here is the pool. So let's go back to our drop manager and drop this twice. Come on, let's duplicate it. Here we go. So the first one will be the candy pool, and the second one the cache pool. Create function, it should actually create a pool of candy. This is a pool of cache, really nice. And we can now create our functions. So of course, these should not be the same. So we should add some prefix or suffix. So candy create function. This is going to be the candy action on get, candy action on release, and candy action on destroy. We can make this a little bit prettier by adding some spaces, like so. Here we go. This is going to be the cache. Cache. Come on. Cache create function, cache action on get, cache action on release, and cache action on destroy. And I really invite you to try and improve this code if you find a way to. And let me know. I'm really curious to see what you can come up with all of the knowledge that you've gained. Because I know things, you know things, and 1 + 1 = 3 regarding knowledge. You can find new ideas that I did not think of. This is why in business, network is really important. Just dropping some quick tips here. So make sure to share, please, in the comment section. All right, let's go on. We can grab the methods from the range enemy attack. So let's grab these from here. So the create function, the action on get, action on release, and so on. And of course, we can rename them. So let's drop them here twice, actually, because we should have some for the candy and some for the cache. Let's grab the prefix, candy create function, candy action on get, candy action on release, and candy blah, blah, blah. Candy. This should return a candy. Okay. Let's go on. So the candy prefab should go here. Shooting point. We don't have a shooting point. Come on. Where should we instantiate the candy? I'm actually going to instantiate it at transform as a child of this. Yeah, like so. We can then configure this, but let's just comment this for now. All right. When getting the candy, so this should be candy, by the way. Candy. When getting it, we're actually going to set the game object to true. So let's remove these two lines like so. This is a candy. We want to set it to false on release. And of course, again, candy. Oh, candy, not candid. Candid. Candidates. Okay, perfect. So we've got all of our methods for our candy. Again, let me give you a quick tip here. When you have methods that only contain one line, what you can do is use the expression bodied statement. So I think that's the correct term, but let's not focus on terminology. What you can do is add equals, greater than, remove the curly brackets, and apply what you want to apply. So this is really similar to having the curly brackets and so on. It does help save space. I don't know if that's more readable, but use it whenever you want. Don't use it if you don't want to. I'm going to use it from time to time, but yeah, I just wanted to explain how it was working. So let's do it or use it right here. Perfect. Because we can now stick these two together. Maybe we can add some tabs here to drop these on the same line. Yeah, again, that's really aesthetical. Really not compulsory. So let's do this here. Bam, bam, destroy. And same thing for here. We can actually return this. Okay, if we are not going to name it whatsoever. And yep, we should be good. So return, by the way, is not necessary here because this is actually returning already. Boom, bam, boom. And let's add our greater equal. Here we go. So these are our 4 methods needed for the pool. We are going to create the same ones for the cache. So let's remove these actually. I'm going to duplicate these. Here we go. I just hit Control D, by the way. So this should return a cache. We are going to use this prefix too. Boom, 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 and bam. Here, here, here. Cache prefab. And we should be good actually. Yeah, this should be cache, by the way. Oh, without a, oh, come on. Without an uppercase. So let's rename this. Here we go. So you see, when you are using combinations of Control R twice, Control C, Control V, Control D, Alt, arrows, and so on, you can get really quick at doing things. So I really encourage you to practice those shortcuts. Okay? Boom, 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 boom. Here we go. Perfect. This is already way cleaner. So now let's go on and implement our other methods. So when spawning the prefabs, what we can do is grab the cache pool.get. So grab the cache from the pool, and this is going to return a cache object. We want to convert that into a game object. You could use the droppable currency instead, so something like that, droppable currency. Maybe we can switch this to droppable currency, blam, blam, blam. Perfect. Now we can remove this because the get method does return a droppable currency. And same thing for the candy. So candy pool.get. Here we go. Already way cleaner. You see, the first thing to do actually is to write the code, make it work, and then refactor. That's the best way of having a working code. And by the way, we should definitely commit our changes later on because we've definitely added stuff here. Now that we have gotten these, we need to release them. So let's add methods to release them. Private void release candy. It should take a candy, let's say, or maybe a game object because the action we've used here returns a game object. We can actually return a candy, but whatever. Release candy, game object, candy. Let's just call the candy pool dot release candy. And of course we need to, we definitely need the candy here. We could add or convert the candy pool into a game object pool, but everything should work properly. Let's duplicate this line to be able to release cache. So release cache like so. Boom, boom, cash pool here. Tough, cash. Okay, let's remove this from here. Here we go. That's already way better. And right now we are not using these methods because we haven't subscribed to the actions. So let's quickly do so. Inside of the awake method right here, candy.uncollected plus equals release candy. Release candy. And same thing for the cash. Candy, so cash.uncollected plus equals this. Boom, boom, boom. Here we go. We are going to add these to the onDestroy method. So right now, of course, we are having errors because, oh, by the way, I've added here. We should not add it here. Sorry, I forgot that. We should actually subtract it from the event or the action. Here we go. So that's already way better. We are having an error here, of course, because we are passing in a candy and cash, but our actions do pass in a game object as an argument. So when making the course, I've used game objects. Let's switch that in here and take some risks. So let's pass in a cash here. So we should pass in this. Perfect. And for the candy, we should pass in a candy. And let's pass in this. Or we could actually pass in the droppable currency, but later on, as I've told you, when using currencies, we should definitely know what we've collected. Now let's go back to our drop manager and we should be good. The only thing left here is to re-enable our candy and cash whenever we want to get them from the pool. Because if you remember well, if you open the droppable currency script, we use the collected boolean to collect the candy or cash. So whenever we collect them, we turn this to true, so we won't be able to collect them again. For that, you can use the onEnable method. And this is called whenever a game object is set back to active. In the drop manager, indeed, we turn the game object back to active or true whenever we get it. So this is the best way of enabling our thingy again. Here, the droppable currency. So collected equals false. Perfect. Now we are able to collect them again. So let's go back to Unity now, and our pool should be working correctly. So let's hit play. What we can do to test it out is to go a little bit further, try and hit 1 or 2 enemies, collect some candy. So, but first I'm gonna collect 1 maybe. Yeah, let's try and hit pause so that I can get further away. Oh, so 2 of these are actually disabled now. That is so cool. So 1 cash and 1 candy. Let's see if we can reuse them. So 805. Okay, so let's try and defeat some enemies. Let's wait for a little bit. I'm gonna hit pause because our weapon should, yeah, it's gonna hit. Okay, let's wait for a little bit. Boom. It has created a new cache. Okay, so we haven't reused that one. Oh, we did reuse that one, of course. What about the candy? So let's go 1 frame at a time. 805. Oh, maybe it's renaming them actually. So we've hit 1, but it's a cache again. Yeah, 805 has been turned on again. Really cool when this one was defeated. So we can go on. Okay, here we go. And of course, now we are not collecting any candy. So to actually notice the effect, we can disable our 2 weapons, exit the pause mode, and collect all of these. Here we go. So now all of our collectibles are disabled. We can re-enable at least 1 weapon. So let's re-enable the candy gun. Okay, boom, 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 boom. Which one is going to be reactivated? Oh, 2 of these. Really nice. Really cool. So the droppable 2820 and the 1271. But they are at the same position or what? Where is this one? Really far away. Oh, interesting. So seems like we are not moving them again. This is really interesting. Let's remove these. Let's try and defeat 2 other enemies. Okay. What about this one? Okay, so we've defeated this enemy, but enabled 2 game objects. So the droppable 7 and the cache clone. Where is the cache clone? Oh, on top of the player. I see. So in the next one, let's debug this. This is really unusual. Welcome back, guys. In this lesson, we are going to fix the issue we had in the previous one.
So if you remember well, we were spawning 2 droppables when hitting or defeating one enemy. And this is actually due to this line right here. We instantiate it after getting it from the pool. But when getting it from the pool, we actually instantiate it or enable it. So no need to have this line, okay? But what we want to do is actually rename this if we want to rename it, but honestly, no need to. So let's remove these lines. We just want to move the droppable at the enemy position. So droppable.transform.position equals enemy pause, enemy position, like so. So we grab it from the pool, then move it to its normal position or where we want it to be. So let's hit play. Let's try and defeat some enemies. Okay, boom, boom, boom. Here is 1, 2. Okay, so let's hit pause really quickly. Disable our weapons. So we have 2 candy. We are going to exit the pause mode, try and collect some candies. So both of them have been collected. Okay, so they are disabled. Let's now re-enable one of the weapons. I think I'm going to re-enable the cotton candy gun, of course. So let's try and hit one enemy. Okay, I'm going to hit pause. And boom, here we go. So let's try and defeat it. It has been defeated, but of course a cache has been spawned. Come on. I want a candy, please. Boom, candy. So this one has been re-enabled and dropped at the enemy position. Really cool. So now everything seems to be working as expected. Nice. Our pooling is working. To wrap up our collectibles, in the next one, we are going to add chests. See you there. Welcome back, guys. In this lesson, we are finally going to add our chest as a really cool power-up. So let's do that. You can actually try and do that as an exercise. It could be really nice. So basically, the chest's behavior is going to be the following. Sometimes enemies can drop chests on top of cash and candy, okay? But the chest should not follow the player. It should just stay at its original position. And yeah, the player should be able to collect it. And I think we are all good. So these are the instructions of the exercise. Let's do it and watch the solution once you've done it. Thank you. Okay, so here's what we're going to do. First off, let's select our prefabs, drops. Let's duplicate the candy and call it chest. We are going to grab it, drop it inside of our scene so we can better see it. Here we go. What we are going to do is remove the candy script, okay? And we can also change the renderer. So let's rename this chest renderer. Here we go. Let's change the source image of our sprite renderer. Let's write chest, boom. So these are multiple sprites in here. We only need, let's say, the first one, okay? Maybe later on we can add an animation using these images. But yeah, right now we only need, let's say, which size fits better. I think not the 4 times, but we've got the body here. We might have the chest somewhere. Let's click here. So that's in platform assets, chest, PNG. Okay, not sliced. We want the separate one 2 times. Here we go. 1 by 2, 2 by 2. Yeah, let's select the 1 by 2. Try this one, maybe. Yep, this is decent. Yeah, I like it. But the pivot is kind of weird here. What we want is actually to set the pivot at the center. No, at the bottom, because the center would be here. So let's set the pivot at the bottom. Let's apply our changes. Here we go. That's already way better. So we can diminish the size of our hierarchy here. Okay. Oh gosh. So here is our chest. We can remove the circle collider because we want to add a box collider 2D to better match or fit the shape of our render. Let's edit the collider to something like this. Okay, maybe try and make it fit the chest a little bit better. And check the isTrigger boolean, of course. Perfect. What we are now going to do is add a chest script, like we've done for the candy and cash. So let's open the scripts folder, drops, right-click, create a new C# script, chest. Here we go. All right, when it's done, we are going to grab this, drop it on the chest, and open it. Here we go. Before opening the script, by the way, what we can do is actually apply the changes we've done. So we've added the box collider, the chest script, removed the circle, candy, and so on. So let's apply all of the changes. Cool.
So let's open the chest script here. And what we want is to inherit from the iCollectible, or implement actually the iCollectible interface. So iCollectible, here we go. We will need to add the collect method so we can use quick actions, Alt Enter. I want to grab this one, drop it. Oh, no, wait. What I'm going to do is actually remove the start and the update method. We are not going to use these. We need an action. So let's create a header for that. Let's add the system library using system. Here we go. Public static action on collected. And we are not going to use the player, but we can just call the onCollected and invoke it actually. Here we go. And after that, we want to destroy the chest. So destroy game object. Nice. So in here, what you can do is use pooling if you want, but I don't think this is necessary. We are not going to spawn that many chests. But if that's the case, and you want really good performance, use pooling. Okay? I leave that decision to you. All right. So after that, we need to spawn chests. So we need to open our drop manager. Inside of here, we need to add a reference to our chest. So serialize field, not serializable, private chest prefab. Here we go. And just really quickly, if you wanted to pull the chests, you could actually apply the same logic that we've applied here. Okay, that's actually really simple. We are now going to add a way to drop these chests. So after the logic for spawning candy and cash, we are going to try and drop a chest at the enemy position, of course. So let's create that method, private void, try drop chest, vector2, enemy pause, or maybe spawn position, something like that. You can actually rename these, that's okay. And to spawn the chest, we are going to use the logic we've used for the cache here. So let's grab this line, drop it here, and we can then instantiate if we should spawn a chest. So should spawn chest. You can rename this one should drop, anything you want actually. So if we should spawn a chest, we're going to spawn it. Otherwise, we are simply going to return like so. Boom. And in here, we can simply instantiate the chest at that position. So instantiate the chest prefab at spawn position, quaternion.identity as a child of the current game object. Cool. So let's first try this out, and then we can actually prevent hard coding these values. We're actually going to use sliders to make it more beautiful, more sustainable, and easier to tweak. And later on, we are also going to add luck in here. So plus luck, which is going to be a stat for the player. But yeah, let's keep that for another lesson, as usual. So let's go back to Unity and check if our chest can be spawned. We will definitely need to remove this boy here. So let's remove this. Okay, so let's select our drop manager. Cache in here to access the folder, drop the chest, hit play. And if that's working, you can already notice the power of interfaces and inheritance now. Because, oh, here is a chest. It was really simple to implement. Have you seen? Now we are able to collect it once we hit it, of course. Oh, 2 other chests. Really cool. And this without editing our player detection script. Remember? We are looking for an iCollectible. Our chest does implement the iCollectible thingy interface, and we can do whatever we want. We can then play particles, play confetti, trigger a certain game state, anything you want, without editing the script again. So that's really powerful. Okay, so now what I'm going to do is add some sliders inside of here to be able to tweak the chance of spawning cache and chests. So let's go to the top. Somewhere around here, we can add a new header for the settings, serialize field, okay, private integer. Maybe let's start with the cache drop chance. Okay, we can add the chest drop chance. Here we go. So let's use these right here. So this should be the cache drop chance, and this is the chest drop chance. Here we go. So now we will be able to change these values from the inspector. But as you're going to see right now in 1 second, like right now, cool, we are able to edit this value and go above 100% or below 0%, which is not ideal. So what we want to do is clump this value. Of course, you have a brain, so you are able to set this to 50 or 10 or values like that are contained within the range that we want them to be in. But in case you want to lend this code to your artist or you're working with other people that are not intended to dive into the code, you can add a range attribute like so to clump the value of your integer. So we are going to use a value between 0 and 100. Okay, so let's try this out for, let's actually try this out for both our boys here. Okay, let's go back to Unity and we can already notice the slider, which is really cool. Compile, please. Thank you. So we can go from 0 to 100%. Really nice. And it's really easy to tweak without going into the code and opening the script and so on. So let's set the cache drop chance to, let's say, 10% and maybe 11. Yeah, let's set the chest drop chance to 1%. Just to be sure or make sure that we can drop chests. I'm going to duplicate enemies. Okay, maybe press... Oh, come on. What the heck? Oh, here we go. W, move them around. Duplicate, move them around. Hit play. I just want to have a lot of enemies to make sure that we can spawn chests actually. So let's try and defeat some of these. Okay, here we go. Oh, the game is already looking really nice. I love it. Okay, so no chest here. Let's try again. Okay, here we go. Please, can we spawn chests or not? Boom, bam, bim, bam, boom. Nothing. Okay, let's try again. And if we can't, it means that we have something wrong in our code. So if it's less or equal, so it should be possible because we have 1. So if it's less or equal to 1, okay. I think I'm going to time-lapse this just to make sure. And if it doesn't work, we're going to change that. Here we go. Here is the chest. Okay, really nice. So we were able to spawn a chest. And of course, later on, we will be able to spawn more of these. So yeah, I hope you really like this one. If that's the case, please consider leaving a review. It does help a lot. Thank you. And in the next one, let's add the player level script. So we will basically add another slider just below this one to store or to track the level of the player. Should be really nice. And you can actually do that as an exercise because you already know how to create a slider, how to add a text as an overlay, and so on. So whenever the player collects a candy right here, you should increase the level of the player of the slider by a certain increment. And whenever it reaches the top, so whenever it's full, you should empty it and increase the level count or the level integer. I really hope you're going to try this exercise. So see you in the next one. Welcome back, guys. In this lesson, we are going to add the player level. So we are going to increase the level of our player depending on how many candies he has collected. Okay, so for that, we will need to add another slider right here. And I hope that you've done your exercise. Okay, so let's select our game panel, duplicate the health slider. But right now, I just want to rearrange it a little bit. So let's make it a little wider, something like this. I'm just going to grab the values from the course because I really liked how it was. And it was 210, maybe minus 70, something like that. Here we go. That's way better already. So I'm now going to duplicate it, maybe move it down by a little bit, somewhere around here, minus 150 maybe. Yep, should be good. Maybe minus 130. Is it too close to the other one? Yeah, I think so. So let's drop it to minus 140. Okay, that's a middle ground. Perfect. So I'm going to rename this one XP bar. Perfect. Let's change its color. So inside of the fill image right here, we are going to select the green color that we have. Really cool. Here is the hexadecimal code if you want to apply the same green color, but of course you are free to select another one. This one is actually a little bit better, maybe. Yeah. Let's keep it as is. Cool. So the health text here will be the XP text. Okay. What else should we change here? Are we still able to change the value? Yep. Really nice. The text will look like something like level maybe 6, level 7, and so on. Yeah, we can use this syntax, or maybe level 7. No, let's use LDL with the actual level. Cool. So this is good for our UI, user interface. Now we only need to add our script to manage or update this. So let's open the player folder, right click, create a new C# script, player level. Here we go. But of course, again, make sure to call it whatever you want. So let's select Dave, our player, and we're going to drop the player level maybe just after the player health. Yep, it does make sense. We are now going to open it. And of course, the first thing we are going to need is a reference to the UI library. So using unityengine.ui, here we go. We also need the slider, of course. So let's add a reference to it again. So a header for the visuals. By the way, we might also need Text Mesh Pro, right? So using TM Pro, like so. And of course, I'm sure that you've already done that, but I need to show that for those of you who haven't. Oh, bad students, come on. So serialize field, private slider, let's call it slider or XP bar, maybe, I don't know. It's actually, we're already inside of the player level script. So yeah, let's call it XP bar actually, that's good. We are also going to need a reference to the text. So Text Mesh Pro UGUI, level texts. Here we go. So as I've told you, our XP bar will actually start at 0. So we should start from level 1. So we definitely need a reference to the current level of the player. We need to know how much XP he needs to level up. And we also need a reference to the current XP so that we can actually update the slider. Let's add a reference to the slider and a reference to the level text, by the way. Really quickly, here we go. We can now go back to our script. Let's add the settings like so. Let's start with the required XP. So private float required XP. Here we go. Private float current XP and private integer level. Perfect. We can actually turn the required XP and current XP into integers actually. So yeah, int and int. So at start, we can imagine having the required XP set to 10 maybe. And whenever we defeat an enemy, we can increase the current XP by 1 until we reach the required XP. Then when we reach the required XP, of course, we want to reset the current XP to 0 and increase the value of the required XP. So it definitely needs to be linked to the level. But right now, we are only going to increase that linearly, but you could definitely imagine increasing it exponentially and make it more and more difficult to level up as the level or as the player progresses. Okay? So at start, let's update our required XP. Update required XP. And we also need to update the visuals after that. So update visuals. Let's create these two methods. Private void update required XP. And private void update visuals. Let's start by the visuals because it's actually easier to understand. We have two things we need to update, so the XP bar and the level text. So the XP bar dot value should be the current XP divided by the required XP. Is it gonna work? Dun, 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 dun. Of course not. We need to convert that or cast it into a float. Come on, you know that now. Let's now update our level text. So level text dot text equals level with a space plus level. Should we write it like so? Dun, 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 dun. Of course not, because level at start equals 0. So you could either initialize that to 1 or use level plus 1 to update the visuals so that we can start from level 0 actually. Again, that's a choice. I prefer doing it like so, but you could initialize your level to 0 and go on with that. So let's now update our required XP. Let's come up with a really simple algorithm here. I'm going to write required XP equals level plus 1 times, let's say 5. So For each level, we need to collect 5 more candies. So level 0, we should collect 5 to level up. Then we should collect 10. After that, 15 and so on. But of course, as I told you, maybe you can use a cubic increase or an exponential one, logarithmic, anything you want. You can use the calculator I told you about in a previous lesson. Yeah, it was the linear interpolation one, if I remember well. So that's the Desmos calculator. It's really helpful when trying to find the perfect algorithm or equation for levels, XP, for health, or anything else. So once this is done, we now need to increase the level whenever we should, actually, but we need to increase the current XP whenever a candy has been collected. So let's add the awake method and the onDestroy method because we need to subscribe to candy.uncollected the action plus equals candy collected callback. Let's also unsubscribe from it right here. Let's create that method maybe at the bottom, private void this. And I think that we need the candy, right? Yep, here it is. We need to pass in the candy as an argument. So candy, even though we are not going to use it. So inside of here, we want to increase the current XP. So current XP plus. Quick tip here, you can write plus, or you can write plus equals 1, or you can write current XP equals current XP plus 1. All of these 3 methods or syntaxes do work. So I like to use plus to increment it. Then we want to check if the current XP is greater or equals to the required XP. So if the current XP is greater or equals the required XP, what should we do? We should level up. So level up. Here we go. And because we only have one method call, we can remove the curly brackets. After that, we are definitely going to update the visuals. Here we go. Let's now add the level up method. Here we go. Again, one thing here, we could have added this logic inside of the condition, but I like to keep my methods really small so that it's way easier to debug. And in here, what we could have done is use the expression bodied statement, but this is just a really small detail. Let's remove the update method. Here we go. So level up. When leveling up, of course, we want to increase our level. So level plus. We want to reset our XP. So current XP equals 0. And we want to recalculate the required XP. So update required XP. Really cool. So I think that we are actually good now. We can try this out. Yep. So let's go back to Unity. Nothing to specify in here. So let's clear the console and hit play. All right, so the XP bar has been initialized, level 1. Let's try and collect some candy. So I'm just going to defeat all of the enemies to have a better view of what I'm doing here. Oh no, I don't want to connect this one. So let's move towards here. Here we go. There you go. Okay, so let's try and collect some candies here. Here's the first one. Boom, it has been updated. What about this one? Boom. Yeah, it's increasing. Level 2, level 3, maybe 4. Can I reach level 4? Ah, no, I can't. You know what? I'm a game dev, so I'm going to re-enable these. And now I can collect them again. Oh, come on. Anyway, level 4. We don't have any error. Come on, clear the console. No more errors. Really cool. So we've now added our player level script, which is really nice. I think that we are now ready to tackle the wave manager. That way we can actually have a call loop that will enable us to add stats or improve the player stats whenever he levels up. So buckle up, it's going to be really intense. See you in the next one. Welcome back, guys. In this lesson, we are not going to start working on the wave manager. Instead, I first want to commit all of the changes that we've done. So basically we have added droppables, something like this. Yep, should be nice. And then what we are going to do is try the game on a real device. Again, we need to test, as I've told you, from time to time because we might have different behaviors between the device and the editor. So for that, I'm going to select build settings, Android. Let's try and see. Yep, my device is right here. Make sure to check that your device is actually connected and visible. Then let's build and run the game. So I'm going to select this. Let's rename it version 2, even though we've made so many changes. But yeah, and let's meet on the other side. All right, so now the game has been built. Okay, let's try this out. Okay, seems like I can actually hit enemies. Really cool. Yep. What about the melee weapon? Yeah, boom. Here we go. Yeah, really cool. So I can also level up. I can collect cash, candy. My health, I did not notice if my health was decreasing. So let's try this out. I did not notice if my health was decreasing. So let's try this out again. Okay, please hit me. Please. Please, someone. Oh, come on. I'm too powerful. Dang. I'm going to relaunch that again. Okay, maybe the range enemy can hit me. Maybe, please. Oh, no. Dang. Okay, so maybe the range enemy should be on the right hand side of the player so that I can't touch it with the bullets, maybe. And I'm also noticing that the chest should be a little bit bigger here. So let me try this again. Okay, so now the range enemy should be able to touch me. Yeah, like so. Perfect. So my health is decreasing here, and I can level up, hit enemies, collect all of the droppables, and so on. That is really cool. All right, so now in the next one, we will be able to implement the wave manager. See you there. Welcome back, guys. In this section, we are going to implement the wave manager. Dun, dun. All right, so first things first, let's remove all of our beautiful enemies. But let's check if we haven't changed anything. Yeah, nothing, really cool. So let's remove all of the enemies, like so. What we want to do now is create the wave manager. So let's right click, create an empty game object, wave manager, and let's create the script that we will attach to this boy. So let's right click, create a new C# script, wave manager. Here we go. Let's grab the script, attach it, and open it. Nice. Please stay focused here. This is really important. Our wave manager will manage waves, right? So let's create a private wave. It's like so, but it will manage waves. So let's turn this one into an array. And we also want to be able to spot it inside of the inspector to manage the waves. So serialize, field, private wave. And we are also going to add a header, elements or settings actually, like so. In my opinion, this is an optimal way of setting up the waves without hitting the timer and so on and so on. But we now need a wave here. So you would either need to create a wave class, public class wave, like so. This is perfectly fine. What I'm going to show you here is that you can actually turn this one into a structure. So a structure is kind of similar to a class, but it's basically a variable that holds other variables. If you want more details on this, the difference is that a structure is a value type and a class is a reference type. And if you want more info on that, because I'm not going to dive deeper in this lesson, this is not the point here. We just want to make use of it, not understand all of the whole memory management. But if some of you are interested in that, I'm going to try and leave some articles linked to this lesson. All right. So let's go back to our script here. Let's create a public struct wave. Here you go. But our wave here doesn't contain anything. We don't have the error anymore, but nothing inside of the wave. So let's add our first variable here. So public string name. This will be the name of our wave. If we jump back to Unity, we will already be able to notice the wave array and specify the name of our waves here. So let's do this, and we can't spot the waves. Why? Because Unity doesn't know how to render these, and they are not serializable. So what we are going to do is use the system.serializable attribute for our wave. Now we will be able to spot them inside of the inspector. Really cool. All right. As I've told you, we are now able to set up our waves. So let's add a wave. Let's call it wave 00 maybe. This can be wave 01 and wave 02. So right now we have 3 waves. Our wave do not contain anything except from a name. So right now this is definitely not useful. So instead what we are going to do is add more data to our waves. So let's add a public list of wave segments and call it segments. Okay. Again, we need to know what is a wave segment here. So public struct wave segment, like so. And we also need to use the system.serializable attribute to be able to spot it inside of the inspector. So we now have our waves, we have our wave segments. Let's just add one variable for now. So public game object enemy prefab, or maybe the prefab we want to spawn during our wave segment. So let's go back to Unity to make sure that we can spot the prefab we want to spawn. Okay, so here are the segments, perfect. So let's say we have one segment in the first wave. We are going to add our enemy, this one, the basic one. The second one can have one segment too, and we can spawn the other enemy, so maybe the range enemy, perfect. And during the third wave, what we can do is add one segment again, or maybe two segments, yeah, something like that. So one with the basic enemy, which is right here, and another one with the range enemy. Perfect. So during the first wave, we should only be able to spawn basic enemies. Then in the second one, the range enemies. And in the third one, enemy and range enemy. Okay? So that's the first step. I think we are going to wrap up this lesson because you already know how to create a structure, how to show it in the inspector. You know that you can create a list of other structures and you can go indefinitely down this way because you can create lists of lists of lists of lists of lists of lists of lists. And that's already really cool. In the next one, we are going to add more data to our segments to determine when we need to spawn these. Okay? So see you in the next one. Welcome back, guys. In this lesson, we are going to keep implementing our wave manager. So let's jump right into it. In the previous one, we've added what we needed to spawn. So for the first wave, first segment, we need to spawn the enemy. Second wave, first segment, range enemy, and so on. So let's actually tackle the first wave. Now that we know what we need to spawn, we need to know when to spawn it. Okay? So let's jump back to our script. And here is what I've decided to set it. We have a first time, so the time 0, when we start spawning the prefab, and the end time, so the time 1, let's say. Let's say that a wave duration is 40 seconds. You can then configure the T1, so it's going to be something like float T0 equals 0 second, and float T1 equals maybe 10 seconds. And from 0 second to 10 seconds, we can spawn this prefab. And we'll also need a float spawn frequency, okay? Something like that. So this is one way to do things, and the other way is to use a min-max slider. This is a really cool implementation by Naughty attributes that allow us to actually have a clear representation of our timers in the inspector. Let me show you. So first off, public float T0, let's say, public float T1. Let's remove these values here. Okay. Public float spawn frequency, cool. Let's now go back to Unity. We can notice our T0 and T1, okay? So that's one thing. It's really possible to use these and actually set up our 0 to 10. This is working, this is cool. Let's set the spawn frequency to 1, so 1 time per second, 1 spawn per second, okay? But the other way I told you about is by using the Naughty attributes. So using Naughty attributes, and this is going to make our process really cool because we need to make a working game, but we need to also enjoy the process, right? So let's remove our 2 times here and use the min-max slider attribute. Brackets min-max slider between 0 and let's say 100, something like that. Public vector2 t start end. Okay, let's now go back to Unity, and you can already notice that this is way better. Like so, it will allow us to say like from 0% to 10% of our time or a wave duration, we want to spawn this prefab at this frequency. So 5 enemies per second, 1 enemy per second, and so on. So we just need a wave duration now because we have a percent, okay? So we can actually rename this person start end, but I like to call it T start end or time. And yep, so let's set up our wave duration now. Is it okay for you now? If it's not, please let me know in the comment section. I will try and explain in other words. Okay, So let's implement our wave duration. So let's go right here, serialize field, private, floats, wave duration. And you know what? I'm actually going to drop it above the waves. Maybe I can add another header for the waves to split them in the inspector. Yeah, I think it's going to be better and more readable like so. And later on in the course, maybe I can show you how to create custom inspectors. Please let me know if that's something you would like to learn. Okay, so let's say that our wave duration is 30 seconds. Our enemy will be spawned from 0 to, let's say, 50%. So from 0 to 15 seconds. Actually, I'm going to use 30% or something like that, just to spawn during the first 10 seconds. And yep, it's actually it. So we now need to implement the logic for that to work. So in the next one, let's implement a timer and the logic for this to work properly. See you in the next one. Welcome back, guys. In this lesson, we are going to keep implementing our wave manager and especially manage the first wave as an example. Okay, so we have the wave duration. We now need a timer to count time, of course. So yeah, private float timer. Here we go. So inside of the update method now, what we want to do is check if the timer is less than the wave duration. We want to manage our current wave, let's say. Okay? So let's try this. Private void manage current wave. Here we go. Inside of this method, we are first going to grab the current wave. So wave, current wave equals, let's say that we are currently inside of the first wave to make it simple. So wave 0. And by the way, it should be waves. I think that it's actually going to change our values. I'm not sure, but I hope it's not. Let's double check. Bim bam boom. Yeah, it did change the values. That's okay. Come on. Let's create one wave. So wave 0, 0. Okay, so let's create one segment with the enemy. Boom. I'm going to do this quickly so that we don't spend that much time. So 30%. And this is going to be 1. Okay, here we go. So let's now go back to Unity. Here we go. So we've stored the first wave. And what we are going to do is loop through all of the segments of this wave and check if we need to do something. So we are going to use the timer to compare it to the t-start end. Check if the timer is inside of this time span. And if that's the case, we are going to check the frequency and spawn the prefab. Okay? So this is the whole principle of this method. Of course, there are so many ways you could have implemented this. This is one that I chose. And if you come up with another one, another solution, maybe a better one, please make sure to let us know. Thank you. Okay. So for I from 0 to current wave dot segments dot length. Oh, this is not this is a list. So we need to use count, not length. Length is used for arrays. This is a list, so we need to use count. Okay. Let's store the current segment. So wave segment equals current wave dot segments at index I. Here we go. And after that, we need to calculate the start time and end time because right now in our segment, we are using persons, remember? So let's write float t-start equals our segment dot t-start-end dot x. So this is the start time divided by 100 to get a proper percent multiplied by the wave duration. Here we go. Same thing for the end time. So t end equals at y. So the y coordinate. And yep, we should be good. So these are our two time markers, the start and the end of the segment. Cool. So now let's check if our timer is within this time span. So if the timer is less than the t-start, or by the way, we've learned end, or did we not learn it? I don't think we did. So quick tip here. If you want to check multiple conditions inside of the same if statement, you can use double end. If you want to check and something, so if this and this, or you can use two vertical bars for or. This is an or statement. If the timer is less than t-start or the timer is greater than the t-end, So T end, it means that we are outside of the bounds of this segment. So we should actually continue and check the next segment, okay? If you wanted to write it in another way, we can check if the timer is greater or equal to T start and the timer is less or equal to the T end. We are inside of the timer, so we should do our logic. So apply logic, okay? So the logic of the segment. But I like to use security gates, as I've told you about in the previous, in one of the previous lessons, yeah. So let's go on. If we are outside of the segment time span, let's continue and check the next segment. Otherwise, we can continue. It means that we are inside of this segment. So float time since segment start equals timer minus T start. Why do we need this? We need this to check our frequency here. Remember, we are using frequency to spawn enemies. So we need to have another timer, let's say, that counts from the start of this segment, not the general timer. We can now use this timer to compare it or use it with the frequency to check if we should spawn an enemy or a prefab. So if our time since the segment start divided by 1 divided by the segment dot spawn frequency. So the 1 divided by segment frequency is a delay here, like we've used inside of the range enemy attack. The attack delay was 1 over the attack frequency. So this is exactly the same logic to convert frequency in delays. So let's jump back to our wave manager right here. So we've got our delay. If you're afraid of having a line that is too long, you can actually write float spawn delay equals this. So 1 over the spawn frequency. Let's drop it here. It's actually going to be cleaner, of course. So spawn delay is greater than a certain value. We should spawn the prefab. And I'm going to tell you what that's value later on. Don't worry about that. So let's add curly brackets here just to rearrange our thing. Boom, bam, beam. Yeah, we have got the error because of these 3 dots, but we're going to fix them. Okay, so let's instantiate our thingies here. So instantiate the segment, the current segment. Where is the segment? Oh, here. Segment. Come on, let's actually use 1 here so that I don't have an error, and we can then change it. So segment dot prefab, this is what we want to instantiate. For now, we can just spawn it at the center of the arena. So vector3.0 or maybe vector2 actually. Let's use quaternion.identity and let's spawn it under the wave manager. So transform. Here we go. After we are done with this, what we can do is increment our timer, because right now we are not incrementing it. So timer plus equals time.delta time. Here we go. So now let me explain this value right here. It's not 1, it's actually 3 dots. Okay, we've just written 1 so that we don't have that error. So let's think about it step by step. Our spawn delay here is not variable because we've set it inside of the inspector. So let's say that our spawn frequency is 1. Our spawn delay will be 1, okay? So if the time since segment start divided by 1 is greater than a certain value, we should spawn. So let's imagine that we are at the start of the timer. So our segment starts from 0 to 10. We are at 0. We increment. After 1 second, 1 divided by this will be greater than 1. So we will spawn. But in the frame just after this one, it's still going to be greater than 1. So we are going to spawn again. So we should have a kind of a counter. So int maybe counter equals 0. And if this is greater than the counter, so counter, then we should instantiate. But we need to increment the counter here, counter plus plus, so that we don't spawn another one on the next frame. So then we are going to increment this one, 1, 1, and so on until 2 seconds. 2 divided by 1 will be greater than the counter. And we are going to spawn, then increment the counter. Then it's going to increment again. 2.5, 2.6, 2.7 until 3 seconds. 3 divided by 1 is going to be greater than 3 and so on. So this counter idea is crucial here to manage our spawning, okay? And again, please, if you don't understand this, please let me know. I'm going to try and explain another way. Maybe I can actually make a cool graphic and so on. And please, again, if you don't get it, let me know. Just ponder this, watch it again first, try and visualize this, okay? But right now, the counter is inside of the manage current wave, so it's always going to be reset. We need to store it outside of the wave. And we also need a counter for each segment. So what I propose to you is to create a list of counters somewhere around here. So private list of float, local counters, equals new list of floats. So we need to instantiate it, or we can instantiate it at start. And inside of our loop here, let's remove this. Inside of the loop, what we can do is local counters at index I plus plus. Here we go. We can now use these local counters right here. Perfect. And we still need to instantiate our counter because right now our list is new, created, but empty. So because we just have one segment in our wave, let's actually write local counters.add 1. So we add the value 1 to our list so that we actually start from 1, not 0 here. Okay? So let's give this a shot and then we're going to call it a day for this lesson because there are already so many information that you need to understand. So please make sure to rewatch if you did not get it from the first time. So let's hit play. All right, so during the first 10 seconds, you should spawn enemies. So 3, 4, 5, 6, 7, 8, 9, 10 maybe? Yep. Okay, so how many enemies did we spawn? I did not count. So let's add a debug line to debug to show our timer here. So debug.log timer plus timer. Here we go. This should be good. So we should be spawning 1 per second during the 10 first seconds. So let's hit play. So maybe we should be spawning 9 actually, 9 enemies. So here's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 enemies here. Because first off, we are not at 30% of it. It's not perfect. If we want 30% of the wave, it's going to be 33 maybe, something like that. So 100 divided by 3. Let's round it to 34. And now we should be spawning 9 if I know how to count. Let's try this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10. Okay, so we actually have 10. So let's try this without the weapons. Beam, let's select both weapons, hit play. Okay, so after 1 second, we start spawning the enemy here.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9.
And 10. So we actually have 10 enemies. Okay, so 1 per second during the 10 first seconds is actually 10, not 9. Thank you, Tapsail. Okay. So, yeah, I hope this is clearer now, and I invite you to play with these values a little bit before jumping to the next one. And yeah, I hope this is clear. And again, if you have any question, feel free to ask. See you in the next one. Welcome back, guys. In this lesson, we are going to take it easy because the previous one was a bit overwhelming. I hope it was not. I hope you got it and you've revised it. Again, please, if you have any question, let me know and I'm going to help. Okay, so in this one, we are actually going to manage the spawn position of the enemies. So basically, they should spawn around a certain radius further from the enemy, from the player, but still inside of the arena, okay? So if the player is right here, they should spawn around him. If the player is somewhere around here, let's say, they should spawn around him, but still inside of the arena, not outside of it, okay? So let's bring it back here. Let's re-enable our weapons, by the way. Oh, really cool effect here. Love it. I really love gizmos sometimes. Okay, so inside of our manage current wave method, we've used vector2.0 to spawn the enemies or the prefabs, because later on we might have other things we might spawn. Let's use get spawn position, like so. Oh, come on. Position, yeah. I wrote it. I've written it well. Private.
What?
Oh, I'm outside of the class here. Yeah, of course. So private vector2 get spawn position. Here we go. So what do we want to do? First off, we need a reference to the player, right? So let's store the player. At the top here, settings, maybe we can create a new header for the elements, private player. And because the wave manager is actually a manager that's not going to change over time, what we can do is add a serialized field attribute, like so, and store or reference the player right from the inspector. So let's go back to Unity. Of course, we have an error. So let's return vector2.0 for now. Yep. Let's go back to Unity just to reference our player. Select the wave manager. Please compile. Thank you. Dave, boom. Here we go. That's cleaner sometimes instead of searching for the player and so on. Let's go on. Get spawn position. Right now, we are going to hard code all of our values, but later on, you can actually turn them into fields so that we can tweak them. I'm using hard-coded values now because our arena is not going to increase in size or diminish right now. So yeah, sometimes it's good actually. So yeah, let's go back to our script. So we first need to set our target position, vector2 target position equals vector2 cast of the player that transform that position plus a certain offset. Okay, offset like so. So let's create that offset. Vector2 offset equals. To determine our offset here, we need to, as I've told you, create a sphere or circle around the player. So we should not spawn directly on top of the player. You should actually get far away from here, maybe from him, maybe by 7 units or something. Let's actually create an empty game object as a child of the player. Let's move it 7 units away from him. Yep, 7 should be good actually. Maybe between 7 and 10. Let's actually create use these gizmos here. Game object. Can I see it? Why can't I see it? 3D icons. Oh, here it is. Here it is. Perfect. Maybe I can use a bigger one. Game object. Nope, I don't like this one. This one is cool. Okay, so maybe between 10 and 7, 6, between 6 and 12, something like that. Yep, should be nice actually. What about the bottom here? So 0, 6, yeah, okay. What about 12? Oh, 6 and 12 is way too much in my opinion. So maybe between 6 and 10. Yep, 6 and 10 should be nice. Okay. So let's use these values here. And by the way, let's actually check out the values or the bounds of our arena while we are still here. So the arena, create an empty game object, is 7. What about 20? But we might want to get somewhere around here. 19 for the X value and maybe 9. Yep, so maybe 18 and what about 8? 18 and 8 seems to be like good values here, okay? And you might have a different arenas. That's why I'm not using the values I've used in my course, but showing you this technique. You need to make sure that you can spawn inside of these bounds here and not go over the bounds of the arena. So it seems like 18 for the X value and 8 for the Y axis are good values here. Yep, so let's use these. Okay, inside of here, our offset will be a certain direction. We need to select a direction from the player and offset it by 6 or 10. So here's how we are going to set our direction. Vector2 direction equals random.onUnitSphere. Okay. So even though this does return a vector3, because we store that value inside of a vector2, it's actually going to return a vector2. So we will have a certain X and Y. We can then grab this direction and normalize it because, as I've told you, it's basically normalized by default, but it's a vector3. So the normalization takes into account the Z-axis. So it might not be normalized in the XY plane, so in 2 dimensions. This is why we normalize it again. Times a random.range between 6 and 10, as we've said before. And we now have our target position. So this is already really cool. We now need to clump this target position. By the way, we can return it instead of returning vector 2.0. And we just need to clump this target position so that we don't go outside of the bounds of the arena. So target position.x equals mathf.clump, the target position.x between minus 18 and 18 for the x value or x-axis, if I remember well, and 8 for the y value. So boom and boom. Here we go. We should be good. So let's try this out. Let's go back to Unity. Let's hit play. Okay, so we should be able to spawn enemies around the player now. I'm just going to reduce the size of the gizmos here. Yeah, that is already really nice. You know what? For better testing purposes, what I'm going to do is increase the spawn frequency. And maybe we can spawn or add another segment where we do spawn the range enemy from 34 or maybe 33 to 100%. So from 33 to 100. Okay, so let's grab the range enemy. Boom. Maybe 10 range enemies. Come on, this is going to be war. All right, let's try this out. And we can already notice that our enemies are spawning here inside of the arena. Really cool. What about the range ones? So 30 seconds, they should be spawning right now. No? Why aren't they spawning? Oh, because we are not managing other segments. Sorry for that. We are only managing one segment right now. But that's already really nice. You now know how to spawn enemies around the player inside of the arena. That is really cool. So in the next one, let's actually tackle the other segments. Okay? See you there. Welcome back, guys. In this lesson, let's better manage our waves and segments here. So let's open our script again. Let's not lose time. Come on. Okay. So right now we are managing the wave inside of the update method, okay? And we are starting the wave right from the start, actually, of the game. So this is not optimal because later on we will have game states and so on. We don't want to start the wave right away. So what I propose to you is to add a boolean, so private bool is timer on, that will help us manage when the timer is on or not. So inside of the update method, what we want to write is if is timer on. So if it's not on, let's use the opposite logic. Let's return. We don't want to do anything if the timer is not on. So we now need to start our wave. Otherwise, it's never going to start. So at start right here, what we want to do is call a method that will help us start the wave. So we can call it start wave with a certain wave index. So let's start wave 0 at start. Like so. Oh, come on, I can't type or what? Start wave. Here we go. Private void start wave with a certain wave index. Okay, we're getting there. So inside of this start wave method, we will definitely turn the timer on. So timer on is timer on equals true. But before turning the timer on, we should do stuff. First off, we need to reinitialize our timer or reset the timer. And even before that, we need to set up or initialize our local counters here. Remember, we use them for the segments, so we definitely need to initialize them. We will have as many counters as we have segments inside of the current wave. So we first want to clear our list, local counters.clear, to make sure that no other wave or segments are going to interfere with our data. And then for each segment inside of the current wave, so for each wave segment, let's call it segment in the current wave will be the waves at index wave index dot segments. Yep, we should actually be good. We're going to add one like we've done right here. Perfect, like so. So we are now properly initializing our local counters. And just like that, our first wave should be working properly. So let's test it out. Let's go back to Unity. We are just going to set a wave duration of 10 seconds, I think, just so that it's actually easier to debug. So from second 0 to 3, we should spawn enemies, and from second 3, around 3 actually, to 10, we should spawn range enemies. Let's actually set it to 5 too, and hit play. Please work, please work, please work. Okay, let's start this out. First off, we have an error here. So let's actually, oh, that's just the screen position. That's Unity, come on. So let's exit the pause mode. Okay, range enemies. Yeah, we are spawning range enemies here. That is so cool. So that's not cool. They're shooting at us, but at least we spawn them. And there are so many droppables here. Really nice. Okay, so we can now notice that this is working as expected. In the next one, we are going to add more waves and learn how to manage them properly. See you in the next one. Welcome back, guys. In this lesson, we are going to learn how to manage multiple waves. So the first thing we need to do here is to create another wave, of course. And just for it to work a little bit better, what we're going to do is actually invert this one. So we can actually duplicate this one, yeah. If we hit plus here, it should duplicate it. So let's rename it wave 01. And we've got our two segments. We are just going to switch them around. Okay, so let's move this here and this here. So we should be spawning a bunch of range enemies first and then end up with enemies. Cool. So what we're going to do is not display our timer, so we can remove the timer from here. But if the timer is less than the wave duration, we want to manage the current wave. Otherwise, it means that the timer is greater or equal to the wave duration, sorry. So we want to start the wave transition or manage the wave transition, like so. So let's create this method. We can actually boom, boom, and create it right here. Private void start wave transition. Here we go. And inside of this wave transition method, we will definitely need to start the next wave. So we need a way to access the wave index here. We've started the wave 0 at start. We now need to start the wave 1 and so on whenever wave 1 is completed. So we need to keep track of the wave index. Inside of the settings here, what I'm going to do is create a private int current wave index. Really cool. Because it starts from 0, we can use it right here. And also because we initialize our local counters, by the way, right here, we can remove this line. Here we go. This is already way cleaner. Again, you know me. It's a good practice to clean your code from time to time. Okay, so start wave transition. We will definitely want to increase the current wave counter to set it to 1 after we've completed the first one. So current wave counter plus plus. And we can then call start wave, current wave index. As simple as it gets, right? And just for debug purposes, what we can do is actually add a debug line here, debug.log starting wave plus wave index. Wave index. Wave index. There is echo around here. Okay, so let's go back to Unity now. We can hit play whenever it's compiled. All right, let's try this out. So we are spawning, starting wave 0. Okay, 10 seconds. So let's wait for all of the enemies to be defeated. Starting wave 1. So now we spawn a bunch of other enemies. Oh, I really can't. It's really hard to notice what we are actually spawning. So there are still a bunch of enemies. Oh, I did not get everything. Oh my god. Wait, let's try this out. Let's exit the play mode. Okay, and what we are going to do, you know what? When completing a wave, what we want to do is actually defeat all of the enemies from the previous wave so that it's clearer to debug. So let's create a way to destroy all of the previous enemies. Private void defeat all enemies, let's say, something like that. And inside of here, we want to write transform.clear. And the clear method here is an extension method that I've created. You can actually hold Control and press just to have a look at it. You can, again, check out my Code Ninja course. This is where I show you how to do this. This is really useful, by the way, really, really useful. So make sure to create extension methods whenever you notice or you find out that you reuse the same piece of code or same lines of code again and again, okay? So defeat all enemies before starting the next wave, of course, right here. We want to defeat the enemies, increase the index, and start the next one. Cool. So let's go back to Unity now. Let's hit play. All right, starting wave 0, So boom, we should be spawning these, then destroy them after 10 seconds. Maybe somewhere around right now. Thank you. And then we are spawning, okay, we are spawning enemies, then ranged enemies. So this is not working as expected here. It should be the opposite actually. We should be spawning ranged enemies first, then enemies. So there is something wrong in our code. And what is wrong in here? This is because we are always using the first wave. Instead of setting waves 0, we should be using the current wave index, like so. Cool. So nothing else that we should change? No, we should be good. So let's go back to Unity and actually set a wave duration of 5 so that it is actually faster to debug. So enemies first, then range enemies. Okay, so let's defeat. Okay, then range enemies, and finally enemies right now. Thank you. Now it's working properly. Really nice. Okay, awesome. What a relief. So as you can notice, we are trying to start a wave index that is way greater than what we have right now. So in the next one, let's fix this and actually make our code a little bit prettier. So see you in the next one. It's going to be really cool. Then we can tackle the UI for our waves. Bye-bye. Welcome back, guys. In this lesson, we are going to fix some issues and make our code prettier, cleaner, more sustainable, more blah, blah, blah. Okay? So let's go back to our code right here and fix our index issue. Okay. So inside of here, we want to defeat all of the enemies, but first off, we also want to set the timer as off. So is timer on should be false here, okay? So is timer on equals false, here we go. Then we are increasing our wave index, and before starting the next wave, we need to make sure that we actually have a wave with that index. So if our current wave index is greater or equals to the waves.length, it means that we don't have any more waves, because if we have 2 waves, the last index will be 1. If we are at index 2, it's greater or equals to 1, which is really bad for us. So we want to debug something here. Let's just debug.log. Waves completed. Hooray! Okay. Otherwise, we want to start the wave at current wave index. Really cool. So let's try this out. Let's go back to Unity, hit play. All right, starting wave 0, starting wave 1, and waves completed. Really cool. That's one thing that we've fixed here. That was a really short lesson. In the next one, let's tackle the UI. See you there. Welcome back, guys. In this lesson, we are going to tackle the UI for our wave manager, or our waves in general. Okay, so let's tackle this. Okay, so inside of the game panel, what we want to do is actually duplicate the XP text maybe, because it's already set up with our font asset and so on. So let's grab it, drop it inside of the game window or game panel, and anchor it to the top of the game window. Okay, let's rename it wave text maybe. Yep, should be good. Let's bring it down, and in here you are free to drop it wherever you want actually. The text will be something like wave 10 about on 20 maybe, not 10 but 20 right here, or 50. I don't know, depends how many waves we have. Let's not auto size the text. We can increase the size of the text. It means that we need to increase the width. Okay, so let's increase it actually, that's okay. Here we go. So that is our wave text, and just below it, what we're going to do is add the timer text. So timer text, here we go. Let's bring it down. And this one should actually be bigger than the wave text. So it's actually going to be like 10 maybe. Come on, why can't I press Control A? Okay, here we go. So 10 for the second, maybe 5 seconds. Maybe increase the size to 70. Okay. And you can actually fast forward this or watch at twice the speed, because it's really like just design here. So let's bring it up. Okay, let's keep it something like that, and we can still improve that later on. Okay, so we've got our wave text and our timer text. We now need to set these up. And for that, we are actually going to create another script that will manage our UI here, because we have the wave manager that manages the waves. You can add the logic right here, but again, I like to split my logic from my rendering here, or your logic from your rendering. So yeah, I think that's a good practice. So I invite you to try and do the same. So let's create a new C# script, wave manager UI. Here we go. Let's attach it to the wave manager. Perfect. Open it like so. And inside of here, of course, we are going to add references to our wave text and timer text. So we need to use the TextMesh Pro library as usual. Let's add a new header for our elements. Serialize field, private TextMesh Pro, UGUI. This is the wave text. The other one is going to be the timer text. Here we go. Perfect. Let's remove these two. And inside of here, we just want to add two methods that will allow the wave manager to control these texts or to change their values. So public void update wave text string wave string, let's say. And this one will simply grab the wave text equals wave string. Here we go. Same thing for the timer. So timer string, timer text, timer string, and update timer text. That is so nice. It's really simple. It's straightforward, but it's working. So let's rerun these to be a little bit prettier again, of course. And now we can open our wave manager, add a reference to the wave manager UI. So we can specify that we need it. Require component, type of wave manager UI. Here we go. Elements, private wave manager UI. Let's call it UI because we are already inside of the wave manager. Inside of the awake method, UI equals get component. Wave manager UI. Here we go. And we can now add the logic to update these texts. So when the timer is less than the wave duration, we are still playing. So we can add some curly brackets, manage the current wave, and update the timer text. So we can write UI.update timer text with the value. Let's actually create it right here. String timer string, let's say. It will be equals to the wave duration minus the timer. Okay, you can actually pass in the timer if you want to count from 0 to the wave duration, but I like to count in reverse. That's a choice. I think that you will also do that. That's the most logical one. So yeah, we are going to grab this difference and turn it into an integer. Okay, so mathf.round to integer, or you can actually cast this into an integer just by using a simple cast and convert it into a string. So you need to make sure that you're using more parentheses to cast this value, then convert that integer into a string. Got it? And finally, we can pass in this to the timer text like so. So this is updating our timer text. We now need to update our wave text. We want to update our wave text, of course, whenever starting a new wave. So UI.update wave text. And the string we are going to pass in here is going to be something like wave with a space plus we need the current wave index right now. So let's write current wave index, but as it does start from 0, we want to add 1. Remember, for the level, I think we've used this logic. Plus divided. Maybe you can add some spaces again. Plus waves dot length. The total amount of waves. Here we go. So we should be good. We only need to add the logic whenever we are cleared. We have cleared all of the waves here, maybe. Yeah. So let's write UI dot update wave texts with waves completed, or maybe stage completed. Okay, each stage is composed of waves. Each wave is composed of segments and so on. UI dot update timer text with a blank string. You could actually add another method to the UI script right here to manage all of this, like on wave completed or wave completed, something like that. That will actually apply the same logic, but there are so many ways, again, that you can code this. So let's now go back to Unity, reference our texts, and we should be good again. So let's set up the wave text, timer text, hit play text, and let's try text. All right. This is what tired developers look like. This is working. Yay! 0, 4, 3, 2, 1, 0. Boom. Stage completed. That was really cool, really easy, really straightforward. I really hope that you got it from the first time and that you actually took the initiative to implement that before I show you how to do so, because if you want to improve, that's what you should do. And yep, so I think that we're good for the wave manager now. In the next one, let's actually work on the core loop, because right now we are starting the wave manually. This is not what we should do. We should actually add a start button, a menu, and so on to start the waves. And whenever we complete a wave, we should check if the player has leveled up. If he has leveled up, we should allow him to pick a stat and so on. So yeah, working on the core loop is the most logical step after this one. So I hope you're ready to tackle this. See you in the next one. Welcome back, guys. In this lesson, we are going to start working on the core loop, okay? So this will imply creating the game manager, some UI, and more. So let's do this step by step. Okay, so the first thing we want to do is to open the wave manager, because this is kind of where we start the next wave. And this is where we want to check if we should start the next one or display the wave transition panel, let's say, the one where we can improve player stats. So yeah, so what we're going to write in here is game manager dot instance
Dot wave completed callback. Here we go.
So what does this instance mean, and what is a game manager? Do we have the game manager first? Yeah, we do have it. But what does instance mean here? This is because we are going to use singletons. So singletons is a design pattern that allow us to call a script using a static instance if you are sure that you will only have one instance of that class. So we know for sure that we are only going to have one game manager. We are also only going to have one wave manager, but for now, no need to turn it into a singleton. But yeah, this is really useful in case you want to call some methods inside of that script. The other way we could have done that is simply by, let's comment this first. We could have written find any object of type, by the way, game manager dot wave completed callback, wave completed callback, like so. We could have added a reference to the game manager at the top right here, like we've done for the player. So yeah, there are so many ways you can do that, but I need to show you new ways to do things, right? So let's use the singleton pattern. Okay, so let's turn our game manager into a singleton. Boom, let's open it. What we're gonna do is add a static instance of the class. So public static game manager instance. Here we go. Now we should not have any more error, except the fact that we don't have this method yet, but come on. So let's add it really quickly. Let's open the game manager, public void wave completed callback. Here we go. This is where we are going to check what we should do. So we are going to check if the player has leveled up and so on. But right now, we haven't instantiated or set up our instance yet. If we try the game, we are going to have an error. So let's give it a quick shot. All right, so we should jump to the next wave, but error, object reference not set to an instance of an object. This is again because our instance has not been initialized. So usually you want to initialize your singletons inside of the awake method. So for that, we are going to check first if the instance equals null. So if we don't have any other instance of the game manager, then instance equals this. This game manager is the instance that we need. Otherwise, we just want to destroy game object, because it means that we have another instance of the game manager. Okay, so let me show you how this works. First, we are going to go back to Unity. I'm going to duplicate the game manager so that we have two game managers. And when I hit play, you will notice that one of these two will disappear. So let's hit play. I'm not going to edit this. Here we go. The first one has disappeared because it seems like this one has been called first. So what did happen here? This one called the awake method, so the instance was null. It set itself as the instance, and when the other one, so the first game manager actually came and checked for an instance, it was not null, so it destroyed itself. So this is how we make sure that we only have one game manager in our game. Really cool. I think will be it for this lesson because you learned about singletons. That is really cool. What I invite you to do is to, as a quick exercise, create a UI manager that will simply enable a wave transition panel whenever we start the wave transition. But first off, we need to check if the player has leveled up or not. If you're ready to tackle this challenge, do it. Let's go. See you in the next one. Hey guys, in this lesson, we are going to keep improving on our game manager so that we can actually have a proper core loop. Here we go. So let's open our game manager. We've added the wave complete callback. Oh, by the way, it should be wave completed callback. So let's rename this, and it should have been renamed in the wave manager. Let's just make sure. So wave completed callback. Here we go. That's really cool. So let's open our game manager again. By the way, I'm just going to close everything, and if we need something, we will open it. I don't know why I've...
Come on, I removed the game manager, but I'm going to open it again.
Here we go. So inside of here, we want to check if the player has leveled up. So basically what we're going to do is call the player.instance, and you now know about singletons, so we can use another one. But of course, you can add a reference to the player at the top right here and so on. You know how it goes. So player.instance has leveled up. So if the player has leveled up, what we want to do is display the wave transition panel. But the game manager will not be responsible for displaying that. The UI manager will. So for now, let's just debug.log. Boom, show with an uppercase, show wave
Transition panel. Here we go.
So let's turn our player into a singleton now. Public static player instance. And inside of the awake method, I can use a code snippet to initialize the singleton, like so. And again, you can learn about code snippets in my Code Ninja course. I invite you to go check it out. All right, so now our player is a singleton. We need to add the has leveled up method that does return a boolean. So public bool has leveled up. Here we go. Inside of here, we have no clue if we've leveled up or not. So we need to ask the player level, of course. So let's return player level dot has leveled up, like so. We can actually add a reference to it. So we can add a comma here, type of player level. But again, there are so many ways you could have added the script here, like we've done for the other things and so on. Come on, you're not new to this. So player level, here we go. We can add a reference to the player level, boom, boom. Get component of type player level. Now we have a reference to it, and we need to add this method to the player level. So let's open it, not the health, the player level. Here we go. Let's add the method public bool has leveled up. And inside of here, how can we detect if we've leveled up during this wave? We are going to create a quick variable at the top here and use it to keep track of our level increase. So we know about our level here. So we just need to know which level we were at when starting the wave. So private int level, maybe levels earned this wave, something like that. Or leveled up this wave, levels earned this wave. It needs to be an integer here. Why? Because if we've leveled up more than once, we should allow the player to select multiple bonuses, so multiple stats increase. If this was a boolean, it's a 0 or a 1. So we would have been able to display the wave transition panel once only. And this is not a really good player experience. So let's keep track of these. Inside of here, we can just return if the levels earned this wave are greater than 0. Then we are going to diminish this count, so minus minus, like we've done plus plus to increment, and then return true. Otherwise, return false. So why this logic? Imagine that the levels earned this wave were 2. So we've earned 2 levels during this wave. It's greater than 0, so we will definitely enter this and return true. We will then display the wave transition panel, select a bonus, and after that we must ask the player level if there are still levels earned this wave. So it means that we need to diminish this count to prevent displaying this over and over again. Another way you could have done this is by grabbing the levels earned this wave from the player level, stored it inside of the game manager, and keep it for later use whenever you want to check if we should display the transition panel or not. Got it? Please, if that's not clear, let me know in the comments section. All right, we will still have to reset this variable whenever we start a new wave, but don't worry, let's keep that for later on. Now we can just go back to the game manager and yeah, maybe we should try this out actually. Otherwise here, if the player has not leveled up, we should simply display the shop. So debug.log display shop. Here we go. So let's go back to Unity now. We are going to try this out. Let's hit play. All right, let's try and not level up maybe. Okay, so we should display the shop. Here we go. So let's now increase the wave manager, the wave duration, to maybe 15 seconds so that we can actually level up by collecting candies. Yeah. Okay, let's wait for a little bit. Here we go. Boom. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we should be able to level up. The scene is going to be crazy. What? Oh my God. So display shop. Okay. So this is not working properly. Why? Because we haven't increased our player, our levels earned this wave variable here. So whenever we level up, we should definitely increase this. So let's add it here, ++, here we go. Now we can go back to Unity, try this out again. Let's collect some candies, here we go. Okay, level 2. So now we should definitely be able to show it. Oh, let's hide the gizmos for now. Okay, boom. Show wave transition panel. Yeah, that's working as expected now. So cool. So now that we know how we can display the wave transition panel and the shop, let's actually add these. So see you in the next one for some UI work. Welcome back, guys. In this lesson, instead of working on the UI, what I propose to you is to actually improve our game manager. Because I've told you that the game manager were not going to be responsible for displaying the wave transition panel, nor the shop. The UI manager should do so. So instead, the role of the game manager here will be to change a game state. So this will be an enum and trigger either an event or use interfaces to let all of the other scripts know, the ones that actually need to know, that the game state has changed. So in here, we change the game state. The UI manager will actually know whenever the game state has changed and act accordingly. Okay, so let's create a new script for our enums here. I don't think we have one yet, so we've got interfaces here. Okay, let's actually create it right here. So C# script enums. Here we go. This is where we are going to store our game states and our player stats too. Let's open it. Okay. So this is actually going to be a public enum. Let's remove the methods. Okay, yeah, we can actually remove pretty much everything because we are simply going to write public enum game state, like so. So our first game state will be the menu. We will also have the game state. We will also have the wave transition. And for now, we can simply keep the shop, okay? Yeah, these 4. I think that's enough just to start with. After that, we can simply go back to the game manager and add some more logic here. Let's create a method to set our game state. So public void set game state. Here we go. Game state, like so. The role of this method is to tell all of the other scripts, the one that will implement the interface, a certain interface that we are going to add, that the game state has changed, again, so that they can act accordingly. Inside of here, what we can do is call the set game state wave transition. When we want to display the shop, we can write set game state dot shop. Here we go. And at start, of course, we can call set game state dot menu. Really simple. So you can already notice the power of enums first and interfaces that we're going to use. This will help us decouple our code like really easily, honestly. We can then add a delay, by the way, here to prevent some harsh transition, yeah? Or we can add the delay inside of the UI manager, depends. But for now, let's just add the logic of the setGameState method. The first thing we want to do is to look for all of the scripts that implement a certain interface. We are going to write IEnumerable of type iGameStateListener. So those who are listening for any game state change. Game state listeners equals find objects by type, mono behavior. For the find objects sort mode, we can actually set it to none. So find objects sort mode, where is it? Here it is, none, perfect. Dot of type iGameStateListener. So iGameStateListener. Here we go, perfect. So first off, we are having an error here because we haven't added the link library yet. We can add it, so using system.link, perfect. So we can now check if the mono behaviors that we've found do implement the iGameStateListener, and then we need to create this interface. And quick tip here, you could either create a new script to store your interface in that script, of course, or we can simply add it right here. So public interface iGameStateListener. Here we go. Oh, without the parentheses, sorry. Like so, perfect. So what's the difference here? None. There is no difference. It might be easier to track the interface if you drop it inside of its own script. Maybe you can create a script for maybe to store all of your interfaces if they are not that long. This one is only going to contain one line, so no need to create a new script for that. And again, I just want to show you variation here. So the fact that you can create interfaces inside of a text file, that's actually a text file. Look, the class encapsulation is right here between these curly brackets. So you can actually create more stuff outside of this. Maybe we can write public enum, my enum, like so, blah, blah, blah. You can create more things. Public class, my class, like so. Here we go. It can also implement mono behavior, like so, and the iGameStateListener, and so on. You can store multiple classes in the same text file, so the same CS file, C# file. But yeah, depends on the organization you want to have. Again, you're free to do whatever you want here. Okay, so inside of our iGameStateListener interface, we are going to have a simple method. So void GameStateChanged callback, a simple callback that other scripts can actually track or subscribe to in some words, even though this is not a subscription here. GameState. Perfect. So now inside of our UI manager, we can check if the new game state is the, let's say, wave transition state. And if that's the case, we can display the wave transition panel. Okay. The only thing left now is to call the game state changed callback, game state changed callback method inside of all of our game state listeners. So let's create a for each loop. For each iGameStateListener. Let's call it GameStateListener. Yeah, maybe, yeah. In GameStateListeners, let's write GameStateListener dot GameStateChanged callback with the new game state. Perfect. What we can do is rearrange our script a little bit. Maybe this can be here. We can add the extension method down there. Depends. However you like it. Okay. I think we are done here, so let's remove the update method. Perfect. We can now jump back to Unity. Do we have something to test here? I don't think we do. The method is a little bit long, but what we can really quickly do is open our Wave Manager, implement the iGameStateChangedListener. Of course, we're having an error because we need to implement the interface, like so at the bottom. Here we go. And inside of here, what I'm going to do is debug.log Wave Manager knows that the new game state is, and I'm going to change the syntax here. So let's add a dollar mark, and we can then add the game state. So game state, here we go. Perfect. Let's go back to Unity and try this out. Let's hit play. All right, Wave Manager knows that the new game state is menu. What about the next one? So let's collect some candy. Bim, bam, boom, doo. Okay, so we should now level up. We have level up actually, but we should be able to try. Yeah, Wave Manager knows that the new game state is wave transition. Oh, our Wave Manager knows everything. Okay, cool. So we now have all of the tools we need to implement the UI Manager and display more panels. That is so cool. By the way, you could also use this logic to prevent the player from moving here. So inside of the player controller, we can kind of lock the player or the control, but no need to do so because we're actually going to hide the game panel and no more joysticks, so we cannot move anymore. It has the same effect. So yeah, so many ways to do the same thing. That is so cool. See you in the next one. Welcome back, guys. In this lesson, we are going to tackle our UI. It's going to be really simple, don't worry. But just before that, what I want to do is open the Wave Manager, and inside of the game state changed callback, I want to add some logic. So depending on the game state, so let's use a switch statement here to check which game state we are in. So in case this is the game state.game, it means that it's either the first time we are going to play or just after the shop game state. Okay, so what we want to do is call the start next wave method, like so. Perfect. And our start next wave method will look like this. So we can add it right here, maybe. Private void start next wave, wave like so. We can simply call start wave with the current wave index, because when starting the wave transition here, we are actually incrementing our current wave index. So it means that the first time we are going to call this method, it's going to call the start wave at index 0, which is really cool. That's what we want. And when increasing or passing the wave transition after the shop, this current wave index variable will be increased. So we are going to call start wave at index 1, which is really cool. So let's go back to Unity and try this out really quickly. Okay, let's try. So 15 seconds. I could have actually, diminished that, but that's okay. Bim, boom. Wait, is it gonna work? Because I'm not sure we are triggering the game thingy. Yeah, starting with there. Yeah, we are not setting back the game state to game actually. So yeah, we should do that later on actually. And we can't check what game state we are in right now. So yeah, I think let's go on because we definitely need to trigger the game state here. Okay, we could add for testing purposes a button that does just that, but let's do that later and tackle the UI first. It's going to be actually a bit more interesting. So let's create a UI manager. Create empty UI manager. All right, let's create a script that we are going to attach to this. Maybe managers. Create a new C# script, UI manager. Here we go. We can now attach it to the UI manager like so. Okay. And before opening it, what we are going to do is add more panels here. So let's duplicate the game panel. We are just going to create placeholder panels. So this is going to be the menu. We can remove the mobile joystick, the health slider, the XP bar, and the timer text from here. I'm simply going to write menu. So maybe, why isn't it visible here? This is because it's behind the thingy. What if we bring it down? Oh, because I haven't changed the text command. So this is menu text actually. Okay, so menu, here we go. Maybe we can center the text and increase its size. So boom, press F. We can play with it a little bit, something like that. Cool. Let's auto size the text. And the maximum can be, I don't know, maybe 500, something like that. We just want to know where we are. Let's re-enable the gizmos. Cool. So we've got our menu. Let's add the wave transition panel, maybe after this one. So please close. Thank you. So this is going to be our wave transition panel. Boom, boom. Wave transition. Let's change the text to wave transition. Here we go. What about the shop now? Shop. Perfect. Oh, come on. Where is my bracket here? Here we go. Shop. Perfect. So we can rename these really quickly, even though we are not going to use them. Come on. You know that we are going to improve these later on. So wave transition text, but it's just for reference here. At first, what we're going to do is hide our game, wave transition, and shop. Got it? And we are going to be in the menu. So from the menu, we should be able to jump to the game panel. Later on, we will add the weapon selection panel, so the weapon that you select whenever you start the game. But for now, let's jump right into the game. So let's add a button. UI button right here. Cool. This is going to be the play or maybe start game button. Well, now let's drop it down somewhere around here and anchor it to the bottom of the screen. Perfect. We can change its image. So let's add the button, basic button, I think. Button base. Yeah, we've got some outlines that we can use later on when polishing the game. But for now, let's just use this one, yeah. I'm going to increase its size so that it's more visible and change its color to blue. Yeah, like so. Let's change its text. Start game. Here we go. Maybe we can also change the font. Helvetica. Perfect. Let's auto size it and change the color to white. Like so. So we already have a functional, kind of beautiful, kind of ugly menu. So let's use this. This is the start text. Perfect. And the goal of our start game button will be to start the game. So game manager right here should actually set the game state. For that, we are going to add a method, so public, to be able to link it to the button. Void start game. All right. And this method will simply call the set game state method and set the game state to game. Perfect. That way we can actually start the waves and so on. By the way, we can also open the wave manager and remove this line because we don't want to start any wave at start. Let's go back to Unity, select the start game button, and we can add a callback to the button, like so, whenever we click. We can drag the game manager, drop it here, and select the game manager start game method. Perfect. So now whenever we click on this button, it should trigger this method. Let's try this out. All right, before we click on the button right here, you can notice that no enemy is spawning and we can't control the player. So if I hit start game, enemies should start spawning, but I won't be able to control the player because the joystick is inside of the game panel. Let's just try this out. Enemies are spawning. If I enable the game panel and disable the menu, I can move. So that's the only thing left here. We need to add some logic to the UI manager to do just that. Let's actually learn how we can do that in the next one. This one is getting a little bit too long. Welcome back, guys. In this lesson, we are going to keep implementing our UI and more specifically, the logic for our UI manager. So let's open our UI manager now. Cool. The first thing we need is references to all of our panels. So let's add a header, panels, serialized field, private game object, menu panel. Let's add another one for the game panel. Let's add another one for the wave transition
Panel.
and finally another one for the shop panel. Here we go. These are the 4 panels we are going to start with. To be able to manage the active property of these panels, we need to implement the iGameStateListener interface. That way we can do stuff whenever the game state has changed. Okay. Let's grab this one and maybe drop it at the bottom somewhere around here. Perfect. And use a switch statement like we've done in the wave manager, if I remember well. Right? Was it there? Bloom, bloom, bloom. Yep. Because then we're gonna have some other logic here. Don't worry. Okay, so switch game state. Like so. Perfect. In case the game state is the
game.
let's break, but then we're going to do stuff. We are also going to have logic when the game state is the wave transition, and logic when the game state is the shop. So keep in mind that you can add all of your logic inside of here, but it's actually better to create methods so that we can better manage this. For now, let's just use the easy route. In case the new state is the game state, what we want to do is hide the menu panel. So menu panel.setActive false, right? We want to display the game panel. So game panel.setActive true. We want to hide the wave transition panel. Okay, so wave transition panel.setActive false. And finally, we want to hide the shop. So shop panel.setActive false. There is already one question we can ask ourselves here. What are the routes that lead to the game states? Well, first off, the menu. So you can reach the game panel from the menu. So we need to disable it. We can reach the game panel from the shop. After purchasing some weapons or stuff, we are definitely going to start the game again. But we can't access the game panel from the wave transition panel, right? It doesn't make sense, except if you want to have this. But in our game, this is not the case. So we can already remove this line. Perfect. Then we are going to keep these and apply the same logic for the wave transition. So what are the routes that lead to the wave transition panel? Well, the game, of course. From the game, we can reach the wave transition. So let's set this one to false, and wave transition panel, let's set active true. Same thing for the shop. We can reach the shop from the game panel if we haven't leveled up. So game panel.setActive false, wave transition panel.setActive false, and shop, come on, I can't write, .setActive true. Here we go. We are first going to try this out, and later on, what I propose to is to refactor this because this is too long. Come on, this is not what we want. So let's go back to Unity first. Let's reference our panels. So menu, game, wave transition, and shop. Let's hit play. All right, let's start the game. Really cool. Now I can move, and the menu panel has been disabled. Game panel has been enabled. So now let's try and level up, please. Can I? Thank you. Okay, 3, 2, 1, 0. Wave transition. Boom. Wave transition. Really cool. So the only thing we need now is to add a button that does trigger the shop. Later on, we are not going to have this button because we need to switch to the shop whenever the player has selected all of the available thingies. What are the stats? Yeah, the stats. And from the shop, we need a button to switch back to the game. So let's add this really quickly. Let's duplicate this button. Let's drop it inside of the wave transition panel. Okay, we can enable it, disable the menu just for better visualize our UI. Let's call it shop, or maybe open shop button. Okay, we could actually change its text. So open shop, and also change its callback. So we can keep the game manager for the logic here. I'm going to add a piece of code right here. So start shop, set game shop. Here we go. Boom, boom, boom. Is it okay? Yep, seems good. So let's go back to Unity here and change the callback of our button. Game manager start shop. We can add another button inside of the shop to switch back to the game state. So let's open our shop, start game button. I could have duplicated the button inside of the menu actually. Yeah, that's way better actually. That's definitely smarter. Okay, let's now hit play and make sure that everything is working properly. So at start, the shop is displaying. This is really bad. Why does that happen? Remember, we are calling the game state menu from the start method in here, but we don't have the menu case in here. So let's add it really quickly. Case game state.menu. What we want to do is hide everything except the menu. So menu panel.setActive true, and all of the other ones should be hidden. So let's grab these, drop them here. I'm going to remove these 3. This one too. Let's set this one to false and we should be good. So we are disabling everything except the menu. Let's go back to Unity, hit play again. All right, now the menu is displaying. Let's start the game, try and level up, please. Boom, okay, like so. Here we go. So we've leveled up for 3, 2, 1, 0. Wave transition. Let's open the shop. This is the shop. Really cool. Let's start the game. Wave number 2 of over 2. Really cool. So our code is working as expected. Let's wait for a little bit. We should not switch to the wave transition now. Stage completed. Nice! So this is good for this lesson. We are getting there actually. Come on, we are making progress. I really hope you're liking the course so far. In the next one, let's learn how we can improve our UI manager because right now it's kind of a mess. I really don't like this. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are going to improve our UI manager so that it's actually easier to manage. Okay, so let's open it again. Previously, we had a lot of logic to enable and disable the panels. So what we're going to do instead is create a method that will display the panel we want to show and hide all of the other ones. So let's create it. Private void show panel, game object, let's call it panel. Here we go. Ideally, what we want to do is in here, show the menu. So let's call the show panel menu panel. Perfect. Same thing for here. We want to show the game panel. So show panel, game panel. In here, the wave transition. So show panel, wave transition panel. And right here, the shop. So show panel, shop panel. Here we go. So that's how we want it to look like because later on we will add more panels, of course. In here, what can we do? Well, we can check if the panel equals menu panel, then display it, menu panel.setActive, true. And same thing for all of the other ones, but this is definitely not the best way of doing things because the more panels you will have, the more lines you will have to add, okay? So instead, we are going to store a reference or create a list of all of our panels so that we can loop through all of them. Here is how we are going to do. Private list, list of game objects panels equals new list of game objects. Perfect. And at start or inside of the awake method, actually, that's way better because we will definitely try and show the menu at start from the game manager. Remember, set menu. So we need to initialize our panels before the start method. This is why the awake method is the best place to initialize your scripts in general. Okay. So in here, we want to set all of our panels. So panels.add range. New, it's going to be a new array of game objects. So game object array. Let's initialize this. Up, menu panel, game panel. Oh, come on, game panel. Here we go, wave transition panel. And finally, shop panel. Here we go. Perfect. So now we've set up all of our panels. What we can do inside of the show panel method is loop through all of them. So using a for loop or a for each loop, actually. So for each game object, let's call it P in panels. If P equals panel, then P.setActive true. If the panel we are looping through is the panel we want to show, then we set its active property to true. Else, P.setActive false. And of course, don't forget to add curly brackets here, otherwise you might have an error. Yep, this is just for precaution here. Perfect. So this is one way of writing things. Again, we are going to use another one. Of course, you know me. What we could have written and what we're actually going to write is P.setActive P equals panel. So we want to set it active if P equals panel. So if that's true, it's going to be true. If that's false, it's going to be false. So we are actually doing the same logic that we are doing right here. Got it? And now we can actually remove the curly brackets and keep one line. Really cool. So let's just make sure that this is working properly. We're going to go back to Unity, hit play again. So we are displaying the menu, start game, displaying the game panel. Okay, we can wait for a little bit. 10 seconds. Yep, it's going to be fast. I can time lapse this. All right, here is the shop because we haven't leveled up, and start game again. Really cool. This is working as expected. Nice. So now, next time we want to add a panel, we can add it right here. So shop panel, let's say panel A, and add it to our list. Shop panel A. Here we go. And it will automatically be disabled in our show panel method. Really cool. There are cases where you don't want to hide the previous panel. Like for instance, if you want to display the pause panel, you don't want to hide the game panel, right? So we are going to use another logic actually. Or what we could do is add a boolean like hide previous panels. And if that is true, well, we will hide them. Otherwise, we will not. So if we can imagine something like that. If hide previous panels, we can apply this logic. So boom, like so. Otherwise, to prevent having errors, we can add a default value here. Hide previous panels by default should be true. And otherwise, we will simply enable the panel. So panel.setActive true. And that way, your method can do two things actually. So hide the panels or not. And you decide. You can decide to, let's say, keep the previous panels when displaying the shop. So we can set this to false to prevent hiding the panels. And yep, this is actually a cool way of doing things and really straightforward in my opinion. So yeah, make sure to use it if you like it. Okay, so let's remove this, and get back to work. Here is a quick exercise. In the next one, try and add the weapon selection panel along with the game over panel with all of the logic that it does imply. So adding these to the UI manager, you should add the states to the enums, and yep, you should also add a way to transition from the weapon selection panel to the game panel because it will be something like that. Menu, weapon selection, game. If the player loses, game over. If he and you can reload the scene actually if the player loses. I think we already have this logic, but if he levels up, we already have all of the other logic. So yeah, that's just add the weapon selection panel along with the game over panel, and watch the solution in the next one. See you there. Welcome back, guys. In this lesson, we are going to add the game over and the weapon selection panel. So let's do that. Okay, so the first thing we want to do is open the enums class here. We are going to add menu weapon selection just after the menu because this is where it is. Then game, then we can add game over and wave transition and shop. While we are here, we can actually also add the wave complete thingy. Maybe we can add a panel later on, of course, whenever the stage is complete. Sorry, not the wave complete. So stage complete. Here we go. So we now have our 1, 2, 3, 4, 5, 6, 7 enums. Perfect. Let's add a way to switch from the weapon selection panel to the game panel. Okay. So we can add a method just after the start game here. Start weapon selection. Okay. Let's rearrange these really quickly. Here we go. So this should be the weapon selection. This is for the shop. Perfect. I don't think we need anything in here. Okay, no, I think we should be good. So let's open our UI manager and add a reference to the weapon selection panel, like so. Let's add a reference to the game over and stage complete. So game over panel and stage complete panel. Perfect. Again, don't forget to add these to the array here, all the lists. So let's add this one here. We should add the game over panel and the stage complete panel. Perfect. So you can already notice how powerful it is because right now we've added the panels right here, but no need to add more logic to show it or hide it, which is really cool. So inside of the game state changed callback, we are going to add 3 other cases. So in case we are in the weapon selection panel, what we want to do is show the panel weapon selection. Here we go. And there might be a faster way to do this using enums. Maybe we can actually pass the game state as an enum and so on. Maybe convert it into a game object name. And there are so many things we can do actually. But let's keep it simple for now. Let's make it work and we can refactor later on. Let's add another way to display the game over. Yeah, let's keep a consistent order here. Show panel, Game over panel. Here we go. Let's break. Break. Like so. Case, stage complete. Show panel. Stage complete. And break. Perfect. So we now have all of the logic that we need. So what we are going to do is add these panels. So let's open our UI. We've got the menu here. Let's duplicate it, enable it, call it weapon selection. Okay. We can change the text that we are displaying here. So weapon selection, perfect. Let's hide the shop. What we can do is actually, should we change this? Nope. We should start the game from the weapon selection, but from the menu, we should display the weapon selection. So we are going to change the callback of the start game button inside of the menu here. So game manager, start weapon selection, perfect. Then weapon selection to the game, then game. From the game, we might jump to the game over or the stage complete. So we're going to add 2 other panels. I don't think that's the best way actually to do this. I think we should duplicate the weapon selection. We are only going to have a button in our game over and the stage complete. Yeah, one to retry in the game over and another one to reload the scene. I think both of these are just going to reload the scene for now. We can add more logic later on. Everything later on. Anyway, so game over. All right, let's hide the weapon selection. Change the text again. So let's call this one game over. Cool. So the start game button in here should reload the scene. Do we have any logic to reload the scene inside of our game manager? Nope, we don't. Where do we do this? I think it was in the player health. So let's open our player health script. Yep, right here. We can grab this line and drop it inside of the game manager. Of course, we are going to have an error, but we don't want the player health to reload the scene. Actually, it should call the game manager and tell him that, yeah, we've lost. So we can remove these. Okay, game manager dot instance dot set game state dot game over. Perfect. This is now way cleaner. Boom. Scene management is actually something really important. So it's better for the game manager to be in charge of it. Yeah. Boom, boom, boom. Set game state. In here, what we can do is check if that's the game over. So if game state equals game state.game over, maybe set game over, maybe manage game over, something like that. Because this is not the definitive way of doing things here. So private void manage game over. We are simply going to call scene manager.load scene at index 0, but we can reload the scene after, let's say, 2 seconds. So lean_tween.delay call after 2 seconds. Let's call this. Perfect. Of course, we need to use a lambda expression here because the delayed call method needs an action. Perfect. So we are managing the game over. What else are we managing? Manage game over. Oh, we need a button, by the way. Yeah. Oh, yeah, I see here. So public, I've made a mistake, sorry. We've added a button to the game over and stage complete scene. So that button will actually reload the scene. We can remove this for now. And simply call the scene manager.load scene if the button has been pressed. Okay. So let's try this out. I think we should be good now. So we just need to add a reference to the weapon selection panel, to the game over panel, and the stage complete. So let's duplicate this one. I thought I had added it, but not yet. So let's do this stage complete. Here we go. And I hope that you've done the exercise so that you don't get lost in here. Okay. Stage complete. Perfect. Start game button. This one should reload the scene. So both of these buttons should reload the scene. So we can call the game manager. Bim bam boom. Manage game over. Here it is. Oh, I should have renamed it another way. But of course, let's just try this out first. Okay, are we good? Stage complete. Perfect. Before I forget. And before I hit play, I'm just going to diminish the wave duration here to 5 seconds, maybe 7, so that I can maybe level up if needed. Okay, so here is the menu. If I start the game, it should display the weapon selection. Weapon selection, perfect. I can't move. If I start the game, I should start the game. Really cool. So let's try and lose. Can I lose? I don't know. Oh, 7 seconds won't allow me to lose. No. So shop directly. Let's just increase this. I'm going to increase it to 15 seconds actually, so that I can lose and display the game over panel. So let's try this out. Okay. Hit me, please. Come on, I'm waiting for you. Maybe we should disable the weapons here. Cotton candy. Yeah. Okay. 3. Yeah, game over. Anyway, they're still shooting at me, but at least we've lost. What we can do is subscribe or check if we've lost in the wave manager and destroy all of the enemies. Okay, so let's hit start game. We should reload the scene. Perfect. We can try this out, but first let's diminish and try the stage complete. So let's diminish the wave duration here to, let's say, 1 second. Come on. Okay, boom, shop, perfect. Wave 2, stage completed. Yay! But we haven't switched the game state when setting stage complete here. So what we need to do is open our wave manager. We can add the game over logic. So gaze game state.game over. What do we want to do? Let's break first. Let's just destroy all of the enemies. So timer is on equals false. We can pause the timer and defeat all enemies. Perfect. Then what we can also do is check for the stage complete. We should trigger stage complete right here. So game manager .instance.set game state stage complete. Here we go. Perfect. Let's now go back to Unity. Let's check the wave manager. Okay, let's set the duration to 1 second again. Hit play. Dun, 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 dun. Start. Okay, shop. Then wave completed. Stage complete. Yeah, and if I hit play, reload. Perfect. It has reloaded the scene. Really cool. So our call loop is now completed. Hooray! I'm sorry if these lessons were a bit boring, but it's kind of always the case with the UI. So I don't know. Anyway, the next ones will be way better, hopefully, because we're going to work on stats and wave transition. So see you in the next one. Welcome back, guys. In this section, we are going to work on the wave transition manager. Dun, dun. Okay, so I will need your whole focus for this section. It's not going to be as trivial as the other ones, but if you succeed and go through all of the lessons, you will drastically improve your coding skills and the rest will be kind of easier. Don't worry, we are still going to tackle dictionaries and so on later on, but at least it's going to be a little bit better. Okay, so the first thing we want to do is open our wave transition manager. So where is it? Here it is. Let's hide the stage complete and open the wave transition manager. Perfect. We are going to hide this text or make it smaller actually. Okay, let's drop it to the top so that we have space to drop our buttons. Let's drop it here. Maybe you can press T, by the way, and resize this. Okay, I hate this. Okay, perfect. So let's add our 3 buttons because as you've seen in the promo video, we have 3 stats we can improve during the wave transition. So let's right click, create an empty game object that will hold our buttons and call it maybe upgrade buttons container, something like that. So we are going to make it a little bit bigger, maybe something like that. We can drop this a little bit below it and diminish its size. Perfect. Now that we have a container for our buttons, we can add the buttons. So let's right click, create a new button. So UI, button right here. Let's improve its size, increase its size, sorry, something like that. Yeah, perfect. And call it upgrade container button. Here we go. So that's 1. We will need 3 of these. So let's duplicate this one twice. And what we can do to lay them out automatically is add a horizontal layout group component to our upgrade buttons container. Here we go. So we now need to set it up so that it's centered. Let's first allow the upgrade buttons container to control the width and the height of our buttons so that they fill the whole space. Then we can align them at the middle center, increase the spacing a little bit, something like that. Of course, you're free to use the values that you want for now. Later on, we will use other values, but for now, this is really not important. So let's set this one to 20, 20, 20, 20. I just want to show you that you can do this. Okay. Our 3 buttons do have a text component inside of it. So the first thing we are going to do is simply change the text that is inside of the upgrade container buttons, dynamically, of course. So let's first change the font, increase the size. So let's just auto size it. Perfect. And I think we are now set up for the buttons. So let's tackle the Wave Transition Manager script. For that, we are going to open the Managers folder, right-click, create a new C# script, and call it Wave Transition Manager. After that, we can create a game object that will hold this script. So Wave Transition Manager, here we go. Attach the script and open it. Perfect. So this boy will configure the buttons right here whenever we switch from the game mode or game state to the Wave Transition Manager. So of course, it needs to implement the game state listener interface, right? So let's use the quick fixes here, Alt Enter or Option Enter on Mac. I'm going to grab this one and drop it here. Perfect. And we are first going to add a reference to our buttons. So header, elements, serialize field, private, button array. Oh, come on, not this. Upgrade containers, let's say. Here we go. Perfect. So we don't have the Unity Engine.ui library. So let's quickly add it. Here we go. Perfect. And we are now good to go. So let's jump back to Unity to reference these buttons. Here is the first one, the second one, and the third one. Now let's add a way to change the value of the text here. So we are going to open our script and jump to the game state change callback here. And let's add a switch statement. So switch game state. In case the game state is wave transition, what we are going to do is configure our, let's say, upgrade containers. Like so, and break. Perfect. So let's now create this method. Private void configure upgrade containers. Containers. Nice. To change the texts of our buttons, we are simply going to grab the upgrade container, grab the first child, because we know that this is the first child. Later on, we will have a specific script for that to comply with OOP principles and to make our lives easier, of course. But yeah, let's create that loop. So for I from 0 to upgrade containers dot length, we are going to grab the text from TextMesh Pro. So let's add the TextMesh Pro library. So using TM Pro. Cool. Let's grab the text. So upgrade containers at index I dot get component in children, or you can actually write transform dot get child at index 0 dot get component of type text mesh pro UGUI dot text equals, let's say, upgrade with index I. Here we go. So this is the first step. We are just going to change the text of the button, and it should display upgrade 0, upgrade 1, upgrade 2. So let's jump back to Unity and hit play. Of course, this is not going to be configured at start, so we need to play a little bit. Here we go. Oh, we need to level up actually. So what we are going to do to debug this is open our player level script. Where is it? Right here, player level. And the has leveled up should always be true. Okay, so let's just return true. That way we will make sure that we display the wave transition panel. And we can actually add a debug element here. So debug, serialize field, private bool, debug. Okay. And if we are in debug mode, let's return true. Nice. So let's go back to Unity now and enable this debug boolean. Boom, bam, boom, boolean. Here we go. Let's hit play. Let's start the game. Start game. Boom. Wave transition. Upgrade 0, 1, 2. Really cool. So we are already able to access the text and change its value here. Really cool. So in the next one, instead of writing a really random text like we've done here, we are going to add player stats and pick a random stat that we will display in these buttons. See you in the next one.